Java has long been one of the most popular languages and platforms. There's no doubt that Java has a promising future. With its popularity among developers, a vast range of tools and resources, and a thriving software development environment, it remains one of the most in-demand programming languages even today. Hello everyone and welcome to this session. You are currently watching an Edureka Java full course video. By the end of this video, you will have a thorough understanding of Java all the way from theory to practical application. If you love watching videos like these, then subscribe to Edureka's YouTube channel and click the bell button to never miss out any updates from us. Also, if you want to learn more about Java after watching this session and wish to obtain Edureka's Java certification course, then please check out the link given below in the description. Now let's begin with our agenda, where we'll have a brief overview of what we'll cover in this Java full course video. We'll start with Java basics, where we'll learn what Java is and why should we learn Java. We'll see how to install Java. Next, we have Java OOPS concepts. Here we'll cover abstraction, encapsulation, inheritance, and polymorphism. Now it's time to deep dive into technical aspects of Java. We'll start with arrays and strings in Java. Now once this is done, we'll understand the data structures in Java. We can then see some of the core concepts in Java like file handling, object serialization, Java threads, and regular expressions in Java. After which we'll learn socket programming in Java, followed by some design patterns used in Java. Now after all this, we'll head over to our Java projects. We truly hope that this session assists you in getting jobs in the industry. In order to accomplish so, we will look on to how a career in Java is, followed by some essential Java interview questions. Now let's get started with our first topic, what is Java?
There are many controversies that say Java is going to die and it has become weak compared to its competitors. So, many beginners and experienced programmers have a doubt if it's really dying. To clear this doubt, let us have a quick look on the major applications and websites once. Airbnb, Uber, Facebook, Instagram, Google, Amazon, Netflix, and lot many. We shall begin with little basic history of Java. Now, why did we recall all these applications and websites? It is because all these tech giants are in the use of none other than Java programming language. It is the base of all data frames, storage, and parts of every single major application. This entirely proves that Java is never going to die. It is getting evolved every single day, and it is one of the major reasons behind the development of much major softwares. Now that we have a good clarification, let us move ahead and learn Java really fast. Java is also used in multiple ways, for example, social media, big data and Hadoop, Android application development, data science and artificial intelligence, data security, software testing, and data analytics. Now that we have a good clarification, let us move ahead and learn Java really fast. We shall begin with a little basic and history of Java. Firstly, history of Java. Java was invented by James Gosling in the year 1995. It was basically invented for interactive television. For God's sake, it was found too advanced and was also able to perform extraordinary and sizable tasks than just a television thing. They found it had some impeccable features as well. Now, let us move ahead and discuss some of those features as well. Some of the major features are as follows. Firstly, open source. Java, since its birth till today, is an open source product. There are many speculations that say Java is not free anymore. But to be sure, Java is still free. And the OpenJDK and Oracle JDK are completely similar to each other. That means you can type your code using Oracle JDK and execute it in OpenJDK. And the JDK versions are also available for all the types of operating systems such as Windows, Linux, Mac, and many other flavors of Linux. Followed by the first feature, the next feature is high performance. Java is an interpreted language, so it will never be as fast as a compiled language like C or C++, but Java enables high performance with the use of just-in-time compiler. So here, Java provides us high performance. Followed by that, the next feature is multi-threading. Java multi-threading feature makes it possible to write a program that can do many tasks simultaneously. The benefit of multi-threading is that it utilizes the same memory and other resources to execute multiple threads at the same time, like while typing, grammatical errors are checked along. Followed by this feature, the fourth feature is secure. When it comes to security, Java is always the first choice. With Java secure features, it enables us to develop virus-free and tamper-free systems. Java program always runs in a Java runtime environment with almost null interaction with host operating system. Hence, it is most secure. Followed by this, the next feature is Java's platform independency. Unlike other programming languages such as C or C++, etc., which are compiled into platform-specific machines, Java is guaranteed to be write once, run anywhere language. On compilation, Java program is compiled into bytecode. This bytecode is platform independent and can be run on any machine. Plus, this bytecode format also provides security. Any machine with Java runtime environment can run Java programs. Followed by this, the next feature is portability. The cross-platform feature enables the Java code to be highly portable. In Java, everything is an object which has some data and behavior. Java can be easily extended as it is based on object-oriented programming model. The last but not the least feature of Java is its robust nature. Java makes an effort to eliminate error-prone codes by emphasizing mainly on compile time error checking and runtime error checking. But the main areas in which Java improvised were memory management and mishandle exceptions by introducing automatic garbage collector and exception handling. Now, let us enter into the installation process. We shall now install Java into the local system. Our local system will be Windows. To download Java, just Google Java download for Windows operating system. You will be redirected to a new web page, and from here, you can select Java SE Downloads Oracle Technology Network Oracle link to download Java for your local system. And now you will be redirected into a new page where you will be shown the Oracle JDK Platform 13. Select the download button, which is shown here in the blue color. Now you will be redirected into the next web page where you can select the version which can match your particular local system. For us, we should be downloading the Oracle JDK version for Windows. Just select Accept License Agreement and click on the version you need to download for your local system, and it's done. You can see that the JDK version for Windows is getting downloaded. Once after the JDK is downloaded into your local system, enter into the system settings and type in Edit Environment Variables. There you can see this particular icon is what we need, which is Edit Environment Variables for your account. Select the environment variables and you can see this dialog box. And in this dialog box, create a new variable, which will be the Java home variable for your JDK. Type in Java home, and inside this second dialog box, you need to add in the location of your Java's bin file. As you can see, the location of my Java JDK is this. So you can just copy this particular path and go back to the Edit Environment Variable dialog box and place in this value. And just select OK to save it. As you can see, I have already set my Java path, so I would prefer to cancel, but you have to select OK. Once after you set the Java home, you need to set the path for your JDK. The path to the JDK can be set using the path select option from the edit environment variables. Just select path and select edit option, and you will be shown with a new dialog box. And in here, you need to select the path to your Java file. You can set the Java path by selecting bin and copying the path. You can see the path to my JDK is C program files Java JDK and bin. Copy this path and paste in the edit environment variable path file. As you can see, I have my JDK path already set, which is C program files Java JDK bin. After this, just select OK. As I have already set my path, I would prefer to select cancel, but you have to select OK. Once after your path is set, select OK and close the edit environment variables properties or your system properties. Now that Java JDK has been installed into your local system, let us check the version of Java which is existing in your system. So to check the Java version in your system, just open your command prompt. Once after the command prompt is open, just type in Java C. So if you get this on your command prompt, then it is sure that Java has been successfully installed into your system. Yet, we can also check the version of Java that is installed onto our local system. To do so, we can type in Java space hyphen version and press enter. You can see that the Java version installed into our local system is Java 1.8. Now, we have got Java installed into our system successfully. To run Java, we might need one of the popular IDEs such as Eclipse, IntelliJ, and many more. To execute our programs, we shall select Eclipse IDE. To install Eclipse into a local system, just type in Eclipse download on Google. Once after you type in and enter Eclipse download, you will be redirected to a new web page where you will find many links, and you should select the first link, which will redirect you into the Eclipse Foundation. And in here, you're supposed to download Eclipse IDE 2019-12 installer file. And you can see your installer file is getting downloaded. You can see that Eclipse installation file has been successfully downloaded into your local system. Now, you just need to open the file. Now you can see multiple options of Eclipse IDE, such as Eclipse IDE for Java developers, IDE for enterprise Java developers, IDE for C or C++ developers, and many more. Now we shall prefer IDE for enterprise Java developers. Now you have got yourself redirected into a new dialog box, and here you've been asked for install option. Just select install and Eclipse IDE will be installed into your local system. I already have an Eclipse IDE installed in my local system, so I would prefer to go back, but you should select install to install it into your local system. Once after you install the Eclipse IDE into your local system, you shall see something like this. So inside the Eclipse IDE, to create a new file in the Eclipse IDE, you need to select File option, and inside File, you need to select New, and inside New, select New Java project, and there you go. You'll be redirected into a new dialog box where you should enter the name for your project. Let us enter Edureka. Followed by that, Finish. Your project has been successfully created. Now, select your project and right-click on it. Or click the drop-down menu and you can see a source file. Select the source file and right-click the source file, and now create a new package. The name of your package will be set as Edureka by default, which is your project name. Just select Finish to create a new package. Once after you create a new package, just select the package and right-click and select New to create a new class. Now, name your class. The class name can be anything. For now, let us write in Hello. And after that, you can also select in public static void main as default. And after that, just finish. And there you go. Your new class has been successfully created. Now, let's go back to our presentation. You can see that we have successfully installed Java. Now let us try to execute a simple Hello World program in our Eclipse IDE and see if our Java and Eclipse are working fine together or not. So here you can see that this is our first program, and inside this we are trying to just print Hello World message. Now to run the code, you need to select all the code and select the run icon which is placed on your tools bar. So this particular bar is your tools bar, and inside which you can see a green button which says run my first Java program. Just select it and you can see this dialog box, and inside this you need to select OK, which says save and launch. Your application has got successfully launched, and you can see the Hello World message has been successfully printed on the console. Now that we have successfully executed our first Java program, let's move ahead and understand the variables in Java. First, let us understand the basic definition of a variable. A variable is a container that holds the value while Java program is being executed. A variable is assigned with a data type. Variable is the name of the memory location, and there are three types of variables in Java, which are local, instance, and static. Let us understand local variable. A variable declared inside the body of a method is called local variable. You can use this variable only within that particular method, and other methods in the class will not be aware of that particular variables which are used in your local class. A local variable cannot be defined with the static keyword. Followed by that, we have instance variable. A variable declared inside the class but outside the body of the method is called instance variable. It is not declared as static. It is called the instant variable because its value is instance specific and not shared among other instances. The last but not the least is the static variable. A variable which can be declared as static is called static variable. It cannot be local. You can create a single copy of static variable and share among all the instances of the class. Memory allocation for static variable happens only once when the class is loaded in the memory. Now, the next part is the data types. The data types supported in Java programming language are int, float, double, long, short, character, byte, and boolean. Now, let us also go through the size of each data type supported by Java. Java supports 2 bytes for integer data type, 4 bytes for float data type, 8 bytes for double, and 8 bytes for long. Followed by that, 2 bytes for character type data type, 1 byte for short, 1 for byte, and 1 byte for boolean. These data types are called as primitive data types. Followed by variables and data types, now let us enter into the operators that are available in Java. The operators in a programming language are specific or special symbols used along with the variables or numbers so as to carry out some specific operations. The various operators available in Java are as follows. They are unary operator, arithmetic operator, shift operator, relational operator, bitwise operator, logical operator, ternary operator, and finally the assignment operator. We shall discuss about each and every single operator available in Java. Firstly, the unary operator. The Java unary operator requires only one operand. The unary operators are used to perform various operations such as incrementing or decrementing a value by 1, negating an expression, inverting the value of a boolean, and many more. Now, let us execute a simple example of unary operator in Java. As you can see, this particular example is based on unary operators. So here, I have declared a value 10 to the variable x of integer data type. And now, I am trying to increment the value of x by 1 by adding the unary operator increment. This particular incrementation is called post increment. Followed by that, we have a similar increment operator which is placed before x, which says it is a pre-increment operator. Followed by that, we will try to decrement the value of x by 1 by using post-decrement operator, where we will provide the decrement operator after x. And similarly, the same decrement operator is used before x, which says that it is a pre-decrement operation. Now, let us try to execute our program and see the output. You can see the output has been successfully generated. Now, followed by this, let us move ahead and understand the arithmetic operator. Java arithmetic operators are used to perform addition, subtraction, multiplication, and division. They act as basic mathematic operations. Now, let us see a basic example for arithmetic operators. You can see I have provided two variables, that is a and b. A has the value 10 and b has the value 5. So, the basic arithmetic operations that I will be performing are addition, subtraction, multiplication, division, and modulus. So the addition symbol is carried out by plus, subtraction is minus, multiplication is star, division is /, and modulus is modulus symbol. These are common. Now, let us execute this and see the output. You can see all the arithmetic operations have been successfully executed and the output is also generated. So you can see the addition is 15, subtraction is 5, multiplication is 50, division is 2, and modulus is 0. Now with this, let us move ahead into the next type of operators, which are none other than the shift operators. The shift operator is used to shift the bits in the value to the left or right side of the specific number of times. We have two types of shift operators, which are left shift operator and the right shift operator. The left shift operator moves the specific number of bits towards the left side and the right shift towards the right side. Now, let us execute a sample program to understand the shift operators in a much better way. You can see I have used shift operator here, which is left shift, and I'm using left shift operator to move 2 bits of 10 towards left side and 3 bits of 10 towards left side and 2 bits of 20 towards left side and 4 bits of 15 towards left side. So basically what happens here is 10 will be converted into binary numbers, and similarly all the other numbers will be converted into binary numbers, and the number of bits which we require, that is 2, will be shifted in that particular converted binary number, and the new number generated will be provided in decimal numbers, and that will be our output. Let us execute this program and see our output. You can see that the program has been getting executed and the new numbers have been generated here as the output. So 10 after shifting 2 bits towards left will be generating 40, and 10 after shifting 3 bits towards left will generate 80, and similarly 15 after shifting 4 bits will generate in 240. Now that we have understood the shift operator, let us move ahead and understand the relational operator. The Java relational operator is used to compare the operands on both the sides of the relational operator. This particular operator judges whether one of the operands is greater or lesser or equal or not equal to the other operator. Now, the basic operation what a relational operator does is, it compares the two numbers. For example, if you have a as 5 and b as 10, and if you compare if a is greater than b, then the result will be false because a is smaller than b. So this is what a relational operator basically does. Now, let us go through a sample program to understand relational operators in a much better way. Here you can see that I have declared three variables, that is A, B and C. A has 10, B has 5 and C has 20. Now what we are doing is we are comparing A is less than B and A is less than C, and followed by that we are comparing again A is less than B and A is less than C. So this example is both for relational operator as well as logical operator. So the logical operation which we have used is AND. Now let us try to execute this program and see the output. And there you go. The result is false because A is greater than B but not less than B. Similarly, A is less than C, but the result of AND logical operator is false because to become true, both sides of the operand should be true. Now, let us move ahead and understand bitwise operator. Basically, the bitwise operator is applied on the bits. For example, if we provide a number to the variable, that particular number will be converted into binary format, and after that, the operation will be applied on the bits one by one. Let us execute a sample program to understand bitwise operators in a much better way. So this particular example is based on bitwise operators. Here also we have the same three values, that is A is equals to 10, B is equals to 5 and C is equals to 20. Now we're performing bitwise operations on the particular variables and comparing them using a logical operator which is AND. Now let us try to execute this program and see the output. You can see that the program has been successfully executed and the output has been printed. But the value of A has been changed here from 10 to 11. This happened because it is based on the bitwise operation which we performed here, that is A++ post increment. Now followed by this, let us move ahead and understand the next type of operators, that are the logical operators. The logical operators are the operators which are applied on both the ends or both the operands. So the basic logical operators supported in Java programming language are AND, OR and NOT. The AND operator is used to perform logical operation on two operands and it will result in a Boolean result. So to become a true Boolean result, AND should be having both the operands as true. And in OR, to result a true value, either one of the operands should be true. And when it comes to NOT, NOT is just a simple logical operator which negates the existing value. That means if the value is true, then after the NOT operation, the value will be converted into false. Now let us see one basic example to understand logical operators in a much better way. You can see the previous example is the best fit to understand logical operators. You can see the value here was false since A is greater than B. So this value will result in a false and this value will result in false. So false and false will result in false. Now moving ahead, we shall understand the next type of operators, which are the ternary operators. The ternary operator is simple but highly powerful operator used in Java programming language. This particular ternary operator will reduce the code length to one line. To understand this in a much better way, let us execute a sample program. Here you can see that we have two different values, which are A and B. A has 2 and B has 5. So the ternary operator is this particular statement. Here we have also allocated a new variable which is of integer type, which is minimum. So minimum is equals to A less than B. If A is less than B, then minimum is A and else B is equals to minimum. So this particular operation is minimum. Here A is compared. If A is truly less than B, then A will be printed into minimum, else B will be printed into minimum. And finally, we shall print the value which is stored into minimum. Now let us execute this and see the output. You can see that the value of A, which is 2, has been printed here after executing the ternary operator present in the line number 7. Now Let us move ahead and understand the next type of operators, which are the assignment operators. The assignment operators used in Java programming language are simply used to allocate the resultant memory into the variable which is located in the left side of the operand. The basic assignment operators used in Java programming language are equals to and double equals to. To understand assignment operators in a much better way, let us execute a sample Java program. So this particular program is based on assignment operations. Here we have two different values, which are a and b. A is equals to 10 and b is equals to 20. Now what we are basically doing here is using the assignment operator and adding value 4 to the value 10 and decrementing value 4 to the value 20. This particular operator used here is the assignment operator. Now the result will be a is equals to 14 and b is equals to 16. Now let us execute this program and see if the output will be correct or not. You can see the output is as expected. With this, let us move ahead and understand the control statements in Java. A control statement in Java is a statement that determines whether the other statement will be executed or not. In simple terms, it controls the flow of a particular program in Java. Now, let us see the control statements which are present in Java. So the control statements supported in Java are if-else loop, while loop, do-while loop, for loop, and switch case. So these are the basic control statements that each and every programmer must be known with. Now, let us understand each and every one of these control statements and also execute a basic program to understand them in a much better way. Firstly, we shall deal with the if statement or if control statement. In this statement, if the condition specified is true, the if block will be executed. Otherwise, the else block will be executed. We shall execute a sample program to understand the if-else statement in a much better way. So this particular program is based on if-else control statement. Here, we have the input a is equals to 15. The first if condition will be, in case if a is greater than 20, then the first printf statement should be executed. Else, the other printf statement should be executed. Now, let us execute this program and see the output. Since we know 15 is less than 20, we should be expecting the second set of statements to be executed, which is a is less than 10 and hello world. You can see the message has been successfully printed here. Followed by this, let us move ahead and understand the next type of control statements which are supported in Java, that is none other than the while loop. Known as the most common loop, the while loop evaluates a certain condition. If the condition is true, then the code is executed. The process is continued until the specific condition turns out to be false. The condition to be specified in while loop must be a Boolean expression. An error will be generated if the type is used is not an integer type or a string type. Let us execute a basic example to understand this while loop in a much better way. As you can see, this particular example is based on while loop. Here, we have a variable I which has the value 5. Here, the condition specified in while loop is I should be less than or equal to 15. Until then, we have to execute the printf statement which prints the value of I. And after that, the value of I will be incremented by 2. Now, this particular set of loop will be executed until the value of I is less than or equal to 15. Once after this condition becomes true, the loop will be terminated. Let us try to execute this program and see the output. You can see the values 5, 7, 9, 11, 13 and 15 are printed successfully. Once after the value of I reached to 15, the loop got terminated and it exited the loop. Now followed by this, let us understand the next type of loop, which is the do-while loop. The do-while loop is completely similar to the while loop. The only difference is that the condition of the do-while loop is evaluated after the execution of the loop body. This guarantees that the loop is executed at least once. Now, let us try to execute a sample program to understand do-while loop in a much better way. You can see that this particular example is based on do-while loop. Here, we have a variable I which stores the value 20. So, once after the value is being declared, we have the do-while loop. So, inside the do-while loop, we are supposed to print the value of I. The value of I will be incremented by 1 every single time the loop is executed. Now, the loop body of do-while loop is finished. So the condition is placed at the end of do-while loop, which says the I value should be less than or equal to 20. Until then, this particular loop is valid. Now, the only suspense between do-while loop and while loop is the do-while loop will be executed at least for once without checking the condition, because the condition is placed after the do loop body. Now let us try to execute this and see the output. You can see that the while loop has been successfully executed. The value 20 is printed only for once because the value of I which we declared was 20 and it is true according to the condition. So the control got terminated. Let us move ahead and understand the next type of loop, which is the for loop. The for loop in Java is used to iterate and evaluate a code multiple times. When the number of iterations is known by the user, it is recommended to use the for loop. To understand the for loop in a much better way, let us try to execute one basic example based on for loop. So this particular example is based on for loop. Here we have the value of I as 1 and the condition is I is less than or equal to 10 and after that a post increment. So in this particular statement, we will be printing the value of I 10 times until the for loop is true. The three basic parts of a for loop are declaration, condition, and increment or decrement. So this particular first block, which is I is equals to 1, is the declaration part, and after that I is less than or equal to 10 is the condition part, and lastly I++, which is the increment, is the last part. Now let us try to execute this program and see the output. You can see that the program has been successfully executed and the value of I is printed for 10 times, which is 1, 2, 3, 4, 5, 6, 7, 8, and 9 and 10. Now followed by this, let us understand the next type of loop, which is the switch case. A switch statement in Java is used to execute a single statement for multiple conditions. The switch case statement can be used with short byte int, long enum types, etc. Certain points must be noted while using the switch statement, which are 1 or n number of case values can be specified for a switch expression. Case values that are duplicate are not permissible. A compile time error is generated by the compiler if unique values are not used. Next, the case value must be a literal or a constant. Variables are not permissible. The last condition is usage of break statement is made to terminate the statement sequence. It is optional to use this statement. If the statement is not specified, the next case is automatically executed. Now, let us try to execute a sample program to understand switch case in a much better way. You can see that this particular program is based on switch statement. The switch condition is instrument. Now here, the condition is that we are supposed to select the instrument number 4, which happens to be flute. Now we have a various set of instruments present in our case, which are piano, drums, guitar, flute, ukulele, violin, and lastly the default statement, which is invalid. Let us try to execute this program and see the output. Since we have provided our selection to be 4, which happens to be flute, the output should be directly generated as flute. Now let us run this and see the output. You can see that the program has been successfully generated and the selected instrument flute has been displayed in the console. Now moving ahead, we shall understand the object-oriented style of programming in Java. Object-oriented programming is a programming style which is associated with programming concepts such as inheritance, polymorphism, abstraction, and encapsulation. Most of the popular programming languages like Java, C++, Ruby, etc. follow an object-oriented programming paradigm. As Java being the most sought after skill, we will talk about object-oriented programming concepts in Java. An object-based application in Java is based on declaring classes, creating objects from them, and interacting between these objects. The first object-oriented programming style we will be discussing today is encapsulation. Encapsulation is a mechanism where you bind your data and code together as a single unit. It also means to hide your data in order to make it safe from any modification. What does this mean? The best way to understand encapsulation is to look at the example of a medical capsule, where the drug is always safe inside the capsule. Similarly, through encapsulation, the methods and variables of a class will be hidden safe. To understand encapsulation in a much better way, let us go through a simple example. So this particular program is the example for encapsulation. Here, we have encapsulated the data members, which are the name of the user, which is Ravi, and account number of the user, and email of the user, and the amount which is present in the particular user's account. Now, we will try to execute this program and print the details of the user. You can see the program has been successfully executed, and the account number of the user has been displayed here along with his name and mail ID along with the balance amount which is present in his particular account. So this particular example was based on encapsulation. Now let us move ahead and understand the next type of object-oriented programming style, which is inheritance. As we can see in the image, a child inherits the properties from his father. Similarly, in Java, there are two classes. They are parent class, which is also called as a superclass or a base class. And the next type of class is a child class, which is also called as a subclass or a derived class. A class which inherits the properties is known as a child class, whereas the class whose properties are inherited is known as the parent class. Inheritance in Java is further classified into four types. They are single inheritance, multi-level inheritance, hierarchical inheritance, and lastly, the hybrid inheritance. The first one, single inheritance. In single inheritance, one class inherits the properties of another. It enables a derived class to inherit the properties and behavior from a single parent class. This will in turn enable code reusability as well as add new features to the existing code. Here, class A is your parent class and class B is your child class, which inherits the properties and behavior from the parent class. Followed by that, we have multi-level inheritance. When a child class is derived from a parent class, which happens to be also derived from another parent class, that is, a class having more than one parent class but at different levels. Such type of inheritance is known as multi-level inheritance. If we talk about the flowchart, class B inherits the properties and behaviors of class A, and class C inherits the properties of class B. So here, class A is the parent class of class B as well as class C. So in this case, class C implicitly inherits the properties and methods of class A along with the class B. This is what we call is a multi-level inheritance. Followed by this, we have hierarchical inheritance. When a class has more than one child class or subclass, in other words, more than one child class have the same parent class, then such type of inheritance is known as hierarchical. If we talk about the flowchart, then class B and class C are the child classes that are inherited from the same parent class, that is class A. Followed by that, the last type of inheritance is called the hybrid inheritance. The hybrid inheritance is a combination of multiple inheritance and multi-level inheritance. Since multiple inheritance is not supported in Java, it leads to ambiguity. This type of inheritance can be only achieved through interfaces. We shall execute examples for each one of the type of inheritances. The first example that we will be executing is based on single inheritance. So in this particular example, we have the parent class as teacher and the child class as Hadoop teacher. So here, what we are trying to do is, we are trying to inherit the properties of the parent class teacher into the child class Hadoop teacher. Let us try to execute this program and see the output. You can see that the program has been successfully executed and the properties of the parent class have been successfully inherited into the child class, that is, the college name, designation of the teacher, and the main subject which he or she will be teaching. Now, followed by this, we shall try to execute the next type of example based on inheritance. Repeat. So the next type of inheritance is the multi-level inheritance. This particular example is based on multi-level inheritance, where one child class inherits the properties of multiple parents at different levels. One happens to be the first class, two happens to be the next class, and lastly, three happens to be the last child class which extends the properties of 1 and 2. Let us try to execute this program and see the output. You can see that the program has been successfully executed and the output has been successfully generated on the console. Edureka, happy learning. Followed by this, we shall move ahead and understand the next type of inheritance. So this particular example is based on hierarchical inheritance, where two or more classes inherit the properties of one parent class. So here, the class 1 happens to be the parent class and class 2 and 3 are the child classes which are inheriting the properties from the same parent class which happens to be 1. Let us try to execute this program and see the output. You can see that the program has been successfully executed and the output has been generated, which says Edureka, happy learning. Now we have discussed all the three inheritances, which are single level inheritance, multi-level inheritance, and hierarchical inheritance. The last type of inheritance, which happens to be multiple inheritance or hybrid inheritance, happens to be not supported in Java. To make this happen, Java has come up with a new idea which is called as interface. So we shall discuss about Java interfaces in the further chapters. So the next concept in object-oriented style of programming is the abstraction. Abstraction refers to the quality of dealing with ideas rather than events. It basically deals with hiding the details and showing the essential things to the user. If you look at the image here, whenever you get a call, we get an option either to pick it up or just to reject it. But in reality, there is a lot of code that runs in the background. So we don't know the internal processing of how a call is generated. That's the beauty of the abstraction. Therefore, abstraction helps to reduce the code complexity. You can achieve abstraction in two ways. That is, by using an abstraction class or an interface. We shall understand abstract classes first. An abstract class in Java contains abstract keyword. What does the abstract keyword mean? If a class is declared abstract, it cannot be instantiated, which means you cannot create an object of an abstract class. Also, an abstract class can contain abstract as well as concrete methods. Now followed by that, the next one is an interface. Interface in Java is known as a blueprint of a class, or you can say it is a collection of abstract methods and static constraints. In interface, each method is public and abstract but does not contain any constructor. Along with abstraction, interface also helps you to achieve multiple inheritance in Java. We shall execute one single example for each one of these to understand abstraction in a much better way. So the first example that we will be executing will be based on abstraction. And the abstract class which is declared here is person. So to declare this particular class, we have used the keyword abstract. So this particular abstract class consists of the following segments. The first one is the name of the person, gender of the person. After this, we have the class which inherits or extends this particular abstract class, which is student. So inside student, we have a variable called as student ID, which is declared as private. Now, the elements from the abstract class will be extended into this particular student class and the output will be generated. So let us execute this program and see the output. You can see the program got successfully executed and the output is being generated. Here, we have the name of the student as Priya and gender female, similarly Karan, Kumari, John and their genders, and also their degrees. Karan, Kumari and John are pursuing engineering and Priya is not studying. So now let's move ahead and understand interfaces in Java. This particular example is based on interface, and here the interface that we have declared is about a basic calculating functions which are add, subtract, multiplication and divide. So here we have declared the interface using the keyword interface. And as you can see, we don't have any constructors inside this interface. And followed by this is our main class, which is student, which will implement the interface match to perform the addition, subtraction, multiplication, and division operations. Let us try to execute this program and see the output. Now you can see the program got successfully executed, and now the program is asking us to enter any two digits to perform addition. Let us enter 10 and 20, and you can see the sum has been successfully generated. Now it is asking values to enter to perform subtraction. Let us enter 10 and 5. You can see the output as 5. Now it is asking for values to perform multiplication. Let us enter 10 and 20. You can see the product as 200. And finally, the division operation, let's enter 20 and 5. You can see the quotient is 4. So this is how interface works. Now followed by this, the fourth and last type of object-oriented programming style is none other than the polymorphism. Polymorphism means taking many forms, where poly means many and morph means forms. It is the ability of a variable, function, or an object to take on multiple forms. In other words, polymorphism allows you to define one interface or method and have multiple implementations. Polymorphism in Java is of two types. First, runtime polymorphism and compile time polymorphism. In Java, runtime polymorphism refers to a process in which a call to an overridden method is resolved at runtime rather than at compile time. In this, a reference variable is used to call an overridden method of a superclass at runtime. Method overriding is an example of runtime polymorphism. We shall understand method overriding and method overloading in the further concepts, that is, the advanced Java programming concepts. And followed by that, we have the next compile time polymorphism. In Java, compile time polymorphism refers to a process in which a call to an overloaded method is resolved at compile time rather than at runtime. Method overloading is an example for compile time polymorphism. Method overloading is a feature that allows a class to have two or more methods having the same name but with different arguments passed to the methods are different. Unlike method overriding, arguments can differ in number of parameters passed to the method, data types of the parameters, sequence of data types when passed to a method. With this, we come to an end of object-oriented style of programming in Java. Now, let us continue with advanced Java concepts. The first amongst the advanced concepts in Java is exception handling. So first of all, what is an exception? An exception is an unwanted or unexpected event which occurs during the execution of a program at runtime that disrupts the normal flow of the program instructions. Error versus exception. Error. An error indicates serious problem that a reasonable application should not try to catch, whereas exception indicates conditions that are reasonable to an application that might try or to catch. Now, how does a JVM handle exception? There is a method called default exception handling. Whenever inside a method, if an exception is occurred, the method creates an object known as exception object and hands it off to the runtime system, that is JVM. The exception objects contain name and description of the exception and the current state of the program where the exception has occurred. So this is how the exception is handled. Let us try to execute a simple program based on exception handling to understand it in a much better way. So this particular example is based on exception handling in Java. So this particular program is related to divide by zero exception, where the given number will be divided by 0, so anything cannot be divided by 0. So this particular exception is called as divide by 0 exception, and we cannot divide any number by 0. Let us run this program and see the output. You can see that the program has been successfully executed and the output has been generated, which says can't divide it by 0. Now moving ahead, the next advanced Java concept is multi-threading. Multi-threading in Java is a feature that allows concurrent execution of two or more parts of a program for maximum utilization of CPU. Each part of such a program is called as thread. Threads are lightweight processes within a same process. Now, let us try to execute a sample program to understand multi-threading in a better way. Now, this particular example is based on multi-threading in Java. We'll be creating multiple threads like 1 or 2, and we will be seeing if that particular thread is existing and running or not. Now let's try to execute this program and see the output. Don't worry about the codes, we will send you at your request if you provide your mail ID. Now you can see threads are created here. Thread 1 and thread 2 have got created, and thread 1 is running, thread 2 is getting started, and also thread 2 is also running. Now you can see the functionalities of thread 1 and thread 2, and they are existing safely. Now with this, let us move ahead into the next concept, which is call by value and call by reference in Java. Call by value and call by reference in Java is just function calling. Firstly, call by value means calling a method or a function with a parameter as value. Through this method, the argument value is passed to the parameter, while on the other hand, call by reference means calling a method with a parameter as a reference, which is the address of the value. Let us execute one example each to understand them in a better way. So this particular example is based on call by value method. Here, we will be providing the values of A and B and call the function swap. So this particular function is based on swapping the values between A and B. So the values of A is 30 and the value of B is 45. So after calling this swap function, the values of A and B will be swapped. Now let's execute this program and see the output. As you can see, the program has been successfully executed, and before swapping, the values were 30 and 45. Now the values are exchanged. Now with this, let us move ahead and execute an example based on call by reference. So this particular example is based on call by reference. We are performing the same swap function here, but here we are providing the address of the values. Now let's run this program and see the output. You can see the program has been executed and the values have been successfully swapped. Now let us move ahead and understand the next advanced programming concept in Java, that is method overloading and method overriding. Method overloading is a feature that allows a class to have more than one method having the same name if their arguments lists are different. It is similar to constructor overloading in Java that allows a case to have more than one constructor having different arguments list. Now let us execute a sample program to understand method overloading in Java. So this particular example is based on method overloading in Java. Here we have two different methods on the same name. The name is add, and the first method is having only 2 variables and the second method is having 3 variables. Now let us try to call these functions and see the output. You can see both the functions have been executed and the sum has been displayed in the output console here. So this was method overloading. Now let us move ahead and understand method overriding in Java. In any object-oriented programming language, overriding is a feature that allows a subclass or a child class to provide a specific implementation of a method that is already provided by one of its superclasses or parent classes. Method overriding is one of the major ways in which Java can achieve runtime polymorphism. Now, this particular example is based on method overriding. Here, we have two different functions. So the first function is in the parent class, which is move, and the second function is with the same name, which is move, that is existing in the child class, that is dog. Both these methods are implemented in the main class, and the functionalities of both the methods are included in the main class. Now let's try to execute this program and see the output. As you can see, the program has been successfully executed and the output has been generated. Apart from this, Edureka offers Java J2EE and SOA certification training. Edureka is the segment leader in providing the best-in-class live instructor-led training on Java technology, and it is provided by industry-level experts with years of real-time experience in the technology. The salient features of Edureka Java training are instructor-led sessions. So in instructor-led sessions, you will be having about 42 hours of online live instructor-led classes, and followed by that, you will be dealing with real-life case studies, which will have a live project based on any of the selected use cases. So followed by real-life case studies, you will be having assignments after each and every class where you'll get a chance to apply the concepts learned. Followed by that, you will be having a lifetime access to the learning management system. And also, you have 24/7 expert support if you have any doubts after the class. Once after you complete your course, Edureka certifies you as an SOA Java developer based on the project reviewed by your expert panel, and this particular certificate has been recognized by many multinational companies. I just want to give you guys a little brief about Java and why exactly people hate it. Now, I would like to ask you guys to imagine a jet fighter plane. Hope you guys have a picture of it in your mind. Now, let's reveal it. I bet you guys did not imagine this old model, which is used in World War type of plane, which appears to be this Hawker Hurricane, right? You would have imagined something big, fast, agile, maneuverable, stealthy, and a dominant jet fighter, which nobody could have got a chance to fight against and survive. In the same way, many of the people think Java to be old. But seriously guys, Java did not stop in the 90s. It started evolving. Java is a powerful and dominant programming language since its birth. Many of the frameworks like Hadoop, Spark, Scala, and all the major big data frameworks use Java. The major operating systems like Android also use Java. So to make things better, Java had to upgrade, and it did. Java is not like the older fighter plane. It's like the latest, stealthiest, high maneuverable F-22 Raptor. Now, let us discuss some of the major reasons why people hate Java. People hate Java for multiple reasons. As per the recent survey, the most common factors for which people hate Java are enlisted below. First one is verbose. Verbose, or in simple terms, people feel it too texty. The implementation of classes and code length make people nauseous, but actually it is not. There are many upgrades in Java to reduce your code length. One of the major updates is the record method. This method can make wonders happen. It is capable to replace your complete class just in one line. After all, classes are just transparent containers that store data. And data is just data. It's not meant to be read or visible all the time. We can make use of records and just make things look a little cooler and readable. One such function is also lombook. This function is capable to compress your hundreds of lines of code into very least number of codes. See, that's the magic even Java can do. Java is evolving, people. It now understands what exactly you need. It was, is, and always will be a beautiful language. The next most common reason why people hate Java is they feel it slow and heavy. Come on, people, the whole world of Android applications, web pages, big data, and whatnot, everything runs on Java. How could one feel it's heavy and slow? It's just a misconception. Let me give you a simple example of a web application. Guess you all know Spring Boot. In Spring Boot, to create a web application, you can just start your Spring Boot and input your dependencies you need and start. Voila, you have your application's groundwork finished and it is almost ready to deploy. I accept that in the earlier days you had to manually configure everything, but as said earlier, Java has completely evolved. Now, it's not like that. You just need to provide your dependencies and your application is ready. Followed by that, the next reason is people say it is slow to write. Writing is actually the programmer who does. And the recent IDEs like Eclipse and IntelliJ, they create classes and construct them for the programmer. At this point, I could just say, please know more about your IDEs. Now, moving ahead, let us have a look on who uses Java. There are multiple million-dollar companies that use Java. Few of the major companies are Airbnb, Uber, Netflix, Spotify, Google, Instagram, Facebook, you name it, we got it. Java is also used for big data analytics. Most of the popular big data frameworks like Spark, Flink, Hive, and Hadoop are written in Java. It's easier to find a Java developer who's comfortable working with Hadoop and Hive, rather than one who is not familiar with Java and the stack. With Java 8 came the lambdas, which rectified most of the Java's verbosity, thus making it less painful to develop large enterprise or data science projects. On the other hand, Java 9 brings in much missed REPL or read eval print loop that facilitates interactive development. So, on the other way, Java is a dominant language in data analytics. So, one way or the other, Java is a dominant language in data analytics. Also, Java is capable to work with AI. There are many misconceptions that only R and Python programming languages can be used for data science or artificial intelligence, but it is not true. Even Java is capable to run the algorithms of data science and also execute programs for artificial intelligence. Followed by this, the next major phase where we use Java is designing. Remember design patterns? Yes. Java design patterns are the standards that are used worldwide to create, design, deploy, and maintain hundreds of applications. Followed by this, the database connectivity. JDBC connections are used worldwide. Most of the biggest and bulkiest data transfers are possible just because of JDBC connections. The next in the docket is development. There is no other language that is better than Java that has so many libraries and simplicities when it comes to development part. Followed by that, we use Java because it enables cross-platform. Java was born to be cross-platform. Java was a great hit just because it followed one principle, CORA or WORA. Don't worry, it is just compile once and run anywhere or write once and run anywhere. Now, let us move on to our next topic, that is about why to use Java, which will explain to us about some major features that make Java more programmer friendly. The first one is open source. Java, since its birth till today, is an open source product. Java is still free. It has open sourced all of its significant commercial features that were previously available only to paying customers, including application class data sharing, Java flight recorder, Java mission control, and Z garbage collector. Oracle builds and OpenJDK builds at this point are functionally interchangeable. This means that you can switch from one to the other as you please. It also means that all of this code is available under the GPL for anyone to build, test, publish, update, and support. You'll also be able to get Java implementations in almost any Linux distributions as well. Followed by that, the next feature is high performance. Java is an interpreted language, so it will never be as fast as a compiled language like C or C++. But Java enables high performance with the use of the just-in-time compiler. Followed by that, the next feature is multi-threading. Java multi-threading features make it possible to write programs that can do many tasks simultaneously. The benefit of multi-threading is that it utilizes the same memory and other resources to execute multiple threads at the same time. Like while typing, grammatical errors are checked along. Followed by this, the next feature is security. When it comes to security, Java is always the first choice. With Java secure features, it enables us to develop virus-free, temper-free system. Java program always runs in Java runtime environment, which has almost the null interaction with system OS. Hence, it is more secure. The next feature is platform independency. Unlike the other programming languages such as C, C++, etc., which are compiled into platform-specific machines, Java is guaranteed to be write once, run anywhere language. On compilation, Java program is compiled into bytecode. This bytecode is platform independent and can be run on any machine. Plus, this bytecode format also provides security. Any machine with Java runtime environment can run Java programs. Followed by platform independency, we have portability. The cross-platform feature enables the Java code to be highly portable. Followed by this, we have object-oriented programming style. In Java, everything is an object, which has some data and behavior. Java can be easily extended as it is based on an object model. And the last feature is robust. Java makes an effort to eliminate error-prone codes by emphasizing mainly on compile time error checking and runtime checking. But the main areas which Java improved were memory management and mishandled exceptions by introducing automatic garbage collector and exception handling. Now, let us go through the Java versions. Since from the beginning to today, Java has got many upgrades. The latest version of Java is the JDK 13. Since from the JDK 7 to JDK 13, it was a great journey and many updates have been shown up. Now, let us check what are the stats has to say about the demand for Java developers. As per the latest stats according to the Indate, there is a huge demand for Java developers for both freshers and experienced. And the demand is on top, leaving the other programming languages like Python and C# far behind. Now, let us discuss the salary trends of Java developers in multiple countries. Firstly, let us consider India. The salary trends of a Java developer in India are: for freshers or entry-level Java developer, the salary trends lie between 4 lakh rupees to 5 lakh rupees per annum. On the other hand, for an experienced level Java developer, the salary trends lie between 10 lakhs to 25 lakhs per annum. Now, let us deal with United Kingdom. The salary trends for a Java developer in United Kingdom for an entry-level Java developer lie between £25,000 to £30,000 per year, and on the other hand, for an experienced level Java developer, the salary trends lie between £55,000 to £80,000 per annum. Now, let us consider the United States of America. For the United States of America, the salary trends for a Java developer entry level will lie between $55,000 to $75,000. On the other hand, for an experienced level Java developer, United States of America is paying $90,000 to $1,25,000 per annum as the salary. Now that we have understood the salary trends of Java developers, let us consider the skills to be learned in 2020 to become a successful Java developer. There are many skills to be learned in 2020, but let us consider the beginner skills first and later move on to the major experience level skills to be learned. The basic beginner level skills to be learned in 2020 based on Java are: he or she should be having a good knowledge of JSP servlets and object-oriented programming concepts and design patterns. Abstract classes and interfaces are a must. Followed by that, the programmer at a beginner level should be comfortable with constructors, file input operations, and output operations. And followed by that, he or she should be comfortable with file input output operation and serialization, collections like list, map, sets, and access specifiers, which will provide the access capability like public, protected, and private. Followed by that, the programmer should be good with exception handling, and finally the generics. Now followed by that, the advanced level of skills that an experienced level of programmer should have are DevOps with Java, then microservices, and also Spring Boot. So these were the skills required by both beginners as well as advanced level programmers in 2020. Now let us discuss the advantages that the freshers will be getting from Java. The first advantage of Java for freshers is Java is a language which is completely easy to learn. It does not require any basic understanding of programming. You can directly start from scratch. Followed by that, Java is object-oriented. This point is really important. If you learn Java, you'll get the understanding of the object-oriented style of programming. Means you can directly switch into any other programming languages like C++, C#, and Python, which are also object-oriented programming languages. So learning Java will not be a waste. Once you understand the object-oriented style of programming, you will feel comfortable to work with any other programming language. Followed by that, Java is completely platform independent. We have discussed this point before, which means once you write a code in Java, you can run this particular program in any of the computer or the operating system, regardless of whatever the operating system you are using on your host system. It can be either a Linux or Windows. Once you write the code, you can directly execute it on multiple computers with different operating systems. Loops in Java are used to run a certain code segment in a project for a finite number of times until a certain condition is satisfied. In this video, we will discuss the different types of loops in Java and their control flow along with their relative examples. If we recall the definition, we find that any particular loop is executed based on the validity of a condition. So, it is important that we also understand the terminology of conditional statements in Java. To understand the conditional statements in Java, let us consider a simple example of a car showroom where Mr. John goes to buy a car. He will be assisted by the sales manager of that particular car showroom. He says that he has a condition to buy a car of either of the three colors, which are black, red, or blue. So he searches the cars which are available in the three colors. First, he'll apply a condition in his mind for searching the car with the color black. If it is not available, then he will go for the car with the color red. If it is not available, then finally he will search for a car which is available in blue. So, if his condition is satisfied, then he'll buy the car. Else, he will not buy the car. That's how the computers also think when a loop is applied onto them. So according to our example, Mr. John finds a car with blue color and finally buys it. Now let us dive into the conditional statements which are available in Java. The conditional statements describes the compiler to carry out the execution of a particular code segment in a program until the condition is satisfied. The types of conditional statements available in Java are ternary operator, if operator, else if operator, else if ladder, nested if, break, and switch. Let us execute some examples related to all these conditional operators one by one. Firstly, we shall execute an example based on if loop. As you can see, this particular example is based on if loop. Here, I'm providing a number which is a negative integer number -10. And here, I'm providing an if condition which says that if the number is greater than 0, then I should be printing a printf statement which is number is positive. Else, my interpreter will be printing the message the number is negative. Now, let us try to execute this program and see how does it work. As you can see, the output has been generated, which says the number is negative. Since the number which I provided was a negative integer number, the condition here is failed, and the message which was lying outside the if loop, which is the number is negative, is being printed here. Now, let us execute the next control statement, which is the else if statement. As you can see, this particular example is based on else if loop. Here, I am trying to provide an integer value to the variable a. According to my condition, if the number which I have included results in a modulus is equals to 0, then I should be printing the message as even number. Else, I should be providing the number as odd number. Now, let us try to execute this program and see how does it work. Now, as you can see, the output screen is asking me to enter an integer value. Let us try to input an even number. As you can see, I have inputted an even number and I have received an output as an even number as the condition of the if loop has been satisfied. Now let us try to input an odd number and see if the else loop is working properly or not. As you can see, it is asking for an input. Now let us try to input an odd number, which is 7, and see the output. As you can see, the output is generated as an odd number, which means the else loop is working fine. Now let us try to execute another example based on else if loop. Here I'm trying to execute an example based on year. I'll be trying to input an year, which the program will find out if it is a leap year or not. The condition I have provided for if statement is if the year modulus is equals to 0 and year modulus 100 is not equals to 0, or year modulus 400 is equals to 0, then I must print the message the year you have entered is a leap year. This means all the conditions which are stated in the if loop must be true. Else, it should print a message which says the year you have entered is not a leap year. Now, let us try to execute this program and see how does it work. As you can see, the output screen is asking me to enter an year. Now let us try to enter a leap year. As you can see, the conditions which are provided in the if statement are true, and we are printing the message, the year you have entered is a leap year. Now let us try to provide an input which is not a leap year. As you can see, now it is asking for an year. Let us input the present year, which is 2019, and see if it is a leap year or not. As you can see, the conditions which were provided in the if loop are not satisfied, and the program is printing the message, which is the year you have entered is not a leap year. Now, let us try to execute some programs based on if-else ladder. In this particular example, we are trying to execute else if ladder condition. As you can see, here I'm trying to provide an integer type input to the variable choice. According to the choices I have provided, the first choice will select a sedan type class car, and the second choice will select SUV type class car. The third choice will provide sports type class car, and the fourth choice will provide crossbreed type class car. If the provided input is neither of all these four, then it will provide the last message, which is invalid choice. As you can see, the first if ladder will compare the choice. If the choice is equals to 1, then it will print the message sedan class. And the next else if ladder will compare the choice if it is equal to 2. If it is equals to 2, then SUV class will be printed. And in the next else if ladder, if the choice is equals to 3, then sports class message will be printed. And followed by that else if ladder, you'll have the next ladder which will compare the choice to be equals to 4. If it is true, then crossbreed segment message will be printed. If neither of all these conditions are true, then finally an else block will print a final message which says it is an invalid choice. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and it is asking for a choice. Now, let us try to select SUV type vehicle. For that, we need to provide an input as 2. As you can see, the SUV class pin is successfully selected. Now, followed by this program, let us execute nested if condition. This particular example is based on nested if condition. In this particular example, I am going to provide inputs for 3 numbers. N1 is equals to 20, N2 is equals to 30, and N3 is equals to 10. And finally, we have another integer type variable which is greatest. Using the nested if condition, we'll try to find out the greatest number out of all these 3. As you can see, the first if statement has the condition if N1 is greater than equal to N2, then it should enter an inner if loop. Inside the inner if loop, we have a condition which says if N1 is greater than or equal to N3, then it should enter the loop and print greatest is equals to N1. Else, it should print greatest is equals to N3. After the completion of the if condition, if neither of the statements which are provided in the if condition are true, then the control will flow into the else condition. Inside the else condition, we have an if condition which states if N2 is greater than or equal to N3, then it should print N2, else it should print N3. Now the final output will be generated along with a message, the largest number is and the greatest value. Now let us try to execute this program and see how does it work. As you can see, the output has been successfully generated and it says the largest number is 30. Now let us try to execute an example based on ternary operator. This particular example is based on ternary operator. As you can see, I am trying to provide an input to 2 numbers which are A and B, which will be integer values. This particular statement is our ternary operation. This states that if the provided input A is greater than B, then A should be declared as the greater number. Else, if the condition is false, then B should be declared as the greater number. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and it is asking for a value for the variable a. Let us enter 10. Now it is asking for a value to the variable b. Let us enter 5. Now let us see the output. As you can see, the output is 10. This states that the number a is greater than number b. Now let us try to execute an example based on switch conditional statements. So this particular example is based on switch conditional statement. Here I'll be asked a question as enter any month. So I'll be entering an integer value to the variable month. If the input value is 1, then the program will execute January. If the input value is 2, the program will execute February. Similarly, if the input value is 12, then it will execute December. And if neither of the cases match to the input which I provide, then it will execute a default message which will be invalid input. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and it is asking me to enter any month. Let us try to input 3. As you can see, March is the message which has been printed by the program. Now let us try to execute an example based on break statement. As you can see in this particular example, I have provided an integer array which has the values 10, 20, 30, 40 and 50. And here I'm trying to print the same array using a print statement with a provided condition. If the number is equals to 40, then the for loop should terminate at that particular instance. Now let us try to execute this program and see how does it work. As you can see, the output has been successfully generated and the values 10, 20 and 30 are printed, but 40 and 50 are not printed because at this particular if statement we have provided a condition that if the number is equals to 40, then the control flow should break. So these were the few examples for conditional statements. Now let us continue with our loops. In Java, we have 3 types of loops. Firstly, the for loop, next is while loop, and finally we have do while loop. The first type of loop is the for loop. The for loop is a conditional flow statement which allows you to execute a specific code segment for a finite number of iterations. For a for loop, we have 3 arguments, namely initialization variable, the condition variable, and the counter variable, which might be either increment or decrement. Now, let us try to execute a program to understand for loop in a better way. Before we execute an example of for loop, let us see the flow diagram of the for loop. Here, we have the initialization step at the first, and later the control flow will enter a conditional statement. If the conditional statement happens to be true, then a particular code segment or a particular set of statements are executed, and after that, the control flow enters into the increment or decrement variable. And the variable will be incremented or decremented according to the condition provided. Once after the increment or decrement process is finished, then the control flow will again enter into the conditional statement and verifies the condition. If the condition is true, then the same loop will be executed. Else, the control will exit from the condition statement. Now, let us try to execute a program to understand this in a better way. This particular example is based on for loop. As you can see, I have a variable by the name arr_data, which is of string type, and this particular variable holds 5 elements which are John, Jerry, Ralph, Jim and Tom, which happen to be the names of the employees of a particular company. Now, we will be using a for loop to display the names of these employees. This happens to be the for loop where we have the initialization variable which is I is equals to 0, and followed by that we have a conditional statement which is I is less than arr_data.length, and finally we have an increment variable which is I++. Now let us try to execute this for loop and see how does it work. As you can see, the loop has been successfully executed and we have our output here. Let us move on to the next example of for loop, which is either called as enhanced for loop or advanced for loop. In this particular for loop, we will be having a conditional statement at the very beginning of the program. The control flow enters the conditional statement and finds if there are any elements present in the array or not. If the statement is true, then the control flow will enter the initialization statement where a variable will be initialized. Once after the initialization is finished, the control flow will directly enter into the condition statement of the program. If there are any elements present in the program and the condition is true, then it will execute the set of statements and initialize the local variable. And once after the local variable is initialized, then the control flow will continue into the same loop again. If there are no elements present in the array, then the control flow will exit the condition and stop. And here, as you can see, if we come back into the initial conditional statement, if there were no elements present in the array, then the condition will become false and the control flow will directly exit the condition and comes to a stop. Now let us try to execute a program to understand this advanced for loop or enhanced for loop in a much better way. As you can see, I have considered the same example of the list of employee names, and here we are using the advanced for loop, which states that the control flow must enter the array and print all the elements present in the array according to their index. Now let us try to execute this program and see how does it work. Once after the control flow will enter into the array, all the elements present in the array are printed until the last index value. As you can see, the program has been successfully executed and the output has been generated. With this, let us try to execute nested for loop. Before executing an example, let us try to understand the flow diagram of the nested for loop. In a nested for loop, the program will begin at start and the control flow will encounter the first loop statement. After that, the control flow will enter into the condition. If the condition is true, then it will enter into the inner for loop. If the condition is false, then the control flow will directly exit the first outer for loop. Now let us see if the condition is true. Once the condition is true, then the control flow will enter into the inner for loop. And inside the inner for loop, it will encounter a condition statement. If the condition is true, then the control flow will start to execute a set of statements which are present inside the inner for loop. And once after the statements are executed, it will enter into the increment or decrement statements. Once after the increment or decrement is done, the control flow will again enter into the condition statement and checks if the condition is true or not. If the condition is true, the same loop will execute again, and if the condition is false, then it will exit the condition statement and it will enter into the increment or decrement variable of the outer for loop. Once after increment or decrement of the outer for loop is done, it will again check the condition in the outer for loop, and if it is false, then it will exit. Now, let us try to execute a program to understand this in a much better way. This particular example is based on nested for loop. As you can see, I have considered an integer type variable which is array, which is going to be a two-dimensional array. And this particular loop is our outer for loop, and this particular loop is our inner for loop. Once after the outer for loop is triggered, it will start the inner for loop. Once after the execution of inner for loop is finished, then the inner for loop will trigger the outer for loop for increment or decrement. Once after the increment or decrement is done, then the condition is verified and the control flow will enter into the inner for loop again. Once after the inner for loop is executed, then it will again trigger the outer for loop and the condition is checked. If the condition is true, the process will continue, else the control flow will exit both the for loops and execute the statements which are present outside the loops. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and the data present in the row 1 and row 2 have been successfully printed here. As you can see, this is the first row, which is row 0, and this is the second row, which is row 1, and the data in the row 0 is 1, 2, and the data in the row 1 is 3 and 4. Now let us learn about while loop. While loop is a control flow statement that executes itself repeatedly until a given Boolean condition is satisfied. While loop can be considered as a repeating if statement. Let us see the flowchart of the while loop to understand this in a much better way. As you can see in this particular example, the control flow will begin at a decision. If the decision is true, then a particular segment of code is executed, and again the control flow will enter into the decision box. If the condition is true, then the loop is repeated, else the condition will exit the decision box. Let us try to execute an example to understand the while loop. This particular example is based on while loop. Here, I'll be providing an input to the integer type variable, which is num. And according to the while condition provided, here we'll find out if the input number is a prime number or not a prime number. For that, we have provided a condition in the while loop which states that if the variable I is less than or equal to the number divided by 2, then it should enter while loop. And inside the while loop, we have again a condition which states that if the number modulus I is equals to 0, then flag will be set to true and the control flow will be broken here and I will be incremented. And outside the while loop, we have an if statement which states if the flag is not true, then we should print it is a prime number, else we should print it is not a prime number. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and it is asking for an input. Now let us try to input a prime number. As you can see, the output is 3 is a prime number. Similarly, now let us understand do while loop. Do while loop is considered to be a conditional statement which is completely similar to the normal while loop. The only difference is that the do while loop has a boolean or a conditional statement present at the end of the loop. This makes the do while loop execute at least for once. To understand this in a better way, let us check out a flow diagram. In this particular example, the control flow will first encounter the statement. So this particular statement will be executed at least for once without checking the condition. Once after the statements are executed, the control flow will enter into the conditional statement. Now the condition is checked. If the condition is true, then the same statements will be executed once more. Once after the statements are executed, then the condition is checked again. If the condition is true, then the same loop will be continued, else the control flow will exit the condition. Now, let us try to execute a program to understand this in a much better way. This particular example is based on do while loop. So in here, I've considered an array into which I'll be entering elements. The process of entering the elements will continue until I provide an input 0. And finally, all the numbers which I have provided into the array will be summed up and the final summation of all the elements present in that particular array will be printed. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and it is asking me to enter the numbers. Let us try to enter a number other than 0. My first number will be 9. And after that, let me enter another number other than 0, which will be 7, followed by that 5. As you can see, it is continuing to accept the numbers which are other than 0. And now let us try to enter 0 and see what happens. As you can see, the loop is been terminated and the summation of all the numbers which were provided into the array are summed up and the summation is provided as 25. So with this, let us execute the next type of loop, which is infinite loop. Before we continue into the infinite loop, let me provide you a simple example to understand while loop and do while loop in a much better way. You must be familiar with the Roadrunner cartoons. As you can see, the Roadrunner here is running on while loop and the coyote, which always tries to hunt the Roadrunner, is trying to execute itself using a do while loop. So here, the condition was checked first and the Roadrunner is safe, and in the case of Coyote, it was using a do while loop and executed itself without checking the condition and it is outside the cliff. So this is the basic difference between the while loop and the do while loop. Now with this, let us enter into the infinite loop. The infinite loop is not actually a practically designed loop. Instead, it is a situation where a condition of the loop fails and the execution persists until you stop it manually. Let us try to execute a program to understand infinite loop in a much better way. So this particular example is based on infinite loop where I have provided a while loop. So here the condition of the while loop is always true and the control flow will enter into the while loop and will print the message Edureka. Let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and it is continuing to print the Edureka message continuously. Now I have to stop this manually and exit the infinite loop. As you can see, the infinite loop has been successfully terminated now.
Object-oriented programming. So guys, this is one of the software design methodologies that how we're gonna write a software solution in the industry, and it's followed widely. So what is this object-oriented programming? It's a methodology or a paradigm using which we can design our software solutions. Now there are two major words which you need to focus on. The first one is object and the second one is class. Now why object comes first and class later? Because of the term itself, object oriented, not class oriented. So we'll discuss on these objects and classes. So guys, object is a real world entity. When I say a real world entity, what does it mean? It means anything which you can see, touch, feel is an object. For example, laptop, mobile phone, chair, table, fan, anything. Even you and me are the objects. So every object will have some state and behavior. What is a class? Class is a blueprint, or I can say it's a drawing of an object. So how an object will look like, how object is going to be represented, that we can do by having this guy called class. So let's say there is a class called dog, which is a representation how a dog will look like. So we will have a representation in two of the ways. The first one is properties and the second one is behavior. Now properties are also referred to as attributes. For example, what is the weight, what is the age, what is the size, color, breed. So these are the properties. I can even say that they are the attributes which are linked to your object. Behavior goes like eat, sleep, run, bark, etc. and etc. So let's say a nose over here is used for having a process called breathing or a respiration. Respiration is a behavior. So we have object with the properties and behavior. So object will have properties, object will have behavior, and these properties and behavior will be written in the class to describe the object. So having object-oriented programming approach, we can have different type of objects. So their properties will remain same, but the value for their properties will change. Now the size, age, color and breed for all the different dog objects, it's gonna change, guys, right? So even when I talk about something like employee to a company, let's say plumber, electrician, carpenter, let's say HR, let's say software engineer. Now the different employees, they have the same details. That's like what is their employee ID, what is their name, what is their age, what is their phone, but the data for these properties will be different. Now same way, the sleep pattern would be different for different people, right? So this is what we are going to understand, that different objects, they will have the properties, same properties, but with the different values, right? So I can say an object is a container which is containing properties and behavior both. Now how we are different from procedural approach, the way we used to write programs in C. So how is it different, right? Let's have some comparisons coming in here. So object-oriented programming is a bottom to up approach. What does this mean? This means you think of an object first and then you start coding. You think of data first. Top-down approach is like where you just start writing the program. We modularize our program into objects, whereas in procedural approach, we need to write functions. For security, we have access modifiers. We got default, private, public, protected, but there we have no access modifiers. Objects can move and communicate with each other through member functions, but whereas in functions we don't have objects, so data is just moving freely. So having access modifiers, our software solution can be designed with much more security, right, as compared to procedural approach. And lastly, we have features like overloading, overriding, inheritance, and many other features which object-oriented programming will give us, so that we can very easily design our softwares, which procedural programming will not do that. Now, there are four major fundamentals when it comes to object-oriented programming structure. Guys, we got encapsulation, abstraction, polymorphism, and inheritance. So these are the four major building blocks of any object-oriented programming language, right? So we even call them the pillars for the OOPs. So we'll discuss them one by one. To begin with, what is inheritance? So guys, inheritance is where the property of an object will be acquired by the other object. We'll have a relationship called is a relationship. So it's a parent-child relationship. So having this relationship, let's say animal is the parent, mammals, reptiles, amphibians, and birds, they are the children. So this is a relationship. Bird, reptile, mammal is an animal, right? So that is how we are relating them. We also call this concept as generalization, because here we are generalizing so many different types as one single type, right? So we call animal as super or the parent class, whereas mammals, reptiles, amphibians, birds, they are known as sub or the child classes. So guys, let us have one example on inheritance, and thereafter let's try to code it. So consider that there is an object structure called product. So product is going to have a product ID, product will have a name, product will have a price. So these are few of the attributes associated with the product, right? Now I'm taking this use case. Let's say we are going to develop an e-commerce solution. For an e-commerce solution, now there will be a product which can be an LED TV. So LED TV will extend the product, right? So what is the benefit of extending LED TV from product? So you'll get all these attributes in the LED TV as well, right? So we just need to write additional parameters. So we will come here and say what is the brand, what can be the technology for LED TV, and any other attributes if you want to have. We can have a mobile which can extend the product. So we can have RAM, what is the OS, what is the SD card size, and many more attributes. So extension is what is called inheritance. So if we don't have extension, so how the things will work, let's see that. With no extension, we need to rewrite a similar code snippet again and again. So you see, PID, name, price, brand, technology is the data associated with LED TV. Same is with the mobile. So PID, name, price, they are the common attributes. So when we know that we have some common attributes or common properties which will be reused again and again, this is like repeating the code again and again. Whereas when we are coming up with this structure here, so we are reusing the similar code again and again. You have product as one guy and you now keep on reusing it again and again. So let's try to come up and write one small program here and understand this example. So I'm going to say a new Java project. So we are using Eclipse as an ID. So you can use IntelliJ, JDeveloper. So whatever you want to use, you can use that. Let's say a new Java project. I'm going to say oops. So in this object-oriented programming structure on the SRC, I'm going to do a right click and say a new class. Now this new class over here, let us name it inheritance app with the main method. So I'm going to write a package. Let's say 𝐶.Edureka. So this package name 𝐶.Edureka contains inheritance app with the main method, right? So we know what is main. Main is executed by JVM, right? when my program will run. Now let's come here and write this class as product. And I'm going to write one constructor here which says CISO product object constructed, and thereafter let's have some attributes. We got product ID, what is the name, and let's say what is the price. So we can even have more attributes, but I got these many details. So I'm going to write methods now. So this is constructor, the default one. So the methods, I'll say void, let's say set product details, where I will say, let's take three inputs, PID, name, and price. So I'm gonna say this dot PID is PID, this dot name is name, and this dot price is price. So we call this guy as a method which is setting the details into the product object. I can even say to write data in product object, we have this method. We also call the methods as behavior, and attributes are also referred to as state. Same way, I'll have show product details, where I will come and say CISO, let's say plus product. Just give me a moment. All right. So I'm gonna say product ID this, and thereafter I'll just have this coming in. Now I will say CISO name a backslash T plus the name. The next way we have price a backslash T and the price. So this is the method which will read the data, right? So to read data from product object. So we call this structure, this class product is textual representation, how an object will look like in the memory, right? You need to understand that this PID name price, they do not belong to the class, they belong to object. So whatever we write in class is in actual property of object as we are describing the object, right? So using class, you are textually describing the object. So PID name price, they do not belong to class. Constructor, the methods, they belong to the object. So if you want something to be property of class, if you want anything which should belong to class, make it static, right? So this is what you need to do. Now coming here, guys, let us create the product object. So create an object. What object? I want product object. Let's say product is a new product. So remember, this statement is an object construction statement, but product is not an object. It's a reference variable which holds the hash code of the object in hexadecimal notation. So what does this mean? This means that if I will say product is plus product, so when you run this code here as Java application, you will get to have a product object constructed, and this guy reference variable is giving you this 7852E922. So we get 7852E922 as a hash code. Now this might vary from system to system, right? So we say product is a reference variable, right? So product is a reference variable, not an object. It is pointing to the object which is created in the memory in the heap. So next is writing data in object. So I will say product dot set the product details. Let's say product ID is 101. Let's say name is iPhone X. Let's say the price is 70,000. So this is the data within the object which we have wrote, and now let's say reading data from object, you will say product dot show the product details. When you run this code here, let me comment out this structure here. And here, after writing the data, I'm just going to put up this CISO statement, data written in product object. So just to show this. So we got product object constructed and then data written in product object, and this is data with respect to your product object. So this is how we get to see data within the object, write and read operations. A very basic structure of an object. Now we can even write the data directly. Coming here, let's write the data directly. So I can say product dot PID. Let me create another object. So I'm gonna say a product. This time let's say this as product 1 is a new product. Or let's say this is a product 2. This guy is product 1. And here I'll say product 2 dot PID is 201. Product 2 dot name is Nike shoes. Product 2 dot price is, let's say, 5,000. So this is writing the data directly. Sorry, my bad. So this is integer. So you'll say product 2 dot show the product details. So just gonna do an empty print line here for the correct output. So what you see is product object constructed. We are not writing the data using any method. We are writing the data directly, and you see the data read operation happening again. So if you don't want the data to be written directly, you can make the attributes go as private. So having your attributes as private, so you are limiting the user not to write the data directly. You see, you are now getting an error here. So I'm not gonna make everything private. Let's say the product ID is private. So when you have any attribute marked as private, you will not do access it. So this is an error now, since attribute marked as private cannot be accessed. You cannot access an attribute which is marked as private. So what we will do now? So we can have an indirect way to access PID. We can create a method which says set the PID. You take integer as input and you say this dot PID is PID. So guys, when I'm using this, so this means reference to the current object. So this means reference to current object. So the left hand side PID belongs to object, right hand side PID belongs to the method set PID. Okay, so LHS belongs to the object and RHS belongs to method. So we can similarly say int get PID, which returns back the PID. So when you say set PID and get PID, what does it mean? So these are the special methods. We call them setters and getters. Setter and getter is required when you have your attribute marked as private. So you have some indirect way of capturing these details in your object. So now I can come here and say product 2 dot set the PID as 201. Now this is going to work for us. So I think the basic product object structure is clear to everyone. Now moving ahead into our use case where we are going to extend the product, right? So let us take one example of mobile and extend the product. Now I'm gonna say a class called mobile where it extends product. So this is known as a relation where we say mobile is a product and here mobile is child and product is parent. So what I'll do is I'll create a mobile constructor and say a CISO mobile object constructed, right? So this is how we are going to deal with the object. Now let us comment out this code snippet in the main. So instead of having the direct product object, I'm going to write a mobile object now. So I'll say a mobile is a new mobile. Now, whenever I am requesting for the mobile object, right? So we are requesting to get mobile object constructed. So this is what we are doing here. Now, when you write this instruction, what you see is before your mobile object is constructed, product object is getting constructed. So it's like parent object is constructed before the object of child, right? So what is the behavior here? So product object gets constructed before the mobile object. So as a rule of inheritance, it is like firstly you get the parent object constructed and then the mobile object constructed. So guys, I hope this is clear, right? So what is happening here? We have parent object constructed before the mobile object, as this becomes the rule to inheritance. And we say this is object to object. Now you will be glad to see that everything, whatever product had, will be acquired in mobile, right? So we can come here and we can say mobile dot set the product details. Mention the PID, let's say 301. Mention the name, let's say iPhone X. Mention the price, let's say 70,000. And then you say mobile dot show the product details. When you run this code, you get to see that product object constructed, mobile object constructed, data written in the product object, and you see the details flowing for you. So guys, I hope this is clear, right? So whatever you had in the parent, you got in the child, right? So we have the things coming up for the child, and we can very easily access those things. Now, this product over here, we can have something like, let's say, string. What is the OS? Int. What is the RAM? And int. What is the size of SD card, right? So let's say SD card size. Now, these are additional attributes of mobile other than the product. So these are the additional attributes. Now what I'm gonna do is I'm going to have this guy over here called set product details. Let's do a copy here and let's try to do a paste here. Now I'm going to say string OS, int RAM, and int SD card size. So here I'll say this dot OS is OS, this dot RAM is RAM, and lastly this dot SD card size is SD card size. You see, PID is not accessible. We are getting an error here. It says it's not visible because it's marked as private. So private is not inherited and visible into the child. All right. I'm gonna make this PID as default. So we'll talk about the access modifiers later, but we are focused on understanding the oops here. Now we actually have this same method name set product details, right? So we have redefined the same method from the parent into the child with different inputs. So we got two methods in the child. So we have now two methods in the child, one from parent and one of child, right? So both are different, as in based on inputs, right? Even though name is same, they are different based on the inputs. So whatsoever belongs to the parent, that is inherited into the child, and now in the child we have the same method coming up again. Why we did this? Because we wanted to set the data for the additional attributes. So this is known as method overloading. Same method name with different inputs. So what I can do now is, why to access the parents method here, I can have my own method mobile dot set the product details with the PID, let's say 301, name, let's say iPhone X, price, let's say 70,000, OS, let's say iOS, RAM, let's say 4, SD card size, let's say 128. And thereafter I'm gonna say mobile dot show the product details. Now when you run this code, guys, what we see is it says data written in product object. So what I can do is I can just manipulate this and I can say data written in mobile object. When you run this code, you see data written in the mobile object, but whatever you are reading is the one which was inherited from the parent. So this read method show product details is inherited from the parent and that is being used here. So hence we cannot see more than 3 details. I'll redefine this method as well. So let's redefine show product details as well. But here we have same inputs, two methods, one from parent, one in child, and we have same signatures. When I say same signatures, it means they have same input details. So what I'll do is I'll extend the data here. So we'll have OS, we'll have RAM, and we'll have SD card. So we'll have this OS, RAM, and SD card size. Now what you will observe is that when the show product details will be executed, so we got two show product details method, one in the parent, one in the child. So child method will be executed and not the parent method. So this fundamental over here is referred to as overriding. Very, very beautiful concept, guys. So overriding versus overloading. Method overloading, whereas this is method overriding. So same method name with same inputs in parent-child relationship. So only in a parent-child relationship. Now when you run this code here, what you see is the other details also coming in. Now we know the reason that why we need to overload a method, why we need to override a method. We need to overload a method so that we can write the exact data which we want. So we are customizing this method in the child. We are overriding the method so that we can display more data. So we are customizing the methods in the child, right? So overloading and overriding is what where we are having customizations to predefined methods. We don't want these predefined methods. We want the way we want to present the data and we have it in front of us. So this is a very quick introduction to object-oriented programming structure, guys. So now let us come here and understand the next part. So inheritance is where one object will acquire the properties of other object. It is a relationship, the parent-child relationship. So syntactically, you need to come up and say extends. So which is extension, right? What are the advantages? Code reusability. So we are reusing the code, having an extensibility. We are using overriding. We are even having the features to hide the data. If you privatize any attribute, you won't be able to inherit it. So we got different types of inheritance. So you got single level, multi-level, and hierarchical, where single level is one parent, one child, multi-level is parent to child to grandchild, and hierarchy is having one parent with more than one children. Multiple inheritance, that's opposite of hierarchy, is not supported in Java. So there is no virtual keyword, there is no pointer technique in Java by which we can solve the problems like dreaded diamond here. So in single level inheritance, we got one parent and we got one child. So arrow is upwards because B is an A, right? So it's extension relationship. Then we have multi-level, parent to child, child to grandchild. And thereafter, guys, we got hierarchy where one parent with the multiple children. So remember, we don't have support for multiple inheritance in Java. That's like the reverse of this hierarchy. Multiple parents having the same object. Next is polymorphism. So guys, it is having the same name with the different definitions. So you can say mothers, they are the best example of polymorphism. They handle kids, they handle office, they handle home. More than one form, right? So here polymorphism can happen in two different ways, compile time and runtime. So what is compile time versus runtime? So compile time means overloading. We call it static polymorphism. So compiler will ensure which method will be executed for which function call. So there are some rules to overload. The method name should be same and the argument list or the inputs to the method, that should be different and unique. So the other form is runtime polymorphism. That's like dynamic polymorphism where we got method overriding. All right. So overriding, we got some rules coming in here. So the rules to override is where the method name should be same, input should be same, return type is something which must be same or the subtype of the overridden method. And access level, it must be same or more restrictive. Now, what is abstraction, guys? So abstraction is achieved using abstract classes and interfaces. So this is where we achieve a runtime polymorphism in a different approach, right? So here we have an abstract class. So an abstract class is created using an abstract keyword. So here we will have the methods with the abstract keyword. We even have non-abstract methods. This is a class for which you cannot create objects. You can have constructors, you can have static methods, but we cannot create the object, right? So you can even have the final methods. So abstract class acts as a template for the various methods and definitions to be executed. So moving ahead, so the better version of abstract class is an interface. So interface is a blueprint for a class which will contain some constants and abstract methods. So it will enable multiple inheritance and helps in achieving the loose coupling. So a class can extend a class implements an interface. Now this is one of the major differences between classes and interfaces. So we got interface to interface inheritance as well. So guys, abstract class and interfaces, so as in practically we'll see it in our other sessions. So lastly, what is encapsulation? Where we are going to privatize the data. So we can have an attribute, we can mark it as private, and when the attribute is marked as private, it cannot be accessed. So we need setters and getters so as to access this private data. So encapsulation leads to data hiding. So it is focusing on security.
What are abstract classes in Java? Abstract class in Java act as a boundary between the implementation method and its functionality. It is used to exchange the functionality between the concrete class members and the abstract class. Abstract classes are considered as those classes that hide the method implementation details from the user and show only the method functionality. They are declared using the keyword abstract, and these methods can include abstract as well as non-abstract methods in them. With this, let us continue with the next topic, which is why do we need an abstract class in Java? We need abstract classes in Java for the following reasons. Firstly, default functionality. Abstract classes are designed to provide default functionality of the defined method for all the subclasses. Next, template. Abstract classes provide a template for future specific classes. Next, code reusability. Abstract classes allow code reusability. Followed by that, we have separate method definition. Abstract classes separate the method definition from the inherited subclasses. Next, we have loose coupling. Abstract classes help the users to achieve loose coupling between the class members and class methods. Last but not the least, which is dynamic method resolution. Abstract classes support dynamic method resolution in runtime. With this, let us jump into our next topic, which is rules for using abstract classes in Java. To use the abstract classes in Java, we are supposed to follow the rules defined as below. Firstly, in any project or a program, always remember that the abstract class cannot be instantiated. The next one is an abstract class can also accommodate final methods. Next, an abstract class must always be declared using the abstract keyword. Followed by that, an abstract class can have both abstract as well as non-abstract methods. Finally, it can have constructors as well as static methods. So these are the rules required to use abstract classes in Java. With this, let us now understand the ways to achieve abstraction in Java. Abstraction is one of the object-oriented programming practices. To achieve abstraction in Java, we have two methods. First, using an abstract class, and the next method using an interface. Now, let us understand the syntax for using abstract classes in Java. For defining abstract classes and abstract methods in Java, we have the following syntax. Firstly, let us understand the syntax to declare an abstract class in Java. For example, here I am declaring a class by the name Edureka and I am using abstract keyword here. Now, similarly, let us understand how to declare a method using the syntax. The syntax for declaring a method is almost similar to the syntax of declaring a class. The only change is that the use of parenthesis and a semicolon. With this, let us try to execute some practical examples of abstract classes in Java to understand the terminology in a much better way. The first example would be student information. After this, we shall execute two more examples. The examples will be same, but implementation will be different. First, we'll use an interface to execute the same program. Followed by that, we'll execute the same program using an abstract class. This is done to understand the difference between an abstract class and an interface. Now, let us execute our first example. As you can see, this particular example is based on abstract classes. You can see that I have used the abstract keyword to declare this particular class, which is person. This person class includes private data members, which are name and gender. Similarly, I have also included another method, which is an abstract method, and I have declared that method using the abstract keyword, and inside the abstract method, I have to return some data related to the person class. Now, let us move on to the next class, which is the student class. This particular student class is a normal class, and this student class is extending the abstract class, which is person. Inside the student class, we have some information related to the student, which are student name, student gender, and student ID. Here we will be extending the abstract class, which is person, into the student class, and from there we'll be extending the details of name and gender. Now let us try to execute this program to understand this in a much better way. As you can see, the program has been successfully executed and the data is also been displayed here. According to the output, the names of the students are Priya, Karan, Kumari and John, and their respective genders are also being displayed here. Now, let us try to execute an example based on interface. The program that we decided to execute based on both interface as well as abstract class is to find out the area of two shapes, which are rectangle and circle. Now, let us try to execute this program and see how does it work. Firstly, we shall implement interface. As you can see in this particular example, I am using interface, and inside the interface, I have described two methods, which are draw and area. Here, we have provided input to both the methods, which are draw and area, for both the shapes, which is circle and rectangle. Now, let us try to execute this program and see the output. As you can see, according to the data provided to both circle and rectangle, here are the outputs of their area. Now let us execute the same program using an abstract class. As you can see, this particular class is the abstract class, which is shape, and inside the shape we have two methods, which are the area of the shape and draw function. Followed by that, we have the class rectangle, which extends the abstract class, which is shape. And inside the rectangle class, we are implementing draw method as well as area method. Similarly, followed by the rectangle class, we have circle class, which extends shape abstract class. And inside the circle class, we also have draw method and area method. Finally, we have the class Edureka, where we'll be providing the data for rectangle class as well as circle class. Now let us try to execute this program and see how does it work. As you can see, the program is successfully executed and the area of rectangle and circle are generated. You can see that the area of rectangle is 600, followed by that the area of circle is 628. With this, let us move on to our next topic, which is the difference between an abstract class and interface. The first difference between abstract class and interface is abstract class can include abstract as well as non-abstract methods, while interface can have only abstract methods. The next difference is abstract class includes non-final variables. On the other hand, interface can include only final variables. Followed by that, abstract class can include static, non-static, final and non-final variables. Compared to abstract classes, interfaces can include only static and final variables. The next difference is abstract class can implement an interface, while interface cannot implement an abstract class. Now we shall discuss how to implement abstract classes as well as interface. To implement an abstract class, we use the keyword extends, and to implement an interface, we use the keyword implements. The next difference is abstract classes can extend Java classes and interfaces, while interface can extend only an interface. The last difference is that members can be private as well as protected in an abstract class, while in an interface, members are declared as public by default.
Exception is a problem that arises during the execution of a program. It can occur for many different reasons. Say a user has entered an invalid data, or a file that needs to be opened cannot be found, or you can also say that a network connection that has been lost in the middle of communications, or the JVM has run out of memory, many such cases. But if we do not handle them, it leads to a system failure. So handling an exception is very important. And that's where Java introduced exception handling mechanism to handle the runtime errors so that the normal execution flow will not be disrupted. For example, class not found, IO exception, SQL exception, etc. Now let's move ahead and see the difference between error and exception. First, errors are impossible to recover, but exception can be recovered by handling them. Next, errors are of type unchecked, but exceptions can be either checked or unchecked type. Just wait a little while and you will know what are checked and unchecked type of exceptions. And errors are something that happen at runtime, but exception can happen either at compile time or runtime. Exceptions are caused by application itself, whereas errors are caused by the environment on which the application is running. So these are the key points of difference between errors and exceptions. Now let's see what is exception hierarchy. All exceptions and errors types are subclasses of class throwable, which is the base class of hierarchy. Here, one branch is headed by exception. That is, this class is used for exceptional conditions that user program should catch. For example, say null pointer exception, runtime exception, etc. And other branch error are used by the Java runtime system to indicate the errors that has to do with the runtime environment itself, that is JRE. For example, virtual machine error or stack overflow error, etc. So how Java virtual machine handles exceptions? Whenever inside a method, if an exception has occurred, then the method creates an object known as exception object and hands it off to the runtime system. And this exception object contains name and description of the exception and also the current state of the program where exception has occurred. And creating the exception object and handling it to the runtime system is called throwing an exception. Then, using try, catch, finally methods, these exceptions can be handled. So this is how Java Virtual Machine handles exceptions internally. Next, let's see the differences between checked and unchecked exceptions. In simple terms, exceptions that happen at compile time are checked exceptions like IO exceptions, etc. And runtime exceptions are called unchecked exceptions like divide by zero, array out of bound, null pointer exception, etc. Basically, unchecked exceptions are built-in exceptions in Java.
So checked exceptions cannot be simply ignored. The programmer should handle these exceptions. And runtime exceptions are ignored at the time of compilation. Now, let's see the basic example of exception. So here, I have defined the class, and inside the main method, I have a try block. So in this try block, the code that we are going to write may raise an exception. That is, it contains the code that raises exception. And then the raised exception will be handled in the catch block. So let's see a small program as how it occurs. First, I will create a new package called exception, Edureka. And now I'll create a new class called sample exception. Finish. So inside the class, the first thing that we are going to do is we are going to write the main method. So here I will create a string str and make it as null. So now after this, I will try to retrieve the length of the string. So when I execute this program, it will throw an exception. Why? Because the string is null and we are trying to retrieve the length of the string. As I said, it throws null pointer exception because the string is null. It does not contain any values. So now let's use try and catch method to handle this exception. So what I'm going to do here, in try block, I'm going to write the code that will raise an exception. Say I have given a as 30 and b as 0. Now I will try to divide a number by 0. Like int c is equal to a by b. So just tell me what happens here. Now say if we try to divide a number by 0, then it says we cannot divide the number by 0 because it raises an arithmetic exception. Correct? So let's see how that occurs. Now, as it throws an exception here, so what I'll do to maintain the normal flow of execution, I will write the catch block to handle this exception. That is, okay, let's run the program and see the output. So as I told, the exception has been catched by catch block. So here first it will throw the exception and then it goes to the catch block. Catch block handles the arithmetic exception E. So it prints cannot divide a number by 0. So this is how exception handling works. Now let's see the various types of exceptions. So in Java, there are two types of exceptions. One, built-in exceptions, and the other one, user-defined exceptions. First, let's see what is built-in exceptions. These are the exceptions which are available in Java libraries, and they are suitable to explain certain error situations, like arithmetic exception, array index out of bound exception, class not found, IO exception, runtime exception, number format, etc. So let's see an example and understand how built-in exception works. So this example is one type of exception, that is arithmetic exception, where we try to divide the number by 0 and it results in arithmetic exception and we have catch the method. So let's see one more example of that kind now. I'll use one more try block. Here what I'm going to do is I'm going to declare an integer number and try to parse a string variable. So what happens? It's an obvious fact that it throws an exception. So let's see how. So just tell me one thing. I have declared an integer number and trying to parse a string variable. So what happens? It obviously throws an exception. Now, in order to maintain the normal flow, we have to handle this exception. So I'll use a catch block and handle the number format exception. So now let's execute and see. First it said cannot divide by 0 because we handled arithmetic exception. And next we handle number format exception. Next we will see how array index out of bound exception occurs and how it can be handled. So here you can see I have created an array of size 5. And now I'll try to access the 7th element in the array. So what happens after this? It will obviously throw an exception. Why? Because the size of the array is 5 and I'm trying to access the array that is out of bound. So what happens when I catch the exception? It says array index out of bound exception. Sorry, it is array index out of bounds. Now again, let's execute. As I said, again the array index out of bounds exception got handled and it printed the output. So this is how built-in exceptions are present in Java libraries. So now I will jump into the methods of exceptions because you need to know the throw and throws methods to understand user-defined exceptions. After I complete the methods of exceptions, I will explain you the user-defined exceptions. So these are the various methods of exceptions, that is try, catch, finally, throw and throws. Let's see each of them. First, try. Try block is used to enclose the code that may throw exception. The syntax is as follows. As you have already seen, it's very simple. We write a code that throws exception and we can handle it using the catch block. Next, nested try. Nested try block is nothing but a try within a try block. For example, you can see here I have declared one try and inside that I have created one more try catch and there is one more try as well. So let's see a small example as how it works. So I'll do one thing here. I'll give a try block within a try block and then after catch I will end the statement and after that I will print like system.out.println. Let's print some other statement. Just look at the program. First, what I did. So from here I have modified the program. I have given one try block and inside one try block I have given one more try and catch block. Okay. And now I have created one more try catch and handled here. After that what I'm doing, I'm just giving a statement as print other statement. After that I'm closing this try block. Then I'm again catching the exception and handling that. Okay. So within this one try block, there are two try blocks. So that's how nested try can be used. So let's see the output. See, first it's saying that cannot divide by 0 because it was the first thing that we have done. And within the try block, it said number format exception because the first try block got executed. And next, for this one more exception that it threw, it said it handled. And again, it's printed other statement. That's all. Because we are not declaring anything in the other try block, that is the main try block. So it is not printing that exception. If this try block has thrown any exception, again that would have been printed. But as there is nothing, it's not printing. So this is a usage of nested try and how it can be declared, and this is how it works. Now, let's see the usage of catch block. As in these previous examples, you have already seen how it can be used. And there's also one more thing, that is multi-catch. That is, if you have to perform various tasks at the occurrence of various exceptions, then you can use Java multi-catch block. So here you can see you have one try block and you have multiple catch blocks. So let's see how that works. I'll modify this program only for you. So here I have one try block and I have two different catch blocks. Let's execute and see. So first it printed number format exception and then it printed other statement. Why this exception did not get handled? Because there was no any exception that was being thrown for this. Okay. If there was any exception that was thrown, then it would have been handled. So this is how you can use multiple catch blocks. Next, we'll see finally. Finally is a block that is used to execute important code such as closing connection, stream, etc. No matter whether exception is handled or not, finally block will always be executed. So in the previous example, you saw that after declaring a try block, you must use catch block to maintain the normal flow. But on using finally block, the catch block is not required. Let's see how. I'll do one thing. I'll remove all the catch blocks here. So I just have a try block. Now I'll give finally and print the statement. Okay. So now let's execute this. As I said, we have not used catch block. It throws the exception. But even on throwing the exception, the flow will not be disrupted there because we have used finally block to execute the code. So you can see the finally block is always executed. So that's how it works. Next, let's see what is throw. throw is nothing but a keyword which is used to throw an exception. So you can see the syntax here. Inside a method, you are throwing an exception. Let's see how it throws an exception. Let's modify this program. First, I'll define the function here. So inside the throw block, I'm going to throw an arithmetic exception. Okay. Now, let's handle the exception using catch block. I'll close this average function and call this function in the main method. So first, I throw the exception in try block and catched it. And now I'm calling the entire function in the main method. So let's see what will be the output. It's just telling the exception is being caught. Correct? Why? Because when we call the average function in the main method, it goes back to the loop. The exception will be thrown, but it has been catched. Correct? So this is how throw is used to throw an exception, and it can be handled in the catch block. Simple? Let's see what is throws. Throws is also a keyword which is used to declare the exceptions. It does not throw any exception, but it specifies that there may occur any exception in the method, and it is always used with the method signature. Let's see how. Again, I'll modify this program itself. As I have told, it is used with method signature. I'm going to use the throws keyword along with the method. And I'm also using a throw keyword to throw the arithmetic exception. Now, inside the main method, I'll use a try block. So this is an example wherein I'm using the throw keywords along with the method signature. And inside this, I'm throwing a new exception. But when I'm calling the method or a function inside the try block in main method, it will throw an exception. So instead of handling it, I'm just printing the finally block. So let's see what happens. So you can see here first the inside average function is printed, and then it says that there is an exception in the main method. That is, we are throwing an exception. As we are not handling that, at the end it's printing the finally block. Simple? So this is how throws is used. Next, let's see the difference between throw and throws. First, throw is explicitly used to throw an exception, but throws is used to declare an exception. We have already seen how it worked. Next, checked exceptions cannot be propagated using only throw, but checked exceptions can be propagated using throws. Throw is followed by an instance and throws is followed by a class. And throw is always used within a method, and throws is used with the method signature. And throw can throw only one exception and not multiple exceptions, and throws can declare multiple exceptions. Just now we saw how it worked. Next, we'll see the difference between final, finally, and finalize. So final is a keyword, finally is a block as we saw, and finalize is a method. Final is used to apply restrictions on class, methods, and variables. But finally is used to place an important code, and finalize is used to perform cleanup processing just before the object is garbage collected. Coming to final, the final class cannot be inherited, and the final method cannot be overridden, and the final variable cannot be changed. Coming to finally, it will be executed whether the exception is handled or not. We already saw how it worked. Now, let's see a user-defined exception. Sometimes the built-in exceptions in Java are not able to describe a certain situation. In such cases, a user can also create exceptions, and that are called as user-defined exceptions. There are two important points. First one, a user-defined exception must extend the exception class. The second one, the exception is thrown using a throw keyword. So let's see how it works. I'll modify the same program. First, inside the try block, I'll throw an exception using throw keyword. I will handle the exception using catch block. I'll close the class. Now, I will extend the exception using extends class. So let's parse some argument here and let's try to print the output. So let's parse some argument as we have thrown a new exception, and when I'm extending my exception, then what happens? Let's see. I have saved the program and I'm giving the value of A to B. Okay. Now let's see what will be the output. As expected, it should print the value as 5. Let's see whether it prints the same prescribed value or not. Exactly. We got the output as desired. That is, the throw keyword is used to create a new exception and throw it to the catch block. And then it got handled, and when extending that, we will get the same desired output. So this is how you can create a user-defined exception. Now coming to the end of the discussion, let's see what are custom exceptions and how to parse an exception. I'll modify the same program again. So in this case, if the number that we entered is more than 100, then it should throw an exception. Else, it should print the provided input is valid. Let's see how. After that, I'm reading a number here and then trying to validate the input in try block. If the input is not validated, then it will be handled in the catch block. Again, this is a user-defined exception, so it must extend the exception class. So this is how I have created custom exception. So let's run the program and check what will be the output. So it's asking to enter the number that is less than 100. So I'll enter 99. Says valid input. Again, I'll run the program. Now I'll enter 101. It says input is greater than 100 and it caught the exception. That is, I have mentioned here, if the number is greater than 100, then it should throw an exception. And that exception is caught in the catch block. So this is how custom exception can be used in Java. Now let's also see how to parse an exception. In this case, we are going to parse a simple date format. So for that, I need a java.simpleDateFormat package. I'll import that now. I'll make the class as public and let's write the code. For the simple date format, I'm going to create a reference called SDF. So I'm going to parse the input date that we enter. So this is very simple. I'll tell you how. If we enter the date in this format, then it should print as valid input, or else it should throw an exception. Let's see how to do that. So in the try block, first I have read the input date and then output date and have created a reference for them. And if there is any error in case of changing the date format or while converting the date formats, then that exception will be handled in the catch block. And next, in the main method, I have used a scanner class to read the format. So let's run the program and check the output. So first, let's enter the date format which is invalid. So I'll give something. So it's telling that some error has occurred while converting the date formats. So it's telling exception is here. That is when we're trying to parse the exception. And the unparsable date will be so and so. Now let's execute it one more time and enter the proper date format. That is 01011996. So it's telling after changing the date format, it will be this. That is the one which I have given in this format. From the input date format, which is in day, month and year, it changed the output date format by parsing the input date to year, month and day. Correct? So this is how we can parse the exception.
Why do we need inheritance? To understand this, let us consider a simple example of two different watches. First one is a classic dial watch and the next one is a modern digital watch. The functionalities defined for a dial watch are display date, display day, and display time. Similarly, let us get into the advanced version of the watch, which would be our digital watch. The functionalities required for the digital watch are as follows: display day, display date, display time, light, set alarm, and set timer. As you can see, three functions from the dial watch are repeating here. In real time, this would be considered as code redundancy. You might avoid by removing the extra code from the digital watch, but it results the digital watch will be missing the three functionalities, which are display time, display date, and display day. You might try to keep them in the digital watch and try to remove those from the dial watch. But again, in the real-time scenario, you will lose the existence of dial watch. The only solution for this problem is by applying inheritance to both the classes, where the dial watch will act as a parent class and digital watch will act as a child class. The child class will inherit all the methods and properties of the parent class and successfully reduces the code redundancy, improves the readability, and the functionality of the code to an exponential level. Now that you have theoretically understood what the term inheritance means, let us now get into Java inheritance and understand it through an example. Like any other programming languages, Java inheritance is also known as a procedure where the child class inherits all the methods and properties of the parent class. As you can see, the tablet here is inheriting the properties both from laptop and a mobile phone. This was a pictorial example. Let us see a practical example through a code. In this particular example, we have two classes. The first one is teacher, which acts as a parent class. Inside the teacher class, we have two strings, teacher and Edureka. Along with that, we also have a print statement which has teaching message inside it. Now, let us get into our child class. Hadoop teacher happens to be our child class, and in our child class, we have a string called as Spark. Now, we will be performing a print operation which has to access the college name, designation, and the main subject. As you can see, we have the main subject inside our child class and college name and designation of the lecturer in our parent class. Now, we'll try to inherit the parent class through the keyword extends. And this is the name of our parent class, which is teacher. Now let us try to run this program and see the output. As you can see, we have successfully inherited both the messages from the parent class, which is Edureka, which happens to be the college name, and the designation, which happens to be the teacher, and the main subject, which is Spark. This is been displayed from the child class, and the message from the parent class, which is teaching. Now that you have understood Java inheritance in a practical way, let us now get into the types of inheritances supported by Java. Java basically supports four types of inheritance, namely single inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. Let us discuss each one of them in detail. Firstly, single inheritance. Single inheritance is a procedure where one child class inherits the methods and properties of one parent class. In simpler words, the whole system consists of only two classes, one parent and one child. Let us understand this through an example. Here, we shall consider two classes. One class will be person and the other class will be employee, where the person class acts as a parent class and employee class acts as a child class. Let us execute this program practically. You can see here that this happens to be a parent class, which is person, which has two different functions. The first function is set age and the second function is set name. Now let us move on to our child class. Inside our child class, we have one method which happens to be set employee ID. The methods set name and set age, which are in the parent class, are required in the child class as well. So let us try to inherit those into this child class. So this is the code for inheriting the properties of the parent class into the child class, where I'll be inheriting the properties of getName and getAge into my child class to display the data of a particular employee in an organization. Now let us try to execute this program and see how does it work. As you can see, the properties of getName are inherited, and I have successfully named my employee as Raghuveer, and I have set the age of Raghuveer as 23, and accordingly his employee ID is EMP1101. So this was single inheritance. Now let us move into the second one, which happens to be the multi-level inheritance. Multi-level inheritance is a process where multiple child classes inherit the properties from their preceding parent classes. To understand this in a better way, let us consider a simple example. As you can see in the picture, class A is the parent class and class B and class C happens to be the child class. Here, child class C is inheriting the properties from its preceding parent, which happens to be class B, and class B is inheriting the properties and methods from the superior class, which happens to be class A. This was a pictorial representation. Now let us see a practical example through a code. As you can see, this is our program and calculator is our parent class, similar to class A in our picture, which performs basic mathematical operations such as multiplication, subtraction, addition, and division. Now, let us move into our class B, which would be the class Advanced. Advanced class can perform a little advanced operations such as modulus of a number, square root of a number, and square of a given number. And now let us move on to our child class C, which happens to be the area. So this class can perform a little advanced calculations such as finding an area of a geometric figure such as square, rectangle, and circle. Now we need a calculator which could perform all these operations in one single class. For this, the only solution would be multi-level inheritance, where we will be inheriting all the methods and properties of superior parent class into the succeeding child classes. Now, we have tried to inherit all the properties and methods of the preceding parent classes into the last child class. Let us try to execute this program and see the output. As you can see, the values are already passed to all the functions. Now, their respective outputs have been successfully displayed. So, this was multi-level inheritance. Now, let us move on to the next one, which happens to be the hierarchical inheritance. Hierarchical inheritance is a procedure where we will be having multiple child classes and all the child classes will be inheriting the properties from the major parent class. Here, let us assume an example of a restaurant. We shall have 4 different restaurants here. The first one would be a parent restaurant and the other 3 will be Chinese restaurant, Italian restaurant, and Mexican restaurant. The parent restaurant will be having various types of ingredients which the child classes might need in their dishes as well. Let us see this practically to understand this in a better way. So this would be our parent restaurant, which will be having the ingredients like bread, vegetable stew, and cheese. Now let us get into the first child class, which happens to be the Chinese restaurant. The Chinese restaurant already has noodles and momos. To cook their special dishes, they might need vegetable stew and cheese. Similarly, let us get into Mexican. Inside Mexican, they already have nachos and sweet potato for their special dish. They might need cheese and vegetable stew or even bread for making some better dishes. Similarly, let us get into Italian, which have pasta and sausage available. So, to prepare their special dishes related to sausage, they might require bread, and to prepare their special dishes related to pasta, they might require cheese and vegetable stew. So, how does all these 3 restaurants get their ingredients from? Simple. They apply hierarchical inheritance and inherit all the properties from the parent class and cook their special dishes. Now, let us run this program and see how does it work. As you can see, all the child classes have successfully inherited their parent and the data is also being displayed. The first one is the Italian restaurant. So, they have requested for bread, vegetable stew, and cheese from the parent class, and they say that they already have pasta and sausage available with them. Now, the second one happens to be the Chinese restaurant, and they say that they have requested for bread and vegetable stew from the parent class along with cheese, and they have noodles and momos already available with them. Similarly, the final child class happens to be the Mexican restaurant, and they say that they have also requested for bread, vegetable stew, and cheese from the parent restaurant, and they already have nachos and sweet potato available with them. So, this was an example for hierarchical inheritance. Now, let us move on to the next one, which happens to be the hybrid inheritance. As simple as the name suggests, hybrid inheritance can be a combination of any other inheritances. As you can see in the picture displayed here, you can see multi-level inheritance here and hierarchical inheritance. So these are the 2 combinations of 2 inheritances possible in Java. The overall inheritance pattern can be called as a hybrid inheritance. Now you might be wondering about another possibility in inheritance, which might be obviously the multiple inheritance. Here, one single child class can inherit all the methods and properties from 2 or more different parent classes. But sadly, in Java, this results in a diamond problem and could not support multiple inheritance. It is possible to achieve this behavior through Java interface. With this, we shall move to our next topic, which is is-a and has-a relation. Is-a relation basically deals with inheritance and interface. Any child class which inherits or implements a parent class is said to be in a is-a relation. Coming into has-a relation, it uses instance variables to reference the objects of the parent class. This might be a little confusing. Let us understand it practically. As you can see, the BMW car is a vehicle which is inheriting the properties of a vehicle. So it happens to be in a is a relationship with vehicle. And coming into has a relation, it has an engine. So the BMW car is referencing to an object of engine class and said to be having an has a relationship with engine class. Let us execute a program and see this practically. As you can see, my child class is BMW and it is extending to the parent class, which is car, and also extending to another parent class, which is Java. So BMW class is in an is a relationship with car and in an has a relationship with engine class. Now let us execute this program and see how does it work. As you can see, the class BMW has successfully inherited both the classes, which are car and engine, and the properties which it inherited from car class is the color, which is blue, and the speed from the engine, which is 256. With this, let us get into our last topic, which is method overloading and method overriding. Method overloading is defined as a procedure of having two or more methods with the same name within a single class, provided the argument list must be different. Method overloading is divided into three types. The first type would be having different number of parameters, and the second one will be having different types of data type, and the third one will be the variation in the sequence of the parameters with different data types. Let us see each one of them practically. This particular example is the first type of method overloading. Here in our parent class, you can see we have two functions on the name of display. So the first display method has one parameter, which is a character type, and in the second display method, we have two parameters, one is of a character type and the other one of an integer type. So from the child class, I am inheriting these both methods, and one of the object has one single parameter, which happens to be the character type, and the second object has two different parameters. One of it is a character type and the other one is an integer type. Let us execute this program and see how does it work. Here you can see the output. The first one is calling the first display method with one single parameter, and the second one is calling the second display method, which has two parameters. Now let us see the second type of overloading. In here, we have two display methods in our parent class. One of the method has character type of data type and the other one is having integer type of data type. In our child class, I am passing character type of data to the first display method and integer type of data to the second display method. Now let us try to execute this program and see how does it work. As you can see, the data has been successfully displayed. The first one is calling the method display with character type, and the second one is calling the method with integer data type. Now let us see the third type of method overloading. In here, we are having the same two display methods in the parent class. One of them is having the character data type in the first position and integer data type in the second position, and vice versa in the second display method. Now similarly, through my child class, I'm passing two different parameters. The first object will be passing character data type in the first position and integer in the second one, and the second object in the vice versa. Now let us execute this program and see how does it work. As you can see, the message from the first display method is being executed here, which shows that the first object is referring to the first display method and the second object to the second display method. Now let us take a step further and understand type promotion as well. In one of my display methods, I have provided character and double attributes, whereas float and character attributes in the object. The interpreter will implicitly promote the data type of the object from float to double. This type of promotion is valid since there was no other display function with matching attributes. Now let us try to execute this program. As you can see, the object has selected the first display method and upgraded the float to double. The message from the first display method is being displayed here, which happens to be function 1. Now let us try an example where we shall have a display function with matching attributes and verify if the promotion is accepted or not. As you can see, the object display is passing two data types, which is an integer one and float one. And here we have the first display function with float and integer data types. Let us try to execute this program. As you can see, we have the output. Now in this scenario, there is no type promotion since there is already the data type which is available and the parameters are matching. With this, we shall get into method overriding. Method overriding is a process where both the child and parent classes have the same methods. There are also some rules for method overriding which say the argument list of the child class should match the parent class. The second one is access modifier of the class should be less restrictive than the parent class. And the third one is local parameters cannot be overridden. Local parameters in the sense the parameters with access modifiers as private, static, and similar ones. Let us see each one of these rules practically. So let us execute our first example. Here we have defined two objects which are pointing to the display methods. The first object implements the display method from the parent class, whereas the second object implements the display method from the child class. This happens in the runtime. Hence, this process is called as runtime polymorphism. Let us execute this program and see how does it work. As you can see, the display methods are being implemented and the data present in the methods are also displayed. Now, let us discuss about some key points of method overriding. First one, the argument list of the child class should always match the argument list of the parent class. Second one, the access modifiers of the child class should be less restrictive when compared to the parent class. Let us see this practically. As you can see, in my example, the child class has an access modifier as public and the parent class is having an access modifier as protected. This program will be executed without any errors. Let us try to execute this. As you can see, the data has been also displayed, which says the child class method is been executed. Now let us try to change the access modifiers. Now the only change what I have done is, I have changed the access modifier of the parent class to public and the access modifier of the child class to protected. As you can see, the Eclipse editor is throwing an error which says that the child class cannot have an access modifier which is highly restricted than the parent class. Now, let us discuss our last topic which happens to be about the super keyword in method overriding. The keyword super can be used in the child class to call the method defined in the parent class with its name. The super method is used to invoke the constructor defined in the parent class. Let us see this practically. Using super keyword, I am calling a method by name myMethod from the parent class. Now let us try to execute this program and see if it can successfully call the method or not. As you can see, it has successfully called the method from the parent class and the data is also been displayed. What is polymorphism? To understand this phenomena, let's take an example of a chameleon. I hope you all know what exactly is a chameleon. In the real world, you might have seen this creature changing its color based on its requirement to hide itself from the predators. If someone inquires you, how does it do that? You can simply say, because of its polymorphic nature. Similarly, in the programming world, Java objects possess the same functionality where each object can take multiple forms. This property is known as polymorphism in Java, where poly means many and morph means one or more forms. In this session for today, we shall discuss one of the key concepts of object-oriented programming, which is none other than polymorphism. Now that we have understood what exactly is polymorphism, let us go through some examples. Here you can see the image. The person in the middle can act in multiple forms. Firstly, you can see the same person being a student. Followed by that, he will become an employee of a company and also he would like to play some sports. Followed by that, the same person is acting as an interviewer for a fresher. Then the same person is acting as a normal human being who is purchasing groceries. And followed by that, the last example of the same person being a family man. You can see the same person is playing different roles at different situations. This is called as the polymorphism of a human being. Now that we have finished the first example, let us go through the second example of polymorphism. Here, suppose you have to save contact numbers of different persons. Now it's not possible that every single person in your contact list have two numbers, but few of them may have. So in this situation, let us assume that you have a friend by name Jack and Jack has two numbers. You have saved the first number, and in case if you want to save the second number, you don't have to create the new method called createContact and save the second identity number. You can just call the same create method what you have created for the first one and save the second number with the same name. Here you have saved Jack contact ID with the same name, but you have two different numbers. So this example is based on polymorphism. Now that we have discussed two examples of polymorphism, let us move ahead to the next topic where we will discuss about the types of polymorphism available in Java. So there are basically two types of polymorphism available in Java. They are static polymorphism and dynamic polymorphism. Let us understand each of these in a bit detail. Firstly, the static polymorphism. A polymorphism that is resolved during compile time is known as static polymorphism. Method overloading is an example of compile time polymorphism. So what exactly is method overloading? Method overloading is a feature that allows a class to include two or more methods to have the same name but the different parameter list. To understand this in a bit more detail, let us go through a sample program. So you can see this particular example is based on polymorphism or method overloading. So in the class called myClass, we have created two methods. The first method is myClass, which has the statement to print the message bricks. Followed by that, in the same class, we have another method called myClass, which has the same name, but inside this method, we have a variable I of integer data type, and inside the second myClass method, we have a message which says building new house, that is plus I plus feet tall. We are giving the height, which is I. So this height will be replaced here and the message will be printed. So followed by this, we have the void. In this void method, which is the info, we have a message again which says houses, height, feet tall. So this height will be replaced by the height we provide in the second myClass method. And followed by that, we have another void info which prints the message saying s plus houses, height, feet tall. So you can see we have two different methods with the same name, that is myClass, and followed by that the second myClass. And followed by that we have the same info or the same info method with different parameters. Now this is our main class which will access these two methods and print the data which we require. Now that we have gone through the program, let's execute this and see the output. As you can see, the program has been successfully executed and the output has been printed here. You can see that the provided height is 0, so the building has been provided as 0 feet tall. If we replace the height with another number like say 100, then the program will be executed again and the updated data will be printed here. So that was static polymorphism and method overloading. Followed by static polymorphism and method overloading, we shall advance into the second type of polymorphism, which is none other than the dynamic polymorphism. So dynamic polymorphism is a process in which a call to an overridden method is resolved at runtime. That's why it is called runtime polymorphism or dynamic polymorphism. Method overriding is one of the ways to achieve dynamic polymorphism. In any object-oriented programming language, overriding is a feature that allows a subclass or a child class to provide specific implementation of a method that is already provided by one of its superclasses or parent classes. Now, let us execute a sample program to understand dynamic polymorphism and function overriding. As you can see, this particular example is based on method overriding or dynamic polymorphism. Here, we have a parent class and a child class. The parent class is the animal and the child class is the dog. So inside the parent class, we have a method called move. And similarly, with the same name, the same method is also included in the child class dog. So what exactly we are doing in the main program is we're trying to call the parent class method move as well as the child class method move in our main program. So let's see and execute the program and generate the output. You can see the program has been successfully executed and both the methods are being called. So inside the parent class animal, the method move is being executed and animals can move message is been printed successfully. Followed by that, in the child class dog, the move method is being called and the message dogs can walk and run message is being printed successfully. So with this, let's move ahead and understand the next topic in our discussion, that is the advantages of dynamic polymorphism. So the first advantage of dynamic polymorphism is support for method overriding. Dynamic polymorphism allows Java to support overriding of methods, which is central for runtime polymorphism. Followed by that, the second advantage is it allows subclasses to add its specific methods, subclasses to define the specific implementation for the same. So these are the few advantages of dynamic polymorphism. Let us move ahead and understand the different characteristics of polymorphism in Java. In addition to these two main types of polymorphism in Java, there are other characteristics in Java programming language that exhibit polymorphism, like coercion. Polymorphic coercion deals with implicit type conversion done by the compiler to prevent type errors. A typical example is seen as an integer and string concatenation as shown in the following example. You can see string str is equals to string is equals to 2. So this example is based on coercion, which will be an implicit type conversion done by the compiler. Followed by coercion, we have operator overloading. An operator or method overloading refers to a polymorphic characteristic of same symbol or operator having different meanings or different forms depending on the context. For example, the plus symbol is used for mathematical addition as well as string concatenation. In either case, only context, that is the argument types, determines the interpretation of the symbol. The first plus symbol is used in string data type, so the plus will be considered as a concatenated operator, and followed by that, the next place where the plus operator is used is in the integer data type. So here the summation of both the numbers will be performed and the output will be as this. So the first one is 22 and the second one is 4. Followed by operator overloading, we have polymorphic parameters. Polymorphic parameters allows the name of a parameter or method in a class to be associated with different types. In the below example, I have defined content as a string and later as an integer. The declaration of polymorphic parameters can lead to a problem known as variable hiding. Here, the local declaration of parameter always overrides the global declaration of another parameter with the same name. To solve this problem, it is often advisable to use global references such as this keyword to point to the global variables within the local context. Now with this, let us move ahead into the next topic, that is the super keyword. Super is a keyword. It is used inside the subclass method definition to call a method defined in the superclass. Let us execute a sample program to understand the functionality of super keyword. As you can see, this particular example is based on super keyword. So here, you can see we are trying to call a method from the parent class or superclass using the super keyword. Now, let's try to execute this program and see the output. You can see that the program has been successfully executed and the method from the superclass is been extended successfully into the child class using super keyword. Now with this, we shall move ahead and understand the basic difference between the static polymorphism and dynamic polymorphism. The first difference is static polymorphism relates to method overloading, whereas the dynamic polymorphism relates to method overriding. The second difference is in the static polymorphism, errors are resolved at compile time, whereas in dynamic polymorphism, errors can only be determined at runtime. Let us go through a code segment to identify errors in static overriding. You can see the first line of code, which is void difference between the numbers x and y. Followed by that, we have another method with the same name where we'll differentiate the numbers x and y of float data type. And the last int diff a and b. So here we identify a compile time error. Similarly, let's go through a code segment for dynamic polymorphism. You can see the college here is the parent class and the object we are creating is from the child class. So the reference of parent is pointing to the child here. That is college obj is equals to new student. Followed by that, the method of child is being called, which is obj.exam. So this is an example for dynamic polymorphism. What is enum in Java? So the definition of enum is Java enums are classes that have a fixed set of constants or variables that do not tend to change. The enumeration in Java is achieved using the keyword enum. The Java enum constants are static and final implicitly. Now, this was the basic definition of enum. Now, let us move on to the next topic to understand what exactly enum is and why do we need it in Java programming. So, when we come into data types, we have two different types of data types, which are user-defined data type and inbuilt data types. So, the basic inbuilt data types that we use in our day-to-day programming are int, float, double, char, and many more. Similarly, we also have user-defined data types. So, enum is one of them. So, why we have user-defined data types when we have inbuilt data types? Okay, the answer for this question is sometimes the inbuilt data types are not enough. Just assume that you have different data of different data types and you have to store all that data in one single variable. In that situation, the inbuilt data types might not be useful. For that reason, we have user-defined data types. So enum is one of them. Now let us understand how does it exactly work. We shall consider our first example as the days of a week. Say Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. Now here we have all the 7 days of a week, and if we had to store all the 7 days of a week into one single variable, then we might tend to use the data structure, which is either an array or a list. But the drawback is the array and list are mutable. So during a different operation in a program, the data which is stored in an array might be variable. So in this case, we use enum. So we'll store all the 7 days of a week into one single variable, which is week, and the values stored in the variable week will be constant. Those will not be changed. Similarly, let us consider another example where you are the boss and you will be providing employment for different employees, which is contract, temporary, and permanent. So if you had to code a program for appointing employees on the basis of contract, temporary, and permanent, then you might look for a code which is simple and small and efficient. So in this case, if you use enum and store all these three values into one single variable, which is job, then your code will be short, simple, and efficient. So this is how enum works. Now to understand this enum in depth, we shall consider switch case. Firstly, we shall come up with a switch case code, and you have the following code here where I have provided switch case as C, and inside the switch case we have three different cases: case 1, case 2, and case 3. So we have some code segments in each of the case and we'll find for a match. So here is the problem with this code. Relationship between int literals 1, 2, 3 and executed code is not obvious. The next problem is if one of the above values, example 2, becomes not supported anymore, then this switch case is not updated accordingly and it will contain forever as the unused code. And followed by this, if new possible value, for example 4, is introduced and the switch case is not updated accordingly, then the code will probably throw an unsupported operation exception at runtime without the compile time notifications. Not only this, we also have few more problems, such as switch structure tends to be duplicated several times in the code that makes problems 2 and 3 even more complicated. And finally, the first simplest fix can be done by using int constants instead of literals. Let's define constants. So after a few changes, this is how the new code looks like. Obviously, in real life, the names of the constant must be self-descriptive. This snippet is more readable, but all other disadvantages are still relevant. The next attempt to improve this initial code snippet uses enums. Enums were introduced in Java from the version 5 in the year 2004. Let's define the following enum, and now the code will be slightly changed. As you can see, this is how the new code looks like with enum. This code is a little bit better and it will produce compile time error if one of the elements is being removed from enum action. However, it will not cause any compilation error if an additional element is added to enum action. In some IDEs or static code analysis tools may produce warnings in this case, but who is paying attention to warnings? Fortunately, enum can declare abstract method and that has to be implemented by each and every element. Now, the switch case statement can be replaced in single line. This solution does not have any of the disadvantages enumerated above. Followed by this, first advantage is it is readable. The method is attached to enum element. One can write as many Java docs as needed if any method is unclear. The second advantage is The code that calls method is trivial. What can be simpler than method invocation? Followed by that, there is no way to remove enum constant without removing the implementation. So, no unused code will remain if some functionality is no longer relevant. Followed by that, new enum element cannot be added without the implementation of method action. Code without implementation can't be compiled. If several actions are required, they all can be implemented in enum. As I have already mentioned, the code that calls specific function is trivial. So now there is no code duplication. And finally, we can conclude that although switch structure is well known and widely used in various programming languages, its usage may cause a lot of problems. Solution that uses Java enums and described above does not have these disadvantages. So now with this, let us move on to our next topic, which is the differences between class and enum. So basically, the first difference between class and enum is class constants can be overridden, while the enum constants cannot be overridden. Followed by that, the next difference is classes support the creation of objects, where on the other hand, Java enum cannot support the creation of new objects. The next difference is classes are capable to extend other classes, but enum cannot extend other classes, but it can implement other interfaces. Similarly, classes. Here, classes can implement an interface, and same goes with enum. Enum can also implement interface. So here, both classes and enums have the upper hand. With this, let us move on to our next topic, where we shall discuss the syntax for enum. So, the following code is the syntax for enum. Here, enum being the keyword and Edureka is the name of the variable and inside which we are going to store the constants. So now, let us move on to the practical examples to understand Java enums in a much better way. So the first practical example that we are going to consider is how to define enum in Java. So our first example will be related to bikes, where we'll learn how to define an enum in Java. As you can see here, I have declared a new package by the name definition, and followed by that I have declared my first enum, which is bike, and this bike variable is storing three different values, which is Bajaj, KTM and Yamaha. So all these three values which are stored in this variable bike will be constant and will not be changed. But you can also add in some new values into your enum, which will not create much difference. But if you try to remove any values, then you might have a compilation error. Now, let us execute this program and see how does it work. As you can see, in my main class, which is Edureka, I am trying to access one particular data from my enum, which happens to be Yamaha. Now, here you have the data which has been accessed and printed in the terminal here. With this, let us move on to our next example, which happens to be enum in switch case. Now, let us try to use enum in the switch case and see its functionality. This is the example that we have discussed earlier, where we shall be using one particular enum and will be providing a variable as day, and inside the enum day we are having, and inside the enum variable day we have all the 7 days of a week, which are Sunday to Saturday. Now inside my main class Edureka, I am trying to access one particular day, and along with that I'll be printing a message. For example, here you can see Monday. Hi, today is Monday. And similarly, the last one, which happens to be Sunday, and along with Sunday I have a message, hi, today is a holiday. And finally, we have a default method where if the input given does not match with any of the cases, then it will print out a default message, please enter a valid day. Now let us execute this program and see how does it work. As you can see, I have provided the day as Monday, so the first case got a match, and the message along with that, which happens to be hi, today is Monday, has been printed here. Now with this, let us move on to the next example. The next one happens to be inheritance in Java. Now we shall understand how does an enum inherits another class. Here, this particular example is based on inheritance related to enums in Java. Here I'll be describing three different manufacturers, which happen to be Google, Huawei and Apple. So I'll be trying to inherit the OS for all these manufacturers. You know that Google uses Android 1 and Huawei uses Hongmeng OS, and finally Apple uses iOS. Now let us try to implement inheritance in this particular class and try to provide the OS for all the manufacturers. Now let us select Google Pixel and try to inherit the OS related to Google Pixel. As you can see, I have successfully selected the phone as Google Pixel and I have inherited the OS for the same, which happens to be Android 1. Now with this, let us move on to the next example related to enums, which is enum with customized values. Now let us try to execute enum with customized values to understand this in a better way. So this particular example is based on enum with customized values. As you can see, I have customized the values of enum as traffic signals, which means red as stop, green as go, and orange to be wait. Now inside my main class, I'll be trying to access the data which is present in enum and provide the information related to the values stored in my enum. Now let us try to execute this program and see how does it work. As you can see, I have successfully accessed all the data present in my enum and I provided the meaning of the values stored in my enum as red action to stop, green action to go, and orange action to wait. Now with this, let us move on to our next example, enum with if-else. We can also use enum in if-else classes. So to understand the functionality, let us execute one example based on this. So this particular example is based on if-else statements with enum. Here, I'll be trying to travel to one particular direction. So in my enum, we have 4 directions which are east, west, north, and south. So according to the input I give from the main program, my enum decides to which particular direction I'm moving to. Now let us execute this program and see how does it work. As you can see, the program has been successfully executed and the output says that I'm moving towards north direction. With this, let us execute our next example that happens to be enum methods. So mainly, enum has 3 different methods, which are value, values of, and ordinal. Now let us execute all these 3 methods and understand the functionality. Now first we shall execute values method. When you create an enum, the Java compiler internally adds a values method. This method returns an array containing all the values of the enum. Now let us consider the following example, which has the following values, which are red, green, and blue. Now let us execute this program and understand the functionality of values method. As you can see, the program has been executed successfully and the data is been returned from values method in form of an array which says that the value red is in the index 0 and the value green is in the index 1 and the value blue is in the index 2. Now with this, let us execute our next method, which happens to be values of method. This method is used to return the enumeration constant whose value is equal to the string passed as an argument while calling this method. Now here, this example is based on values of method. You can see that I have given the values of my enum mobile as Samsung, Apple, and Google. Along with the elements, I have also provided the cost tags of all the mobiles. As you can see, the value of Samsung phone is $1,099, followed by that Apple has $1,250, and finally Google has $1,325. Now from the main method, I'll be passing one value to my enum which happens to be Samsung. Now what my program does is, it will enter into enum and it will access the cost details of the phone Samsung and it will display on the terminal. Now let us execute this program. You can see I have selected my input as Samsung and the cost of all the phones is been displayed here and the cost of Samsung is $1,099. Now with this, let us execute the last method of enums, which happens to be ordinal method. The Java interpreter adds the ordinal method internally when it creates an enum. The ordinal method returns the index of the enum value. This is completely similar to the values method, yet we shall execute one more example to understand this. So this particular example is based on ordinal method. And here I've defined 2 different enums. The first enum happens to be fruits and the second enum happens to be vegetables. So both these enums have different values stored in them. And from my main method, I'll be trying to access all the elements present in the first enum, which is fruits. And after that, I'll be trying to detect the position of apple present in the first enum, which is fruits. Now let us execute this program and see how does it work. As you can see, the program has been successfully executed and the elements index values are also been displayed. You can see that the index value of apple is 0, followed by that banana 1, cherry 2, date 3, and berry at 4. You can see that cherry comes after apple. You can see that apple stays in the first position and cherry is displayed after apple has been displayed first. Now with this, let us move on to our next topic, which happens to be advantages of enum. So we have many advantages when we use enum in programming, but let us consider the major advantages we have. Firstly, enum in Java improves type safety. The next one, enum is easily usable in switch cases. Then enum can be easily traversed. Followed by that, enum has fields, methods as well as constructors. And the last one, enum can implement interfaces. With this, let us come into our last topic, the use case. The rock, paper, scissors game using enum. So this particular program is based on our today's use case, and the enum we are going to use is hand sign. So the hand signs that we have loaded for the use case are scissor, paper and stone. Followed by that we have SPS main class, inside which we have provided if-else cases along with while loops, which will decide the hand signs which we provide. Along with that, the computer will play with us and decide who is the winner. The choices of the computer will be random and the choices of both the players will be evaluated and the winner will be declared. Now let us execute this use case to understand how it works. As you can see, the program has been executed and now the interpreter is asking us to input a choice. S for scissor, P for paper and T for stone. Now let me input P for paper. As you can see, the computer has thrown scissor and now it says I'm the winner. Now let us get another trial. Now let me insert S. As you can see, the computer has also provided scissor and it is a tie. Now let us go for another play. This time I'll input T for stone. We have another tie. Now let's play stone again. And finally we have a win here. I chose paper and the computer chose stone, and over stone paper wins.
Let's begin with the arrays. Now in the software design, so you are storing the data. So when you are storing the data, there might be a use case where you need to store a lot of data all together in a single container, right? For example, you need to store population of a country as in some states. So there are, let's say, n number of states for which we have a population count. So you see there will be approximately data which will be in lot of values. So we'll have more than one value associated to the container called population for the country. So we can have an array. For every element in an array, we can mention the population count for one of the states, right? So to begin with, guys, array is a data structure to hold, more than one values. So it's gonna be a multi-value container for us. So it can contain homogeneous elements. So you can say it's a limitation or it's a plus point, right? So it maintains the type safety check. So we cannot store different type of data in the same array. So it has to be the same type. So if you are going to create an array for integers, it must be only integers. Now all the elements, they are stored under one single variable name. So we have a reference variable which will be pointing to the array. Now the data stored in an array is a contiguous memory location. It means that they are the neighbors now. So there are various different types by which we can represent the data in arrays. So we can represent the data as single dimensional or 1D array, which is storing the elements as in a row. So just consider it as a row. In a continuous row, we are storing the elements. So that is how we started, right? So in a use case to store the country's population, so this element can store state 1 population count, next element can store the other state population count, so on and so forth. Now two-dimensional array is array of arrays, right? So it's a collection of collection now. So here what we are understanding, two-dimensional array, that it's gonna hold the population for the world. Let's say the first array will store the population for Indian states. The second array can hold the population for some other countries, different states. So if you have more than these kind of problems, so where you have data coming up in the form of some, let's say you want to process images, right? You want to rotate an image, you want to process an image on some colors. So here we just don't have a two-dimensional array. We just don't have array of arrays. So we got multi-dimensional arrays. So in that regard, we got this multi-dimensional arrays where a lot of data can be stored. So typically, when you are going to come up with the image processing problem, so you'll be working in the multi-dimensional array. So one of the use cases. Now let's see how we can work with arrays. So guys, how we can create a 1D array. So creating a 1D array is very basic. So you give a reference variable name and you mention the data type with the new operator with the size, and you'll be able to get your array created in the RAM area. So reference variable with the new integer 5 will give you an array of 5 integers, right? So you need to be having this syntax where we can create an array. Now, when you will create an array, it will be indexed on the basis of size. Let's say the size is 5. So there will be 4 indexes. So 0 to n minus 1. So it's going to be 0 to 4 for a size of 5. Now, every element in an array is accessible through this index. For example, when you say my array 0 assign 10, you're writing the data in the 0th index. So thereafter, you say 1 is 20, 2 is 30, 3 is 40, 4 is 50. So you are actually writing the data into the array. So a basic write operation, and same way when you have the array constructed, so at the time of construction, you can mention the data, right? So the values can be given exactly at the time of construction. So this time you need not to write the data. So by default, we'll have the values coming in for your array. So guys, when we want to access any element in an array, so you write down the reference variable name and you mention the index in a square bracket and you will be able to access it. For example, you say my array 1, it's gonna access the value 20. So you say my array 4, right? So array 4 over here is supposed to be the value 50. So when you want to update something, so you can just mention the index and you can give a new value. So here it goes like my array 4 assign 100. So you are going to replace your array 4 as 100. So let's have a quick practical example on 1D arrays. So what I'm going to do is I'm going to create a new Java project. So let's say a new Java project called array demo. So we'll begin with why we need arrays, and thereafter we'll process it further, right? So I'm gonna say arrays with the main method, or let's say 1D arrays. The package goes like co.edureka. Now consider you wanna store the population of a country, right? So you will have state 1. Let's say the population count is 502. Same way you will have some other states coming in, let's say state 2, state 3, state 4, and state 5. Right, so let us say some populations are coming in for us. Now having this population stored in 5 different single value containers, right? So what are they? They are single value containers. They cannot hold more than one value. So when I'm talking about state 1, state 2, state 3, state 4, and state 5, they are the different states, right, containing the population. So I can say state 1 population count to be more precise, right? So considering that these are the different population counts for the different states of a country. So rather than containing these single value containers, what is a solution is to have a multi-value container, right? So how you'll create a multi-value container? So we'll write one integer array. So I'll say population. I'll just write down this name as state population, which goes like a new integer with 5 elements, right? So I gave the size myself that this array should have 5 elements. So when you print out this state population, when you run this code here, so you will see that we are getting some hash code in a hexadecimal format. It says some integer array at this 785E922. So what exactly has happened here? So guys, in the RAM area, so whenever you're gonna run the program, so in this RAM structure, so you'll have this stack coming in as a data structure. And the second thing is heap for us. So I'll just quickly write. So this is the RAM allocated, this is the stack data structure, this is the heap data structure. Now we got this guy called population. So if you see this state population, So I'll not use the term state population, rather I'll say country population. So this guy contains 785E922. Right, so country population is containing some hexadecimal over here, 785.2E922. So it can be any number which is coming for us over here because it is not generated by us. Now in the heap area, there will be a storage container which will be created at the same hex code, right? So this is key value pair. I mean to say it's like hashing as in algorithm. So this guy acts as a key where this is the storage container. So we got these indexes coming in for your array, right? So that's like 0 index, 1 index, 2 index, 3 index, and the 4th index. And by default, we get the data as zeros, right? So we have all the data coming in as zeros. So we have everything over here as 0, and this guy country population is basically pointing out here. Now coming here, I will first of all read the element in array. The first thing is reading the element in array. So what I'll do, I'll simply say please print me the country population 0th element. So when I'll say 0th element, so here we are with the 0th element, right? So when you run this code, you get to see that the value is 0. So same way, if I read it for the first element, so you will see it's gonna give me again 0, right? So this is like reading the element, and it's like read single element. So you access the element, right? So there can be the other way around, that's like read all. So I can just put up a for loop. I can say start with 0, go till country population dot length. So length will give me the size of the array. So what I will do is I will say CISO country population of I is plus country population I. So where each and every index will represent a state. Okay. So now when you run this code here, you get to see all the values coming in as 0. So when you create any array, so all the elements will be by default 0. So what I can do is, so before I access my array, I can do a write operation in array, right? So write operation, so write slash update operation. So both of them are same for us. So I can come here and say that the country population of 0 index is 502. Same way we have 1, then the 2, then the 3, then the 4. So you got 765, 987, 456, and 876. So we are able to write the data, and now I'm just gonna do an empty line here and we'll say rereading after write operation. So when you run this code here, so what you see is once we do a reread operation after writing the content in the array, so we see the updated data, right? So now we have these values coming in 502, 765, 987, 456, and 876. It means that here we don't have zeros now, right? So rather than 0, so you got the data coming in for us. For example, this guy will go as 502. Now every index represents a state with the population count, right? So having single value containers differently, so we were having single value containers differently rather than having it in an array is a more better version. Now the same syntax over here can be replaced like this. So I can say int array country population goes like this number 502, 765, 987, 456, and 876. So what does this mean? This means that, so here by default all the elements were 0, right? So in this declaration when we read, so all elements were by default 0, but here elements have some default initial value. So here elements, they have a default initial value. So even you don't write the data. So let's say we are not writing the data here. So when you try to read it, so you'll always have the data in the array now, right? So we're not performing rather any write operation. So what you will see is that you have the data coming in before you even do a write operation. So choice is yours. So whatever the way you wanna write an array, you can do that. So you can have an array with all the elements having default value as 0, or you just specify the values whatever you wanna provide. So the same syntax can come up like this as well. All right. So don't get confused. It's the same story, right? So this is an implicit way versus this is an explicit way. So choice is yours, right? So any syntax you want to follow, you can follow that. So now the next thing is update operation. So you already have the data. So you can use the same assignment operator to update the data, right? So let's see this update operation coming into the picture. So now when you run the code, so before you had this data and now you are having this data. So guys, I hope this is clear to everyone, right? So rereading after the write operation. So now this write operation has become the update operation. So we can use 1D array anytime with the help of indexes. We can perform a read operation on a single element. We can perform read on all the elements. We can even perform a write or update operation, but everything happens with the help of indexing, right? So there is one more way to read the array in Java. So that's like your enhanced for loop, or sometimes we call it as for each loop. So any name can be given to this guy. So you say for int any element in your country population array, you say print me the element. So you run the code here. So you get to see the data once again. So here you don't have indexes. This loop will start from the 0th index, will copy the element at 0th index into this variable ELM, which can be any name of your choice, right? So it's just an identifier. So we are iterating in this loop. So now you seriously want to come up and calculate the population for this country. So I can create a variable called count, which goes like 0. And here I can say count plus assign, or let it be simpler, count is count plus the element, right? And let me come here and say population count for entire country is plus the count. So let's run this code here, and what you see is the population count coming in. Now you might be surprised in a way that this was a bit easier approach, storing the values in a single value container and having state 1 population count. So why we are messing around with these indexes, even though this looks very easy. Now assuming that you have to work on 30 states, so you'll be doing 1 plus 2 plus 3 plus 4 plus 5 plus 6. It's like a lot of time consuming thing, as in development effort is highly reduced. So having this one liner where you just mention all the population counts and having a loop as couple of lines and summing up the entire population. So when data is having more dimensions, so you need to focus on array, right? So solving the problems where you have a lot of data, so you structure it in a better way, and arrays, they are one of the most easiest data structures to use in your software solutions. So with this, let's now move to the next part. So the next part is working with two-dimensional arrays, right? So guys, we call them array of arrays, right? So here we mention the row and column. So row column here does not literally means a matrix concept. So row column over here means that how many number of 1D arrays you want. So the first element means how many 1D arrays, and the second means how many elements in 1D array, right? So it's basically array of arrays. We can represent a matrix using two-dimensional arrays. So this is like zeroth array's zeroth element, zeroth array's first element. Same way, first array's zeroth element, first array's first element. So if you want to access, you can say 0, 0 is 100. So zeroth array's zeroth element, right? So you put the data. So same way you can put the data for the other elements. Now, if you want, you can access any element in a 2D array by mentioning its indexes. And if you want to update the data, it's again on the basis of indexing, right? So guys, let us try to have one example on 2D arrays. So I'm gonna write one new class. Let's say 2D arrays with the main method. So to begin with, I'll just say int two brackets. I'm gonna say world population. So considering this world population, so I'm going to have the first array for the first country, right? So let's say, all right. Now this is first array and let it be the second one. So this goes like some second array and this goes like some third array, right? So this is zeroth index, this is first index, and this is second index. Now when we are understanding this problem statement, so we mean to say that 0 represents country 1 and 1 represents some country 2. So just taking an example. So this represents some country 3. Same way here, this is country 1's 0, country 1's 1, then 2, then 3, then 4 and 5 and 6. So this is 0th state, first state. So these are the states now which we are talking about, guys, right? States for country 1. So these are the states for country 1, right? As in indexing. So the next is the state for the country 2, states for the country 3. So these are all counts, right? So they are the population counts, all right? So let's say that you got country 1 as India, and let's say the 0th state is Punjab. So we got the population count for Punjab. So that is how we are representing it. So there can be some other country 2, there can be some other country 3. So we have represented the data into this entire array. Now, when I will just try to say world population is plus world population and size is plus world population dot length, or let's say and length is. Now when I will run this code here as Java application, so what you will see is that it's an array of arrays at a hash code, right? And the length is 3. So I got this guy called world population. So I'm just gonna take this another example here. So we got this guy as world population 785E2922, some hash code. So this world population is something like this. So it's basically having 3 indexes, and you got indexes coming as 2, 1 and 0, right? So this hash code goes like this, and we got a reference coming in here. Now the next thing is we got the 0, 1 and 2. We got this world population coming in. Now what I'm gonna do is I'm gonna access the 0th index, right? So I'll say world population 0, then 1 and then 2, right? So we will come up here and say 0, 1 and 2. So guys, this is array of arrays, right? So 0th index is an array, first index is an array, and second index is also an array. So I'm going to say print me the zeros length, print me first length, and print me the second length. So 0 length is like what? 7, right? Because there are 7 elements. Then the next guy and the next guy, they have their own sizes. So when you run this program here, so you get to see the sizes as 7, 5 and 6. At the same time, what you see is we got different references coming in, some 4E2, 705C6. So we have some hash codes. So I'm just gonna represent these hash codes here. let's say some 4001, let's say some 3001, let's say some 2001. So I'm just considering these numbers as hash codes. So further we got these arrays. So this is like 4001 array, 3001 and 2000. So guys, I'm just considering these mathematical numbers as hash codes, right? So this is like further pointing out here, this guy pointing out here, and this guy pointing out here. So what is this concept? This concept is array of arrays. So world's population zeroth index is an array, right? So we get to see this data over here. So this data is available over here, right? So as in indexes. So 0 index, right? So this guy is indexed for us. So 0 index, 1 index, 2 index, then 3, then 4, then 5, and then 6. So on and so forth, guys, the others as well. So if you say world population, zeroth array's first element, it's gonna be 4, 5, 6, 7. So that is how, if I come here and if I say, please print me world population, let's say zeroth array's zeroth element, right? So world population 0, 0. You run this code here, and what you get to see is 1, 2, 3, 4. So guys, I hope you understood this point, right? So when I say 1 and 2, so first array is 0th index, first index, and the second index. That's like 8, 7, 6, 5. So here you are, right? So this is like 1 and 2. So anytime you wanna read the array, so this is like read single element, right? So you wanna write the data. So write or update, they work in the same way, right? So for example, now I will be doing an update operation. So I'll say world population of 1 and 2 is some number, all sevens. So you say CISO rereading, and now when I will do a reread operation here, so let's run this code. So here you are with the number all sevens. So same way you can even perform a read all operation. So I can write a loop. So the outer loop shall work for the world population dot length. So this loop's gonna iterate 3 times because the length is 3. So from 0 to 2, because we got 3 1D arrays. Then I got an inner loop which will go from, let's say, j as in 0. We'll say j less than world population of I dot length and j plus plus, right? And thereafter I'm gonna say world population of ith arrays jth index, right? The print line, and print line will do in the next case. So let me give one empty line here. So here you are. So now you are able to print the entire 2D array. So guys, array of arrays, they can be powerful data structures when you have a lot of data. So you can even create an array of arrays by saying an ARR is a new integer. So I want 3 1D arrays with 5 elements each, right? So 3 1D arrays with 5 elements each. So here, if you will try to read this guy, so if you try to read ARR, so any guesses, guys, what will be the output when you read ARR? So what do you think? What will be the output for the ARR, right? So output for the ARR would be all zeros, right? So when you give the sizes, you get the default values as 0. And when you don't give the sizes, you give the default values. So it's just the basic conclusion to understand the arrays, right? So giving sizes, we need to put the data later. Hence, data initially would be 0. So this is how we are understanding this guy array, right? So giving data first, we need not to give any size. So that's like the thumb rule. And guys, explore enhanced for loop on 2D arrays. right? So explore that how you can convert this nested for loop with the help of enhanced for loop, right? So that you guys explore. So this is how we got something known as two-dimensional arrays. And let me do one more problem statement. So how we can solve this matrices problem. So if you can recall your childhood mathematics, so we used to do an addition, subtraction, multiplication, and a lot of other things on arrays or on matrices. So we'll write one small program here and we'll try to solve it as an addition problem, right? So let's perform an operation on array once again. So let's take a problem statement here to add two arrays. So I'll write one 2D array called A, which goes like the first array having 1, 1, and 1. So I'll have all the values as ones, right? So same way, I'm gonna have the other guy called B. So this array B, I'm gonna have the values as twos. So it's a 3 cross 3 matrix representation, 3 rows and 3 columns, 3 rows and 3 columns. So when I have this matrix representation coming in, so what I'm gonna do is I'm gonna print them first, right? So let's see matrix A. So I'll say for int go with the 0, go less than a dot length, and then I'll write one more for loop. So we got this 2D array, so we need to access the elements. So you need to come up with a of I dot length and j plus plus. So here I'm going to print this guy called a of I and j. So this is the representation for matrix A. Let's represent the matrix B. So I'll say b dot length, b of I and b of ij. So let's run the code here. So this is how the two different matrices are coming, guys, right? Now what I'll do is I'll come here and I'll create another matrix that's like C, which is a new integer of 3 and 3, right? So we'll take 3 rows, 3 columns. And what I'll do is I'll take one loop here, run it till C's length, and I'll say C of ij is a of ij. So guys, we are adding the elements here, right? And b of ij. So what we are doing is we are adding this one with this two, then this one with this two, so on and so forth, right? And once I'm done with it, so I'll represent this guy called matrix C here after the addition. So all elements, they should come up as C. So you run the code here. So you get to see that the matrix 3 is coming as all the threes. So here we are. So one basic mathematical operation on matrices, guys, right? We'll see sorting and searching in arrays. So there are various different algorithms through which we can sort the elements in an array, and same way we can even do searching. Now, typically when you are in an e-commerce shopping website, let's say Amazon or any other e-commerce, so you want to sort the items on the basis of the price, right? So that's like either ascending way or the descending way. So one of the practical usages where you can actually apply these sorting algorithms. So these are some commonly used algorithms, and they have their own, time and space complexities, but we are not going to discuss that in detail here. So we'll typically see how they work and how we're gonna solve this problem to sort the data in an array. So we got bubble sort, selection sort, insertion sort, quick sort, and merge sort as algorithms, which we are going to discuss for the day. So let's begin with bubble sort. So guys, given the sorting techniques, so when it comes to the bubble sort, it's one of the simplest sorting algorithm, right? So what it's gonna do is it's gonna perform the swapping of the adjacent elements in case they are in a wrong order, right? So we're gonna always swap the adjacent elements if they are in a wrong order. So we are considering that we're gonna sort the array elements in an ascending arrangement. So let us see how it's gonna work. So consider that we got set of elements as 4, 1, 10, -3, and 12. So what bubble sort will do? So in case of bubble sort, so we'll start one of the iteration. So consider the ith iteration. So we'll start from the 0th index and we'll compare the index 0 with the index 0 plus 1. That's like 4 and 1 we are going to compare here. So when we compare, we find that 4 is greater than 1. So we swap the elements. Now the next is where we are comparing 4 and 10. So 4 and 10 will pass because 4 is lesser than 10. Then we'll move on to the next adjacent elements. That's like 10 and minus 3. So when we compared them, we found that minus 3 is a smaller one. So we swap them. And same way when we compare 10 and 12, so it's perfectly fine. So let's pass. Now in the next iteration, so we'll again begin and we'll now start from the next index of the ith loop. So here now we'll see minus 3 and 4 has been swapped, and thereafter we'll compare 4 and 10, and finally guys, the last iteration, so on and so forth, will finally sort the array. So what we are doing, we are just comparing the adjacent elements. So if one is found to be lesser than the other, so you swap them, right? So let's try to write a small code snippet on bubble sort and see how it's gonna work for us. So I'll write one small program here. So let's create a new class. So I'll say a bubble sort with the main method. So considering that we got the elements of an array, so let us take the same use case. So 4, 1, 10, minus 3 and 12. So this is the input sequence, right? So this is something which we are looking forward to sort. Now, in order to sort, I'll write one method here. So let's say this goes like static void. I'm just gonna say sort here. So I'll take array as input. So the array which I want to sort, and here will come up and say bubble sort dot sort the ARR. So you're passing by reference. It means that if you sort this reference, right, so automatically this will be sorted. So it's basically reference concept which we are using here. So the first thing first, so I'm going to now calculate the length of the array. So let's say length is ARR dot length. So this is the size of array more or less, right? So we'll run one loop. So this is, let's say, the outer loop which starts from 0, and this loop shall go till less than your length minus 1, and thereafter I'll say an I plus plus. So it means that this loop will go from 0. So this I loop's gonna work from the 0 index, then 1, then 2, and then 3, right? Not the last one, right? So it's less than length minus 1, right? So if the length of my array is 5, so let's say the length is 5, so the outer loop here shall work from 0 to 3. So it's length minus 1. So we want to iterate till here. Now I'll have one more loop. So let's say this is the J loop. So J loops begin with 0, and J loop will run from 0 to length minus of I and minus of 1, and then I'm gonna say J plus plus. It means the jth loop is dependent on the ith value. So if the I value is 0, consider that if I is 0, so your j will vary from 0 to, now length minus I minus 1, right? So what is the length? Length is 5 minus 0 minus 1. That's like 0 to 4. So on and so forth. It's gonna work for the other indexes of I. Now let us compare in case the ARR's jth index is greater than ARR's j plus 1 index, right? So if the element is greater, we are checking for the adjacent elements. Now if the adjacent elements are being compared and we find that ARR j is the greater guy, so we'll swap it, right? And we'll use the swapping technique as a very basic swapping technique. So we'll have a temporary variable in which I'm gonna put this jth element, and thereafter we'll have ARR's jth element allocated with the ARR j plus 1, And lastly, we'll have ARR J plus 1 having the 10. So I'll just write down here, swap the adjacent elements, and this is how our logic's gonna work, right? So we keep on swapping, and once this entire swapping is done, the loops are terminated. So you will get one sorted arrangement of your elements. So when you say bubble sort dot sort the ARR, so now if you say for loop, let's say int element in the ARR, so I'll simply CSO and I'll say element with some space. So you run the code here as Java application. So what you see is the sorted arrangement of your array -3, 1, 4, 10, and 12. So this is the very first and the very basic technique called bubble sort. So we compare the adjacent elements and we swap them. So guys, let's move next. So for our next sorting algorithm, we got something known as selection sort. So guys, selection sort is also one of the sorting algorithms. And here, this guy will sort an array by finding the minimum element and putting it to the beginning. So we'll keep on repeatedly doing these steps. We'll find the minimum element repeatedly and we'll just place it in the beginning of the array. So that is how our selection sort is going to work, right? So let us understand this. So when we are in the first iteration, so we exactly are trying to see the minimum number, and we will find that -3 is the minimum number in the first iteration. So we'll put it in the beginning. Now we'll shift the next index and we'll just keep on comparing and we'll see that 1 is the shortest one. So let it be there. So thereafter, we'll move the index to the next position and we'll see now who is the other small element. We'll find that 4 is the small element. We'll now come up and put it in the beginning. And lastly, we are in the sorted set, right? So selection sort is comparing the number. So we are just going to compare the number with all the elements. Wherever we find the shortest element, we put it to the beginning, right? So let us have one small program with respect to selection sort and see how it's gonna work for us. So the way we got bubble sort, I'm going to say a new class here. Let us say this goes like selection sort with the main method. So we'll take the same use case. So instead of having this bubble sort, we'll have selection sort. So I'll create a similar sort method. So let me copy this. So we'll have a similar method where we're gonna sort the data, right? So the structure begins in the same way. So the thing is, we need to come up and iterate for the same structure. We're gonna iterate from 0 to length -1. So the internal structure, it's gonna be a bit different now, right? So what I'll do is, I'll first of all assume that the minimum element, or you can say that minimum element on the index is the element at the ith index, right? So the minimum element, right? So I'll just write here. So assuming minimum element is at ith index. So we're assuming this part now, right? And we'll now look for any element who is a minimum than this. So for that, I'll put up a loop which starts as in j's value with I plus 1, and j shall run less than the length of the array. So we are iterating over the entire array. And if in case we say that ARR of j is less than ARR of minimum index, so considering that what we have is we have the jth element less than the minimum index element. So what I'm gonna do is I'm gonna say let minimum index go as j. So in the array we are finding the minimum index, and once we got the minimum element, so our minimum index over here means, guys, we are targeting the minimum element, right? So here we are targeting the values, not the index. So we are just capturing the index of the minimum element. Now, once we captured that, so thereafter what I'm going to do is I'll swap the minimum element with the first element. So swap minimum element with first element. So what I'll do now is I'll take up one temporary variable in which I'm going to store the minimum index. So thereafter, let's have ARR of minimum index with ARR of I, and thereafter the ARR of I will be having the temporary. So this is like swapping the element and not the adjacent elements the way we had it in the bubble sort. So this is a bit different way of dealing with the things. But at the same time, when you will execute this program of yours, so what you find is the data is again sorted for us. So how these algorithms are different? So they have the different approaches to solve the same problem. So they vary in time and space complexity, of course, but that is not something which we are going to take now. So guys, this is something known as selection sort, right? So how we are selecting the element which is minimum and then putting it into the beginning. Now let us move to the next part. So guys, next part we're gonna come up and discuss something known as insertion sort. Now what is insertion sort? So when I'm talking about insertion sort, so this is very much similar when we are playing the cards. So what we do is we pick up the smallest card and we put it in the beginning. So here we are going to work in the same way, right? So we're gonna pick an element and insert into the sorted sequence. So let's see one iteration that how insertion sort will be working for us. So for insertion sort, let us assume the same input. So when we will compare 4 and 1, so you see that over here we got 4 and 1 being compared. So we'll swap them and now we'll move into the guy called 10, and thereafter we see that -3 is again a smaller element, so we're gonna shuffle it to the beginning. So it's just like the way you sort your cards. So finally you'll get a sorted sequence, right? So guys, insertion sort is something which is sorting the data in a different approach for us. So here we are going to again find the smallest value and swap the same, right? Let's try to write a code snippet on insertion sort and see how it's going to work for us. So let me come here and create a new class. So this goes like insertion sort with the main method. So let me take a similar method here. So we'll call it sort itself, and coming here. So we are going to work from 0 to length. That's like 0 to 4. So we'll take the same sequence and we'll see how it's going to work for us. So I'm going to say insertion sort dot sort, right? So let us now write the code to sort the array. Now I'll first of all consider that there is a key which is basically ARR of I. So we are assuming that the very first index itself is a key. And I'm going to now create one J which shall be your I minus 1. So basically I want to move the elements of the ARR from 0 to this J, so that whatsoever are greater than the key to the position ahead of their current position, right? So let me write the code that's gonna be more helpful for us. So here I'll say while J is greater than and equal to 0 and ARR of J is greater than key. So run the loop till we have these conditions being satisfied, and if the loop is in execution, so what I'll do is I'll say ARR of J plus 1, you just copy the ARR of J and you decrement the value of J by 1. And once this loop is terminated, come out of the loop and we'll have J plus 1 index with the key. So that is how we are sorting the array over here, guys. So in order to sort, what we are doing over here is We are moving elements of ARR from 0 to I minus 1, right? But we are moving only those elements which are greater than key. And where we are moving? So we are moving them to one position ahead of their current position. So if the current position is J, we are moving it to J plus 1, exactly the way we do it in the cards, right? So you're just moving them one position. So guys, now let us try to run the same code and see what happens for the sorting technique over here. So what we see is insertion sort has also sorted the array and the technique is modified, but the outcome still remains the same. So insertion sort in action. So guys, once now we have since understood what is insertion sort, so we'll be now moving into the other algorithm called quick sort. Quick sort is not as in that it's really a quicker algorithm to sort the elements, but when it compares itself to the merge sort, yes, it is quicker. So what exactly happens in the quick sort algorithm? So guys, it's a divide and conquer algorithm. So what we do is we partition our array and then we try to solve the problem. So consider the set of elements 9, 5, 4, 1, 7, 2, 3 and 6. So what we try to do over here is we will decide one of the elements in this array which can be serving as a pivot or a pivot. So the pivot element is the element which can be either the first element, the last element, or the middle element, or any random element of your choice. So it can be any element. Now the whole idea is to choose this pivot element and break your array in such a way that all the elements left to the pivot should be less than or equal to it, and the right to the same pivot we should have greater than elements. So we are going to make our pivot to go into the exact position. So this way we will be coming up and sorting up the entire array. So shifting the pivot to the right position will be our key success. Now consider 6 is the pivot number from the entire list of sequence. Now consider the ith index or the ith variable and a jth variable. So the variable j will be iterating over the array and we will be comparing each and every element to the pivot that's like 6. So considering when your j is 0, that's like the number 9. So we're gonna compare 6 and 9. So we know that when you compare the number 6 and 9, so 9 is greater than 6, right? So we are okay to go with it. Now we increment the j and we bring it to the 5. When you compare 5 and 6, we find that this jth element is less than the pivot. So whosoever is less, it should move in the beginning or to the left. So what we are going to do is if we find the element lesser than the pivot, we are going to move it to the beginning, or we are just going to swap number 9 and number 5. And now I am again reiterating on the jth index and I have incremented the I index as well. So let's say initially I was pointing to this guy 5, but when we did a swap on 9 and 5, we incremented the variable I as well. Now the new number with the jth index is 4. So if you compare 6 and 4, so we understood that 4 is lesser than 6. So what we'll be doing is we will be re-swapping your number 9 and 4 and then increment I. Now again 6 and 1 there compared and we see that 1 is less, so you again swap. But 7 is greater, you don't swap. But 2 is what which we know is lesser. So what we're gonna do is we're gonna swap your 2 with the 9. So on and so forth. So lastly what you will have is you'll have the elements that's like 5, 4, 1, 2 and 3 which are lesser than the 6 and 9 and 7 greater than the 6. So we get this 6 exactly positioned after 3 and before 9, right? So guys, that is how we are doing this partition, and then we are sorting the structure. So let's see a code snippet on quicksort. So I have this code walkthrough here. So what I have is I have the input sequence of the same elements 9, 5, 4, 1, 7, 2, 3, and 6. So we got this sort method here where I'm passing array, the 0th index, the length -1. So these are the initial inputs to this sort method. So here we are with the sort method. So if you got low less than the high, which exactly it is, so we are going to call the method partition with the array low and high. Now partition method is working in the same way. So we are considering the pivot as the last index. So high means the last index, the last element. Now index of the smaller element shall be low -1. So that's like we are creating this variable I, and we are iterating in the jth loop, which will iterate in the entire array. So if the ARR_j is less than the pivot, we are going to swap ARR_I and ARR_j, and we'll also increment the variable I. And finally, once you are done with everything, so what we're gonna do is we're gonna move our pivot to the right place. So eventually, entire array to the left of pivot should be less or equal, and to the right will be greater. So putting the pivot to the correct position. That is what we did in this partition method. So recursively, we are going to sort it, and till time we don't get the correct elements in the list, we keep on sorting them. So when we run this code, quicksort.sort, and you see we will have the elements in the correct order. That's like 1, 2, 3, 4, 5, 6, 7, and 9. So this is what we got as in quicksort, guys, right? So guys, now let's have look at the other algorithm for sorting. That's like the merge sort. Now merge sort is also a divide and conquer algorithmic approach. So what we're gonna do is we're gonna divide the array in 2 halves, right? So you say it as left and the right one. So here what we will be doing is we'll take one example of the same sequence 4, 1, 10, -3, and 12. So we're gonna divide this array into 2 different halves. So once you divide the array, so you keep on dividing the array further. So you see, once you are dividing the array, you divide till we got all the single individual elements. And once we have all the single individual elements, right, so thereafter we'll start working on merging these arrays, right? So here, guys, we'll write something known as a merge function, which will merge the 2 halves based on which is greater, which is smaller. So what we're gonna do is we're gonna merge, first of all, 1 and 4. We'll see that 1 is smaller number, so we're gonna place it first, and then we're gonna bring it 4, right? So on and so forth, we keep on merging the elements, and we'll first of all finish the merge on the left array, then we'll finish the merge on the right array, and lastly we're gonna merge left and right array both, which will be the sorted arrangement at the end. So in this merge sort algorithm, divide the arrays into 2 sub arrays, left and right. So thereafter you sort the arrays at the end, right? So let's have a quick look on how this algorithm can work for us. So I already have the code snippet for this. So let me just open it. So here we are. So now typically for a merge sort algorithm, how it's gonna work is, so we got this function called merge, and I'm gonna take the same sequence of inputs. So that's like 4, 1, 10, -3, and 12. So just give me a moment. So 4, 1, 10, -3, and 12, right? So what we are doing here, let's see now. So we got this guy called merge as one method, which is supposed to merge 2 arrays. And if you will see over here, we got sort, which is going to sort the 2 arrays, and thereafter it's gonna merge. So I'm going to initiate my program by executing the sort method, right? So for the sort method, I am passing array to be sorted. I'm passing the lower index, that's like 0, and I'm passing the higher index, that's like your length minus 1. So this 0th index and this guy is the 4th index. Now in case L is less than R, which it is, so we are going to come up and say, let us find the mid L plus R by 2, and we now calling the sort method twice. The first sort happens on the ARR L comma M. The second sort happens on M plus 1 and R, right? So once we sort the left and the right part, then we are going to merge both of them. So over here, when I'm doing a sorting, so you need to understand that it's a recursive call. So we are calling the method again and again until this condition is satisfied. So what happens in the merge part? So here what we see is we got two different sizes, right? So S1 and S2 are the two different sizes for the arrays. So we are creating the left array and the right array based on two different sizes. So the left and the right array size. So what I do is I copy the elements in the left array and in the right array. So this is merge over here method. So this is going to merge two arrays which we partitioned, and you got LARR which will be working from your L to M, and we have this guy called, let's say, RARR. So there is subarray 1 and subarray 2, right? So I'll just say ARR 1 and this guy ARR 2. So the second array is going to work from M plus 1 till R. Now we are copying the elements here. So create subarrays. So this is like create subarrays. And here what we are doing is we are copying elements into subarrays. And now once you have copied the elements, so we'll start the process of merging, right? So let's say start merging process here. Now in the merging process, so what we got is we got indexes for the first and the second array. So I'll take the 0th index to be the initial index. And once I have taken that, so I'll take the initial index of merged sub array. So that's like K is L. Now while your I is less than the S1 and J is less than S2, so what we will be doing is we'll be further checking if I index in the left is less than or equal to. If it is so, we're gonna assign the ARR's kth index with the ith index in the left array, and then you increment the I. Other way around, it's the right array which has to be considered. So till I will be less than S1, we are going to come up and copy the ith index in the left array into the kth index, and then you increment the I and the K. So lastly guys, if the J index is less than S2, you do it for the same part, but you are doing it in the right array. So we got something known as merge process and we got something known as sort process. So when you run this code here, so eventually you will again get the sorted outcome. So guys, sorting can work in various different ways. So we got this technique called merge sort, where you keep on dividing the array, and thereafter once you have individual elements, you start the merging sequence. So this is the final outcome, that how we're gonna work with it. Next part is how we are going to search in the arrays. The first one is a linear search. So what we're gonna do is we're gonna identify an element, that whether it is there in the array or not. So we'll begin from the 0th index, we'll keep on advancing till the last index. So once the element is found, we get to know the index, which index it is, and thereafter we return back the index. So in the linear search operation, so we get to see that there are few inputs to the method. So we're gonna return the index of the element which is found, right? So considering the use case, right? So we are planning to have this linear search. So we'll write one small program. Let's have it with the main method. So I'm going to take the same sequence of inputs which we have been following. So this is the array, and let's say the element which you want to search is the number 10, whether the 10 is there or not. So I'll write down this static int search, or let's say this is linear search. So in the linear search, I'll pass one array and element which I want to search, right? So this is how we are going to come up with the linear search approach. So we'll get to find the index. So by default, I'm keeping the value of index as -1 and I will return the index at the end. Now you just say for int I is 0, I less than the arr dot length and I plus plus, right? So you are iterating in the entire array. So less than length is your n. Now if element is going to match the arr of I, right? So if it is going to match the arr of I, so I'm gonna say index is I, and thereafter I'm going to break the loop. So now you come here and say int found index is linear search dot linear search array and the element 10. We know where is the 10 element, right? The 10 element is at 0, 1 and 2, second index. So let us say if I is not equal to -1, we'll find the element and so this guy is found index. So let's say if the found index is not less than, not equal to -1. So we got the element. In the else case, I'll say so element plus element not found. Or the other way around, I'll say so element plus the element found at plus the found index. So this is what we got. So now when you run this code here, so it says element 10 found at 2 index, right? So it's the second index where you have this element 10. Let's say this guy has 12, you run the code, it's gonna say at 4 index, but if you try to enter something like 120, so you gonna get element 120 not found. So guys, linear search algorithm is where you begin from the 0th index and you keep on comparing till the last index, right? So the next searching technique over here with us is binary search. So in the binary search, what we're gonna do is we're gonna sort the array first, right? So we should have a sorted set of array. And when you are going to find the element, so you are dividing this array into two parts. So we're gonna divide the array as in the left side and the right side. So if you are finding some array in the binary search, right? So this is now very much simple approach what we did in a linear search, but the only thing is this, we'll be searching the element into a corresponding half. So we keep on dividing the array to find the element. Okay, so now let's say you wanna find this element number 79. So what we are going to do is we are going to take the right part of the array so as to search that element. We will not iterate into the lower half. And into the upper half also we'll keep on dividing the array again and again. So let's try to write a binary search algorithm and see how we can do a small search operation. So this is basically gonna save the time. So this is optimized on time complexity. So let me write a new class and this goes like binary search with the main method. So similar to your linear search, I'll just have this. So this is what we got over here as, let's say, static int binary search. So I'm gonna take array as input, then I'm gonna take something like left, something like right, and the last one is, let's say, the element x, so which you are going to search. Now the guy over here is gonna check whether R is greater than or equal to L. So if R is greater than equal to L, then we're gonna find the mid. So the mid goes like L plus R minus L divided by 2. So we got the mid part, and now, so I'll use recursive technique over here. So in case, so let's say if element is found at the same middle index. So I'll just keep a check that if ARR of mid is equal to this guy called X, then you just return this guy called mid. So I'll return the middle index itself, right? Now there can be the other possible use cases. So let's say if element is smaller than the middle, in case element is smaller than the middle, so it means what? Hence element shall be present in the left part of array. So element would be there in the left array, and hence what I'll do is I'll just put up a small condition that in case ARR of mid is greater than the X, the element which we are going to found. So here I will again do the binary search. So I'm gonna do again the binary search, but to do the binary search now, so I'll go with mid -1 and I'm finding the same guy X, right? So we are finding the same guy X over here. And lastly guys, so I'm gonna say return me. So return me a binary search of ARR, your mid +1, right, and X. So else the element will only be available in the right part of array. So this is the case where element shall be present in the right part of array. So if it is in the left, so you execute this, so return from here, else you come, if this condition fails, we're gonna return this part. And let's say if we reach to a stage where element is not at all available, right? So if the element is not present, then what? Then you should return -1. So let's try to come and say return of -1. So here I'm gonna perform a binary search called binary search, and you need to make sure that the array is in a sorted arrangement, right? So we'll say this array over here. So you need to sort this array first. So what I can do is I can just make it -3, 1, 4, 10, and 12, right? So that's like the precondition. Array must be sorted first. Now when your array is sorted, so let's say you need to find the element called 4, and in the binary search you pass the ARR, that's like the first thing, then you pass your 0th index. So guys, let me just take some more inputs here. So let's say the length is ARR dot length. So this is the length of the ARR, and I'll pass length -1 and the element which I want to search. So we are searching for this guy called 4. Let's give a small run on this and let's try to see what happens. So it says element 4 found at 2nd index. Let's search for 12. It says at 4th index, and when I say 120, you give a run here, it says 120 not found. So guys, this is a binary search operation. You keep on dividing your array into sub arrays to the left and to the right, and then follow that array in which your element would be present, right? So greater than or less than condition check. So this is a recursion approach through which we are solving this binary search problem. So this is what we have over here as in the binary search part.
A Java collection framework provides an architecture to store and manipulate a group of objects, and it includes interfaces, classes, and algorithm. In this figure, blue boxes refers to the different interfaces, and the gray color rectangles defines a class. So here, list is an interface, and array list, linked list, vector, all these classes implements list as an interface. Similarly, as dq is also an interface, so it extends and inherits q interface. Now talking about array list, it uses a dynamic array for storing the elements. It inherits abstract list class and implements list interface. Then list interface extends collection and iterable interfaces in hierarchical order. So this is about the hierarchy of array list class. Now let's see what is array list. Array list is a part of collection framework and is the implementation of list interface where the elements can be dynamically added or removed from the list. Also, the size of the list is increased dynamically if the elements are added more than the initial size. Though it may be slower than the standard arrays, but can be very helpful in programs where lots of manipulation in the array is required. Some key points to note here. Array list is initialized by a size. However, the size can increase if the collection grows or shrunk if the objects are removed from the collection. Next, array list allows us to randomly access the list. And array list cannot be used for primitive types like int, char, etc. To access all those, we need a wrapper class for such cases. Now let's move further and see the internal working of array list. First, we create an empty array and then go on adding the elements. Once the size of the array is full, that is, if the size of the current elements is greater than the maximum size of the array, then we have to increase the size of the array. But the size of the array cannot be increased dynamically. So what happens internally is a new array is created and the old array is copied to the new array. So by this, automatically the size will be doubled and it will be increased. So you can go on adding the elements how much you require. So that's how it works internally. Now let's see the various constructors supported by Java array list. First, array list. This constructor builds an empty array list. Coming to syntax, my array is a reference to an array list that holds the references to object of type E. Array has an initial capacity of 10 cells, although the capacity will be increased as needed as references are added to the list. And cells will contain references to objects of type E. Next, array list of collection C. This constructor is used to add all the elements of specified collection C to the current array list. That is, you can add all the specified collection C to the current array list. Next, array list of incapacity. Here, this is used to build an array list that has a specified initial capacity. An initial capacity is the number of cells that the array list starts with. It can expand beyond this capacity if you add more elements. Now let's see a small example to understand how and where these constructors are used in array list. I will open my Eclipse and first create package called Edureka. Now I will create a class called constructor. The very first thing that I do before writing the code is I will import util.star package. Now, let's begin with the code. I will first create an array list of type string. I initialize the counter value to 0 and using advanced for loop, I'm trying to increase the count of counter. But we don't have any elements present in the array list. So if I try to print the counter value, it will not retain any value. Why? Because we don't have any elements present in the list. Okay? Now, I will create one more array list and initialize the capacity to that. I'll change the name and give it as B. And I will initialize the capacity to 30. Okay? Now again, if we try to print the counter value, it will not print because we have just initialized the capacity. Again, if we try to obtain the value of counter, it won't get incremented. Why? Because we don't have anything in the list. Now, let's create a string array and add some elements into it. After creating a string array, I will create an object of array list and then append an element using add method. So let's see how to do that. So this is how I will add an element using add method. Now I will use advanced for loop to print the elements present in the array list. Now let's run the program and see what will be the output. So here is the output. As I have already told, it won't return the counter value because the array list is empty and the counter value will be automatically 0. Next, on creating a string and adding the elements, it has retrieved all the elements present in the string, even with the one that we have added. that is J2EE. So this is how constructors are used in ArrayList. Now let's dive into the various methods supported by ArrayList. First, add method. This method is used to add the elements to the ArrayList. That is, it is used to insert a specific element at a specific position index in a list. For example, you can create an array list and go on adding the elements using the add method. We will demonstrate and see all the methods of array list in Eclipse after knowing the concepts of them. Next, clear method. This method is used to remove all the elements from the list. That is, you can just use clear method to remove all the elements present in the list. Next, trim to size. This method trims the capacity of an array list instance to the list's current size. That is, if you are creating an array list of size 9 and if you're adding only 3 elements to that, on calling this method trim to size, it trims the size of array list from 9 to 3. That is, it reduces the array list size to the number of elements that it contains in the array list. Next, index of. This method returns the index of first occurrence of the specified element in the list. If that element is not present in the list, then it returns -1. Suppose in this case, if you want to return the index of 5, and if you write here 5, then it will return A of 2 because A of 1 and A of 2. But if you try to find the index of 3 which is not present in the array list, then it will return -1. That is, it returns -1 if the list does not contain the particular element. Next, object clone. This method is used to return a copy of the array list. That is, on calling this method, it clones the entire array list. So for example, if you're adding 2 elements in the array and you're cloning the entire thing, then again after clone list, it will return the whole element present in the array list. Next, object to array. This method is used to return an array containing of all the elements in the list in the current order. For example, if you have all the elements in the list, then it will return all the elements in the list in the correct order. Next, remove method. This method removes the first occurrence of a specified element from the list if it is present. For example, if you want to remove n from the added list, then it removes the first occurrence of n. If there is one more occurrence of n here, it won't remove that. Next, int size. This returns the number of elements in the list, that is the size of the list. Suppose say we have added 4 elements, then it returns the size of the array list as 4. Now let's demonstrate all the methods and see how it works and how it is used. I'll create one more class called ArrayList. Now in this example, we'll see how to add the elements. We'll create an array list of type AL, that is a reference. And we'll go on adding the elements into this. Now we have added 3 elements. Now let's try to print the size of the array and the contents present in the array. Let's execute and see what will be the output. So the size of the array list is 3 and the contents of array is Edureka, Java and arrays. Now I want to remove Java from the list. So what will I do here is I will use a remove method to remove the element from the list. Now again, let's print the size of the array list after deletions. So when you remove Java from the list, it retrieved only Edureka and arrays and the size will be decreased to 2. So this is how we can remove the element, we can add the elements and we can retrieve the size of the array list. Now let's see how to clone the array list. First we'll make clone list as an object and then call the method. Now let's execute and see how the clone list appears. So as we have already removed the elements from the list, so it returns only the elements after deletion in the clone list. So if I make whole remove part as comment and execute, then it will retrieve the entire elements present in the array list. See, that is elements in the clone list are Edureka, Java and arrays. Now let's see how object to array method works. On executing this is how the output looks. Now let's use clear method and clear the array list. It's very simple. al.clear and print the elements. After applying clear method, nothing will be present in the array. That is, the entire list will be cleared. Now let's see how to create a custom array list and add the elements, remove the elements, and retrieve the size of that. I'll create a class called custom array. Say I want to create a class of student data wherein I will be initializing roll number, name, marks, and phone number. So let's see how to do that. I'll create a class called student data and initialize the variables. Now I will create a constructor and add the reference to these variables. Now let's begin with the main method. Now let's create a custom array list and reference the variables. Using add values method, I'm adding the values. Now I will invoke this function and define it. Here I'm invoking list.add method to add the elements in the list. Now, in order to print the values present in the list, I'm invoking a function called print values of list, and here I will give the definition for that. And now let's print the values present in the list. Now let's execute and see what will be the output. That is, it displays all the elements present in the array list. That is the roll number, name, marks, and mobile number. Now, if you want to remove one of the rows from the array list, let's see how to do it using remove method. Here I will give list.remove. Now, if you want to remove the row of elements from the array list, then you can remove the elements from the list and then print the rest of the elements. So let's see what will be the output. So output is like this. First, it has printed all the elements present in the list. Then it printed the size of the list and it removed the first occurrence. When you use remove method, it removes the first occurrence present in the list. That is, it removes the first value. So it has removed the first row, that is Chris, and it retrieved the rest of the elements. So that's how you can create a custom array list and add the elements accordingly. Now let's jump into the last topic of today's discussion, that is advantages of array list over array. First, array list is variable length. Arrays are of fixed length. You cannot change the size of the array once they are created. But array list is variable length, that is, it can grow and shrink dynamically. Next, size of the array can be modified dynamically. When you add the elements into an array, the size will be increased, and if you remove the elements, the size will be automatically decreased. Next, you can add any type of the data, maybe list, union, structure, etc. Not only that, it also allows you to add the duplicate elements in the list. Next, you can traverse an array list in both the directions, that is, forward and backward directions using list iterator. And it also allows you to insert and remove the elements at a particular position. So I hope you understood the concept of array list and the difference between array and array list.
Now, when we are talking about strings, so we are basically storing the data, which is like a lot of characters all together. So we can say they are sentences now. So you want to store a character or a letter or an alphabet. So we got char data type. But when it comes to a word or a sentence or a paragraph, right? So there we look into the string. So string in Java is an object. It represents the sequence of characters, kind of word or sentence. Then if we talk about string, so it's basically a class which is used to create and manipulate the string objects. So it is in the java.lang package. So that is how we say string is a reference type, not a primitive type. Now, when we create a string, it is immutable in nature. So what is meant by immutability? It means the data which is once there in the string object, it cannot be manipulated. So manipulation for the strings we cannot do. Now, if we're talking about Java strings, right? So we can process our textual data very easily. Given a use case, so we write a sentence, so we can very easily search some words in the sentence. We can use an API like contains, which can tell whether the word is there in the string or not, right? So searching is one of the inbuilt feature in the string API. Then we can divide our string into, multiple parts. So we can say as a substring. Moving ahead, we can even create new strings out of the old strings. So for example, the quick brown fox jumps over the lazy dog. We can say the quick fox jumps and the quick lazy dog. So these are the different strings which we can manipulate our existing strings, and we can create the new string. But remember, the old string never ever changes. It's always the new string which is created, since strings in Java, they are immutable. Now, java.lang.string is a class in Java. So guys, this class is basically implementing few interfaces: serializable, comparable, and char sequence. So when we talk about the class string, it's a final class which you cannot inherit. So every class in Java will be the child of object either you create or it's a built-in class. So it implements serializable, comparable, and the char sequence. So let us see what these three interfaces will be for strings. Now, serializable is just a marker interface. Now, when we talk about a marker interface, guys, so it will not contain any data member or method. It is basically marking the Java classes so that our compiler can come to know about these classes. Now, serializable are the ones for whom we can save the state in some files. So there's a concept called serialization and deserialization. So saving the state of an object and recovering the state of an object from a file. Now, comparable is basically that if you have a string and if you want to order the data in the string, you want to sort, you want to compare. So we got some methods available with the help of which we can very easily do that. For example, a method called compare to can compare one string with the other string, whether they are equal or not. Then we got char sequence interface. Guys, this is a readable sequence of characters, and this is supposed to provide some read-only access. And the other thing is that char sequence is basically parent to three classes, right? String, string buffer, and string builder. Now, string is a class which can create textual content for us, where this guy is immutable. So we cannot change the data once it is created. So you can even say strings, they are nothing but their data or their values, they are literals and we cannot change them. But string buffer and string builder, they are again the char sequences which can manipulate the data within. So they are the mutable versions of the string. Moving ahead, buffer and builder, they are different in a way that buffer is not thread safe, whereas builder is thread safe. So my bad. Buffer is thread safe, whereas builder is not thread safe, right? So what is thread safety, guys? Thread safety is synchronization. When multiple threads they are going to access the same single object, there we need synchronization. So string buffer is built in and it is by default synchronized, but the builder is not synchronized. So that is the difference between buffer and builder. Now we'll understand how we can create strings in the memory. So strings in the memory, they are created in an area called string pool. Now when we are talking about string pool, so Java string pool refers to collection of strings which are stored in the heap memory. So in the heap area, so there would be a string pool which will be created, and as string objects are immutable in nature, the concept of string pool came into the picture. So string pool will help in saving the space for Java runtime. So let us see how string pool is gonna work for us and how it's gonna save memory for us. Now, if you wanna create a string, there are two ways. Either you can create it as a literal, we call it an interned string, or you create it with the new keyword, we call it an object, right? So let us have a quick look on how we create a string and how the string pool comes into action. So considering we are going to use literal to create a string, so guys, Java string literal is created by just writing the string literal in double quotes. So how you will do it? You will say string str is Edureka. So you need to use these double quotes. So when I'm saying str, so guys, str is basically a reference variable which is pointing to Edureka, like this. So in the string pool, we got a literal called Edureka, and str will contain the hash code for that literal, and this is how we got a relationship mapping. Now, same way, when we want to create a new string with the same name, let's say I want to write another string, but that will also be Edureka. So for that, what happens? So before creating a string literal, right? So first a lookup happens for the value in the string pool. If the same value is already available in the string pool, right? So a new string will not be created, rather the reference of that string will be returned. For an instance, if I write string str1 is Edureka, it means what will happen, str1 will also point to the same string. So literals, they are created once, they are not recreated. Same way, when I will say string str2 is welcome, now welcome is not there in the string pool. So what will happen? A new literal welcome will be created to which str2 will point. So once again, a quick review. String literals, we also call them an interned way of creating the strings. Interned way of creating the strings is where a string literal gets created into the string pool. Once a literal is created, it will not be recreated. So if you said that string str is Edureka, so we are not going to come up again for string str1 is Edureka. So it's gonna point to the same string literal. For a different string literal, we'll have a different, memory region created. So string str2 is welcome will point to a different literal, and hence the string pool. So how it is saving the memory? By creating literals once, right? So sharing of string literals, because these literals, they are the values and they can never ever be modified. They are kind of constants now. The way 10, 1, 0 is a literal, it cannot be changed. Same way, these are the literals, they cannot be changed. Now, the other way of creating a string is if you write a new keyword. So whenever you're going to use a new keyword, so it is basically going to create a new object in the heap memory. So for an instance, if I say string str3 is a new string Edureka, what's going to happen? So there will be a new object created in the heap memory. So it's like just the other objects which get created in the memory, right? So it's always a new object. It's not gonna point to the string pool now. So guys, this is the difference between how we can create a string literal and how we can create a string object. So object construction happens with the new keyword, and it is always a new object. So even if I will say string str4 is a new string with Edureka, it will be a different object constructed in the memory. Even though the contents are same, but new keyword will always create a new string object in the memory. Now we'll see some string methods. So guys, we got string class, which is a built-in class, and we will be exploring these methods. What are the built-in methods? We will also try to explore them practically. But let's first of all have a look on the list. So we got this method called equals, which will check whether the given string is equal to the other string or not. So it's comparing the contents in the string. Now equals ignore case will ignore the case, right? So whether the uppercase or the lower case, it won't matter for us. Length returns the length of a string. Then we can get the character at any index. Now string is a collection of characters, so they are indexed internally from 0 to n-1. So char at, you pass the index and you'll get the character at that index from the string. To uppercase returns the string in the uppercase. Lowercase will generate a lowercase string. Then replace can replace an old character with the new character, and thereafter a new string can be constructed. So remember, whenever we are manipulating the strings, whether the intern strings or the non-intern strings, we are always getting a new string. Now trim is a method which is going to remove the white spaces from the beginning and the ending of the string. Then contains method will give a quick check. So it's gonna search whether a string is existing in a string. So part of string exists in a string or not. To char array, so we can get our strings converted to the character array by calling the method to char array. Then we got is empty to check whether the string is empty or not. Ends with, so we can check that whether the string ends with a specified suffix. For example, you wanna generate an application where you wanna list all the images. So you are writing a file explorer app. You wanna read the files and you wanna check whether their extensions are .jpg or .png. So we got ends with, right? Then similar to the ends with, we even have starts with. Then we got concat, which can concatenate the two strings, right? So it's like appending the strings and regenerating a new string. So guys, let's have a small demonstration on string methods. So I'm gonna create a new Java project. So let us name this as strings demo. So here I'm going to write a class. Let's say strings, Java strings. I'm going to say a q.edureka as a package with the main method. There are two ways to create a string. So I will say string str1 is hello, right? So this is known as interned way, or we can say string literals. So where are they stored? They are stored in string pool, right? Now I will say string str2 is also hello. So guys, str1 and str2, they are two different reference variables, but they are pointing to the same literal hello. str1 and str2 reference variables pointing to the same literal. So as we saw in our string pool example during the presentation part. Now, if I'm going to compare these strings, if I will say if str1 is equal to str2, so here I'm gonna say str1 equal to str2. In the else case, I will say str1 not equal to str2. So what are we comparing here? We are not comparing content that is hello. So what we are doing here? So we are comparing hash codes of str1 and str2. Hash codes in str1 and in str2, which will be same for the string hello. Now literal is created once, right? So str1 as a reference variable and str2 as a reference variable, they are pointing to the same string hello. So we are comparing the references here. So when I will run this code, what you will get to see is that they are equal. Now, the other way around is where I'm going to say string str3 is a new string of hello. So what is this? This is known as object, string object. That is, we used new operator. So here string object is constructed in heap area with hello as its contents. At the same time, when I will say string str4 is new string hello. So guys, what has happened? str1, str3 and str4 are reference variables which are pointing to two different objects whose content is same. Now that is something which we need to understand. So we are basically having these two different strings, two different reference variables, which are pointing to two different objects whose content is same. So when we are going to compare str3 and str4, we are not comparing the content, we are again comparing the hash codes in str3 and str4, which will be different for the string object containing hello. So you see there's a difference now, right? So if you will compare 3 with the 4, so when I'll compare 3 and 4, you will see it is not equal to. So this is the first proof of concept, and as a conclusion, we understand equals to will compare reference variables, that is hash codes, and not the real content, that is hello. So equal to is comparing the references, it's not comparing the content. And we also saw that if we have a literal, if we create a string literal, so there we get to have the same reference for the same string. So str1 was compared, but str3 and str4 were not compared. So how we should compare, right? So how should we compare strings? There are two ways. The first way, I'm going to write here that if str3 dot equals str4, so that's like the equals method, it's gonna return me the true or false. So I'm gonna say str3 is equal to str4, and the else part where it is not equal to str4. Now when you run the code, you see it is equal. So remember, if you wanna compare the strings, right, so that is the content within, right? So you want to compare the content within, you never ever use equal to operator, because equal to operators is working, it is working only on the reference comparison, where equals as a method is comparing the content within, right? Now the equals method is one thing, the other thing is compare to method. You can say if str3 dot compare to str4, and if this gives me 0, right? So this is a comparison, str3 compared to str4. In the else case, I can just say str3 not compared to str4. So let us run this code here. So compared to str4 and is equal to str4. So this is what we got, guys, right? As in the two different, if else structures, how we can compare the strings. Now let us explore some string APIs. So more on string APIs. So some string methods to begin with. Let us create a string called str, which is John, Jenny, Jim, Jack, Joe. So we got this string John, Jenny, Jim, Jack, and Joe. And what I'm going to do here is, so I will say the first thing, we'll get the length, right? So I'll say int length is str dot length. So we can say CISO length of str is plus the length. Now when I run the code here, you see it gives us the length as 28. So when I get the length as 28, now there are characters, right? So I can just come here and say str dot char at 0 plus a bar plus str dot char at length minus 1. So when you run the code, so even before I run the code, so I'll just print out the str. So let's say str is plus str. So I'm just gonna print the string. So it says str is John, Jenny, Jim, Jack, and Joe. Length is 28. The character at 0 is J, and the character at length minus 1, that is 28 minus 1, 27, is E. So string starts with the 0 and goes till n minus 1, that's like length minus 1. Now considering, I will say str dot to uppercase. I will say str now or str after uppercase is plus str. So we are very simply trying to say that I want to convert the string to uppercase. But when you run this code here, you see that string is not manipulated. So here we see no changes, right? So why we didn't see any change? So reason is that strings are immutable. So when you run this code here, so you see no change. String remains the same. So what exactly is happening here? So you are getting a new string, let's say S1. So you're getting a new string generated, and when you will say see, so S1 is plus S1, so you run the code here, you see that S1 is manipulated. A new string is created. So guys, whenever we are talking about string manipulation means a new string will be generated, but old string will not be modified. So that brings in the first understanding that strings are immutable. They cannot be changed. We cannot modify their content. Now the next part. So the way we got to uppercase, in a similar way we got to lowercase. So I can search in the string. I can say if str dot contains John, right? Or let's say not the John, let's say Jim. So Jim is somewhere in between. So I'll simply come here and say Jim is in the string. You run the code now. It says Jim is in the string. So contains method will help us to check whether a string is there, a substring is there in the string or not. Now considering you want to break the string into a small string, we can use a substring method. I can say string s2 is str dot substring from the index number 5. So this is 0, 1, 2, 3, 4, and 5 index is this space, right? So I will say CISO S2 is plus S2. You run the code. Now what you see is that the guy John is trimmed off from the space till the end. We got a new string. So this is known as a substring. A substring, you mention the index. So till from 0 to 4, string will be removed, and there onwards, 5 onwards, you get a new string. So even I can say string s3 is str dot a substring. You go from 6 till let us say 10. So let us see what we will get in S3. So I'll say S3 is plus S3. So when I run this code, you see it is saying JENN. Now what is 6? Let us see here, guys, right? So 0, 1, 2, 3, 4, and this 5. Till here we got the 5 index. So start with 6. 6, 7, 8, and 9. So 10 not inclusive, right? So what is this? So starts with 6th index and till 9 index, right? So it's like that is less than 10. So that's like substringing. So we can have a string. So we can even replace the characters here. So what I can do is I can say string s4 is str dot replace the character j with the character k. So remember, always you will get a new string, right? So now if you say S4 is plus of S4. So if you run this code here, you see Con, Canny, Kim, Cac, and Co. So instead of John, Jenny, Jim, Jack, and Joe. Now the next part here, I will try to now get all the characters from the string. So I will create a char array char, which is str dot to char array. So I have just converted the entire string into the array of characters. So I got the array of characters from the string. Now I can say for char ch in char, so putting up an enhanced for loop. So I'll just do a print, not the print line. And I'm going to print the ch along with some space. That is what I'm going to do. So lastly, I put an empty print line. So when I run the code here, so you see the string with the space coming in. So this was read as an array of characters. So we got array of characters coming in. Now let us take one of the use cases where I want all these names pulled out of this string. That is like str. I want to pull all the names from this string. So what I can do is I can say a string array. So let us say str. So we will say str dot split on the basis of comma. So we need to put in a pattern on the basis of which we can split the string. So thereafter I will say for string s in str. So I'm gonna do a CISO on s. So when you run the code here, what you see is that we got all the strings coming in. But here we can see some space in the beginning because we got a space in the beginning after this comma, right? So if you want to remove the space, you can just call the method called trim. So trim is going to remove the space in the front or in the end, beginning or ending, right? So now you see there is no space. So splitting will help us to get the strings out of the string on the basis of some pattern, right? Some pattern. Now moving ahead, I'm gonna write a string called email, which is like john at some example.com, and string like let's say phone, which is some phone number, let's say 9999 and thereafter 8888 and 8. So some string, right, for the phone number. And let's say there is a password. So for this, the password goes like password 123. So this is data during registration, right? So while we are registering the user, we are going to have this data from the user. So you want to validate the data, right? So we would like to validate the data from user. That is whether the data is correct or not, right? So I can simply come up and say if email dot is empty. So I'll put a not here. So if email is not empty, right? So I can say CISO email is available. Other than in the else case, I can say CISO please provide an email. Now if email is not empty, email is available, there can be even one more check, that if email dot contains @ and email dot contains a dot operator. So if it is containing, then it's a valid email, right? So if I'll put a not here, it means that if anything is missing, I can simply say email is available, but email is not a valid email. In the else case, I can say CISO email is a valid one. So this is how we can use our string operations to check whether we get the correct string from the user or not. So when I run this code here, it says email is available, email is a valid one. So if you don't put the email, so let's say email is empty here and you run the code, so what you see is that email over here is not provided, so it says please provide an email. So same way, if you write an email with missing of @, so it says email is available, All right, so I think here I just need to put a check. Email contains, so it should contain this and this, right? So email is available, but the email is not a valid email. So we can put some conditions and check whether the data is correctly formed or not. At the same time, I can simply come here if phone dot is empty. So if phone is not empty, right? Same way the else part. So please provide a phone number. So here what we can do is we can say phone number is available, and I can put one more check if phone dot length is, let's say, not equal to 10. So we are looking for a phone with the length as 10, right? And the else part. So I can say CISO phone number is a valid one, right? So here I can say, but phone number is not a valid number. So similar validations, right? It says phone number is available, phone number is a valid one. So you miss out the phone number here. You run the code. It says, please provide a phone number. So you can get the things in order, guys, right? So if the length is not 10, it says phone number is not a valid number. So we are putting some validations here. So same way you can put it on password. Now, all these discussions which we have done, so we are concluding one thing, that strings are immutable. So it means what? If I create a string, let's say string is a new string, and I say hello here, and thereafter I will say string dot concat a space and a world, right? So concat is to append. So we can even append the data like with the plus operator. So that will also append the data. Now I will say CISO string is plus the string. If you run the code here, it is just hello. So this brings up the conclusion that strings are immutable. We cannot change them. So it is always a new string which will be constructed if you are going to do a concatenation. Now we got a version called string buffer. So here I'm going to say hello. Now buffer and strings, they are similar. So we will use append instead of concat, right? So here I'll say world, and now when you will say CISO, buffer is plus the buffer. So what you will see is that in case of string buffer, string is appended. So data is manipulated in case of string buffer, but not in case of string over here. So this brings out that in case you want to manipulate the data in the same string, right? So we got this guy called string buffer, which is mutable. So mutable sequences of the string, they are known as string buffer, as well string builder. So the way you got buffer, in a similar way we have string builder. The only difference is that builder is not thread safe, whereas buffer is a thread safe structure. So the output shall be same for both of them, and the usage is also same. So I will say builder is plus the builder here. So you run the code. So you see buffer and builder, they work same way. The difference is that buffer is thread safe, whereas this guy is not thread safe. So guys, all the three versions like string, string buffer, or string builder. So we are very well aware with the you see strings now. So we also understood what we need to do in case we need to use the mutable sequences. So all three, they implement char sequence. It means the reference variable to the char sequence, let's say CS, it is, let's say, null. So CS can point to a string, let's say hello. CS can also point to a string buffer, let's say awesome, and CS can also point to a string builder. So that's like bye. So that's like runtime polymorphism, right? So this is like runtime polymorphism in action. So this is what we got as in the strings, where strings, they are immutable. If you want mutable versions, you go with the buffer and the builder. Guys, we got many more APIs in the string buffer and string builder. So explore more from here. So I hope this entire content is clear to everyone.
What is an interface? In simple words, an interface can be defined as anything which shares a boundary between two components. In case of computers, it separates two systems and acts as a boundary which helps in data exchange. Now, what is a Java interface? A Java interface can be defined as an abstract type which stores the methods and helps other classes to implement the behavior of the methods which an interface actually stores. Now you might get a question. We have interface for that? Yeah, absolutely. With this, we begin our next question, why we need interface. We all know that Java supports inheritance. But when it comes to multiple inheritance, Java cannot support it. It ends up facing ambiguity between two parent classes and fails to provide the required result. This particular problem is called as diamond problem. Here, as you can see, there is a superclass, and this superclass is being inherited by two classes called as class A and class B. Now, we are trying to inherit the properties of class A and class B into a new class which is class C, which practically seems impossible in terms of Java. Now the question would be, is it seriously impossible to do it? That's when the interface comes to the picture. Using interface, we can achieve multiple inheritance. Here we are inheriting one class and implementing the behavior of another class. Confused? Let me explain with a little example. Let us consider an airplane which requires both the properties of carrying huge cargo and passengers. Let us assume we have two planes. One is capable only to carry passengers and the other one is capable only to carry cargo. Now we need to carry both passengers and cargo in one single plane, which seems to be impossible on the basis of how the Java works, as it feels it cannot access the properties of two different parent classes at the same time. But you can make it possible by making Java feel that it is inheriting one plane and implementing the methods present in the other one. It is like building a commercial plane which takes both the passengers and cargo luggage. Interface is like making a bigger plane which could do both the tasks without interfering with the components of one another, instead just borrowing the methods which are present in the interface class. Now let us get practical. First, let us understand what was the problem in multiple inheritance. Here, I have defined the first class, class A, and then the next class, which is class B, and finally the class C. Here I am trying to inherit the properties of class A and class B together in the class C by using extends keyword. As you can see, the editor is throwing an error which says that it is not possible to inherit the properties of both the classes. Now let us find the solution for this. The solution is none other than using an interface. Here in this solution, I am creating an interface. I am having the same messages which I had in my earlier example, both the messages present in class A and class B. And similarly, I have also defined the interface which has both the methods, hello and welcome. Now let us run this program and see how does it work. As you can see, it is accessing both the methods and printing the message present in both the classes, class A and class B. Now let us try a different example. In this example, I am declaring 4 methods: addition, subtraction, multiplication and division. Now let us enter into a class. Here I'll be trying to access all the 4 methods and print the output. Now let us try to run this program and see how the output appears. As you can see, the program has been successfully compiled and now it is asking for 2 integer values to perform the first operation, which is addition. The output has been successfully generated and now it is asking for 2 more integer values to perform subtraction. The difference is been displayed. Now it is asking for 2 more integer values for performing the multiplication operation. The output is clear. Now let us perform our final operation, which is division. As you can see, we have our result here. Now let us understand the interface nesting. As you can see, I have nested an interface by the name inner interface inside another interface which is the outer interface. And then I am trying to generate a Fibonacci series using the method which is present in the inner interface, which is none other than the inner method. Using this method, we will be generating the Fibonacci series. Let's try to run the program and see the output. As you can see, we have our Fibonacci series printed here, and this process was being executed from the nested inner interface method. Now let us try to see an example for nesting by nesting an interface inside a class. Here, I have nested an interface called Edureka interface inside a public class which is Edureka class. And inside the Edureka interface, I have a method called nested method using which I'll be performing a string reverse operation. Let us execute this program. As you can see, the string I have provided is Edureka, and after the operation, you can see the string has been successfully reversed. Now let us have one short quick revision about how to declare an interface. So this is the syntax for declaring an interface, where you will be using an interface keyword followed by the name of your interface, and inside the interface you can declare your methods. By default, all the methods which you declare in interface are considered to be public. With this, let us find out the few differences between class and an interface. The first difference is multiple inheritance. Interface was designed to provide multiple inheritance, where on the other hand, classes cannot. The next difference is data members. Interface does not have data members. All it includes is methods, which decrease the probability of confusion during the implementation process. On the other hand, classes include data members, which mean to say that the user must be careful while using the data members to avoid ambiguity. The next difference is constructors. Interface does not have constructors, while on the other hand, classes take up the advantage by including them, which will help them to set the values to the members of an object. And the next one is complete and incomplete members. Interfaces comprise of only methods, which make them have only the signature methods in them. While on the other hand, classes include both data members, which are also called as abstract members, as well as methods, which are known as signature members. The next one is access modifiers. Interfaces does not have access modifiers. By default, interfaces take up public as their access modifiers, whereas classes provide private access modifiers which are not available in the interface. The next one is static members. Interface cannot have any static members, whereas class has all its members as static. With this, let us get into the major advantages and disadvantages of interface. First, let us begin with advantages. We can achieve multiple inheritance in Java. We can easily break up complexity and enable clear dependency between the objects. We can achieve loosely coupled applications through an interface. Don't just be on the bright side, interfaces have some disadvantages as well. Java interfaces make the application slower when compared to the competitors like Python, which support multiple inheritance. The next one is, once an interface is included in an application, it might be used once in a while, or it might end up being used multiple times at a larger scale. With this, let us discuss about the key points about Java interfaces. The first one is, can we instantiate an interface? Well, we cannot create an object of an interface. Hence, we cannot provide instances in an interface. The next one is abstraction. The major key advantage of interface is abstraction, because none of the methods declared in an interface have a body. The next key point is implementing an interface. The keyword implement is used in a class to implement the methods of an interface. The method in an interface must be provided with an access modifier as public. By default, the methods declared in an interface are also considered as public. Class must implement all the methods declared in an interface, or else it must be declared in an abstract class. Let us see an example about implementing an interface. Here I have defined an interface and declared two methods into the interface, method 1 and method 2. The first method is used to find out a square root of the given number, and the second method is used to print a message. Now let us try to execute this program. As you can see, it is asking for an input. Now let us provide a number to find out its square root. As you can see, the square root of the given number is 4. Now let us try to execute a different example where we'll be implementing the methods from two different interfaces. As you can see, this is my first interface, and here my first method is to find out whether a given number is an Armstrong number or not. And later, let us see a second interface where I have declared a method to find out if the given number is prime number or not. Now, let us try to execute this example and see if the program can implement both the methods from two different interfaces or not. As you can see, the class Edureka2 has successfully implemented both the methods from interface 1 and interface 2 and displayed the output. I have given 3 as the input for finding whether it is prime number or not, and the result is it is a prime number. Similarly, I have given 153 to find out if it is an Armstrong number or not, and the program provided the output as it is an Armstrong number. With this, let us continue with the key points. The next one is access modifiers in an interface. Interface can be declared as private, protected, and transient. All the interface methods by default are abstract and public. Variables declared in an interface are public, static, and final by default. Interface variables must be initialized at the time of the declaration, otherwise the compiler will throw an error. Inside any implementation class, you cannot change the variables declared in an interface. Let us discuss each one of these points practically. Here, I have defined an interface by name try. Here, I am trying to declare an integer type variable a using int a is equals to 10, which is valid. And similarly, you can do it by using an access modifier public, which is same as the previous one. And you can also declare this variable by using public access modifier and making it as static and final. The variable can also be declared by using final keyword and also the static keyword. All the above stand the same. Now let us see the next point which we discussed in our access modifiers. We discussed that the variables which we declare in an interface must be assigned to a value. Here I am trying to declare an integer type variable x without assigning it to any value. Now let us try to run this program and see if there is an output or not. And I'm trying to access the same x here in the main class, and let's execute this program. As you can see, there is an error, which means that we were supposed to assign a value to the variable which we declared in the interface. With this, let us move on to our next stage of key points. The next one is extending an interface. An interface can extend any number of interfaces but cannot implement them, whereas a class can implement any number of interfaces. If there are two or more same methods in different interfaces, then the class can implement all the interfaces, but one single method is enough to perform the operation. A class cannot implement two interfaces that have methods with same name but different return type. The major advantage of using an interface is that variable name conflicts can be easily resolved by using the interface name. Let us see this practically. As you can see, here I have defined an interface A with the method display, and similarly, I have also defined an interface B with the same display method inside it. Now I am trying to implement both the interfaces A and B in my class same, and I am trying to access the display method. Let us try to execute this program and see if this runs or not. As you can see, the program has been successfully compiled and the output has been generated, which says displaying data. Now let us discuss the next point. Here I have defined an interface A which has the variable x of integer data type storing the value 1000. And similarly, I have also defined another interface with name B which has the same variable x with storing different value. Now in my main program, if I try to access the variable x, then it might provide me an ambiguity. But if I use the interface name, then I can successfully access both the variables and display the data present in them without facing any of the ambiguity. Now let us execute this program and see the output. As you can see, the value of x in the first interface A was 1000, which is displayed here, and the value of x in the second interface, which is 2000, is also being displayed here. I have used the interface name A and interface name B in the print statement provided here.
Let's understand what are data structures in Java. A data structure is a way of storing and organizing the data in a computer so that it can be used efficiently. It provides a means to manage large amounts of data efficiently. And efficient data structures are key to designing efficient algorithms. Next, we have two types of data structures, that is linear and hierarchical. So what is linear data structures? Linear data structures are those whose elements are sequential and ordered in a way so that there is only one first element and has only one next element. There is only last element and has no previous element, while all the other elements have a next and a previous element. Understood? Like you can have only first and a next element, and there is only last element but has only one previous element. So there cannot be any multiple previous elements or multiple next elements. Okay? But all the other elements have a next and a previous element. Note that there is only one previous and next elements. Simple. So based on these categories, linear data structure are being divided into stack, queue, and linked list. Now talking about the stack. Stack is an abstract data structure. It is a collection of objects that are inserted and removed according to the last in first out principle, that is LIFO. Objects can be inserted into a stack at any point of time, but only the most recently inserted, that is the last object, can be removed at any time. So you can see here, this is a bottom element and this is a top element. When you push the element into the stack, it goes into the bottom. And the last element, that is the top element, can be popped out. So once the top element is popped out, the next element which is available in the stack can be popped out. But the bottom element cannot be popped out first. Understood? So this is how it works. That is, it is an ordered list in which insertion and deletion can be performed at only one end, that is the top. It is a recursive data structure with a pointer to its top element. It supports two fundamental methods, that is push, that is you can insert the element to the top of the stack, and pop, remove and return the top element onto the stack. So if I have to give you an example, it can be reversing a word to check the correctness of a parenthesis sequence, implementing back functionality in browsers, and many more. Now let's see a small example of stack. So I have created a class called stack, and the maximum capacity of the stack is 1000. And as I told, we need an element called top, right? Because it's a main thing. So that's the reason. And then I'm initializing the maximum size of stack. So there are two conditions. First is empty. So if the stack is empty, then return top less than 0. Because there is no element in the top. When stack itself is empty, then there is nothing, right? That's the reason. And then I'm creating a constructor for stack and initializing the top size to -1 because nothing is there. Next, what I'm doing, I'm pushing the element into the stack. So if top is greater than or equal to maximum size -1, then print stack overflow. Return false. Else, insert the element to the top of the stack and initialize it to the variable, that is x, which is this one. Next, say that, so this element, which is the element that you have inserted into the stack, is pushed into the stack. Okay. Then return. Then again I'm creating a method called pop. That is removing the element out of the stack. So if top is less than 0, then say stack underflow. Else, int x is equal to delete one element from the stack, that is a of top minus minus. Then return x. Again, I'm creating one more method called peak. If top is less than 0, then say stack underflow. Else, return the element at the top of the stack and return send it to x. That is the element which you have taken it over here. Simple. Now I'm writing a driver code, that is the main method. I'm initializing a stack and creating an object of a new stack and sending elements push 10, push 20 and push 30. And then when all these elements are inserted into the stack, if I want again, I can, say push 40. So when I use s.pop, so what do you think? Will this element will be popped out first or this element? Obviously this element, right? So now let's run and check for the output. So you can see first 10 was pushed into the stack, 20 was pushed, 30 was pushed into the stack and then 40. But when I used s.pop, the last element was popped out. So if I don't have this element, I'll just save this. Now see, the last element, which is 30, is popped out from the stack, right? So this is how you can execute your stack, and these are the operations that is performed on a stack. So this is how it works. Now talking about the next data structure, that is queue. Queue is also another type of abstract data structure. Unlike a stack, the queue is a collection of objects that are inserted and removed according to first in first out principle. That is, elements can be inserted at any point of time, but only the element that has been in the queue the longest can be removed at any time. So you can see here it has two ends, that is front end and back end, that is the front end and the rear end. So if you insert an element, it goes to the front and that can be popped out, that is removed. But in case of stack, it is last in first out. In case of queue, it is first in first out. It supports two most fundamentals, that is NQ and DQ. NQ means you have to insert the element at E, that is at the rear of the queue. And DQ means remove and return the element from the front of the queue. So whatever element you insert at the rear end will go to front as soon as you insert it more, right? So simple, that can be taken off from the queue end. So queues are used in the asynchronous transfer of data between two processes. That is CPU scheduling, disk scheduling, and other situations where resources are shared among the multiple users and served on first come first served basis. So these are some of the situations where queue can be used. Okay. So now let's take an example and understand how it works. So this is very simple. I have created a class called queue, and I'm creating a string of queue and assigning it to a linked list. So what I'm doing is I'm using queue.add, and I'm adding all the 4 elements and then displaying the elements present in the queue. So when I say queue.remove of 3, it will display the elements present in the queue and the queue size, and says whether it contains the element 2 or not. If yes, it displays that. Let's run and check the output. So first, when I print this, it displays the size. And let me tell you one thing, this is an inbuilt function. So that is the reason when I'm using add, it is being added automatically. So then what I did, I removed the element 3. So you can see here I can remove any element. It's not that the element which is there at the last or the element that is there at the top or nothing like that. You can just remove the element from any corner. And then when I remove the element and I print the queue, it says only the remaining elements, that is 1, 2, and 4. Next, queue sizes, queue.size, that is 3. And then whether does it contain the element 2 in the queue? Yes, true. If I say element 3 in the queue, it should say false because I have popped it out, right? So let's see what it says. It says true because initially in the queue it was present. So if I now say element 5, then run. So when I say queue.contains 5, it should say false because it's not there in the list, right? See, it's telling false. So this is how you can perform the operations on the queue. The next data structure is linked list. A linked list is a linear data structure with the collection of multiple nodes where each element stores its own data and a pointer to the location of the next element. The last link in a linked list points to null, indicating the end of the chain. Element in a linked list is called a node. the first node is the head and the last node is a tail. So there are three types of linked list. One is singly linked list, that is unidirectional, where it contains only the information of the next node. So when it comes to doubly linked list, it contains the information of the next node, also the pointer to a previous node. And when it comes to circular linked list, head points to a tail and the last node points to the first element of the first node. That is, the last element of the last node points to the first element of the first node. So if I have to tell an example, so imagine a linked list like a chain of paper clips and they are linked together. You can easily add another paper clip to the top or bottom. It's even quick to insert to one in the middle. All you have to do is you have to just disconnect the chain at the middle, add the new paper clip, then reconnect the other half. A linked list is a similar way of doing all these operations. Let's take a small example and understand this in a better way. So I have created a class called linked list example and node head is the head of the list. And I have created a class called static node. The inner class is made static so that main can access it. That is, the main method can access it. So I have the data and the next node. And the constructor for the node is int d because data is equal to d and next should be assigned to null. Now the next step is to insert a new node. So for that, what I'm doing, I'm creating a static method for linked list example and I'm inserting linked list example list and int data. And I have to create a new node with the given data. So what I'm doing, I'm creating a new node with the data and assigning the next node to null because that is mandatory. So if the linked list is empty, then make the new node as head. So if linked list is empty, that is if list.head is equal to null, then make the new node as head. That is new node is equal to head. Else traverse till the last node. That is node last is equal to list.head. And then insert the new node. Again, insert the new node at the last node. And finally, you have to return the list by head. Okay. Now, this is a method to print the linked list. So current node is equal to list.head. And the linked list contains the elements that is being present in the current node and the list that is already being inserted. So when I have to traverse to the linked list, I'll check whether current node is not equal to null. If it is not equal to null, then print the data at the current node using the statement. Or else go to the next node. In the main method, I'm creating an object of a new linked list and I'm inserting the values into the list in sequence. Then finally, I'm printing the list. Okay. So now let's run and check the output. So see, the elements are being inserted in the sequential order. So this is how it works. So this was all about the linear data structures. Now moving further, we have hierarchical data structures which comprise of binary tree, binary heap and Hashmap as well. So binary tree is a hierarchical tree data structure in which each node has at most two children, which are referred to as left child and the right child. Each binary tree has a group of nodes, that is root node, left subtree and the right subtree. The root node is the topmost node and often referred to as main node because all the other nodes can be reached from the root. And left subtree and the right subtree is also a binary tree. And binary tree can be traversed in two ways, that is depth first traversal, that is in order, pre-order and post-order, and breadth first traversal, that is level order traversal. And the complexity is big O of n and the maximum number of nodes at level L is 2 raised to the power L minus 1. And binary search applications include, it can be used in many search applications where data is constantly entering and leaving, also as a workflow for compositing digital images for visual effects, used in almost every high bandwidth router for storing router tables, also used in wireless networking and memory allocation, also used in compression algorithms, and many more. So this is all about the binary tree. Now talking about the heap, it's a complete binary tree which answers to the heap property. In simple terms, it is a variation of a binary tree with the properties like: a tree is said to be complete if all its levels except possibly the deepest are complete. The property of the binary tree makes it suitable to be stored in an array. It follows heap property, that is, a binary heap is either a min heap or max heap. Min heap is for every node in a heap, node's value is lesser than or equals to value of the children. Maximum binary heap is for every node in a heap, the node's value is greater than or equal to values of the children. And popular applications of binary heap include implementing efficient priority queues, efficiently finding the k smallest elements in an array, and many more. The next concept is hash tables. Imagine that you have an object and you want to assign a key to it to make searching very easy. To store that key value pair, you can use a simple array like a data structure where keys, that is integers, can be used directly as an index to store data values. However, in cases where the keys are too large and cannot be used directly as an index, a technique called hashing is used. In hashing, the large keys are converted into small keys by using hash functions. The values are then stored in a data structure called a hash table. A hash table is a data structure that implements a dictionary ADT, that is a structure that can map unique keys to values. In general, a hash table has two components, one bucket array and the hash function. A bucket array for a hash table is an array A of size n, where each cell of A is thought of as a bucket, that is the collection of key value pairs. The integer n defines the capacity of the array. Next, hash function. It is any function that maps each key k in our map to an integer in the range 0, n-1, where n is the capacity of the bucket array for the table. When we put objects into a hash table, it is possible that different objects might have the same hash code, and this concept is called as collision. To deal with a collision, there are techniques like chaining and open addressing. So these are some of the most basics and frequently used data structures in Java. Now that you are aware of these, you can start implementing them in your Java programs. So I hope you understood the concept of linear and hierarchical data structures.
What is linked list? A linked list is considered as a data structure similar to any other data structure like arrays, stacks, and queues. The linked lists have three major parts: head, tail, and node. Every node in the linked list is interconnected using the address of the next node. Before we get started with the linked list, let us understand the terminology of array. Before using an array, we actually reserve the memory blocks in the memory to store the data in order to process them. For example, I have reserved an array of integer data type and I'll be storing 5 elements into it. The name of my array is myArray and the addresses for the array are 0, 1, 2, 3, and 4. So now let us try to add the elements into my array. The first element is 10. As you can see, the first element is stored in the index 0 of my array. Similarly, I'll try to add 4 more elements into my array, which are 20, 30, 40, and 50. As you can see, the data is being successfully inserted and the insertion order is being secured. Each and every element is being inserted into the array in a sequential order, and now we can access them using their index numbers. But in case of linked lists, this doesn't happen. Unlike arrays, they do not work with the completely reserved sequential collection of memory. Instead, they choose the random blocks from the heap and store the data into it and provide access to the data whenever needed. The best part is, once the use of linked list is done, and if you won't need it, then you can actually dump the memory blocks back into the memory heap, which makes them reusable. Once you provide the data into the linked list, it will borrow the particular number of memory blocks from the heap based on the data type you provide. For example, 2 or 4 bytes for each block of an integer data type, and 4 bytes for each block of a float data type, and 16 bytes of data for each block of double data type, and so on. Each block it selects will have a memory address along with it and a space for data to be stored. Once the data is stored, then the last memory block will replace the address with a null value which indicates the end of the linked list. Using the interconnection between the nodes, the linked list behaves like an array and displays all the data in the form of a sequence. Now that we have understood what exactly a linked list is, let us discuss about the types of linked lists. The linked lists are majorly divided into 3 types: the singly linked list, the doubly linked list, and the circular linked list. A singly linked list is a standard linked list which mainly consists of 2 fields: the address space to store the address of the next node and the block for storing the data. As you can see, this particular node is the head node and this particular node is the tail node. This is the block which stores the address of the upcoming node, and this block stores the data. We can traverse in one single direction in a singly linked list. The next one is the doubly linked list. The doubly linked list is completely similar to a singly linked list, but the only difference is that the nodes in the doubly linked list have 3 fields, namely the address node for the next upcoming node, the memory block to store the data, and finally the block which stores the address of the previous node. As you can see, this particular node is the head node, this particular node is the tail node, and these nodes are the intermediate nodes which are lying in between the head node and the tail node. As you can see, this particular block of this node is pointing to its previous node, and this particular block of this node is pointing to the upcoming node. And this particular block is designed to store the data which you provide into it. This makes the doubly linked list traverse in both directions. Now, let us move into circular linked list. The circular linked list is a singly linked list, but the only difference is that the final node address block is not ended with a null value. Instead, it points to the address of the head node. As you can see, in this particular linked list, the address of the first block is pointing to the next one, and the next to the next one, followed by which we will reach the tail node. In the tail node, the address here is not null. Instead, it is pointing to the address of the head node. That's what it makes as a circular linked list. Now, let us discuss some important features of linked list. The important features of linked lists are: first one is Q and DQ interface. The linked list implements Q and DQ interface. Therefore, it can also be used as a queue, DQ, or a stack. The next one is it can contain all the elements including duplicates and null. The third one is linked list maintain insertion order of elements. The next one is Java linked list is not synchronized. That means in a multi-threaded environment, you must synchronize concurrent modifications to the linked list externally. We can use collections.synchronizedList to get synchronized linked list. Linked list class does not implement a random access interface, so we can access elements in a sequential order only. We can use list iterator to iterate the elements through the list. Now that we have understood the features of the linked list, let us move into the methods that we can use in the linked list. There are more than 40 methods that we can apply in linked list, but here, to save time, let us discuss the crucial methods required to actually work with linked lists. Here, as you can see, I have used the linked list method which is provided in Java, and I am creating a linked list. And then I am trying to add the string type values into my linked list using the link.add method. And finally, we shall also use collection method which is previously described in Java to add few more elements which are of string type into our linked list and try to append them in the tail section of the linked list. Let us try to execute this program and see how does it work. As you can see, the output is being printed here. The first data which we tried to insert into our linked list was welcome to Edureka. And after that, we tried to append the data of string type into the end part of our linked list, which happens to be the tail. And the linked list after appending the string data type at the last is welcome to Edureka, an online technology training center. Now, let us try to insert the data at the head part of the linked list. So in this particular program, I'm making use of the linked list method, which is previously described in Java, and I'm adding the elements welcome and Edureka, which are string data type, into the linked list. And in the next section, I'm using collection method, and I'm adding few more elements into the linked list at the head section of the linked list. Now let us try to execute this program and see how does it work. As you can see, the output has been successfully generated, and the data of the linked list before appending the data to the head section was welcome Edureka, and after appending the data to the head section, we have welcome to the most popular online technology training center, Edureka. Now let us execute add method. In this particular method, we are just appending new elements into the linked list. Similar to the previous methods, I have created a linked list using the linked list method, which is previously programmed in Java, and I'm trying to add up the elements into it. As you can see, in this first section, I'm having few elements called hello world message from Edureka, and after that, in the second section, I'm trying to add two new elements, which are new and element. Let us try to execute this program and see how does it work. As you can see, the output has been successfully generated, and the linked list before appending the new element to it is hello world message from Edureka, and after appending the new element, we have hello world message from Edureka and the new elements, which are new and element. Now let us try to append the data using add method by using the index followed in the linked list. As you can see, in this particular example, I am trying to add two new elements, which are you and welcome, at the index locations 2 and 4 respectively. Now let us try to execute this program and see how does it work. As you can see, the output has been successfully generated, and the output before adding two new elements are how are to Edureka. Here, I'm adding you and welcome into this particular linked list in a designated location, which is 2 and 4. So after adding two new elements, this particular linked list is making a sensible statement, which is how are you and welcome to Edureka. Now let us try to execute clear method. As you can see, in this particular example, I have created a linked list, and I have also added some elements into the linked list, which is Edureka Online Training Institute. After that, I'll be clearing the linked list using the command list.clear. Once after I clear the linked list becomes completely empty. After that, I'll be using the add method again to add up new elements into the linked list. So now here, the linked list will be completely erased in the first half, and after that, once if I try to insert new elements into it, then it will take up the new elements and add them into the previously existing blocks without having the previous data in the linked list. Now let us try to execute this program and see how does it work and understand it in a better way. As you can see, the data has been successfully generated, and the data which was present in the linked list before clearing was Edureka Online Training Institute. Once after the data has been cleared successfully, the new elements have been added into the linked list, which are now tied up with NIT Warangal. Now let us try to execute clone method. In this particular example, I'll be using clone method. The clone method is nothing but you are cloning the existing linked list. Now let us try to execute this program and understand this in a better way. As you can see, the first linked list is example for clone method. I'm using clone method and I'm trying to duplicate the first linked list, which has the same data as you can see, which is example for clone method. Now let us try to execute index method. As you can see in this particular example, I'm using index of method. So here I have inserted some data into my linked list, which is using index of method. So what I'll do here is I'll be using list.indexOf method to find out the index of a particular element. So here I've chosen using element and method element to find out the index of those particular elements. Let us try to execute this program and see how does it work. As you can see, the output has been successfully generated and the linked list was using index of method. Now the index of the element called using is 0 and the index of the element method is index 3. Now let us execute offer method. As you can see in this particular method, I have created a linked list and added the elements BMW, Porsche and Mercedes. And I'm using offer last method to add the final element which is Jaguar to the linked list. So let us try to execute this program and see how does it work. As you can see, the output has been successfully generated and the elements in the linked list before using offer last were BMW, Porsche and Mercedes. And the elements after executing the offer last method is BMW, Porsche, Mercedes and Jaguar, where the element Jaguar is included into the linked list at the last section, which happens to be the tail. Now let us execute offer first method. In this particular example, I am creating a linked list which will be having the elements C language, Java and Kotlin. And finally, I'll be using the offer first method where I'll be including the Python element in the head section of the linked list. Now let us execute this program and see how does it work. As you can see, the Python element is included here at the head section. Now let us try to execute pop method. In this particular example, I have pushed in two elements which is A and B, and here I'll be using the pop method to pop the last element which is pushed into the stack. And after that, I'll try to push a new element which is C into the stack. And finally, we'll print the stack which is existing right now. Let us try to execute this program. As you can see, the last element which was pushed into the stack was B, and after popping it, we have the elements C and A which are existing in the current stack. Now, let us try to execute the push example. As you can see, this particular example is similar to the previous one. Here we are just pushing the elements into the stack using the stack push method. As you can see, the output has been successfully generated and the elements which we have pushed into the stack are 100, 200 and 300. Now let us try to execute a remove method. As you can see in this particular example, I am trying to insert 4 elements into the list which are apple, banana and grape, and here I am using list.remove method to remove one element from the linked list which is the first element, which happens to be apple. Now let us try to execute this program and see how does it work. As you can see, the elements before removing the element apple are apple, banana, grape and pineapple. So once after I remove the first element, the remaining elements are banana, grape and pineapple. Now let us try to execute the set method. In this particular example, I'll be using list.set method. Here I am trying to set 2 elements into the linked list which are kiwi and orange at the position 2 and 3. As you can see, this is the element kiwi and this is the element orange, and I'm trying to set kiwi into the position number 2 and orange into the position number 3. Let us try to execute this program to understand this in a better way. As you can see, the output has been successfully generated and the elements before inserting them into the second and third position are apple, banana, grape and pineapple. The objects grape and pineapple which were at the positions 2 and 3 are replaced with kiwi and orange. Now let us try to understand size method. Size method is not a complicated method. All it does is shows the number of elements which are present in an array. Now let us try to execute this program and find out the size of the particular linked list. As you can see, I'm using list.size over here and I'll be finding out the size of this particular linked list. Now let us try to execute this program. As you can see, the linked list is apple, banana, grape and pineapple, and the size of this particular linked list is 4. Now let us try to convert an array into the linked list. As you can see in this particular example, I am trying to add the array which is courses which has Java, PHP, Hadoop, DevOps and Python elements into a linked list. So here I am using for loop into which I'll be adding the string s elements which are courses into the linked list, which is a course list, using the add method. Now let us try to execute this program and see how does it work. As you can see, the elements Java, PHP, Hadoop, DevOps, and Python were actually the elements of an array called courses. And using the add method, we have added the elements of an array into the course list, which happens to be the linked list. And here the output has been printed successfully, which happens to be the output of a linked list. Now, let us try to convert a linked list into an array. In this particular example, I've used add method to add the Java, Python, DevOps, Hadoop, and AWS elements into a linked list called as course list. Now we'll be using toArray method to add all the elements which are present in a linked list into an array. Now let us try to execute this program and understand this in a better way. As you can see, the size of the linked list was 5. The elements of the linked list were Java, Python, Hadoop, DevOps, and AWS, which are now included into the array called as numbers, which is displayed as follows: Java, Python, DevOps, Hadoop, and AWS. So these are the elements which are present in the array called as numbers. So we have successfully converted a linked list into an array. Now let us discuss the major differences between arrays and linked lists. The arrays are not resizable because the size of the array has been defined at the declaration section itself. But on the other hand, linked lists are dynamically resizable. The next difference is the arrays offer more methods compared to linked lists, while the linked lists are concise to few methods compared to arrays. The third difference is the arrays have insertion, addition, and removal operations done in a faster way, while in linked lists you have to traverse from head to tail. The random access is not provided by linked lists, so these operations are comparatively slow in linked lists. The last difference is the arrays consume more memory because hardly the array memory which you allocate is being reused. But in terms of linked list, the memory which you use can be dumped back into the heap and it is readily available for reuse. So arrays consume more memory and the linked list consume less memory.
Let's understand what is a hash map in Java. Hashmap is a part of Java's collection since Java version 1.2. It provides the basic implementation of map interface in Java. It stores the data in key-value pairs. To access a value, one must know its key. Hashmap is known as hashmap because it uses a technique called hashing. So what is hashing? It is a technique of converting a large string to a small string that represents the same string. A shorter value helps in indexing and faster searches. HashSet also uses hashmap internally. It internally uses a linked list to store key value pairs. So the important features of hashmap are: it is a part of Java util package. It extends an abstract class, that is abstract map, which also provides an incomplete implementation of map interface. Hashmap also implements clonable and serializable interface. It does not allow duplicate keys, but it allows duplicate values. That means a single key cannot contain more than one value, but more than one key can contain a single value. Hashmap allows null key also, but only once, and multiple null values. And this class makes no guarantees as to the order of the map. In particular, it does not guarantee that the order will remain constant over time. It is roughly similar to hash table but is unsynchronized. So these are the various features that makes it the popularly used data structure. Next, talking about the internal structure of hashmap, it contains an array of node, and node is represented as a class which contains 4 fields, that is int hash, k-key, v-value, and node next. It can be seen that node is containing a reference of its own object. So that is the reason it is called a linked list. So very simple, it comprises of a node which comprises of a key and value, and it has the int hash, and node is having the reference of the next variable as well. So this is all about the internal structure of Hashmap. Now talking about the performance of Hashmap, it mainly depends on two parameters, that is initial capacity and the load factor. So capacity is the number of buckets where the initial capacity is the capacity of the Hashmap instance when it is created. The load factor is the measure that when rehashing should be done. And rehashing is a process of increasing the capacity. In Hashmap, capacity is multiplied by 2. And load factor is also a measure that what fraction of the Hashmap is allowed to fill before rehashing. When the number of entries in a Hashmap increases, the product of current capacity and the load factor is also increased. That is, it implies rehashing is done. If the initial capacity is kept higher, then rehashing will never be done. But by keeping it higher, it increases the time complexity of iteration. So it should be chosen very cleverly to increase the performance. The expected number of values should be taken into account to set the initial capacity. Most generally, preferred load factor value is 0.75, which provides a good deal between the time and space cost. And the load factor's value varies between 0 and 1. Based on these two factors, that is initial capacity and a load factor, performance of a Hashmap is measured. Now, let's move into the next section and understand what is a synchronized Hashmap. As it is already told that Hashmap is unsynchronized. That is, multiple threads can access it simultaneously. If multiple threads access this class simultaneously and at least one thread manipulates it structurally, then it is necessary to make it synchronized externally. It is done by synchronizing some object which encapsulates the map. If no such object exists, then it can be wrapped around collection synchronized map to make Hashmap synchronized and avoid accidental unsynchronized access. So you can see that I have used collections.synchronized map and created a new Hashmap. So by using this, a map M is synchronized. Iterators of this class are fail fast if any structure modification is done after the creation of iterator in any way except through the iterator's remove method. In a failure of an iterator, it will throw concurrent modification exception. So this is how you can make a map as synchronized. Now let's see some of the constructors that are widely being used. Hashmap provides 4 constructors and access modifiers of each one of them is public. First one, Hashmap. It is a default constructor which creates an instance of a Hashmap with initial capacity 16 and load factor 0.75. Next, Hashmap with int initial capacity. This also creates a Hashmap instance with specified initial capacity and a load factor 0.75. Next, Hashmap with int initial capacity and float load factor. It creates a Hashmap instance with specified initial capacity and a specified load factor. Next one, that is the last constructor, Hashmap, which has arguments of type map. It creates the instance of Hashmap with same mappings as a specified map. So now let's write a small program and understand how does the Hashmap work. So I have created a class called Hashmap, and inside that I have a main method. And you can see I'm using Hashmap and I'm passing the parameters like string and integer, and I'm mapping it with the object of a new Hashmap. So first, when I print the map, it should say this map is empty because nothing is there in the map, right? So then I'm using the put method to insert the elements into the map, that is ABC10, MNO30 and XYZ20. Then when I print this, it will say the size of the map, that is 3. Then next, I will check whether a map contains a key called ABC. So this is the keys and this is the value of the respective key, right? So when I check if it has a key called ABC, then I'm using a map.get to display the value of ABC. So the value for key ABC will be whatever is present in this, right? Then again I'm clearing the map and again printing the map. Now I'm using a method called print and I'm passing the arguments for map. Means it should contain the map of same mappings. So if it is empty, then print map is empty, else return the elements and that is the key value pairs present in the map. So let's run and check the output. So first what it said map is empty because I'm printing the map without entering anything in that. So it will go to the print method and check whether the map is empty or not. Yes, it is empty. So it will retrieve the result. So next, this statement got executed and is telling the size of the map is 3 because it has the key value for 3 different categories. Again, it will print the map. So this will again go to the function definition and print this statement because now the map is not empty. So there's a function call over here. And now size of the map is map.size. What is the size? 3. So it is displaying the size of the map as 3 and is printing all these elements. Now value for key ABC is 10. So that's what I'm checking over here. That is, get the key for ABC and print its value. So if I do it again, like, MNO, again change it over here as well and here as well. Okay. So it will print the value will be 30. So finally, after clearing the map, again it's telling map is empty. Now let's run and check the output. It's MNO. You can see that the value for the key MNO is 30, right? I hope you understood this. So this is how you can configure your hash map and map it accordingly. So now talking about the complexity of hash map, it provides a constant time complexity for basic operations, that is get and put. If hash function is properly written and it disperses the elements properly among the buckets. Iteration over hash map depends on the capacity of hash map and the number of key value pairs. Basically, it is directly proportional to the capacity plus size. And capacity is the number of buckets in the hash map. So it is not a good idea to keep a higher number of buckets in hash map initially. So this is all about the time complexity. Now let's have a look at the various methods that are widely being used in a hash map. First, void clear. This is used to remove all the mappings from a map. Next, Boolean contains key, that is parameter will be object key. This is used to return true if for a specified key mapping is present in the map. And again, Boolean contains value of object value. This is used to return true if one or more key is mapped to a specified value. Next method is object clone. This is used to return a shallow copy of the object of the mentioned hash map. Next, Boolean is empty, used to check whether the map is empty, returns true if it is empty. Next, object get object key. This is used to retrieve or fetch the value mapped by a particular key. Set key set. This is used to return a set views of the key. Int size used to return the size of the map. Next, object put. Parameters will be key and value. This is used to return a particular mapping of key value pair into a map. Next, put all of map M. This is used to copy all of the elements from one map to other. Next, object remove object key. This is used to remove the values for any particular key in the map. And the last one is collection values. This is used to return a collection view of the values in the hash map. So these are the various methods that are widely being used in the hash map. Let's understand what is generics in Java. Generics is a term that denotes a set of language features that are related to the definition and the use of generic types and methods. Java generic methods differ from regular data types and methods. So before generics, we use the collections to store any type of objects. It can be either a generic or non-generic object. Now, generics force the Java programmer to store a specific types of objects. So basically, this is all about what is generics. Now let's move further and see why do you need Java generics. If you look at the Java collections framework, then you will observe that most of the classes take parameter or argument of type object. So basically what happens in this form, they can take any Java type as argument and return the same object or argument. It can be either a homogeneous or heterogeneous, that is not of a similar type. So sometimes in the Java application, the data type of the input is not fixed. The input can be an integer, a float, or a Java string. In order to assign the input to the variable of the right data type, prior checks had to be conducted. In the traditional approach, after taking the input, the data type of the input was checked and then it was assigned to the variable of the right data type. When this logic was used, the length of the code and execution time was increased. So to avoid this, generics were introduced. So on using generics, the parameters in the code is checked at compile time automatically and it sets the data type by default. So this is where you need the concept of generics in Java, as the execution time and the time that you invest in writing the code will also be decreased. So now that you know what is generics in Java and why do you need it, let's move further and see some of the types of generics. So basically there are 4 types. First, generic type class, and you have interface, method, and constructor. First, let's understand what is generic type class. A class is said to be generic if it declares one or more types of variables. So these variable types are known as the parameters of the Java class. Let's understand this with the help of an example. So here you can see I have created a class with one property X and the type of the property is object, correct? So what happens? Once you initialize the class with a certain type, the class should be used with that particular type only. For example, if you want one instance of a class to hold the value of type string, then programmer should set and get only string type. Since I have declared the property type to object, there is no way to enforce this restriction. A programmer can set any object and expect any return value from the get method, since all Java types are subtypes of object class. So it's very simple, right? So here I'm creating a method for set and get, and I am using the this keyword for reference. And then when I return the value of the X, it can be any type. But all the Java types are subtypes of object class. So I can set a property for integer and I can return string. Anything it can be. So this is how it works. The next type is generic type interface. An interface in Java refers to the abstract data types. They allow Java collections to be manipulated independently from the details of the representation. Also, they form a hierarchy in object-oriented programming languages. So let's take an example and understand this. So here I have created an interface for generic and I'm doing 2 operations for T1 and T2. So for T2 what I'm doing, I'm performing the execution. I'm passing 2 variables, that is T1 and X. And next what I am doing, I'm performing a reverse execution of whatever I have performed in the above statement. So when I create a class for generic and implement the interface, whatever I perform the execution will be reversed in the next execution. Suppose say while performing the execution, I'm passing a string variable and that can be easily converted to an integer variable when I'm reversing the execution. So basically all that matters is the type of the object, and there is no way that I have to enforce a restriction or anything like that. It can be a string, integer, double, float, anything. So I hope you was able to understand how generics can be applied to interfaces. Now let's see what's next. The next type is generic type method. So generic methods are much similar to generic classes, but they differ from each other in only one aspect, that is, the scope or type of information is available inside the method only. Generic methods introduce their own type parameters. So let's take an example and understand this. So in this case, what happens? If you pass a list of string to search in the method, it will work fine. But if you try to find a number in the list of a string, it will give compile time error. Yes, right? Because see, first I'm using advanced for loop and I'm trying to check the element present in the list. If the list is a string, then it will match, because always list is a string. Like list can be a string, it can't be an integer. So when I try to find a number in this list, it will give error, right? So that's how I have coded this program, and that's how the generic type method tells you. That is, they introduce their own type parameters. There is no way that I have to define something or user have to define something. There's nothing like that. It's like they define their own type of parameters. So this analogy is similar for constructor as well. So if I talk about the generic type constructors, the same goes here as well. So basically a constructor is a block of code that initializes the newly created object. A constructor resembles an instance method in Java, but it is not a method as it does not have a return type. The constructor has the same name as the class and looks like how I have written in the code. So here in this example, dimension class constructor has the type information, as you can see that. So basically you can have an instance of dimension with all the attributes of a single type only. For example, you have a class dimension that is of a type T, and I have created 3 variables. So when I create a constructor for all these 3 values, you will get the length, width and a height by using the this reference. Because I am giving this dot length is equal to length, this dot width is equal to width, and this dot height is equal to height. So you cannot get any other parameters apart from this in this regard. That is, you can have an instance of dimension with all attributes of a single type. There won't be any different types over here. So this is how you can use type constructors. So now let's see a small example of generics and understand how actually it works. So here I have created a class called test1 and I have passed 2 variables, that is T and U. T is a type of an object O1 and U is a type of an object O2. O1 and O2 are object of type T and U, correct? So now for this I'm creating a constructor. And then I'm giving this reference, that is this dot object 1 is equal to O1 and this dot object 2, that is O2 is equal to O2. And now I want to print the objects of T and U. So I'm basically creating a method called print and then I'm passing these 2 variables in this. And after that I'm creating a class called generic, and inside the main method for the test1 for object T and U, one will be the string that I will be passing and the other one will be integer. So you can see here that I have not created any specific integer or string variable. Instead, I'm just passing the type of an object, that is T and U, to be a string and an integer, correct? There's no restriction or I don't have to enforce anything over here. So I'm going to create a new object for that is test1 and pass the variables as Edureka and integer value will be 10. So when I give object.print, this object is nothing but this reference. It will call the method or the object from this print. So what will happen? It will display the elements present in the O1 and O2. So the elements present in O1 and O2 is nothing but the Edureka and 10. So when I execute this, let's see what happens. I'll run this as a Java application and let's see. So you can see here that in the output screen, it said Edureka and 10, which means there is no type restriction over here. It's very simple. As you saw, all that refers to is a type of the object. Like all the Java types are subtypes of object class, and that is the reason I've taken object class and referred all the elements as objects and then passed whatever I wish to, that is a string and an integer, and then I print it. So this is how it works. Now let's see what is generic functions. So we can also write generic functions that can be called with different types of arguments based on the type of the arguments passed to the generic method, and further compiler handles each of these methods. So let's see how it works. So I have a class called test. In this, I have created a method that is generic display and passed the element as T element. Okay. So now I've made this as static and I'm using the generic type T. Okay. So next, when I'm giving system.out.println element.get class.getName plus element. Okay. So you can see here that in one single print statement, I'm trying to get the class, get the name and also the element. So let's see how this one single line of code works. So inside the main method, I'm calling generic method with integer argument. Okay. So generic display is nothing but this method, right? So the T element, that is the type of the element, is integer. So it is 3, 4, 5, 6, correct? So next, I'm again calling the generic method with string argument. That is, I'm calling the method that I've created above and I'm passing the element of type T as a string. And after that, with double. So you can see here that there are 3 different types of elements, that is integer, string and double. And all these are of different data types, right? So when I say get class dot get name plus element, it will say the class is this and the name will be the integer type and the element will be the value. Yes, let's execute and then you will understand what actually that statement does. As I told you, element dot get class dot get name is equal to element, right? So element is Java. Dot lang is a type of the class. Dot integer is a type of the name. First one is integer. So element dot get class dot get name is equal to this value. So same goes for next also. Element, that is Java, dot lang is the get class, dot string is get name, and Edureka is the value. Same goes with double as well. So you can see here multiple types of arguments was being passed at one single instance. So this is how the generic function works, as you can pass n number of arguments by just referring to it as a type T. There is no specification, there is no restriction that you have to enforce it on. All that you have to do is create the object of a type generic and then go on adding the values. Simple? Yes, that's how generic works. Now let's move into the last part of the session and understand some of the advantages of generics in Java. First, code reusability. You can compose a strategy or a class or an interface once and use for any type or any way that you need. Next, type safety. As you just saw that whenever you use different types of arguments and when you casted in different types of arguments, it was very safe, right? There was no hampering of the code, or there was no destruction of the code, or there was no any type issues when you try to cast the code, or when you use various types of code, there was no hampering between those codes. So obviously it is type safety. Individual typecasting is not required. Basically, whenever you recover information from array list every time, you need to typecast it. But typecasting at each recovery task is a major migraine. So in order to eradicate that approach, generics were introduced. As you just saw, you can use various data types and there is no casting of that required because you can use all of them at once and all that refers to is an object. So that's why I think typecasting is not required. Next, implementing a non-generic algorithm. It can calculate the algorithm that works on various sort of items that are type safe as well. It can be a generic or a non-generic. No matter what, it will implement everything. Let's understand what is file handling in Java. So file handling implies how to read from a file and how to write to a file in Java. And Java basically provides the basic input-output package for reading and writing streams. And also, Java.input-output package allows you to do all the input and output tasks in Java. So in order to use a file class, you need to create an object of the class and specify the file name or directory name as shown below. So first, you will write import java.io.file, that is used to import the file class, and then you have to create an object of a file and specify the file name. Simple? So let me tell you one thing. Java uses the concept of stream to make input and output operations on a file. So let's now understand what is stream in Java. So the stream is a sequence of data. It can be of two types, byte stream and character stream. Now talking about the byte stream, it mainly incorporates with byte data. When an input and output process happens with the byte data, then it is called the file handling process with byte stream. Now talking about the character stream, it is a stream which incorporates with characters. When an input and output process happens with a character, then it is called as the file handling process with byte stream. So these are the two types of streams that are available. Now let's move further and have a look at the various file methods that are useful to perform Java file operations. First, can read. This method is used to test whether the file is readable or not. Next, can write. This method tests whether the file is writable or not. And next you have a create new file, which creates an empty file. And next, delete. This command is used to delete the file. Exist. This tests whether the file exists or not. And next you have getName, which is used to return the name of the file, and you have getAbsolutePath, and this is used to return the absolute path name of the file. And next you have length, and it returns the size of the file in bytes. Now moving further, you have list. This method is used to return the array of the file in a directory. And you have mkdir, which is used to create a directory. Okay. Now these methods are used to perform various file operations. Now let's see what are the various file operations that are present in Java. So first you need to create a file. Then once you create a file, you need to get the information out of the file. After that, you have to write the information to the file, and then you have to read the data from the file. Correct? So now let's understand all these things in a much better way with the help of an example. First, create a file. In this case, in order to create a file, you can use the create new file method. Okay? And this method returns true if the file was successfully created, and it returns false if the file already exists. Okay? So here is an example for creating a file. So first I have created a package, and inside that I have a class called createFile. As I have already told you, I need to import the file class, so that is the reason I'm using this package. Okay? And next, in order to import the input-output exception class to handle the errors, I have java.input-output.io_exception. Okay? So next, after that, I have created a class called createFile. And inside the main method, I'm using two blocks, that is try and catch. So inside the try block, what I'll do, I'll write a code that has to execute. And in the catch block, so if there is any error that is going to occur in try block, it will be handled. And in this case, most expected error can be the IO exception. So that is the reason I'm using a catch block to handle that. Okay, so inside the try block, let's see what I have written. So I have written file my object is equal to, I'm creating a new file in the specified directory. If I don't give the path, if I just give the name of the file, that is file f1.txt, it will by default go and store this file in the location where my Eclipse workspace is. So I don't want to do that. I want to create a file in a specified file location, and that's the reason I'm giving this. And now if my obj, that is my object.create new file, then if the file is being created with this object, then it is telling file created and get the object name, that is get name. So get name will be what? File f1.txt, right? Else, if the file already exists, it will say file already exists. And if there is any exception, it will be handled in the catch block. So now let's run and check the output. So you can see that it's telling file created, and it returned the name of the file, that is my obj.getName, that is file f1.txt. Correct? So yes, that's how it works. Now let's cross verify this. I'll go to my D drive. I will go to file handling, and you can see file f1 created. Correct? So in this location itself, I have created the file. So if I run this program one more time, so let's see what happens. So it's telling file already exists, because one time you created a file, it will be present in that particular location. So it will say file already exists. Correct? So this is how you need to create a file. So the next step is to get the file information. So here again, I'm importing the file class, and then I'm creating a class called file information, and inside the main method I'm creating a new file. Okay, and I will check if this already exists, then it should print the file name, get file name, that is my obj.getName, and then it should again print the absolute path of the file, and for that I'm using get absolute path method, and then I'm using, if it is writable, it will print can write. If the file is readable, it will say can read. And the file size in bytes will be my obj.length. Okay. Else, if the file does not exist, then it will print file does not exist. So you can see that I have used all the methods that I have explained you before, that is get name, get absolute path, can read, write, and length, right? So let's run the program and check for the output. So you can see that the file name is file1.txt. The absolute path is, it's in this location that I have already showed you just now. For writable and readable, it's telling true, because yeah, it is readable and writable, and the file size in bytes is 0. So I have one more file here. Let me show you that. I have a file called new file1.txt. Okay. So inside that, I have written some text. So it means it consists of a text, right? So when I say the file size in byte, it has to return the length. But here it is telling 0 because I have not written anything into that file. So now if I change the file name, let's see what it will return for this statement. Let me run and check it once again. So you can see that it returned the file name, absolute path, it is readable and writable, and the file size in bytes is 52. Correct? So if you have written anything in the file, then it will return the file size, or else it will not. Simple. So this is how you need to get the file information. Next, let's see how to write to a file. So here I have created a class called write to file, and inside the main method again I have two blocks, that is try and catch. And here I am using the myWriter method. So here I have used the FileWriter class together with its write method to write some text into the file. Let's now understand how actually it works. So I have used the FileWriter and I've created an object of the writer. And this is the path where I have saved my file, and this is where I want to write some data into the file, right? Then I'm using myWriter's write method to write this particular context in the file. And after that I have to close it. So once I close this, I will say successfully wrote to the file. Okay. If the data has been written into the file, then it will say I have successfully written the data into the file. Else it will throw an error and will be handled in the catch block. Let's now run and check the output. So it's telling successfully wrote to the file. Now let's cross check this. So you can see that it has written the data into the file. That is, Java is a prominent programming language of the millennium. If you want to do any editing over here, you can do, which means it is writable. And if I want to read the data from the file, I can read it as well, right? Correct? See? So simple. It will even ask whether to save or not. If I say save, yes, it will get saved. Very simple, right? So that's how you need to write the data to the file. Now that you have written the data to the file, you know that you can go to the particular file location and check whether the data is being written into the file or not. But how does Java know that, right? So now let's write a Java program to read the data that you have written into the file. Again, I'll create a class called read from file, and inside the main method, I will write file myObj is equal to new file, and this is the path of my file. And then I'm using scanner and my reader. Why? Because I want to read it. That is the reason. And I'll pass the parameter as myObj. MyObj refers to the file, which is this one, right? And next, while myReader.has next line. So if it has next line, or if there is n number of data that is being present in that, it will read everything. So that is the reason I want to check whether it has a next line. If yes, again string data is equal to myReader.nextLine, and it will print the data. And after everything, it says myReader.close because I have to close this. And finally, if the file has not found, then it will throw an error and will be handled in the catch block. Simple. Now let's run and check the output. So you can see that it returned Java as a prominent programming language of the millennium, which I had written from this thing, right? So from the write method. And this I manually typed, so it will again print the data that has been present. So this is how you need to read the data from the file. I hope you understood how to create a file, how to get the information from the file, how to write to a file, and how to read from a file. So these are the various file operations that you can perform on a file. So that's how it works, and that was all about the file operations.
What is serialization? To understand serialization in a much better way, let us consider a simple example where we have two different JVMs at two different locations. Let us assume that JVM1 is executing a particular object, and the same object is expected to be executed in JVM2 as well. Now, the only way would be transferring this object from JVM1 to JVM2. To transfer the object from JVM1 to JVM2, we must either follow the process of serialization, or we must be using an externalizable interface. Now here, we shall use serialization process. In the process of serialization, the object is converted into a byte stream, and this byte stream is either saved in memory or a database or in form of a file. This byte stream is transferred to the JVM2, and at the JVM2 end, this byte stream will be deserialized and the object is retrieved to the original state and will be executed in JVM2. With this example, we can finally conclude the definition of serialization as follows. Serialization in Java is the process of converting the object code into a byte stream and transfer the object code from one Java virtual machine to another and recreate it using the process of deserialization. Now, with this, let us move on to our next topic, which is why do we need serialization in Java? We need serialization in Java for the following reasons. Firstly, communication. Serialization involves the procedure of object serialization and transmission. This enables multiple computer systems to design, share, and execute objects simultaneously. The next reason is persistence. The state of any object can be directly stored by applying serialization onto it, and it can be stored in a database so that it can be retrieved later. Note that only the particular state of an object is stored here, not the entire object. Followed by this, the next reason for using serialization will be deep copy. Cloning process is made simple by using serialization. An exact replica of an object is obtained by the process of serializing the object into a byte array and then deserializing it. The next reason will be caching. The time consumed in building an object is more compared to the time required for deserializing it. Hence, we can prove that serialization minimizes the time consumption by caching the giant objects. The final and the most important reason for using serialization is cross-JVM synchronization. The major advantage of serialization is that it works across different JVMs that might be running on different architectures or operating systems. With this, let us continue with our next topic, which is how do we serialize an object. A Java object is serializable if and only if its class or its parent class is implementing either of the two libraries, which are java.io.serializable interface or its subinterface, which is java.io.externalizable. In the serialization process, we convert an object state into a byte stream so that it could be transferred from one JVM to the other and revert the byte stream back into the original object. To understand this in a better way, we shall execute an example. In this particular example, we have class persist. The class persist takes care of the process of serialization. In the class persist, we have some details of the employees, which are the employee IDs and the employee names. Now, we have another class called employee, and in this class, we are implementing the library, which is java.io.serializable. And in the last class, which is dpersist, which is none other than the deserialization class, which takes care of the process of deserialization. Now, we shall execute this program and see how does it work. As you can see, the program has been successfully executed and the IDs and names of the employees have been displayed here. Now with this, let us get into our next topic, which is based on the advantages and disadvantages related to the serialization process in Java. Firstly, we shall discuss advantages. The first advantage is serialization process is a built-in feature. Hence, it does not require any third-party software to execute serialization. The next advantage is the serialization procedure is proven to be simple and easy to understand. Next, the serialization process is completely universal and developers from different backgrounds are familiar to it. The next advantage is serialization is easy to use and simple to customize. The next advantage is serialized data streams support encryption, compression, authentication, and secure Java computing. And the last important advantage is that there are many critical technologies which are relying in the process of serialization. Now with this, let us move on to the disadvantages of using serialization process in Java. The major disadvantages are as follows. Objects while deserialization becomes completely brittle and they are not sure to be deserialized effectively. The next disadvantage is the declaration of transient variables while serialization creates memory space, but the constructor is not called. This results in the failure of initialization of transient variables, resulting in the variation to the standard Java flow. The next disadvantage is the process of serialization is inefficient in terms of memory utilization. The next disadvantage is serialization is not preferable to be used in the application which need concurrent access without the requirement of third-party APIs. as serialization does not offer any transition control mechanism for every software enterprise. The last disadvantage is serialization procedure fails to offer fine-grained control to access objects. With this, let us jump into the practical examples based on serialization in Java. Firstly, we shall execute serialization using interface in Java. In inheritance, we shall deal with case 1. In case 1, if superclass is serializable, then by default all its subclasses are also serializable. Now, let us execute an example to understand this in a much better way. As you can see, this particular example is based on case 1. In this particular example, we have two different classes, which is class A and class B. Class A is superclass and it is serializable. Hence, its subclass, which is class B, must be also serializable. Now, let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and the output has been displayed, which says that the object has been successfully serialized as well as deserialized, and the deserialized objects are displayed here, which have the values I is equals to 10 and j is equals to 20. Now let us try to execute the second case of example. The second case says that if the superclass is not implementing the serializable interface, then the objects of the subclass can be manually serialized by implementing the serializable interface in the subclass. Now let us try to execute a program to understand this in a much better way. As you can see, this particular example is based on case 2, and this particular class is a superclass which is not serializable, and this particular class is a subclass which is implementing serializable interface manually. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and the output is been generated here. Now let us move on to the next case, which is case 3. In this case, the serialization of subclass can be prevented by implementing the write object method or read object method in the subclass, and it needs to throw a not serializable exception from these methods. Now let us try to execute a program to understand this in a much better way. As you can see, this particular example is based on case 3, and this class is the parent class which is implementing the serializable interface. And in child class, we can see that we have two methods, which is write object method and read object method. Now let us try to execute this program and see if it throws an exception or not. As you can see, the program has been successfully executed and the serialization of the objects is being stopped. And the program did throw an exception, which is java.io.notSerializable exception. Now with this, let us get into our next topic, which is serialization using a static member. Serialization of a static member field is ignored in the process of serialization. Serialization is always related to the object's latest state. Hence, only the data associated with the specific instance of a class is serialized, but not the static member field. Now, let us try to execute an example to understand this in a much better way. This particular example is based on serializing a static member. As you can see, I have declared a static integer variable I which stores the value 100, and I am trying to serialize this particular data member using the process of serialization, as my class static serial is implementing the serializable interface. Now let us try to execute this program and see if this particular static member will be serialized or not. As you can see, this particular program has been executed successfully and the value of the static member variable is changed from 100 to 99. Now with this, let us get into our next topic, which is externalizable interface. The externalizable interface in Java is similar to serialization, but the only difference is that it is capable to offer customized serialization where you get to decide the objects to be stored in the stream. The externalizable interface is available in the java.io library, and it provides two methods, which is public void write external method and public void read external methods, and both of them throw an exception. The key differences between serialization and externalizable interface are as follows. Firstly, implementation. Externalizable interface expects the user to explicitly mention the objects to be serialized, while in serialization interface, all the objects and variables are serialized in the runtime. The next difference is backward compatibility and control. Externalizable interface supports serialization regardless of the version control, and the only problem is that the user must be responsible while serializing superclass. On the other hand, serialization interface requires the same version of JVMs on both the ends, but it incorporates automatic serialization of all the objects and classes including the superclass. The next difference is public no-arg constructor. The externalizable interface requires no-arg constructor to reconstruct the serialized object, while serialization interface does not require no-arg constructor. Instead, it uses reflection to reconstruct the serialized object or class. The next difference is process. Serialization process in externalizable interface provides customization to the serialization process, but serialization interface will provide default serialization process. The last difference is methods. Externalizable interface consists of two methods, namely write external and read external, whereas serialization interface does not include any methods. Now let us execute an example based on externalizable interface to understand it in a much better way. This particular example is based on externalizable interface. Now we have two different classes, which is the demo class and the test class. Inside the demo class we have a default constructor, and inside the test class we are trying to use the process of serialization. Now let us try to execute this program and see how does it work. As you can see, the process has been successfully executed and the objects have been serialized as well as deserialized using the externalizable interface. Now let us move on to our next topic, which is transient keyword. The transient keyword is a reserved keyword in Java. It is used as a variable modifier at the time of serialization process. Declaring a variable with transient keyword avoids the variable from serialization. The next topic for our discussion is serial version UID. Before the process of serialization begins, every serializable class or objects gets associated with a unique identification number provided by the JVM of the host machine. This unique ID is called as serial version UID. This UID is used as an identification by the JVM from the receiving end to confirm that the same object is being deserialized at the receiving end. Now let us move on to the controversies based on serialization process in Java. Oracle's architects intend to remove serialization from Java as they considered it as a horrible mistake of 1997. After a hectic research, the developers at Oracle found out few flaws in the design of serialization procedure which pose a threat to the data. In the year 1997, Mark Renault states, "We like to call serialization the gift that keeps on giving. The type of gift it keeps on giving is security vulnerabilities. Probably the third of all Java vulnerabilities have involved serialization. It could be over half. It is astonishingly a fecund source of vulnerabilities, not to mention instabilities. There are chances that serialization would be removed or replaced in the upcoming updates of Java, and on the other hand, for a beginner in Java, serialization could not be an idealistic option in their projects." With this, let us move on to our last topic, which is best practices to be followed while using serialization in Java. The best practices are as follows. It is recommended to use Java doc@serial tag for denoting serializable fields. The .ser extension is preferred to be used for files representing serialized objects. It is not recommended for any static or transient fields to undergo default serialization. Extendable classes should not be serialized unless it is mandatory. Inner classes should be avoided to be involved in serialization.
What is a Java thread? So guys, a Java thread is a lightweight sub-process. Now in an application, so we have one main thread. So when our application is running, so operating system is going to create one process. So same way over here, Java virtual machine will take care of your Java applications. So process would be created and each and every process will have a main thread. So thread is a lightweight sub-process. So here it is the smallest independent unit of a program. It contains a separate path of execution, and every Java program will have at least one thread that is something known as the main thread. So main is nothing, it's an execution context where the certain jobs will be executed one after the other in a sequence. Now, if you want to create a thread in Java, so we got this thread API from the java.lang package itself. You need not to even import it. So it's by default in the lang package. Once we create a thread, it will have a life cycle. So how it's gonna work, right? So a thread can lie only in one of the shown states at any point of time. So typically, guys, we'll have a thread with a state called new. So when you create a thread, its state is new. Then we move into the runnable, then into the running, and finally the thread will be terminated. In between, a thread can have the waiting state, which can iterate between your runnable and running. So let us have a look on to individual states. What exactly is what state? So having a new state means that we are going to initiate a new object of a thread. You can even say that the thread is just born, right? It's just like creating an object of a thread in the memory. Thereafter, once a thread is created, we start the thread. So once we start the thread, the state is changed to the runnable state, right? So that it can run. And finally, your thread is now running. So running means it is executing a run method, which is the method we have to override from the thread class, right? And we even have the yield method that can send them to go back to the runnable state again. What is waiting state? When a thread enters a state of inactivity, so thread is not performing any action, it is waiting for some other thread to give back the data, or it is sleeping, or it is blocked at certain scenario or a use case. So that is known as a waiting state. Your thread is not currently resuming the tasks. Finally, the thread is terminated. So when your thread has completed its task, right, so it is terminated. Now let us take one example of this thread. Consider that you are going to play one audio file in a media player, right? So let's say you have a media player and you're going to play an audio file. Now the moment you tap on the button to play that audio in your phone or in your PC, right, so a new thread is created. And you see that finally the thread starts proceeding. So your song starts to play. So from the runnable, it enters into the running state and it keeps on running till the song is not finished, right? So that's like the terminated. So in between, you just go for the pause, right? That's like where your thread is now doing a wait operation. So when your song is automatically finished or you stop the song, that is the terminated state. So one of the just an analogy that how the thread is going to work for us. Same way, there can be a use case that you want to download some image from the server. Now, threads are typically used when we have to perform a long running operation, right? So there we create this thread. Downloading an image can be a long running operation because it is dependent on the network speed. Now, when you want to download an image, so you create a new thread. So in the background, what we will do is we'll start fetching the bytes from the server for the image, right? And in the running state, your thread is continuously fetching the data. There can be a state called waiting. Let's say network connection has been disconnected. So our thread can wait until the network connection is, re-established. And terminated would be a state when the image is properly downloaded. So a couple of examples demonstrating how the life cycle of the thread is supposed to be. So now we will look into how we can create a thread. So guys, if you want to create a thread, right, you need to understand the reason why you want to create a thread. So we by default will have a main thread in our application that is represented by the main method. So what is a main thread, right? So typically whenever you run your Java application or any application, you will write your code in the main method. Now the code in the main method is executed as a main thread itself, right? So main method will have the instructions written within it, and all those instructions are being executed as a part of the main thread in a sequence, one after the other. Now, what will happen if you are going to do a long running operation within the main itself? It can take time, right? So the below written instructions in the main method, they will be blocked because of a long running job, right? Now that is where your operating system, it will start giving messages to the user that this application is not responding. Would you like to wait or kill this application? So this is what we need to understand, right? So when we have long running operations, we need not to put the load on the main method or the main thread. We need to create a separate thread. So that is what we are going to understand now. So creating a thread is like what now? We have two different ways by which we can create the thread. Either we extend from the thread or we can implement the runnable interface, right? So guys, having a thread class, so we'll just say extends thread. Any class name extends thread. You override the run method, you create the object of your thread class, and we invoke the start method, which will internally execute the run method. Same way, so here you can see a bit of code snippet coming in. So there can be a class called myThread extending the thread. We have a run method which will do some job, and in the main method you create the object of the thread and you just say start. So start method will internally execute the run method. The way we got thread class, in a similar way we do have something known as runnable. Now many a times we are already into inheritance, right? So let's say your class is inheriting some other class. Now it cannot inherit thread at the same time because multiple inheritance is not supported in Java. So what we got runnable interface. So if you are already extending some class, you cannot extend the thread class, but we got a runnable interface which can be implemented. Rest of the structure remains the same, right? So you override the run method, create the object of the class, and invoke the start method. So guys, here we go, right? So your thread class will implement runnable. So let's now do a little bit of coding here and understand that how it's going to work for us, right? So I'm going to write a new Java project. We'll see how we can create threads using the thread API and the runnable interface. So I'm going to say threads demo. Let's say next and say finish. So we got a small Java project created here in the SRC. I'm going to write a new class and I'm going to say threads with the main method, or I will say this as app with the main method, right? So app means application here, app with the main method. Now when we have this main method coming in, so guys, we will come here and say that main method represents main thread, right? So main method represents main thread. So whatever we write in here will be executed by main thread, and threads always execute the jobs in a sequence. So whatever the job you're gonna give to the thread, they're gonna execute in a sequence. For example, I will write down one of the job. It goes like application started, and thereafter I can have a job called application finished. So in between I can have, let's say, a small job. It will print some documents for me, right? So I'm going to say that for int of, let's say, document 1 till the document number 10 and document plus plus. So I'm printing some documents, right? So let's say this will be some code snippet, right? So some code to print the documents, right? So this guy is printing some documents for us. So I will write down the CISO statement here. So printing document plus the doc, right? So whatever the document we are printing, so I'm just putting up here. Now when I will run this program, it is all CISO statements. It's nothing complicated to understand, I hope so. So your application started. We printed the document 1 till the document number 10. So we are printing these 10 documents in a loop. So you see, everything is happening in a sequence. So what I'm trying to say is that this goes like your job 1. Consider this entire snippet as job 2. And this goes like, let's say, some job 3. So we are not getting job 3 before the job 2 or job 1 after the job 3. So what is the output? Output is a sequential output, right? Now that is what a thread is. So what is a thread? Thread is an execution context. So what does this mean? This means that it's gonna execute your code in a sequence. Threads always execute code in a sequence, right? So one after the other. So this is one of the demonstration regarding the main thread, which is nothing represented by the main method. Now what I will do is I will write one class here. Now this class goes like some my task, which extends, not extends, let's say my task. So my task is going to execute a task for me. So this will execute a task for me. Here what I'm gonna do is I'm gonna say CISO. So even we'll put up a loop here, and this loop goes like a similar loop. So printing the document number document, right? So here I'm going to put some different delimiter so that we can understand. Printing document number this from printer 1, right? So this is from, let's say, printer 2. And coming here, I'm going to say this is your printer 1. So this is how we are going to come up and understand. So my task over here is having a method which is going to print the document, but this guy will print the document from the printer 2. And this guy over here is going to print the documents from the printer 1. So within the job 1 and job 2, I'm going to introduce this job called my task. So my task is a new my task, right? And coming here, I will say task.execute the task. If you will see now what we have done, we have made my task as job 2 and this guy as job 3, and this goes like job 4. Now, when I will run this code, what you will find is that application started, printing of documents started. So printer 2 is in use, and thereafter printer 1 is in use, right? So as per our discussion, main is executing everything in a sequence. And to your surprise, you need to understand this point here, that till this task is not completed, below written jobs, they are blocked. I need to now mention this point. Till job 2 is not finished, below written jobs are waiting and are not executed. So this is something which we need to understand because of sequential operation here, right? So we are seeing a sequential operation. So that is the reason till job 2 is not completed, below mentioned instructions or the jobs, they are waiting. Now, in case job 2 is a long running operation, right? So in case job 2 is a long running operation, consider this guy is going to print several documents, right? There can be some several documents which we are supposed to print. Now, till these several documents are not printed, right? In case job 2 is a long running operation, that is several documents are supposed to be printed, right? So this is a use case which, so in such a use case, OS/JVM shall give a message that application is not responding, right? Or we will have some, you can say, behavior, some sluggish behavior in the apps. Now, what is meant by this sluggish behavior in the app? It means that we will be able to see some kind of apps which are hanging, right? So you see that apps, they are going to hang, right? So even I can say app seems to hang. Now, why app will seem to hang? Because your main thread is blocked, right? So the only point here is that your apps, they might seem to hang, they will have some sluggish behavior in case you are doing a long running operation within the main thread. Now, this is the use case where we need a thread. So I think the use case is clear, right? So what I'm going to do is, so this my task, you come up with this my task in the same way. So let me comment down this code part. So instead of having it a normal class, you make it a thread. You override this run method with the public, because run in the parent is public, so you need to override it. So this guy is override it here for us, right? The run method. So I get the same operation being performed, but this goes in the run method and my task is now a thread, right? So I can very simply understand that my task is a thread because inheritance makes this relationship to come up as is a relationship, right? So my task is a thread. So guys, this is certainly clear to everyone, I hope so. So in the next part of this is like what now? So you won't say execute the task. So rather we will come here and say task dot start. So start method internally calls the run method, right? So start shall internally execute run method. Now let us re-execute the same code and see what is the outcome. So we see a similar output here, right? But if you can observe, application finished is coming somewhere in between. Previously it used to come in the end. So I'll give a rerun again. Now I see a different output, right? Application started. Sometimes printer 1 is being used, sometimes printer 2 is being used, and thereafter a lot of times printer 2, then sometimes printer 1, and then the app getting finished. So again, rerun this application, you see again a different output. So every time when you will execute your code over here, what you will see is a different kind of an output, right? Why now the outputs are mixed for us? Because along with the job 3, job 2 is executed parallelly, right? What I can say now, so now main and my task are executing both parallelly or concurrently. That is the reason you are able to see a mixed output for both of these threads. So guys, when you write a thread, thread's gonna work parallelly to your main thread, right? So now my task is also known as a child thread, or sometimes the terminology can be a worker thread. So child thread or a worker thread, right? So this guy is going to perform certain operation which will not affect the performance of the main method or the main thread, right? So we are having this main thread which is not supposed to be getting affected by the operation of my task because my task is executing separately, main is executing separately within the same process, of course. So they are not interfering in a way that it has to be waiting for one guy, that it should stop, it should finish its execution, then the main will resume. So we are getting the things executed in a parallel operation. Now the same thread called my task can also be created. So considering that you have a class called some CA, right? And I'm just gonna comment down this guy now. So considering that we have this my task extending CA and thread both. Now this is not allowed in Java. Multiple inheritance is not supported, right? This is an error. Why? Because multiple inheritance isn't supported. So what we will do? So we'll come here and we will say extend CA, but don't come up with the thread. You can say implements runnable. So that's just one basic change here. Rest everything remains the same. So guys, in case your class is already a child of some other class, right? So if you are already having this inheritance implemented, so you won't be able to write comma thread. Multiple inheritance isn't supported in Java. So you can anytime come up and say implements runnable. Coming here, you are now going to do it in a different way, right? So let us see how we can create the object. So you can say runnable R is a new of my task. So you write a polymorphic statement. The reference variable of the interface is pointing to the object which implements it. Then I will create a normal thread object. I will say thread task is a new thread within which I'm going to pass this runnable reference, and then I will say task dot start. So this is a bit of change when it comes to runnable versus your threads. So you run this code here. So it's gonna work in the same way for us, right? So it's again a thread. So printer 1 or printer 2, right? So they are now the mixed outputs. Mixed outputs, they definitely show that our jobs are getting executed parallelly. So main is not getting affected now, right? So that is how we are able to understand this point. So every time you will run this code, you might end up in looking the different outputs. Why different outputs? Because execution of threads is not in our hands. It is in the hands of JVM. JVM can perform time slicing. It can give some time to the main thread, some time to the my task, right? So that's how we are able to understand the threads in Java, guys. I hope you have understood it. So now we shall be proceeding towards the next part. So the next part over here is to differentiate between thread class and the runnable interface, right? So guys, there is some common things and some dissimilarities. So over here in thread and in runnable, so a unique object is created for both of the cases, right? So memory consumption of course increases because we have a separate thread running in the same process. Then class extending the thread cannot extend any other class because of the multiple inheritance. But here runnable helps us to perform this same use case. So if you are already extending, you can implement the runnable. So thread class is extended only if there is a need of overriding the other methods of it. So if you are actually inheriting the thread class, so you might be looking forward to override its other methods as well. But in case you don't want to do that, runnable is the best use case, right? Because runnable, you can only have this run method which you can override. Then having thread, we got tight coupling, and runnable is loose coupling. So of course, guys, when you have a loose coupling, dependencies, they gets reduced and is a better use case to use. So moving ahead now, so I hope thread versus runnable is good to go. We saw how to create a thread, what is a thread, and how it is helping the main thread to accomplish the jobs. So what is this main thread? Once again, main thread revisited. Guys, main thread is the important or the most important part of any application or a Java program. So whenever you run your application, your main thread is executed. So every program will have this main thread, and Java main thread is needed so that we can spawn the child threads. We can create child threads, we can start them. You have seen that we created my task, we started the my task, right? So it must be the last thread to finish the execution. That is, the main thread stops the program, terminations. So it's gonna terminate the program. So when your main thread is finished, so it is basically a termination of your application itself, right? So Java main thread, guys, how it's gonna work, let's see that part now. So typically JVM is going to start the main thread and some other daemon threads at the same time, right? So when you run your application, the main thread and the daemon threads, they are started by the JVM. Your main thread can further start multiple child threads. For example, child thread A, child thread B, and the threads can further start the other threads. For example, thread A can start the thread C. So if we talk about our example here, so there can be my task, there can be your task. For an instance, we can have some other guy called your task, right? So this guy is working on some printer 3, right? So we can have these multiple threads which can be spawned in the main method itself. So here I can just say thread your task is a new thread. In between I can pass a new of your task, and then I can say your task dot start, right? So it's one the same story. Either you write this polymorphic statement or you directly pass the reference. So these two instructions can also be, written in a way of a new thread, and in a new thread you pass a new of your task, and then you simply say the start, right? So you can conclude it in a single statement in case you want, if you don't want to have the reference to the thread. So these threads, right? So they can be multiple threads here and there. So now we see multiple threads in action, right? So if you want, you can have your threads in a lot of threads executed from the main thread itself. Even what we can do is from these threads, we can execute some other threads. So that is what we were trying to understand. And one more thing, any thread can be marked as a daemon thread. So you can just say task dot set the daemon as true, right? So what is this daemon thread? Daemon thread is a thread which is going to be executed by the JVM whenever the application starts, right? It's gonna execute the thread along with the main thread. If you see the image, so that is a bit about how the main thread is going to be executed. So now next part is multi-threading in Java. So typically multi-threading begins when you have more than one thread in your process. So of course, if along with the main thread a new thread is getting into execution, that is a perfect example of multi-threading itself. But what we are going to do is we are going to take up some use case that in case there are a couple of threads or multiple threads other than the main thread, so how they're gonna work and what can be the scenarios which we can observe when they are executed. So what is multi-threading? So guys, multi-threading is the ability of a program to execute more than one threads concurrently, where each thread is handling a different task at the same time, right? So that the available resources can be utilized in the most optimal manner. So let's say there's a main thread, and main thread is going to start some child threads, and there can some switching between these child threads, right? Because they are going to perform the jobs, and your time slicing will be coming into the action where some jobs of thread A will be finished, some jobs of thread B, some jobs of thread C, right? So there will be a switching between these execution of the threads. So let us see one demonstration where multiple threads can be introduced. So I'm going to write a new Java program, so a new class. So this goes like my let's say sync app with the main method. So this time I'm going to perform a separate operation, right? So consider that here your application started. So this is your beginning of the main thread, and this will be the ending of the main thread, right? So that is how we are considering. So main is a thread. Now we understand it, right? So main is representing main thread. Always remember this, guys. So in order to prove this, what I can do is I can just try to say int I is 10 divided by 0, right? And I will run this code here as Java application. So what you see is it says there is an exception, and the term which JVM is using is thread main at line number 11. If you see this line number 11 is divide by 0 error. That's like arithmetic exception, right? So what I'm getting is thread main, right? So JVM says main method as thread. So that is one of the proof of concept what I'm trying to say, that why main is representing the main thread, right? Now there is a class called printer. So printer is supposed to print the documents. So I'll have this guy called print documents, right? So printer is supposed to print the documents. How many documents do you want to print, right? So in begin, or let's say int some number, right? So I'm just gonna take some number here. So I will say for int I assign 1, go till this number and say plus plus. So there can be even more details in the print document, but I'm just taking one of the examples here. So I will say CISO printing document plus the I. So we are going to have this document printing done for this I. I can even take one of the name, right? So I can take doc name, and this can go like number of copies. What is the name of the document which you want to print and how many number of copies you want. So I'll take this number of copies goes less than equal to number of copies, right? And printing instead of the document, I'm just going to have this document name. So I think this is one of the use cases which I wanted. Yeah. Now having a printer object, so I'm going to write a printer object. Printer is a new printer. This is one of the printer object. And if I want to print the documents, right? So what I will do is I will say, dear printer, please print me the documents. I want 10 copies for a document called Ishanth's profile.pdf. So I want the 10 documents for Ishanth's profile.pdf. So when I will run this code here, so you see your printer is printing the copies. So it has clearly said 1 to 10, right? Now, why we should be getting the documents printed here in the main method, in the main thread? We can have a separate thread, right? So I'm going to write a separate thread. So this thread goes like, let's say my thread, which extends thread, and I'm going to override this run method. Always remember, guys, you can anytime have your runnable interface or this thread, whatever the way you are comfortable, right? So here in the my thread, I'm going to have this guy called printer pref. I'm going to have a reference to the printer in the constructor. So I will take printer p here and I will say pref is p. So in the run method here, I will say pref dot print the document. So I need 10 copies. So this is like John's profile, or let's say John's profile is the name. So now, so once I created the printer object, I'll create the object of my thread. So I will say my thread mref is a new my thread, and I'm passing the printer over here. You see, we have one object of printer, right? How many objects of printer I have created? So we have only one single object of printer, right? Only one single object of printer. So we are giving the reference. So my thread is having reference to the printer object. So since my thread is having reference to the printer object, so printer is copied to the P is copied to the pref, and you are doing a print documents here. So I will say mref dot start. Now what will be the benefit? The benefit is that printing is happening in a separate thread. That's like my thread. So now when you run this code, you see application started, application finished. So main thread is okay to go with it, right? And the jobs are getting executed for John's profile by my thread. Now consider along with the my thread, you see you got this my thread. I'm gonna write a your thread, which is very much same. All right, it's exactly the same story. So instead of John's profile, this is Fiona's profile, which we want to print, right? So the way we got my thread, in a similar way, I'm gonna say your thread. Let's say yref is a new of your thread. So it's gonna work on the same printer. So you see, my thread is having a reference to the printer object. Your thread is also having reference to the printer object. But guys, what is the use case or the scenario? Scenario is that we have multiple threads working on the same printer object. Now this is a very difficult use case. So you see, printer is now going to be shared between two threads. If I start both the threads now, so I say yref dot start as well, right? So you see what's going to happen. So we are getting the documents printed. So you will run this code. So any point of time, what you will see is that the outputs they're going to get mixed up for us, right? So let me just keep on running this part here. So you see the outputs, they are getting mixed up now. So 1 to 9 for the John, then 1 to 10, and then the John profile. So it's totally, you see the output coming here now, right? So it's all mixed up. Can you imagine such a scenario in a real-time environment? So let's say two people, they want to print the documents in the printer. Can you imagine printer printing document 1 from the first fellow, and then the document 2, and then document 3, then 4? So it's all mixed up, right? So rather, what printer will do? Printer will take the commands from the multiple people, multiple computers, but it will print one after the other. So this is one of the use cases which is not good to go, guys, right? So this is certainly not what we want. So what is this? This is known as asynchronization. Threads are running parallelly. Now there can be a use case, there can be a scenario where multiple threads, so if multiple threads are going to work on the same single object, we must synchronize them. So they are not supposed to be executed in a sequence. So what I'll do is I'll introduce one more method here in this for loop here. So I will say a thread dot sleep for, let's say, 500. What is this thread dot sleep? Guys, sleep method will temporarily pause the execution. All right. So I'm going to select this guy and say surround with try catch, because sleep method will throw an exception. Now when I run this program here, so what do you see is, along with some delay, the output is coming up for us, right? So let me run this code once again. But this output is not at all acceptable, since my thread and your thread are working parallelly on the same object. So it is printing the document sometimes for my thread, sometime for your thread, which is not a real life use case. This is implemented something in a wrong manner, right? So what I can do is, immediately after the start method, I can say mref.join. So what does this join method is going to do? So it will again throw an error. So we'll surround it with the try catch block. So now what you will observe is synchronization coming into the action. Let me run this code. What you see is, after putting the join, all the documents are printed from the my thread, and then it is your thread in execution. Let me re-execute the program for you people. So guys, you see your John's profile, till John's profile or John's papers are not finished, Fiona's paper were not started. That is what we are able to understand as synchronization. That is by having this join method coming into the action. So if you have many people who are going to, get this printer utilized, you cannot put join on each and every, method call on every thread. So what I can do is, I can come here and I can just mark my method to go as synchronized. So what is synchronized method now? So when your thread is going to execute this method called print documents, it will acquire a lock. We call it an intrinsic lock, right? Now, once the lock is acquired, no other thread can access the print documents. So rather than having the join function call, what I'm doing is I'm marking my method as synchronized. So if multiple threads are going to access the same method again and again, so what we are going to do is we are going to synchronize them. And now when I will run the code, what you see is the same output coming in for us, right? What is the benefit here? The benefit is, now we need not to put join method calls on each and every thread, right? So we got this synchronized method itself. We can come here in our thread, we can say a synchronized block instead. So synchronized method was acquiring the lock on the method, right? So no other thread can access it if one thread has acquired the lock. So this is acquiring the lock as a block. Now no thread can execute or access the printer object till this block is not finished, right? So this synchronized block has to go in your threads. So there are two different ways by which we can implement synchronization using the synchronized keyword. So the output will again remain the same for us. Now, where is synchronization needed? In multi-threading. We need synchronization in multi-threading when both the threads or multiple threads, they are working on the same single object. Now that is the use case where you need to implement synchronization. So guys, I hope this is clear to everyone. What is the synchronized keyword? So now let us come back. So guys, this way we have synchronization. In a similar way, we have something known as a thread pool, right? So thread pool will manage the pool of worker threads and contains a queue that keep the tasks waiting to get executed. So there will be a queue now. We will have a lot of tasks, right, for the application which we have to do. And a pool can be maintained for these threads which will be executed automatically by this API called thread pool. So explore this part. So what are the various thread methods, guys? So in order to create the threads, we got a thread object and then say start, right? So we can join the thread. There is something known as a thread.sleep. There can even be an inter-thread communication. So guys, we have wait and notify as methods, and a thread can be marked as a daemon thread. You just say set daemon as to what's a daemon thread. It's gonna get executed along with the main, right? So when the JVM is gonna start the app, it's gonna start the main as well as the daemon threads.
Let's understand what are regular expressions. A regular expression is a sequence of characters that constructs a search pattern. When you search for a data in the text, you can use the search pattern in order to describe what you are looking for. So for example, you have a regular expression like this as shown in the slide, and you can see that the cap represents the start of the line. And a set which is enclosed within the square brackets represents letters, numbers, underscore, hyphen, everything. It comprises of all the alphabets, numericals, and special characters as well. And also, if you want to write a regular expression which is of 3 to 15 characters long, then you can enclose it within the curly braces as shown here, and the dollar symbol implies the end of the line. So this is the basic regular expression where you can understand how you have to start writing a regular expression and how you can include the alphabets, the patterns, everything within the square brackets, and how to represent the length of the characters in flower braces, and finally the end of the line, right? So a regular expression can be a single character or a more complicated pattern. It can be used for any type of text search and text replace operations. A regex character can be simple ABC, or it can be a combination of simple and special characters like AB into C, or it can be example with braces which includes a D star, D plus, anything. So I hope you understood how actually it looks like. Now with this, let's understand what is Java regex. So a Java regex is an API which is used to define a pattern for searching or manipulating the strings. It is widely used to define the constraint on strings such as password and email validation. So you can see in this below GIF over here that it is trying to search for a regex, that is a regular expression, and it's trying to figure out whether it is able to match the pattern or not. So there are different methods of using Java regex. So let's move ahead and look at the different categories of regular expressions. The first on the list is matcher class. This class is used to perform the match operations on a character sequence. So this is used to match a character sequence. So it comprises of various methods. The first one is Boolean matches. This is used to test whether the given regular expression matches or not. Next, Boolean find. This method is used to find the next expression that matches the pattern. So once you get the matches, then it will go ahead and find the next expression which will be able to match the pattern or not. If not, it stops there, and then it will again go ahead and find the next one. Next, Boolean find in start. So here I'm passing the parameter called in start, and by doing this, it will help to search the next expression from the given start number. So you have one more method called string group. Again, this is used to return the matched sequence. So when you get the proper match sequence by using the Boolean matches and Boolean find, then you have to return the match sequence. In order to do that, you need to write the string group method. Next, in start. This method is used to return the starting index of the regular expression. And similarly, int end is used to return the ending index of the regular expression. And you have the group count, which is used to return the total number of the match sequence. So these are the methods of matcher class. Now let's move ahead and have a look at the various methods of pattern class. Pattern class is a compiled version of regular expression which is used to define the pattern for a regex engine. So again, this also comprises of various methods. First, static pattern compile, and here I am passing the parameter as string regex. Okay. This method will compile the given regex and returns the instance of a pattern. I will tell you how exactly all these methods work with the help of an example after this. For now, let's understand all the different methods. Next, you have a matcher match, which comprise of a parameter called char sequence input. So this is used to create a matcher that matches the given input with the pattern, and the matcher is the one which is the previous one, which comprises of a boolean find, boolean search, int start, int end, everything. And this matcher is used to create a matcher that matches the given input with the pattern. So suppose say you have a pattern that comprises of special characters along with the numericals and alphabets. So what it will do, it will try to match the given input with the pattern. So for that reason, you need to use this method. Next method is static boolean matches string regex. So this works as a combination of compile and matcher methods. Next, you have string split. This is used to split the given string around the matches of a given pattern. So after that, you have a method called string pattern, and this is used to return the regular expression pattern. Now let's see a small example of how exactly it works. So here I have an example. In this, I am going to check both categories, that is matcher and pattern as well. So first what I'll do, I'll just import the package for regex, and then I am creating a class called regexExample. And inside the main method, I'm giving the pattern as pattern.compile dot and dot, that is the starting index and the ending index. So it implies I can use anything as a starting index and I can use anything as an ending index. But the thing is, it should comprise these x and x in between. So for that, I will use the matcher, which is used to match the given pattern, right? So inside this matcher, I'll write A and B. So what it will do, it will match the given pattern. So this is the pattern and this is the matcher. I'm using both the classes, that is the matcher and the pattern. So I will check whether the given pattern will match the given input string or not. And if the string matches the given regex, then it will say matcher.matches and it will display the output. So now let's run and check for the output. Okay. So it's telling string matches the given regex, and as I already told you, it will always display the boolean result, that is true or false. So it is telling true. So now even if I give something like this, so what do you think will be the output? Let's run and check for it. So you can see again it's telling string matches a regex pattern, but then if I remove one x from here and then I write x over here, so it does not match the given pattern, right? So obviously it will say as false. So you can see here it's telling false, right? So I hope you understood how to write the pattern and how to write the matcher for the given pattern. And remember one thing, it always displays the output in the form of a boolean, that is either true or false. So what happened here? In this case, internally it uses pattern and matcher Java regex classes to do the processing. But obviously, this reduces the code lines. And pattern class also contains the matcher method that takes the regex and input string as argument and returns the boolean result after matching them. So this code works fine for matching the input string with a regular expression in Java. So that's exactly how it works. Now let's move further and see the next category, that is regex character class. So again, even this comprises of various methods like ABC. So it comprises of ABC, which implies a simple class that comprises of A, B or C. Next, negation of ABC. This comprises of any character except A, B or C. That is a negation. Next, you have A to Z and capital A to Z, which implies a range that includes small a to Z and capital letters from A to Z. Next, it has A through D or M through P. That is a union. That is A through D or M to P. And next you have D, E or F, which is the intersection for A to Z. And next you have A through Z except for B and C. That is AD to Z. That is a subtraction, but you have to negate B and C. Okay? And the last one is A through Z and not M through P. So these are the various categories of a character class. Let's again take a small example and understand whether this works fine or not. So now let's check how this works. So again, inside the main method, I'm using a pattern.matches method to check whether the given set of characters matches with the given pattern or not. So first, it comprises of X, Y, and Z. So you can see here all the character set comprise of the simple class that is ABC, that is X, Y, Z. So when I pass WBCD, it will obviously return false because it is not among X or Y or Z. And now if I just pass X, it returns to Y because inside this class, it comprises of X, Y or Z, right? And again, if I try to pass double X, 5Y and 1Z, it returns false because X and Y comes more than once. So that's the reason it will return false. Now let's run and check for the output. So as I have already told you, it returns false, true and false. So this is the given character class, right? And if I try to match the pattern that is out of the character class, then it will obviously return false. So this is how you can write an example for character class and check whether the given set matches with the input pattern or not. Now let's move ahead and understand what are regex quantifiers. The quantifiers specify the number of occurrences of a character. So again, even this comprises of various methods. For example, X followed by a question mark. It implies X occurs either once or not at all. Then you have X plus, which implies X occurs more than one time. And X with a star, that is a multiplication symbol, implies X occurs 0 or more times. And if you have an X followed by an N within the curly braces, it implies X occurs N times only. And if you have a N with a comma, then it implies X occurs N or more times. And if you have a parameter like Y, Z, then it implies X occurs at least Y times but less than Z times. So these are the various methods of regex quantifiers, and let's see even how this works. So inside the main method, I'm simply printing this thing, that is quantifier, and now I will try to check whether the pattern matches or not. This symbol in the quantifier implies it should occur either one or it should not occur at all, right? So when I say A, Y, and Z followed by a question mark, and inside that if I just pass a parameter A, it will say true, which implies A occurs only one time. Next, in the same category, if I write A 3 times, it says false because A comes more than one time. So as I've already told, the symbol implies either once or not at all. Again, in the same category of class, if I write this, it will again say false because all these alphabets comes more than one time. So that's the reason. Again, even for this case, which says AMNTA, it is false because MNT is not under this category and A comes twice. That is the reason. And this should be true because AYZ again does AYZ as well. Okay. Next, plus quantifier implies what? It should occur more than one time. So AYZ plus implies it should occur more than one time. So it says true because A comes once. Even if I write 3A, again it says true because A comes more than one time. And even if I write this pattern, again it says true because it comes more than one time. And even if I write this, it says false because MMT is not a matching pattern. Okay, that is M and T are not a matching pattern. So this implies it should occur either 0 or more number of times, right? So when I give this pattern followed by a star, which implies, and if I write the matcher this, it says yes, because A, Y, and Z occur either 0 or more number of times. So let's execute and check the output. So you can see here the results with respect to the above, correct? So as I've already mentioned you, quantifier works with star plus and question mark. It implies either it should come one time, or it should come 0 or more than one time, or it should occur more than one time. So depending on the type of the quantifier, you can give your matcher and it will check whether the given pattern matches with the quantifier or not. So this is how it works. So the last category on the list is regex meta characters. So the regular expression meta characters work as shortcodes. So dot implies it can be any character. D implies digit. Capital D implies non-digit. S represents any white space. And capital S represents non-white space character. W can be a word character and caps W can be a non-word character. B can represent a boundary and capital B represents a non-word boundary. So out of all this, you can understand that it just represents what? A shortcode, right? So let's also check an example of how exactly this works. So inside the main method, I have written meta characters D. So D means digit, right? So in D, if I give ABC, it will say false. Again, in D, if I give 1, it says true. Why? Because digit comes only once. And in the same D, if I give 444 and 3, it says false because digit comes more than once. And inside the D, if I give a combination of digit and a character, again it says false, right? So now in case of meta characters capital D, so if I give a meta character capital D and if I try to write an alphabet that is a character, it says false because capital D means a non-digit, but it comes more than once. So if I give in the capital D as just 1, it says false again because it is a digit. Again, the same thing goes with here as well because these are the digits. So in this capital meta character D, if I give a matcher M, it is true because it is a non-digit and it comes only once. So a meta characters D with the quantifier. So if I give D and followed by a star and if I pass ABC, then it says true because it is a non-digit and it can occur 0 or more number of times. So in these cases, what happened? I just use a single meta character and I tried to pass a string. So that was the reason it was telling false. Now if I give this, it obviously says true because it is a non-digit and also it can occur more number of times. So here only, if I give D plus, so it will say true only. So this is how it actually works. So that was all about the meta characters. Now let's move further and see a small demo where I will tell you how to find the given pattern out of the string, and also I will explain you how to verify the email validation. Okay, so I have an example over here. This is used to find a given regex pattern and it will also check whether the given string matches with our given pattern or not. So I have a class called demo and inside the main method I am using scanner sc is equal to new scanner of system.in. I am using a scanner class because I want to read the input from the user. So first what I'm saying inside the while loop I'm telling enter the regex pattern. And I have to obviously use this because I want to scan for the next line if there is anything as such. Then I'm using a pattern class to compile the given regex pattern, that is a user input pattern. And then I will use the matcher class to match whether the given input string will fall under this given matcher or not. If not, it will say match not found. If it will find the pattern with the help of a matcher.find, it will say found the text, whatever is entered by the user, at the starting index of what is the start of the index. The matcher group is used to return the matched patterns group and the ending index, and finally it will retrieve the matcher.end, means the ending point. So it will say found the text at the group starting at the index, the location where it started and the location where it ended. If it is not found, then it will say matcher is not found. So let's execute and check for the output. So it's asking me to enter the regex pattern. So what I have to enter, either I have to enter a part of it or I can enter the full thing. So I will do one thing. I'll just type YouTube channel, right? So you can see it is telling found the text YouTube channel, the one which I entered, starting at index 19 and ending at index 34. So now check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it is starting at the index 19 and it ends at index 34, which is this thing, right? So again, if I enter the pattern Edureka and I'll keep it as small, it says match not found. Even the case sensitivity also matters. No matter you give the same string, again the case sensitivity also matters a lot. So if I give welcome, it says it is starting at the index 0 because this is 0 and it ends at the index 7, correct? So this is how you can match the pattern with the given input string. So this is all about the searcher and the finder. Now let's see a small example of email validator. So I have created two classes here, one for email validator and the other one is for the testing of an email validator. So in this regard, I'm performing a email validator test, that is unit testing. So inside the email validator, I need two classes. One is a pattern and the other one is a matcher. So the email pattern that I'm going to give comprise of all this. That is, this is the starting index as I have already told you, and this is the ending index, right? So it should comprise of all these things plus these things, and there should be a @ symbol because it's an email address, followed by again a digits and small and capital letters, and again the same thing. And it can also comprise of more number of digits, and finally it has the ending pattern, right? So inside the email validator, I'll try to match with the given email pattern. And I have a boolean validate final string hex. So this is used to match the hex of the given parameter, and finally it returns the matcher. And now I have the email validator testing. So here I'm using data provider to provide the data, and this will be the unit test case which I will be running as a testng test. So if you wish to know more about what is testng, how exactly it works, what is unit testing, you can check out the videos on our YouTube playlist and you will get hands-on on even those topics as well. So now you have a public class email validator test. I'm going to create an object of a new email validator, and using the data provider, I'm providing the valid email address that comprises of a string followed by a @ symbol, and then it comprises of the domain followed by a particular domain. It can be .net, it can be .com, .co, anything, right? Which implies it has to comprise of this followed by @. If it is Gmail, so it has to compile Gmail dot again com test, anything. So these are the email address which is valid. And I again have an invalid email address. So you can see if I simply give as Edureka, it is not a valid email address, right? So the email address should comprise of this pattern. If not, it is an invalid email address. Again here, Edureka followed by a dot and gmail.com. Again, it is an invalid. So again, you can see after a gmail.com, again it comprises of something that is also a non-valid email address. Comprise of star, percentage, so many things, right? So these are not a valid email address. So what I'm doing, I'm using @test annotation to test the valid email address. So here what I'm doing, I'm passing the valid email provider. So what happens is it will check both the valid and invalid email address and it will display the output. So the data provider is used to provide the set of the data, and from there, you can validate the email address. So I'm writing two tests, one for valid email provider and the other one for invalid email provider. So whatever is present in this, I'm sending it to a variable temp and then I'm validating that. And finally, I'm checking if the result is true, then I'm using assert equals to true. And if the result is false, I'm giving assert is equal to false. So let's check the output. So I'm going to run it as a test-ng test and let's check for the output. So you can see here, first, the valid email addresses till here, right? So these are the email addresses which are valid and that's true. And now talking about the invalid email addresses, it starts from here and it is false. Why? Because that's not true. That's the reason it is false. And it will also return the string for valid email test and the invalid email test. So both on the default test and suit, the test that was executed was true and there were no failures because whatever I have written the code was working perfectly fine and that's the reason. So even if I have to check the result of running class email validator test, you can check all these. The test that was run was true, one is valid and one was invalid. And this is the class name which is followed by a package. On both the default suit and test, the test was run within these many seconds. Yes. So this is how you need to validate the given email address and check whether it is invalid or invalid. That's exactly how it works, and I hope you got a brief idea about what is regular expression, how you write a regular expression, what are the different categories of regular expressions, and how to configure your program and check whether the given regular expression or a pattern matches with the given input string or not, and how to validate an email address as well. Let me tell you what is socket programming in Java. So Java socket programming is used for communication between the applications that is running on different Java runtime environment. It can be either connection oriented or connectionless. So basically socket and server socket classes are used for connection oriented socket programming. I also told you that it also has a connectionless programming, and that is achieved with the help of a datagram socket and datagram packet. So basically the client in the socket programming must have two information. One, the IP address of the server, and the other one, the port number. So in order to connect to a server from the client, and if the client wants to send a request to the server, then it should know the IP address of the network and the port number which the server is operating on. So this is all about the brief of the socket programming. Now let's move further and understand what is a socket. A socket is one endpoint of a two-way communication link between the two programs that is running on the network. The socket is bound to be a port number so that the TCP layer can identify the application that data is destined to be sent. So basically, a connection will always happen between the server and the client port. And obviously, when a client sends a request, server has to wait for the client request. Then the server has to accept the request and then establish a connection with the client and processes the request and send the response back to the client. So this is what it does. And for all these things, what do you need? You need a socket, which is an endpoint for a two-way communication between the two networks or the two programs that is running on the same network. So I hope you understood this. Now let's move further and see some of the methods of socket and socket server classes. The first method for socket class is public input stream get input stream. So this method will return the input stream that is attached with this particular socket. Next, output stream, and this method will return the output stream that is attached with the socket. And next you have public synchronized void close. If you use this particular method, it will just close the socket. That is a connection. The next one is socket server. This will return the socket and establish a connection between the client and server. Because as it is a socket of the server end, it will obviously have to return the socket and establish the connection. Because that is what it is doing, right? When a client sends the request and if the server will not accept the request, then there won't be any connection between them. So that's what a public socket accept does. And after that, you have one more, that is public synchronized void close, and this will obviously close the server. So these are few methods of socket and socket server classes. Having understood this, now let's move further and understand the client-side programming. So what do you think a client-side programming and a server-side programming as? So basically, when a client wants to connect to a server, or if a client has a request that a server should accept and a server wants to send back the response, then what happens? You need to first write a client program for which you need to send a request to the server, and you have to write a server-side programming so that your client will get the response back from the server by accepting the request. So that's why we need the client and the server-side programming, and this is achieved with the help of a socket, which will help you to connect between a network and which will act as an interlink to help you to connect to a network between the client side and the server side. To connect to one another machine, we need a socket connection. As I have already told you, a socket connection means the two machines will have the information about each other's network location, that is the IP address and the TCP port. And the java.net.socket class represents a class. So in order to open the socket, what you need to do, you need to create an object of a new socket and pass the IP address and the port number. Okay. So that's how you need to first establish a socket connection using java.net.socket and provide the IP address and the TCP port number. And after that, you need to communicate over a socket connection, and the streams are used to both input and output the data. So that's what is communication with the client, where you use the streams to input and output the data. And after that, you have to close the connection by using public synchronized void close. Simple. So this is all about the client-side programming. And now I'll also tell you what is server-side programming, and then we will see a demo how to establish a connection and how the client sends a request and how the server accepts a request and how it responds back everything. Before that, I will explain you what is server-side programming. So after you close the connection using the client, the socket connection is automatically closed explicitly once the message to server is sent. And now the first thing is I have to establish a socket connection, and to write a server application you need two sockets. A server socket will wait for the client request when a client makes a new socket, and a plain old socket is used for communication with the client. And after that, you have to output and communicate with the client through socket. So you will use the get output stream method. After finishing everything, it is important to close the connection by closing the socket as well as all the input and output streams. Now let's take an example and understand its working. So here I have two programs, that is the client and the server. So first I'll tell you about the client. I have imported the package, that is import java.net.star, because I want a network connection. That is the reason I'm importing that. And after that, I'm importing the java.io.star because I want the input and output streams. That is the reason. So first what I will do, I'll initialize the socket, I'll initialize the input stream and the output data stream. So for that, what I'm doing, I'm just writing it as private socket is equal to null. I'm initializing all the variables to null because I want to use it in the later part. And after that, I'm creating a constructor for this class, that is client, and I'm passing the address and the port number, that is the IP address and the port number. And now, what is the first step? I have to establish a connection. So in order to establish a connection, what I'll do, I'll give socket, I'll create an object of a new socket and pass parameters and the arguments as address and port. And as soon as it does that, I have to print connected. And now for that, I need to take the input from the terminal. So for that, what I'll do, I'll give new input data stream is equal to system.in. And after that, out is equal to, it has to send the output to the socket. So that is the reason I'll use this. So any exception, then it has to handle. And after that, I need a string to read the message from the input tab. That is the reason I'm using it in this way. And one more important thing over here, it keeps on reading unless and until over is displayed on the screen. So I can write as many number of lines as possible unless and until this over will be displayed on the console. So inside that, I'm getting line is equal to input.readLine and I'm outputting that. Again, after that, I'm sending the request, I'm establishing the connection, I'm communicating with the server. Finally, I have to close the connection. So I have to explicitly close all these connections. That is the input data stream, the socket, and the output data stream. So these are the variables for that, and I'm closing all these connections. And finally, inside the main method, I'm just giving the IP address and the port number. So this is all about the client. But before the client has to say connected, I need a server program which has to wait for the client to get connected, right? So let's now see about the server program. Again, the same thing, but here, instead of the output data stream, I will get the server socket, because I told it is a server-side programming and I need a server socket for this. That is the reason I'm using this. And then I'm creating a constructor of this and passing the variable as input. So I'll create an object of a new server socket and pass the variable as port. And I'll say server has started waiting for the client. Then client get connected. When I go back and connect the client by passing the address and the port number, server says client accepted. So after that, what I'm doing, I'm writing the string unless and until the over will be displayed. So this line will take the input from the get input stream. Okay. And it will read the string line from that. And after that, I have given input because I need to do input.readline and out.write UTF. So here what I'll do, inside the try block, it will say read the input that is given by the client and then display that. After that, again, I have to close the connection and create an object of a new server with the port number. Here I'm passing everything. Here just I'll give the port number because client is connected to a port and server is connected with both IP address and the port number. So that's how I'm writing this. First I'll execute the server and then it will wait for a client, and then I will execute the client and it will say connected, and then I'll start writing anything. Then server will say client accepted and it displays the request that client has sent and it will revert back the response with the client. I hope you understood this. Now let me first run server. So you can do the same execution by opening your command prompt or your terminal. But as I'm using Eclipse and I have an inbuilt option to execute it like this, so I'm doing it on my Eclipse itself. So it is telling server started and waiting for the client. Now what I'll do, I'll execute the client. So run as Java application. So it's telling client accepted. So there are basically two consoles. It's telling connected and it is asking me to type whatever I want. I'll go on typing. Even though I wrote so much, it still did not display over, right? So it has the ability to enter as many number of lines and you can send as many number of requests that you want to the server, right? So now when I check the server, it's telling client accepted. It's displaying what all I wrote. It's displaying like, hi everyone, I welcome you to Edureka YouTube channel. I hope you're understanding the socket programming in Java and so many things, right? So yes, you just saw first the server started. It's telling waiting for a client, and then when I connected with the client, it told connected and it just took the string arguments from whatever I was passing from here, right? And then the server told client accepted and it displayed whatever request I'm just going on typing over there. Again, if I write something else also, it will again display in the server screen. I'll just say enter and you can just see that on the server screen, right? So that's how it basically works, and it will get connected to your client. It will send back the response and it will display all the client requests and respond back. So that's all about the client and server side programming using sockets in Java. So this is how you can actually establish a connection using the socket, because it's an interlink between the two programs that is running on the same network, right?
Why do we need design patterns? We need Java design patterns to provide easy to recognize and use object-oriented programming solutions to common problems. They are inherently easy to maintain as many developers are familiar with them. In some other cases, the pattern is also a way to deal with the inefficiencies of a programming language. So our next topic is, what are design patterns? Software design patterns can be defined as a software template or a description to solve a problem that occurs in multiple instances while designing a software application or a software framework. Now, let us deal with the structure of design patterns. Structure of any design pattern is considered to be highly organized. They are often documented in the form of a template such that the users can visually identify the problem, and instantaneously find a solution to it based on the relationship between the classes and objects. The design patterns template described by the original authors of the design patterns are as follows. The first one is pattern name and classification. Pattern name specifies the essence of a pattern. A good name is a key as it will become a part of our design vocabulary. Coming into classification, it specifies the type of a particular pattern. The second one is intent. Intent can be defined as a short statement that tells us what the pattern does and which design issue or the problem the pattern addresses. The next one is motivation. Motivation can be defined as a scenario that illustrates a design problem and how the class and object structures solve that problem. The scenario will help us understand the abstract pattern definition. The next one is applicability. This specifies in which situations a design pattern can be applied, what are the examples of poor designs of a pattern can address, and how to recognize these situations. The next one is participants. The classes and objects are the entities participating in a pattern along with their responsibilities. The next one is collaborations. Collaborations describe how the class and objects collaborate with each other to carry out their responsibilities. The next one is consequences. Consequences tell us the costs and benefits of using a certain pattern. They also tell us which part of the system can be changed independently. The next one is implementation. Implementation specifies what techniques we should be aware of while implementing the pattern and also tell us if there are any language specific issues. The next one is sample code. The sample code fragments are the ones that tell us how to implement a pattern in Java. Known uses. Known uses can be defined as an example usage of a certain pattern in real world problems. And the last one is related patterns. Related patterns specify which other patterns are related to this particular pattern and what are the differences between the both. With this, let us get into the types of design patterns. Java design patterns are typically divided into 4 categories. They are creational design patterns, structural design patterns, behavioral design patterns, and JEE design patterns. Let us discuss each one of them in detail. The first one is creational design patterns. Creational design patterns are concerned with the method of creating objects. They are preferred during the process of class initiation. The creational design patterns are further classified as follows. They are factory design pattern, abstract factory pattern, singleton pattern, prototype pattern, builder pattern, and object pool pattern. Let us discuss some of the important creational Java design patterns practically. The first one would be factory design pattern. The factory design pattern follows the principle of define an interface abstract class for creating an object, but let the subclasses decide which class to instantiate. The factory method is also known as a virtual constructor. The advantage of factory design pattern is it is designed to allow the subclasses to choose the type of objects so as to create them. Let us deal with an example of factory design pattern. Let us assume that we have 3 cellular network plans which describe the call cost per minute. Here we have 3 different networks, namely ABC network, PQR network, and XYZ network, along with their charges per minute. Let us find out the cost of a certain number of minutes on each network. So this is the UML diagram for our example. Now let us execute this practically. As you can see, we have begun with our factory design pattern example. Here we have the first network, which is the ABC network, and similarly the PQR network and XYZ network. All of these networks have different costs for their plans. Now let us execute our factory design pattern to find out the cost of each and every network for a particular number of minutes used. So this is our factory method. Now let us execute it. As you can see, the console is asking us for the network we want to use, and we have 3 networks here. Let us choose ABC network. Now we shall try to insert the number of minutes we require. Let us take 35 minutes. As you can see, the ABC network will cost us 52.5 rupees for 35 minutes of talk time. Now let us deal with the next type of creational Java design pattern, which is the singleton design pattern. The singleton design pattern follows the principle of define a class that has only one instance and provides a global point of access to it. The class must ensure that only a single instance should be created and a single object can be used by all other classes. The major advantages of singleton design pattern are it is designed to save memory and the object is not created on every request. Instead, a single instance is reused. Let us deal with an example related to singleton design patterns. Let us assume that we have a MySQL database and we are trying to insert data into that database using one single instance. Here, we shall have 4 different operations which will be performed upon the database. And all of those 4 operations will be using one single object instance. So this is the UML diagram for the solution to our problem. Now let us execute this code practically. So as you can see, this is the example for our singleton design pattern. So this is the program for our JDBC connector which will be connecting to our MySQL database. And this is a program for the operations which we will be performing on our MySQL database. Now if I execute this program will throw an error because I have a virtual machine on my system which will be using all the virtual ports. So before I begin this program, I need to switch off all the VMware ports. Here you can see that I'm switching off all the VMware tasks. Now let us start our MySQL and Apache. As you can see, both Apache and MySQL have been started. Let us start our localhost. Now our local host is also started. So Edureka is our database which has the details of employees. Now let us try to insert new data into our database by executing the program of singleton design patterns. Now let us execute this. As you can see, the program has been successfully executed and it is providing us 4 different database operations. Let us try to execute the first operation, which happens to be the insertion. To do so, I must be selecting the operation 1. Now let us insert the name of an employee. Now let us provide a password for the user. And let us designate an ID to the employee. The data has been successfully inserted into the database. Now let us try to view the data which we have inserted. The username must be Rajesh. As you can see, the name of the employee is Rajesh and his password is also being displayed. Now let us try to execute the third command, which would be delete. Now let us give the user ID which we need to delete. The data which we wanted to delete was Rajesh and his ID was 1011 and 01. Now let us try to execute the fourth operation, which is update. Now let us update the data of an existing employee in the database. Now we shall enter a new password to this user. As you can see, the data has been successfully updated. Now let us try out to exit this program. With this, we finish the execution of singleton design patterns. Now let us deal with the next ones. The next type of design patterns are the structural design patterns. The structural design patterns deal with the composition of classes and objects which form large structures. They simplify the structure by identifying the relationship between the classes and objects. The structural design patterns are further classified as below. They are facade design pattern, bridge design pattern, composite design pattern, decorator pattern, adapter design pattern, flyweight design pattern, proxy design pattern, and lastly, the filter design pattern. Let us discuss some of the important structural Java design patterns practically. The first one would be the facade design pattern. The facade design pattern describes a higher level interface that makes a subsystem easier to use. Every abstract factory is a facade design pattern. The major advantage of facade design pattern is it protects the end users from the complex subsystem components. Let us deal with an example to understand facade design patterns in a much better way. Let us assume that we have a business plan and we are trying to purchase the franchise of one of the top food and beverages companies. We have McDonald's, Domino's, and KFC, and let us design a program based on facade design pattern to find out the cost of each and every franchise we want to buy. So this is the UML diagram of the facade design pattern. Now let us execute this code practically. So this is the code for one of the franchise, which happens to be Domino's, and the next one is the KFC, and the last one is the McDonald's. Now this is the franchise service registration code, and finally this is the client code. Now let us try to execute this program and find out the output. As you can see, we have already got the output, and this is asking for the franchise which we need to buy. Let us select KFC. As you can see, we have got the output here, and it says the franchise cost for KFC is 1 crore. Now let us deal with the next structural design pattern, which happens to be the adapter design pattern. The adapter design pattern provides an interface according to client requirement while using the services of a class with different interface. The adapter pattern is also known as a wrapper. The major advantage of an adapter design pattern is it is designed to enable two or more previously incomplete objects to interact with each other. Let us deal with an example of adapter design pattern where we have a simple library card example which is designed to issue a library card to a new user of a library which includes all the details like book holder ID, account number, and many more. Let us execute this adapter design pattern and see how does it work. So this is the UML diagram for our example. Now let us execute this practically. So this particular segment of code deals with the book holder ID, name, and account number, and the next one is related to the library card, and finally this code will give us the details of libraries such as library name, book holder ID, and many more. And finally the adapter class. This class is going to interact with all the other classes and get the details which we need. Now let us try to execute this code and see the output. As you can see, the library account holder name is being asked here. Let us input a library account holder name here. Now let us try to provide an account number to the account holder. Now let us give the name of the library. As you can see, the library card has been successfully issued, as it says the account number 201907 of Karan in MG library is valid and authenticated for issuing a library card. Now let us deal with the next type of Java design patterns, which happens to be the behavioral design pattern. The behavioral design patterns are concerned with the responsibility and interaction between the objects. These design patterns make sure that the objects are loosely coupled, yet can easily communicate with each other. The behavioral design patterns are further classified as below: chain of responsibility pattern, strategy design pattern, interpreter pattern, iterator pattern, mediator pattern, memento pattern, command pattern, state pattern, observer pattern, template pattern, and visitor pattern. Let us discuss some of the important behavioral patterns practically. The first one would be the strategy design pattern. The strategy design pattern defines the family of functionality and encapsulates each one and make them interchangeable. The strategy pattern is also known as a policy. The major advantage of strategy design pattern is it is designed to provide a substitute for subclasses. Let us deal with an example to understand strategy design pattern in a better way. We are going to consider a simple example of a calculator. We need to perform 5 different operations. Now we shall try to encapsulate all those 5 different operations into one calculator class and execute the program using strategy design pattern. So this is the UML diagram for strategy design pattern. Now let us execute this practically and see how does it work. As you can see, we have 5 different operations which are addition, subtraction, division, multiplication, and modulus. We also have one interface which is calculator, which all the other operations will be implementing. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully executed, and now it is asking for the value of the first one. Now let us similarly provide the second value. As you can see, the operations have been successfully executed on both the numbers, and the outputs for the same have been displayed. Now let us deal with the next behavioral design pattern, which happens to be the command design pattern. The command design pattern encapsulates a request under an object as a command and passes it to the invoker object. The invoker object looks for an appropriate object which can handle this command and pass the command to the corresponding object, and that object executes the command. It is also known as action or transaction. The major advantage of command design pattern is it separates the object that invokes the operation with the object that actually performs the operation. Let us deal with an example to understand command design pattern in a better way. This example demonstrates a simple command execution cycle where the user requires to exhibit switching on and off of the various electronic devices in his house like bulb, stereo player. He invokes the command using an invoker object called as simple remote control. Now let us see the UML diagram of this example. As you can see, we have two different electronic devices in the home which are light and stereo. Now let us try to execute this program and see how does it work. So as you can see, this is our code, and the first one is our interface, which is command, and this is the code for light. Now this happens to be the command for executing the light operations. The first one is light on operation and the next one is light off operation. Similarly, we have a class for stereo which functions for on and off as well. The first one is stereo off command and the next one is stereo on with cd command. Now let us try to execute this remote control operation and see how does it work. As you can see, the remote control has been successfully executed and the lights are switched on and the stereo as well. Now let us move on to our next design pattern, which is the observer design pattern. The observer design pattern defines one-to-one dependency so that when one object changes state, all its dependents are notified and updated automatically. The major advantages of observer design pattern are it illustrates the coupling between the objects and the observer. It provides support for broadcast type communication. Now let us deal with an example to understand observer design patterns in a better way. We are going to execute a program using observer design pattern to display the current average score and the current predictable score of a cricket match. This happens to be the UML diagram for the observer design pattern. Now let us execute this practically and see the output. As you can see, we have the first class, which is the cricket data, which happens to be displaying the current score display and the average score display. And the next one is related to the average score display, which calculates the runs and gives us the score. And now let us try to execute this program. As you can see, the output has been successfully displayed. According to the data provided to the program, it displays the data as 10.2 overs are already played and the average run rate is 8.8 and the predictable score according to this run rate would be 441 runs. Now let us move on to our next design patterns, which happens to be the JEE design patterns. The JEE design patterns are concerned with providing the solutions to the Java EE based software applications and frameworks. These patterns are widely used in Spring. JEE design patterns are further classified as below. They are MVC design pattern, dependency injection pattern, DAO design pattern, business delegate pattern, intercepting filter pattern, service locator pattern, transfer object pattern. Let us now discuss some of the important JEE design patterns practically. The first one would be MVC design pattern. The MVC design pattern is defined as follows. Models. Models are basically used as blueprints for all the objects that are going to be used in the application. The next one is views. The views are used to represent the presentational aspect of the information and the data located in the models. And the last one is controllers. Controllers control and act both as models as well as views. They serve as a connection between the models and views. Controllers are capable to instantiate, update, and delete models. They load them with information and then send the data to the views to present them to the end user. The major advantage of MVC design pattern is it supports multiple views of a particular model. Let us deal with an example to understand MVC design pattern in a better way. We are going to use the MVC design pattern to set and print the data of the students of a particular school. So the UML diagram for this particular example is as follows. Let us try to execute this practically. As you can see, this particular code segment is related to the student, which has the roll number and name of that particular student. Now this particular code segment happens to be the view of the MVC design pattern, and this particular code segment happens to be the controller part of the MVC design pattern. Now let us execute this design pattern and see how does it work. As you can see, the program has been successfully executed and the output has been displayed. According to the input provided, the students are Karan Kumar and Sandeep Shukla, and relatively their roll numbers are also displayed. Now let us deal with our last design pattern in JEE design patterns and see how does it work. The last one in JEE design patterns is the DAO design pattern. The DAO is a pattern in which the objects are dedicated to the communication with data layer. These objects instantiate session factories and handle all of the logic behind communicating with the database. The major advantage of DAO design pattern is it uses common calls to retrieve the objects. We shall deal with an example to understand DAO design patterns in a better way. In this example, we are going to display the developer details of a certain IT company using the DAO design pattern. The UML diagram for our example is as follows. Now let us try to execute this practically. As you can see, this particular class is a developer class, and similarly we have an interface called developer DAO, which will be implemented by the other classes of this program. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and the data has been displayed, and according to the details we have provided to our developers, the name of the first employee is Kushagra and his developer ID is 0, and the second employee is Vikram and his developer ID is 1. As you can see, we have also provided an update operation inside the code, according to which we have updated the employee Kushagra with Lokesh and provided his ID to the new employee, which is Lokesh. Now with this, we should move on to the next topic, which is the overview of design patterns. The Java design patterns are designed to be reusable in multiple projects. They furnish solutions that help to define system architecture with ease. Java design patterns are capable to capture the software engineering experiences. They provide transparency to the design of an application. And finally, Java design patterns provide clarity to the system architecture and provide the possibility of building a better system.
We will be discussing 3 useful projects which are based on core and advanced Java concepts. The projects that I will be discussing today are ATM machine, which is based on core Java concepts, text editor that is based on swings and applets, and the sign-up form which will make use of servlets and JSP concepts. Without wasting any further time, let's get started. First, ATM machine. All of you know what is ATM and how it works, but implementing the same using core Java concepts is something interesting. So let's see how to do that. Here we will be developing the code for user account details, bank account, and then further we will perform few operations like deposit the amount, withdraw, check the balance, etc. Basically, it's based on core Java concepts and is developed using Eclipse. So all that you require is your Java install, that is your JDK and JRE, and you just need to have Eclipse installed on your machine. Let me tell you one important thing, that is I have set the privileges for account number and password. That is, you can see on the screen that I have given 2 account numbers and passwords. While running the code, if you give the account number and password as mentioned on the screen, only then you can do the further operations. Else it will just display a message saying wrong account number or PIN. Now let's see how it works and how the code is being developed. So basically, when you run the code, this is how your console appears, and it asked me to enter the account number. That will be the one which I mentioned on the screen, and the password is going to be this thing, enter. So when you enter this, it will ask you to select the account you want to access, that is whether your checking account, your saving account, etc. So first I will say type 1, that is checking account. So in the checking account, the operations that you can do is you can view the balance, you can withdraw funds, you can deposit the funds. So let's see how much balance is there in my account. It's 0, is it? Now I want to deposit the funds in the checking account. So how will I do that? Again, checking account, option 3, which is deposit funds. So it's asking me amount you want to deposit from checking account. So I say I want to deposit some 10,000, enter. So you can see here the new checking account balance is 10,000, correct? Again, I will choose checking account, and now I want to withdraw the amount from the checking account. So I'll say option 2, and I'll say I want some 5,000 from that account. So you can see here I've withdrawn 5,000 and the new checking account balance will be 5,000. So this implies I've withdrawn 5,000 from the account. Again, I will choose option 1, I will view the balance. So it says 5,000 is remaining. Correct? Now we'll go to savings account and again view the balance and do the same operations. Balance is 0. Again same thing, I want to withdraw some funds like say 4,000. It says 4,000. And now I want to withdraw some funds, say some 5,000. Let's see what it says when the amount that we want to withdraw is more than the amount which is in the bank account. It says balance cannot be negative. Correct? So when you try to access more amount than which is there in the bank account, like the savings account, it says balance cannot be negative. Similarly, you cannot just enter the negative values into this. Now say I want to just withdraw some 2,000 and it says the new saving account balance will be 2,000. So basically this is how you can do operations like same way you do it on your ATM machines. And now I want to just say I want to exit. So suppose if I enter invalid account number, say I'll enter something like this and I'll give the PIN something. It says wrong customer number or PIN number. That is, I have set the privileges only for those two account credentials so that I can access using only those two numbers. You can even include more account numbers and PINs. I'll show you how to do that. So basically this is all about the working of ATM machine. Let's take a look at the code now. So here in Edureka 1 package, I have created 3 Java files. One is for account, one is ATM and one is option menu. So now let's see why we have 3 files for ATM and how it works. First we'll see option menu. So you can see here option menu extends account class. That is this Java class. I'm just reading a money format that will be in decimal. And then I'm creating a hash map of integer and then I'm creating a variable of type Hashmap and giving a reference for that. So basically the first thing that I want to do is I want to validate the login information, that is customer number and PIN number. As I have already told you that I have set the privileges for 2 numbers. That is these 2 account numbers and PINs. If you want more, you can just copy this data.put, paste it and you can change like whatever you want. You can add more number of privileges like this. So the first step when you execute, it will just say welcome to ATM project and enter your customer number. Correct? So first what you will do, you will enter either of these customer numbers and then it will ask for PIN number. I am reading the customer number and PIN number using menu input.nextInt. So in case if you enter some characters, it has to catch an exception. Correct? So what it will do? It will say invalid characters and it will ask you to enter only numbers because I have set the privileges only for numbers. So in this for loop, I'm trying to check whether the entered customer number and PIN number is correct or not. If it is not correct, it will print saying wrong customer number or PIN number that you already saw in the output. So after that, if the entered credentials are correct, then this method will execute. That is the get account type. In this get account type, I have mentioned these choices. That is select the account you want to access, checking account, saving account, choice, etc. And then using the switch case, I am using get checking, get saving methods. If you press exit, it will say thank you for using the ATM, bye. And in the default choice, if you press the choice that is not correct, it will say invalid choice. So here is the get checking and I have defined the method over here. That is get checking. So what all we had in the get checking method? View balance, withdraw funds, deposit funds, exit. Correct? Now I am reading everything. That is account balance using money format, withdraw input, deposit input, and everything will be in get account type method. Correct? And obviously case 4 will be your exit. So it will just print saying thank you for using the ATM, bye. Now similarly for savings account, that is view balance, withdraw funds, deposit funds, etc. Again, we are using switch case to print the saving account balance, saving withdraw input, saving deposit input, everything. So this is all about your option menu class. Now we will see what is there in account class. So here it is just required to set the customer number and set the PIN number. That is first you set the customer number and return customer number. And then you set the PIN number and return the PIN number. So basically account class is to retrieve all the details that is being set in option menu. That is your checking balance, saving balance, your withdraw input, deposit funds, everything that is being mentioned in option menu class. So you can see here that I have checking balance method and I'm returning the same. And again I have saving balance So here you can calculate the checking account withdrawal, that is checking balance equals to checking balance minus account. And then it will return the same. That is, we saw that when we want to withdraw 2000 from 4000, it will say the new saving balance will be 2000. Similarly, the same thing will be here. That is saving balance minus amount, like that. So similarly, you can calculate the account deposit, the saving account deposit, that is the balance plus the amount that you enter. Suppose say the saving balance is 0 and if you enter 2000, so it will add and it will return the balance. Similarly, the same thing with this as well. That is account withdraw input and customer saving account withdraw input as well. And then it will just check the deposit amount. Same thing for savings as well. And I have initialized all these variables as private because I want them to be local to the class. So this is how it works. And now coming to the last file, that is atm.java. So here this class extends the option menu and option menu extends account. So what ATM should do? It should obviously extend option menu. And I'm just creating an object of option menu and just trying to get the login from option menu. So when I execute again, it works same. It will ask same thing again. If I enter something, it says wrong customer PIN or account number. As I have told, if I enter something else apart from the numerics, it says invalid characters, only numbers. That is the exception that I have thrown. So this is all about the ATM project. I hope you understood it. Now let's move further and see the text editor. So here I'm making use of Java swings. That is, I will be using JText area, menu bar, J menu bar, etc. And all the menu items will have action listener to detect any action. And as I have told, it makes use of Java applet and swing concepts. And similarly, all that you just need is a Java installed and the Eclipse IDE. We can say like we can perform all the operations like we perform in your WordPad or your Notepad, and it is very efficient. So now let's see how it works. So first let's execute and see how it works, and then I will explain you the code. So you got a text editor here. You can see you have file and it consists of all the operations like new, open, save, exit. And you have edit option like cut, copy and paste. You have font like bold, plain, italic, and you have size like up to 28. And you have font type, that is Roman, Helvetica, Arial, Courier, Century, etc. And also you can set the background and foreground color, and you can undo and redo the operations. Now let's see each of them how it works. So I want to say like welcome to Edureka YouTube channel and enjoy learning. Now suppose I want to change the font of this. I'll capture everything like Ctrl A and then I'll give font like bold. So you can see here it became bold. Say suppose I want it to be italic. You can see even that became italic as well. I want to increase the font size like 28. It got done. I want to change the font type to Century. Even that happened. Say I want Helvetica. I want Times Roman. Even that happened. Say I want a color to give for that like background color in something like say I want red. Okay. You can see the background color is red. So I want to remove the background color now. Now I will change the font color to be. Say I want to enter some more text like I did as Java projects, and I want to undo that. I can just press Ctrl Z and it goes on removing all that thing, and Ctrl 5 for whatever I have deleted. You can see it's going on. Also you can create a new file that I just did. Also if you want to open something that is already present, you can open from the libraries. Also if I want to save this, I can save it like however I want in the downloads or in desktop, wherever you want. You can save the file by giving save it. It will be saved. I can enter something and again if I want to save it, it will be saved like applet 1. Similarly, you can even check that whether it is being saved or not. So in desktop, you can see it is being saved as applet and applet 1. So basically, this is all about your text editor as how it works. Like you can perform all the operations like edit, font, file, color, undo, redo, everything, etc. Sounds interesting? Let's see what is the code behind this now. So here you can see a undoable text area that extends the text area and implements state editable. Why it implements state editable is because we have defined the editable class in which we can edit all the options like I showed you on the text editor. So you can see here I have given the key state as undoable text area key, and then I have declared the current edit and undo manager. In the first undoable text area, I have defined it in various ways. The first thing, it is 0 parameterized, and then in the next I have defined some parameters like string, and I have given it in super as well. And then I have used rows and columns, and then I have used string along with rows and columns, and then string, rows, columns, and scroll bars as well. So in various ways, I have declared this undoable text area constructor. So if in case something happens, you are stuck and you cannot undo some operations that you have performed, then automatically the exception will be catched here. And next, same for redo as well. If you cannot perform any redo operations, then it again catches an exception. You might be wondering why it need to catch an exception, correct? It's just because to maintain the normal flow of execution so that your further operations will not be interrupted. And next, to store the state and restore the state that I have given, I'm using the key state as a variable. And for the snapshot method, I'm giving like condition if the text is being changed, then use undo and add edit to edit the current state. And now I'm declaring the init undoable and giving some new reference variables for undo manager and current edit, and I'm adding the key listener for new adapter. And then I'm using the focus listener to focus the event that was being captured. And similarly for text listener as well. If the value is changed, it has to say that the text is being changed. And now you can see there's a text editor class which undoable text area has extended. In this, I'm declaring few parameters like frame, file dialog, font, etc. And now here comes the text editor parameters like say courier, its style, its size, everything. And here I have used the option menu bar, that is Times Roman, Helvetica, Arial, Century, etc. And I have given one parameters for each of them. And then using the add method, I'm adding all of them, like appending it to the menu. And we have to use the action listener to detect any action that is being performed. So similarly for bold, plain, italic menu that all we saw. And again using action listener, we are calling that event. And then I'm declaring all the sizes over here that you saw, like till 28. And appending it using the add method. And to detect them, I'm using add action listener. Even for new, open, save, exit. Again using action listener for all them. And for cut, copy, paste, edit options as well. For background and foreground color, and for color, for undo, redo, for everything, it all remains the same. And then I'm implementing the action listener class to invoke that method, correct? Like for undo and redo, and similarly for file name, untitled, for select menu, everything. So whatever the options we have seen here, they all have to implement the action listener class. So you can see I'm detecting save. Else what happens, the action will not be detected. You can see again for exit as well, for read file, everything. And even cut, copy, paste. For everything we have to use action listener classes. Even the size class implements action listener, like for size 10, size 12, for 14, 16, 18, similarly till 28. That's all. And then I'm extending an applet class and implementing the action listener even for this. In bold, I want courier, font, everything. And even in plain, I want the same thing. So as you can see, if I type anything here, so it is by default courier, correct? So that's what is here. That is in get action command, in bold, plain and italic, whatever it is, the first thing is courier, correct? And then comes the type, that is Times Roman, Helvetica, Courier, Arial, Black, Century, everything. And then again, I'm choosing the color, that is the background or foreground colors. And then I'm implementing the main method and setting the size of the text editor to 800 and 600. So that's how it works. Like you can perform any operations on text editor and do rest everything. Now let's move further and see the sign-up form, which is developed using servlets, JSP, and web development tools like HTML, CSS, etc. So I'm just going to create a basic sign-up form. And all that you need is servlets, Java server pages, Apache Tomcat server, and cascading style sheets, and Eclipse for enterprise edition. And it's very easy to develop, as I'll be showing you how. So first let's run the output and check, and then I will explain you the backend code. Make sure that you run on server. My Tomcat server is starting now. So this is the sign up form that we have created. You can enter the name. I'll give some email like 13 or older is my option. So here in the sign up form, you can see your name, email, password, your age. I'll give some biography like I am a footballer, singer, swimmer, etc. Like just my hobbies. I can give my education, everything you can give. Like it's not mandatory that it should be the same thing. And the job role have so many options in web, mobile, business and others. So I'm very interested in iOS developer, so I'll give that. And interests are in development, design, business, everything. And when I sign up, it says, "Hi Chris, welcome to Edureka," because the sign up that I have done got saved. So where will be the output? Like, or where you can see the details that you have entered in the backend. In this console tab, you can see the details that you have entered. That is your name, your email ID, your password, your over 13, your biography, your job role, your interest, etc. So that's all was there in the form. So you can see here in this form, these are the basic information that is being given. So now let's take a look at the backend code. In the sign up, I have created 5 files like HTML for creating a form, CSS file to add some beauty or makeup to the form that we have created. We have servlet class files like request post form and person1.java class. And then to retrieve the data from the servlets, we have the JSP file. And also we have the web.xml file to add the mappings to the servlet. And we have JSP file to retrieve the data from the servlets. So for this front end, that is your sign up form, we have used HTML. You can see here that I have linked with CSS as well. That is for giving some makeup to the file. That is, you can say beauty to the form that you have created. I'm giving form action as request post form and method will be post. So here you can see in the label, you have created like name, email, password, age, your under 13 or above 13, whatever it is. And then for your profile or your biography, you have created one more label tag and giving the text ID is equal to bio and name is equal to user bio. And for the job roles, there are so many. So you have created a first label for job role. And the first opt group label will be web. In web, you have so many options. And again, you're closing that and opening one more opt group label. That will be your mobile, your business, your other. So same things. And then for your interest, like this one, you can see you have checkboxes over here, correct? For that checkboxes, we have given the class type, value, everything. Like for development, for design, for business, everything. And last, it will be the submit button. That will be your sign up. So this is how your index.html file will be. And now coming to main.css file. For each and everything, I have given the paddings like the font family, the color, the maximum width, the margin, background, everything. Even for the first thing that will be the H1, I have aligned it to center. You can see here I have aligned it to center and that is in H1. Even for that, I have given the specified color and the font family as well. And coming down for form as well. And for all these things, I'm using a select type for background, border, font size, height, margin, outline, padding, width, color, everything. Even for the box shadow as well, you can see there's a shadow for this box. It's not just a simple one. And even for the checkboxes, for buttons that is present as well, for field set, for legend tags, for label, for number tags, everything. So this will be your main.css. Now let's take a look at the servlet classes. So first, what I'm doing here is I'm extending a HTTP servlet class, correct? And I'm using a doPost method and declaring parameters for request and response. And I'm requesting all the parameters, that is your username, email, password, age, biography, job. And for your user interest, again the same thing. And then I'm creating an object of person and trying to retrieve all the details. And then I'm trying to request and set the attribute of my person. And then using the dispatcher, I'm trying to request the get request dispatcher from JSP. And obviously in the dispatcher.forward, you will be having a response and request, both of them. So as I have created an object, let's see what is there in the person. In this, it's nothing but it will retrieve all the details. That is, I have made everything as private because I want it to be a private to the person class, and this class is called as a bean class. I'll tell you why. I have made a constructor of person1, and then using the parameterized constructor, I'm trying to reference and retrieve all the details. You can see, like for get name method, I'm returning the name, and set name I'm retrieving. Again, for get email and set email methods, for get password, for get age, set age, for bio, job roles, interest, everything. This is nothing but defining a constructor and retrieving the details. And request post form is essential to send a request and response. And then person1.java is essential to retrieve the details. And then, as I have told, it is requesting a dispatcher to login1. So in the login1.jsp class, I have imported the bean class, that is edureka.person1. Why? Because Edureka is my package and person1 is my class. And then I am giving the scope as request. And similarly, as I have imported the bean class, and similarly to redirect it to the next page, I have used a small icon, and you can say that it says welcome to Edureka. So this is all about the JSP. And then now coming to the last file, that is web.xml, you have to add mappings to the file. You can give servlet name like anything, but make sure you give the servlet class name very properly. That is, it should be like Edureka, that is your package, and your request post form, which is your class name. This should be very correct. And then for URL pattern, that is request post form URL, this should be same as the one which you give in form action tab, that is your request post form URL, or else it will result in an error. So this is all about the sign up form. I hope you understood how it works.
Who is a Java developer? Java developer is a computer software developer, a programmer who integrates Java programming language into the development of mobile and computer applications, web development, and other sorts of requirements needed at both client and server end. Now with this, let us move on to our next topic, which is how to become a Java developer. To become a Java developer, there are basically 3 stages. In the first stage, you have to earn a college degree. The first stage requires you to complete a qualification in computer science with a focus on software development. This could be any degree related to computer science and information technology, or you can either choose Bachelor of Engineering or Bachelor of Technology in the field of computer science or information technology. In the next stage, you need to get certified with Java. The second stage requires you to complete an online or an offline course specializing in core and advanced Java. Trying out online examples is a good way to develop your specialization in Java. And in the third stage, you need to get experienced. The third stage needs you to look for a placement or an internship program while studying. This will provide you with relevant experience as well as guidance and mentorship from experienced software developers. And finally, you become an experienced and professional Java developer. With this, let us move on to our next topic, which deals with the Java developer skills overview. When you Google for the skills required to become a Java developer, you have a lot of skills showing up. Now, we shall categorize the skills required for Java developers into 2 variants. Firstly, the Java developer skills, technical, and later the soft skills of a Java developer. Firstly, the technical skills. The technical skills required for a Java developer are: he must be well known with core Java. The core Java includes object-oriented programming techniques as well as the design patterns in Java, abstract classes in Java, interface, and serialization. Followed by that, we have ORM. ORM stands for Object Relational Mapping. So in this skill, you need to be well versed with Hibernate, Java Persistence API, Eclipse Link, OpenJPA. And after that, you have the Java build tools. Java build tools are the most crucial skills required by every Java developer. Some of the most important build tools are Maven and Gradle. Followed by that, we have web technologies. A Java developer should be well versed with CSS, HTML, jQuery, and JavaScript. Followed by that, he or she must be exposed to Java web frameworks like MVC, Play, Java Server Faces, and next to the Java web frameworks, we have application containers. The most trending application containers are JBoss, Jetty, WebSphere, and WebLogic. And next we have Java testing tools. TestNG, JUnit, and Selenium are the most trending top testing tools for Java. And later we have Big Data. The Java developers must be well versed with DBMS, Hadoop, SQL, and JDBC. Next, we have Java EE components. The most important Java EE components are servlets, Java Beans, Java server pages, and finally, the code version control, which is GitHub. Don't worry, we shall discuss each and every one of them in detail for a better understanding in our next topic, which happens to be the skills required for a Java developer. Firstly, we shall discuss core Java. The most basic and essential skills required to become a Java developer is the core Java. Core Java skills are the building blocks of every successful Java developer. The crucial core Java skills that most recruiters are looking for are: firstly, the object-oriented programming skills. Object-oriented programming approach introduces class and object style of coding that deals with the concept of inheritance, encapsulation, abstraction, polymorphism. The main motto of object-oriented programming is to bind the data with the functions together and improve the code stability and safety. Followed by that, we have design patterns. Design patterns in Java are the standard solutions followed to solve routine problems faced in software designing lifecycle. Every design pattern acts as a blueprint that allows customization to solve any given design problem in any code during the development of software modules. Followed by design patterns, we have abstract classes in Java. Abstract classes in Java help the developers to achieve abstraction. Abstraction in object-oriented programming reduces code complexity by showing the relevant details of the objects used in the program and enhances code readability. Followed by abstract classes in Java, we have inheritance. Java inheritance is an advanced level of achieving abstraction in Java programming language. The interface in Java enables a better and efficient way of achieving abstraction. Followed by this, we have serialization. Serialization in Java is a concept that deals with the conversion of objects into a byte stream and transport the Java objects from one Java virtual machine to another and recreate them to the original form. Serialization enables developers to meet various factors in real-time programming. With this, let us move on to the next stage where we shall discuss about the Java build tools. Depending on the task assigned, developers need to use a specific tool for every particular task. For a Java developer, understanding the terminology of build tools in Java comes handy, as Java build tools are the programs that automate the creation of executable applications. Build tools that one must know are Maven and Gradle. Followed by this, we shall discuss the web technologies. Web technologies provide a simplified and faster way to create dynamic web content. Having a better grip on web technology is important as it helps to understand the technique of establishing communication between multiple computer systems via markup languages. It gives a way to interact with hosts for the information like websites, and it involves HTML, jQuery, and CSS at the most. Followed by this, we shall discuss Java Web Frameworks. To build a mobile application with best features and limited code, Java Web Frameworks are the best-in-class solutions. They support the development of web applications including web services, web resources, and web APIs in a standard way to build and deploy web applications on World Wide Web. Some of the best-in-class frameworks are Spring MVC and Play. Followed by this, we shall discuss Java Application Containers. Java Application Container is an application program in which the software building blocks known as the compartment can be run. Application containers are designed to provide multiple functionalities such as to provide user authentication, logging, or establishing a connection with the database. Top-notch application containers are JBoss and Jetty. With this, let us move on to the next stage where we shall discuss the Java testing tools. Java tests with an interface where you don't have to actually launch your application onto a web browser. They support multiple test activities from planning, requirements, creating a build, test execution, defect logging, and test analysis. Some of the major testing tools that a Java developer should be well versed with are Selenium and TestNG. With this, let us move on to our next topic, which is big data. Big data has become a trillion-dollar industry, and handling such a huge amount of data has become close to impossible by traditional data processing software. Learning big data technologies will help the developers to analyze and extract information from complex datasets. Some of the powerful big data technologies are Hadoop and Spark. Now with this, let us move on to the next topic for our discussion, which is Java EE components. Java EE components or enterprise components. The Java enterprise components enable developers to write server-side applications. One of the most common challenges that an enterprise developer faces is how to handle requests coming from web-based clients. To ease this challenge, Java Enterprise provides the Java Servlet and Java Server Pages APIs that enable methods for logging activities using cookies on a user's browser and simplify these kind of issues and provide the best solution. Some major Java Enterprise components are Servlets, Java Beans, and Java Server Pages. With this, let us move on to the next topic, which is code version control. Code version control allows developers to keep track of their work and helps easily to explore any changes they made in their data, coding, scripts, commits, etc. that is much smoother and easier to implement. With this, let us discuss the second stage of Java developer skills, which are the soft skills. Soft skills are people skills, communication skills, character, and social intelligence, among others. Soft skills enable people to navigate their environment, work well with others, perform well, and achieve their goals. Now, the first soft skill that we will discuss today is the communication skill. Good communication skills include active listening, where you have to pay close attention to the person who is speaking to you and try adapting your communication style to your audience and convey your message in a better manner. Followed by this, the next one is open to learning. Knowledge is never ending. Successful Java developers should always be open to learning new upgrades in the technology and keep themselves updated. The next one is teamwork. Teamwork is a collaborative effort of a team to achieve common goal and to complete a task in the most efficient and effective way. The next one is work ethics. Work ethic is a belief that hard work and dedication have a moral benefit and an inherent ability, virtue, or value to strengthen character and individual abilities. The next one is interpersonal skills. Interpersonal skills are the qualities and behavior of a person used to interact with others properly. The better the interpersonal skills, the better the growth in one's career. Now with this, let us discuss the last part of this session, which is salary details of a Java developer. Java programming language is one of the most demanded ones in the IT industries. Let us now discuss the salaries offered to Java developers. As you can see, for a beginner, the salary package lies between 3 to 8 lakhs per annum. And similarly, for an experienced candidate, 8 to 13 lakhs per annum, and the maximum salary offered to a Java developer who is experienced for more than 8 years, approximately 28 lakhs per annum, or greater than that as well.
To get started with Java, first you need to understand how Java behaves. So what exactly is the way it communicates with the end user? Its compiler, its interpreter, the JVM, and its terminology. In Java, we do have a compiler. Don't take me wrong, but yeah, we do have a compiler. So basically, when a Java developer writes a code, it will be the first decoded and converted into bytecode by the Java compiler. This bytecode is then transformed to the JVM. JVM, or the Java Virtual Machine, is the one that makes magic happen. Here is where the code is interpreted and the relevant output gets generated. It is because of this virtual machine methodology, Java has become platform independent, and it can perform its operations regardless of what operating system it is running on. The same code that you have written in a Linux operating system can be run on Windows. Now moving ahead, we shall get into the variables, data structures, data types, methods, and the libraries available in Java. Similar to the C programming language, Java also has all the similar types of variables and data types. We have integer, float, double, string, character are a few to name. So followed by the data types and variables, we have the data structures. So data structures is a data organization, management, and storage format that enables efficient access and modification. So more precisely, a data structure is a collection of data values, the relationships among them, and the functions or the operations that can be applied to the data. In Java, we have arrays, linked list, everything similar to C programming language, and now discussing each one of them deeply would take a lot of time and effort, but don't you worry guys, I have dropped down a link in the description box that will redirect you to the landing page of Java complete tutorial, and also there's a link to the data structures and algorithm videos as well. So your next mission would be to install and set up Java environment in your local system. Don't worry, I'll drop a link in the description box below that will clearly explain you to install Java and set up its environment in your local system. Now that we have a briefing about fundamentals, let us move right ahead into the next part, that is the core Java. So inside core Java, we get to learn the basics of OOPS concepts, which is nothing but object-oriented programming concepts like data abstraction, encapsulation, inheritance, and polymorphism. Then we learn about the basic Java constructs like loops and data types, string handling, collection framework. Then there is multi-threading, exceptional handling, generics, and synchronization. After that, we learn about serialization and deserialization, concurrent collection, etc. These happens to be the most crucial parts. Edureka has beautifully organized these concepts in a step-by-step manner with detailed description of technology along with practical examples for a better understanding, and also have prepared video tutorials on the same. Followed by core Java, we move ahead and learn advanced level of Java programming that will introduce us to the following concepts, which is JDBC, nothing but Java database connectivity. There is servlet, JSP, and testing, and many more. Of course, so by now you will be able to write programs on your own and also create a beginner's project as well. But hey, wait, journey doesn't have to end here. Every beginner, intermediate, or a professional programmer always try to learn Java to enter into a specific development domain. Similarly, Java too has multiple development domains into which you can see yourself after mastering Java programming language. Top-notch domains you can enter after mastering Java are as follows. So first one is Android application development, then you have big data and cloud. There is desktop application development, and lastly machine learning and artificial intelligence. Yes, you heard me right. Machine learning and artificial intelligence. Java has been evolving since day one, and Java, which we have seen back in the days, and the Java in the current scenario are completely different. And its evolution made Java so powerful and capable that one could not only design machine learning algorithms, but also many more. Now let's discuss about the frameworks that person needs to learn to enter into a specific domain. So the first one is Android development. To master Android development using Java, one needs to learn the following frameworks, which is Corona SDK, quite easy to learn and very powerful. Yes, you heard me right, Corona. And please guys, let's just stay home and upskill and find ourselves at the best working environments after the pandemic ends. And now let's get back to our framework. So Corona SDK is a cross-platform framework for rapidly creating apps and games for mobile and desktop devices. That means you can code once and load the apps and games into multiple devices at once. And the Java platform independence actually is the nature that helps us load the games and apps regardless of the operating system the device is working on. After this, we have the app builder, which is used by some of the principals enterprises across the globe. So the app builder framework supports a codeless user interface to enable swift app development. It works most excellent when utilized to build information-based applications. The framework has pre-built blocks for functionalities like push notifications, polls, feedbacks, updates related to content, intelligence, and analytics. Best of all, it integrates with Google Play, making it probable to publish completed apps with just a single click. Then we have a phone app, which is being sponsored by Adobe and Apache, and it actually works as a cross-platform application. It is the most trendy Android app development framework around the globe, and it comes from the team following Apache Cordova, which is an open source mobile development framework that utilizes C, SS3, HTML5, and JavaScript for cross-platform development and is entirely open source. At its heart is an instinctive desktop application utilized to build apps and serve those applications to link mobile devices. At the end of the day, they are no more difficult to understand text commands which can simply turn or get erroneous and are even tough to memorize as an Android developer framework. After that, we have Appcelerator. The Appcelerator Titanium framework is an integral part of the Appcelerator platform, which comprises each tool mobile app developers may require in developing, applying to test, and the development of the needed apps. The Titanium framework uses functionalities of JavaScript to call an enormous collection of APIs, and these APIs call native features of the operating systems, providing incomparable performance as well as native look and feel. Followed by Android development, we have big data and cloud. So servers are the backbone of big data and cloud. So for Java developer, learning server-side programming is mandatory. First one would be Spring. With its concept of dependency injection and aspect-oriented programming features, Spring took the development world by storm. It is an open source framework used for enterprise applications. With Spring, developers can create loosely coupled modules wherein dependencies are handled by the framework rather than depending on the libraries in the code. Then we have Struts. Apache Struts is another robust open source framework for web applications. It follows the MVC, which is Model View Controller model, and extends the JSP API. In a traditional servlet JSP approach, If a user submits, let's say, a form with his details, the information then goes to a servlet for processing, or the control goes over to the next JSP. This becomes confusing for complex applications, as the view or the presentation layer should ideally not have business logic. Then we have Hibernate. Though Hibernate is not a full stack framework, it completely changed the way we looked at the database. Implementation of Java Persistent API, or we can also call it as JPA. Hibernate is an object relational mapping or ORM database for Java applications. Just like SQL, queries in Hibernate are called HQL, like Hibernate Query Language. Hibernate directly maps Java classes to corresponding database tables and vice versa. And then we have Apache Wicket. So if you have already worked with JSP, the learning wicket will be a cakewalk. A simple web application framework, Wicket has a component-oriented structure, and all you need to know is Java and HTML. Absolutely no XMLs or configuration files. Wicket is lightweight and you can build applications really fast. It is also easy to unit test code written in Wicket. Then we have Java server faces. So don't confuse JSF with JSP, which is just a text document that can have static and dynamic content. So JSF is developed by Oracle as a part of the Java Enterprise Edition 7. It is a component-based MVC framework and has reusable UI components for server-based applications. The main idea is to encapsulate various client-side technologies like CSS, JavaScript, and HTML that will allow developers to create UI without knowing any of these technologies in depth. So they can just drag and drop UI components and focus more on their presentation layer specifics. Next in the docket is the desktop development. So to master desktop development using Java, one needs to learn the following frameworks, which is Blade, nothing but a simple application framework with a minimal footprint. And Blade is a lightweight and high performance Java framework that allows you to build fast web applications in a straightforward way. The creators want users to understand the whole framework in a single day. Therefore, Blade focuses on the simplicity and elegance. Then we have Drop Wizard, which is nothing but a production-ready RESTful web services. So Drop Wizard is a high-performance but straightforward Java framework for rapid development of RESTful web services. It's especially suitable for creating Java microservices. Then we have Grails, which is a Groovy-based web application framework. And Grails is a web application framework that uses the Groovy programming language. And Groovy is an object-oriented language for the Java platform that intends to enhance developer productivity. Its syntax is compatible with Java and it's compiled to JVM, which is Java Virtual Machine bytecode. Then we have Google Web Toolkit, which is a client-side Java apps deployed as JavaScript. Or the Google Web Toolkit is a brilliant web framework created by Google. In fact, GWT fulfills the dream of every developer who wants to build Java apps for the web, as it allows you to write client-side Java code and deploy it as JavaScript for the browser. And then we have Hibernate, which is an object relational mapping framework for a better database communication. Hibernate is a stable object relational mapping framework that makes better communication possible between the Java programming language and relational database management systems. And also with these, one needs to learn to build tools, GitHubs, and design patterns. So the build tools like Maven, Gradle, and software development methodologies like DevOps and continuous integration and continuous deployment helps programmers excel in the process of software development. The GitHub helps programmers to stay updated with all their codes and pull requests. Design patterns are like the predefined and tested recipes for programmers to design their softwares in the perfect ways to avoid all possible bugs in their coding approach. And I will have the design patterns in Java article and tutorial video linked in the description box below for better learning.
What are Java frameworks? Java frameworks are the bodies of pre-written code to which you can add your own code in order to solve a problem. You make use of the frameworks by calling its methods, inheritance, supplying callbacks, listeners, or other implementations of the pattern. A framework will often dictate the structure of an application. Some frameworks even supply so much code that all you have to do is write a very little code for your application. This can be good or bad depending on how easy is it to use. Frameworks are actually the substance of the program. You can either build it on a good one if your program is solid and fast and comes together beautifully, or you can build it on a bad one if it is short and brutish. Okay? Jokes apart, but Java frameworks plays a vital role in software development. So now that you've understood what are Java frameworks, let's take a look at the different frameworks in use. So I have a couple of popular Java frameworks on list. So they are namely Spring, Hibernate, Structs, JWT, that is Google Web Toolkit. Then we have Java Server Faces, that is JSF. We have Grails, we have Varden, Blade, Drop Visit, and Play. So let's understand them in detail. First, we'll start with understanding the Spring Framework. Spring Framework is a powerful, lightweight application development framework used for Java Enterprise. The core features of the Spring Framework can be used in developing any Java application. It is described as a complete modular framework. This framework can be used for all layer implementations of a real-time application. It can also be used for the development of particular layer of a real-time application, unlike the other frameworks. But with Spring, we can develop all the layers. Spring includes all the modules of Spring MVC, Spring Core, Spring Security, and Spring ORM, which are basically used in enterprise applications. Now let's see where this Spring Framework is used. Spring Framework is mainly used for web application development. Its features can be used to create any Java application, and it is also used in Java Enterprise. Okay, so these are the uses of Spring Framework. Now let's take a look at the advantages of the Spring. It provides a lightweight container that can be triggered without using a web server or application server software. Spring supports JDBC that improves productivity and reduces the error. It also targets to make J2EE development easier to use. Spring also supports both XML and annotation-based configuration and also provides backward compatibility and testability of code. Okay, now these are the notable advantages of Spring. Moving ahead, let's discuss about the top companies which use the Spring Framework for application development. They're namely Netflix uses Spring Boot, Yatra uses Spring MVC, Amazon, and eBay. Okay, so these are the notable companies which use Spring Framework. I hope you guys are clear with the Spring Framework. Now let's move ahead to our next framework, that is Hibernate. Hibernate ORM is a stable object relational mapping framework for Java. It makes better communication possible between the Java programming language and the Relational Database Management System, that is RDBMS. Okay, so let me brief you about this. When you work with an object-oriented language like Java, you'll encounter a problem called object relational impedance mismatch, which is also called paradigm mismatch. This is because the object-oriented languages and the RDBMS handle the data differently, which can lead to severe mismatch problems. So this Hibernate provides you with a framework that overcomes the mismatch problems in Java. Okay, now let's take a look at the uses. It allows you to develop persistent classes following the object-oriented idiom. It also allows you to communicate with any database using very tiny alterations in the code, bridging the gap between the objects and the relational words. It also offers an advanced ORM framework that lets you perform the database operation on the Java entities. So this is about the uses of the Hibernate framework. Now let's take a look at the advantages of this framework. It mainly offers portability, productivity, and maintainability. It is free and open source framework, so you don't have to pay for this framework at all. And it also removes a lot of repetitive code from the JDBC API. Okay? Now talking about the major companies that use Hibernate framework for application development, we have Oracle, IBM, Dell, Accenture, and many more. Okay? So I hope you guys are clear with the Hibernate framework. Now let's move ahead and understand what is the Struct framework about. This is another enterprise level framework maintained by the Apache Software Foundation, that is ASF. This is a fully featured Java web application framework that allows the developers to create an easy to maintain Java application. There are mainly two versions of this framework, that is namely Struct 1 and Structs 2. But all the companies prefer using Structs 2 because it is the upgraded version of Apache Structs. And what is this Structs 2? Structs 2 is the combination of the web framework of OpenSymfony and Structs 1. Now let's take a look at the uses of this framework. The Structs 2 framework is used to develop an MVC-based web application. It uses and extends the Java Servlet API in order to help the developers to develop an MVC architecture. Okay, so this is about the uses of structs. Now let's take a look at the advantages. This framework documentation is written for active web developers and assumes a working knowledge about how Java applications are built. It also reduces the development time and makes the manageability of the application easier. It offers centralized configuration. Rather than coding information into Java programs, many structs values are represented in XML or property files. You can also integrate structs with other Java frameworks in order to perform tasks that are not built on the platform. Okay, so this is about the advantages of structs. Now let's take a look at the major companies that use structs framework for application development. They are namely Infosys, Accenture, NextGen, and many more. Okay, so I hope you guys understood what are structs. Now let's move ahead to our next framework, that is Google Web Toolkit or GWT. This Google Web Toolkit is a completely free open source framework that helps the developers to write client-side Java code and establish it as JavaScript. A lot of Google products are written using JWT as AdSense, Google Wallet, and Blogger, and many more. Using GWT, developers can easily code complex browser applications rapidly. It also allows to develop and debug Ajax applications in Java. Another most awesome thing to note about GWT is that you can write complex browser-based applications without being an expert in front-end technologies like JavaScript optimization or responsive design. Okay, so this is about GWT. Now let's take a look at the uses. Okay, it is mainly developer friendly. It is used in all the Google APIs. It helps in creating and maintaining complex JavaScript front-end applications. Okay, now let's take a look at the advantages. It supports reusability for common web development tasks. Google APIs can also be used in GWT applications. It also offers cross-browsing portability, UI abstraction, bookmarking, internationalization, and history management. So this is about GWT. Now let's move ahead and understand what are Java Server Faces, that is JSF. Java Server Faces was developed by Oracle for building user interfaces for Java-based web applications. It is also an official standard of the Java Community Process Initiative, and it is also a pretty stable framework. JSF is a component-based UI application. It is based on the MVC software design pattern and has an architecture that totally defines a distinction between application logic and representation. Okay, now let's take a look at the uses. As I mentioned, it offers component-based UI framework and helps in building native applications. Okay, now let's take a look at the advantages. JSF is an integral part of Java Enterprise Edition. It provides excellent tools and rich libraries. It also allows existing backend Java code to be extended with the web interface without having to change the base application by introducing a new framework. Okay, so this is about the Java Server Faces. Now let's move ahead to our next framework, that is Grails. I think most of you would have heard about Grails. Grails is a dynamic framework coined by the groovy JVM programming language. It is an object-oriented language for the Java platform which intends to enhance the developer productivity. Its syntax is compatible with Java and it's compiled to JVM bytecode. Grails also work with Java technologies like Java Enterprise Edition containers, Spring, SiteMesh, Quartz, and Hibernate. Now let's take a look at the uses. It is a developer-friendly framework as it comes with detailed and easy-to-read documentation. You can also build your own plugins and include the Grails IDE support for different platforms. Most of the e-commerce sites make use of this Grails. Now let's take a look at the advantages. It utilizes Groovy as its coding standard, and since Groovy is similar to Java, programmers out there think it is easier to begin with Grails instead of Java. And it is also easy to use object mapping features. It also promotes reusability of code between different Grails applications by modularizing the application in the form of plugins. It provides flexible profiles. Okay, so this is about the Grails framework. Now let's move ahead and understand what is Vaadin. Vaadin is a web application framework which focuses on UX accessibility. It provides you with a platform for streamlined Java development. Vaadin also allows you to build web applications of customizable components. A recent version of Vaadin, that is Vaadin 10, approaches web application development in an entirely new way. It gives you direct access to the document object model from the Java virtual machine. With this new release, the Vaadin team split the previously monolithic framework into two parts. It also has a lightweight Java framework called Vaadin Flow that handles routing and server-client communication. Vaadin comes with a big set of web components that are fine-tuned for UX performance and accessibility. This means that you can build great-looking applications faster. It is also considered as the fastest way to build web applications in Java. Now let's take a look at the uses. This framework automates all the communication between the browser and the server. It also simplifies the web application development. Now let's take a look at the advantages of Vaadin. Vaadin gives you an opportunity to bind data using either MVC or MVP. The drag and drop support along with other outstanding features simplifies the creation of a single page UI. It also offers automatic client-server communication with WebSocket support. It makes use of Java or HTML for building views. Data binding is also possible. It also offers router with the nested root and parameter support. It supports JVM languages like Kotlin and Scala and also has built-in Spring support. Okay, so this is about the advantages of Vaadin. Now let's move ahead to our next framework, that is Blade. Blade is a simple, lightweight and high-performance Java framework used for providing a full-stack web framework. It is a lightweight MVC framework that provides a RESTful routing interface, making the web API cleaner and much easier to understand, and also helps in synchronizing data with the website. Blade is based on the Java 8 version, and the web server and the template engines are built into the framework too. It has a minimal code impression, which means that the source code is less than 500 KB in total. Isn't that great? Now let's take a look at the uses of this Blade. Blade helps you to be self-contained, elegant, intuitive, and super fast. It is used to create a small MVC application, not a bigger one, but a very smaller one. Now let's take a look at the advantages of Blade. Blade supports plugin extensions and WebJar resources. It supports configuring multiple files at the same time and XSS, that is cross-site scripting, and also possesses cross-site request forgery, that is CSRF, and cross-site scripting XSS for defense support. Okay, now this is about Blade. Now let's move to our next framework, that is Dropwizard. Dropwizard is a high-performance Java framework used for rapid development of RESTful web services. It is especially suitable for creating Java microservices. The Dropwizard framework pulls together various well-established Java libraries in order to provide with a fast and distraction-free development platform. Dropwizard is a separate ecosystem that contains all the dependencies bundled into a single package. Okay? Most of the developers out there would not have known about this framework. But let's take a look at the uses. It offers operational friendly Java frameworks. It also helps in creating Java microservices. Now, what about the advantages? You can easily perform rapid prototyping using Drop Wizard. It helps in developing high performance RESTful web services and also supports many open source and independent libraries. It also offers quick project bootstrap and also helps in increasing the productivity of the application. So this is everything you need to know about Drop Wizard. Now let's move ahead to our final framework, that is Play. Play is a reactive web and mobile framework for highly scalable Java applications. It is also considered as a unique Java framework as it does not rely on Java Enterprise Edition standards. Play makes it possible to develop lightweight and web-friendly Java and Scala applications for desktop and mobile interfaces. It is often considered with powerful frameworks of other languages like Ruby on Rails for Ruby or Django for Python. It intends to remove all the inconvenience of traditional Java web development like slow development cycles, a lot of configuration, and many more. Built upon aka toolkit, Play framework truncates the creation of concurrent and distributed applications on a Java virtual machine. So this is about Play. Now let's take a look at the uses. It helps in creating web applications that demand content creation. It also builds Java and Scala applications. Now let's take a look at the advantages. It offers features like hot code reloading, convention over configuration, and error messages in the browser. It also supports non-blocking I/O, which is crucial for high-performance applications. It is more flexible and offers failure-tolerant results. Okay? So this is everything you need to know about the top 10 Java frameworks which are in use. You might get a question, which of these are the best and which one should you use? The answer to this would be, it depends on what you want to develop. If you want to create a front-end application, you can use Google Web Toolkit. Or if you want to develop a Java Enterprise Edition web application, you can use Struts. Okay? In the same way, it depends on the user what he wants to develop. So it's up to the user which framework he wants to use for his application.
The beginners level category, which will deal with head-first Java, clean code, Java, the complete reference, Java concurrency in practice, effective Java. Now let's get started. So the first book that we will be discussing in our first category, the beginners level, is The Head-First Java. The author of The Head-First Java is Kathy Sierra and Bert Bates. The latest version of this particular book, which is the second edition, has been recently published. It was published by the most famous publisher, which is none other than Schroff O'Reilly. If you're just getting started with Java, there is no other book better than Head-First Java. This book is really simple that explains the concepts in layman's terms and easily relates the Java programming concepts to real-life analogies. This book covers all the object-oriented programming concepts in great detail, which makes the beginner to easily get the hang of programming in Java. A few other helpful topics covered in this book are common object-oriented mistakes, distributed programming with RMI and network sockets, and threads, along with 42 mind-bending puzzles for a thorough understanding of the concepts. Though this book hasn't been updated after Java 5.0, still it is an absolute stepping stone for a building programmer. Now, followed by the Head-First Java, we have another book by the name Clean Code, a handbook of agile software craftsmanship. The author for this particular book is Robert Martin, also known as Uncle Bob. Its first edition is being published by the most famous publishers, the Pearson Education. Clean Code is one of the classic books preferred by Java programmers. If you are a noob, this book will definitely help you constructing better code, which otherwise can be a bit challenging. While this book is mainly centered around the object-oriented principles, you will find this book divided into 3 sections based on the level of complexity of the concepts. The first section, which covers the patterns, practices, and principles, which are the pillars for writing clean code. The next section covers a wide range of case studies in an ascending complexity order. Finally, the third section, which is just one chapter, focuses on a list of techniques gathered while curating the case studies in the previous section of this book. To conclude, I would say this book will give you a strong base for building knowledge on Java and teach you various programming techniques and practices that will eventually help you in day-to-day life as a programmer. Now, followed by the clean code, the third book in the list is Java, the complete reference. This book was written by Herbert Schelt. The latest version of this particular book is the 11th edition, and it is published by the famous publishers McGraw-Hill Education. This book is one of the most recommended and easily available books to get your hands on Java programming. It might not be that helpful for a complete novice, but if you have a basic understanding of Java, then this book will work wonders for you. As the name suggests, it is a very convenient and comprehensive reference book with over 1,000 pages. This book is a well-structured and fully featured source of Java programming with real-world examples. This book is a perfect tool for learning Java as it covers basic Java concepts such as Java 8 APIs, fundamental programming principles, Java language syntax, and keywords with extensive topics like Java beans, servlets, applets, and swing. So, if you're on a journey to master Java, this book is a perfect match for you. Followed by Java, the complete reference, the fourth book in the list is Java Concurrency in Practice. The authors for this particular book are Brian, Tim, Joshua, Joseph, David, and Douglas. The latest edition of this particular book is being published by Addison Weasley Professional. This book is not definitely for the noobs, but it is definitely for the programmers whose feet are already wet with Java programming. The Java Concurrency in Practice book is one of the best Java programming books out there if you want to gain rich understanding of Java concepts such as concurrency and multi-threading. It is very essential for any ardent Java developer, but might appear a bit challenging at the beginning. Thus, before you jump onto this book, I would suggest you to get your basics done. Else, this book will appear as an alien language book to you. But let me make one thing very clear. There is no better book than Java Concurrency for learning concurrency and multi-threading in Java, which is an integral part of this language. So the fifth book in the docket is Effective Java, and the author is Joshua Block. The latest edition of this particular book is the third edition published by Addison Weasley. The book Effective Java falls under the category of must-have book for every Java programmer as well as Java aspirant. This book can be referred to along with other Java books or learning material. This book basically constitutes 78 best practices that help a programmer to code effectively. All the mentioned best practices in this book have been categorized into 11 distinct sections like concurrency, generics, and methods. This makes the learning curve shallower and helps in better understanding. The book hands down something to Java programmers of any skill level. The latest edition of this book is strongly built around Java version 7, version 8, and version 9. So with this, we conclude the first category of the top 10 books for learning Java. Followed by the beginner's level, we have the advanced level. In this category, the books discussed are Java, a beginner's guide, Java Performance, a definitive guide, Spring in Action, Test-driven, Mastering Java Machine Learning. Now we shall move ahead and understand the remaining 5 books for learning Java. The sixth book in the docket is Java, a beginner's guide. The author is Herbert Schelt, and the latest edition of this particular book is the 8th edition published by McGraw-Hill Education. As the saying goes, never judge a book by its cover. Well, in this case, by its title. Though the title says Beginner's Guide, actually this book is very useful even for the seasoned Java programmers. It is one of the most comprehensive and complete books available in the market for learning Java. It comes with extensive hands-on exercises as well as a quiz section at the end of each chapter. This enables the reader to self-evaluate his or her learning journey. With the latest edition release, this book has been fully revised to include Java 11 SE, which means it includes complex concepts such as lambda expressions and functional interfaces. So, this might be the book just what you're looking for. Now, followed by Java A Beginner's Guide, the 7th book in the docket is The Definitive Guide to Java Performance. The author is Scott Oakes, and the latest edition has been published by O'Reilly Media. Moving further into advanced Java programming, we come across the concepts such as garbage collection, Java virtual machine, and performance tuning, and many more. The only way of mastering these concepts is through the book Java Performance. This book covers all the above mentioned topics in a simplest yet effective manner. This book will teach you how to maximize Java threading and synchronization performance features, improve Java-driven database applications, tackle performance issues in Java EE and Java SE APIs, and many more. So, followed by the Java Performance, the 8th book in the list is Spring in Action. The author of Spring in Action is Craig Walls, and the latest edition, which is the 5th edition, has been published by Manning Publications. Learning Java will always be incomplete without learning about at least one of its frameworks. Spring is one of the most heavily used Java frameworks for web application developments. You can learn it easily through this Spring in Action book. This book doesn't just focus on Spring framework, but along with the course, you will dig deeper into the concepts like JDBC to find out the unseen shortcomings of JDK and many more. Not just this book will also tell you how the Spring framework helps in filling these small yet significant gaps. One thing is for sure, once you are through this book, you will discover new horizons of Java. Now, the 9th book in the docket is Test-Driven. Test-Driven Design and Acceptance, Test-Driven Design for Java Developers. So the author for this particular book is Lasse Koskela. The latest edition of this particular book has been published by Manning Publications. For the programmers who want to change their field from developing to testing, this book is a perfect solution for you. This book is an excellent book for learning how to build unique automation testing programs. This book provides industry-based examples to test drive Java code. It also covers topics like acceptance test-driven development, the FIT framework, and testing Java EE components, JSPs, servlets, and Spring controllers. So, if you're one among those who prioritize code quality as well as have a knack for writing unit, integration, and automation testing, this book is definitely for you. So, followed by Test-Driven, the last book in the list is Mastering Java Machine Learning. The author is Edureka Java. The latest edition, which is the 2nd edition, has been published by Pact Publishing. This book covers a wide range of topics that are used rigorously today in the machine learning domain. Through this book, you will gain a comprehensive knowledge of linear algebra, probability, and statistics. Not only this, but through the Java Machine Learning book, you will also learn about standard issues such as text mining, classification, clustering, big data, and machine learning. The main highlight of this book is that it is loaded with 10 real-world case studies, each of them highlighting various techniques of machine learning. So, in case you have already mastered Java, this will help you in exploring the new domain of machine learning.
So let's just start with something known as the basic questions which are asked to the candidates in the entry process. So the very first is the difference between 3 terms, that's like JDK, JRE, and JVM. So as a Java developer, you must have a fair knowledge what exactly are these 3 terms, right? So guys, let us understand now. So Java virtual machine is basically an abstract machine. It's a software which is already provided by the platform. So it provides the runtime environment. Whenever you are writing the Java source code, it gets compiled into the bytecode. So JVM is that there which is going to execute your bytecode now. Other than that, you got JRE, which is the runtime environment. Now it's basically where JVM is gonna use the JRE. So JRE is set of libraries required by the JVM in order to execute your code. JDK is one development kit required by the Java developer. So it consists of various APIs for you. through which you can write your code. So just for an instance, right, so JDK will contain your various packages coming into, for example, java.io, java.utils, all these APIs, the set of library, the information that comes from your Java development kit. Other than that, it has various tools also available. For example, Java and Java C, right? So Java C is a tool which is used for compilation, whereas Java is for the execution of your bytecode. So these tools are also part of JDK. So let's switch on to the next question. What is synchronization? This is one of the hot favorite questions. Whenever you talk of threads, so we do have this term known as synchronization. So synchronization is something where multiple threads, if they're gonna access the same object, right? So there is only one resource which multiple threads they want to access. You need to come up with something known as synchronization. So guys, what is synchronizations? Here we'll take up one example. Let's say we want to book a movie ticket and it's gonna be one seat which has to be booked by multiple people, right? So let's say one corner seat in the last row has to be booked by multiple people. So multiple people over the web will treat them as multiple threads. They are looking on to a single object on a single resource that's like the last row, last seat, right? So whosoever will first of all try to block that seat will be given an access, and no other person can thereafter block that seat. So synchronization is very much in line to this concept. When you got multiple threads which are going to work over a single object, you need to use a keyword known as synchronized, with the help of which you will be able to acquire the locks on your objects. So synchronization is a process which gonna keep all the concurrent threads in the execution to be in a synchronous mode, one after the other. The lock acquisition is gonna come up into action. Synchronization will avoid the memory consistency errors due to any inconsistent view of the shared memory. Let us understand the difference between processes and threads now. So synchronized word came up and we started off something known as thread. So let us understand what exactly is process and what is a thread now. So guys, in order to come up with process and thread, let's just have one visual coming in. Let us say you got this layer as an operating system, right? So we'll say that this is one operating system. It can be any OS now, right? It can be Windows, Mac, Linux, any of the flavor. So when you're gonna run the program, what OS will do? OS will create a process, right? So this process will be created by the operating system whenever you are supposed to execute your application. So other than that, what it does is it will also give you some storage space where RAM will come into action, right? So further, the RAM can have various data structures coming into it. For example, you can have the data being stored in the form of stack or the heap, right? So that's like the storage concept. Let us say I got one program which I need to execute. So whenever I'm going to execute my program, so the running instance of your program over the operating system is nothing but it's a process. Within the process, we have one guy known as main thread. So main thread is what? This is the guy which will execute some instructions, or you can say some sequential tasks which you mention in your main method, right? So whatever the statements you are writing in your main method, they are nothing, they are these tasks which are executed one after the other via main thread within the process. So guys, a process is running instance of your program over the operating system, and a thread like a main thread is running within the process. So we must understand threads are available within the processes, and processes are running on top of operating system. There might be a scenario that a particular task, like I'm just going to highlight this task over here. So this might take a longer time, right? So let us say this particular task will take a minute or so because it's gonna fetch the data from the server now. So in this context, right, so these three tasks, they will be blocked, right? So when I am talking about these three tasks, the yellow states, so they're gonna get blocked now. So what we can do, we can bring down one more thread, and we'll say that this is one user thread or child thread. So we got various other terminologies for this guy, right? And we'll offload the heavier task over here of the main thread to the user thread. In this way, what we are able to do is we are able to outsource the heavier task to some other thread, and we will be coming up with a concept of concurrent programming. That is what we want to achieve now, right? So let us understand what has happened over here, guys. So let's see this part now. So process and thread, they are two different concepts, but we must understand now any executing instance of a program on top of your operating system is nothing but it's a process. So on operating system, we got multi-processing, whereas thread is something which is a subset of the process now. So within a process, you got multiple threads. So multiple processes on OS level, multiple threading on process level. When you talk about the communication, so one process, when it wants to interact with the other process, we call the processes as inter-process communication, where threads within a process, they can directly interact with each other. When we talk of the control statement, so processes can only exercise control over the child processes, whereas threads can exercise considerable control over the threads of the same process. Any change in the parent process will not affect the child process, whereas if there is something where the main thread is getting affected, the other user threads or the child threads, they might get affected. If you talk of the memory structure, so processes, they run in the separate memory space. Each and every process will have its own memory space, whereas threads, they want to share the same memory space which is being allocated to the process by the operating system. So guys, once again, process is controlled by OS, whereas threads are controlled by the programmer in a program, right? Or you can say by the process itself. If you talk of the dependency level, processes are independent, where threads, they're gonna get dependent, because if you can notice this image right over here, so we created this user thread and there is a dependency that this task has been outsourced to this user thread by the main thread. So dependency of the main thread over the user thread relies, and vice versa, right? So it can be based on our logics even. So let us move to the next concept now. So the next fundamental is, what exactly is a wrapper class? Now this is also one of the hot favorite question which is always asked. What is the wrapper class? What is meant by the term boxing or the auto boxing? So let us see this part, guys. So wrapper classes, they are the way where we can convert the Java primitives into the reference types, that's like the objects. So each and every primitive type has a wrapper class defined, and it's in by default they are available in java.lang package. You need not to import any package. So for boolean we got boolean, right? For char we got character, and for int we got integer, for double, so on and so forth, guys. So wrapper classes are the means by which you are able to convert your primitives into the references. So let us understand what exactly is this conversion of primitives into references. Let us say I got this I as 10. So we call this guy as a single value container, because I can contain only one value. It's not an object now, it's a primitive type. You want to convert this primitive guy into an object, you say integer iref assign new of integer, and you mention this guy I as a part of constructor. So what we have done, we have boxed. So it's like constructing the object now, constructing the object. So that's what we have done, guys, over here, right? So this particular statement over here is known as boxing. On the other way around, when you say in jassign iref dot int value, so this concept is known as unboxing, right? Extracting the value from object. So you must understand this concept over here, boxing versus unboxing, which is achieved with the help of wrapper classes. Other than that, you can also say integer kref assign I. So this is known as auto boxing, right? So this instruction is translated internally by the compiler as in integer kref assign new of integer, where we got this guy known as I, right? So this is auto translation. You need not to write the whole statement. So you just mention the partial statement or the implicit statement. We call it as auto boxing. And if you write down, let's say L assign kref, right? So this is known as auto unboxing. So important question again, what is boxing versus unboxing, and thereafter what is auto boxing versus auto unboxing. So the major reason why we do boxing or unboxing is to convert primitives into the objects. Now if you're talking about object oriented programming structure, right, so we are always thinking of objects now. So if you are able to convert primitives into the objects, it means that you are strictly and truly following object oriented programming structure. So we got one way of doing it, and now you can also pass by reference the primitives. So that's one more way of coming up, like why you do a boxing part. So we can pass the variables by references now, right? Because here you are getting the references to the objects. All right, so let's come back now to the next question, number 5. That's like, what are the keywords final, finally, and finalize, and what is exactly the purpose of it? So they are now the 3 different keywords, right? So even the final term is something which means the last thing, but they have different meanings in different contexts now. Now final is a kind of a constant. So if you mark a variable as final, you can't change its value. So here if you can see a very small snippet, right? So a is 1000 and you try to change its value, the compiler will not allow you to do so. So final is a keyword where you are able to mark your variables as constant. You can also mark your classes to be final. In that context, you cannot inherit from that class. You can also mark the methods to be final. In this regard, your methods, they will not be overridden. So final can be used with 3 of the concepts: final as a variable, final as a class, and final as a method. Finally is the other context where we use it with the exception handling techniques now. So what exactly is the place where we will be coming up with finally? So many a times when you are writing the exception handling code with a try and a catch clause, there might be a scenario whenever the exception will come, the statements mentioned within the try block, they will not be executed below the statement where the exception will come, right? So let's say there are 10 instructions in the try, and on the 5th instruction in the try you get an exception. So below 6, 7, 8, 9 and 10 instructions, they will not be executed. You need finally block to mention such instructions which must be executed, either exception comes or it does not. So finally is that piece of block which will be executed whether the exception is coming or it is not coming. For example, if you want to close the database connections, now exception is there or not, but we would like to close the connection at any cost, right? So you mention all such statements in your finally block. So the next part is finalize. So guys, finalize is a kind of a destructor. So whenever the object will be removed from the memory by the garbage collector, so this finalize method will be executed. So you can explicitly try out this example where you can say system.gc, right? And you need to just mention your references to be pointing to the null, and thereafter your finalize will be executed. So we can just have a small example on this, right? So what I can do, I can just demonstrate this. So let's say we got this class known as finalize demo, right? And I'm just gonna make this method finalize over here. So I'll say CISO object finalized, right? So here we go. Now what I'll do, I'll create the object of finalized demo. So I'll say finalized demo, fd reference assign new of finalize demo. So here we created an instance, and thereafter I'll say fd ref to go as null. It means it is not pointing to anything now. So later I'll say system.gc. So GC is called to the garbage collector, and it's gonna destroy the objects which are no longer required. So now you can see over here. So let me run it as a Java application. It says object finalized. Why is it coming? Because it's acting as a destructor call. So anything which you want to do before your object is removed from the memory, right, you can write it into the finalize method. All right. So let's go to the next concept. It's a difference between string buffer and string builder, right? So before we jump on the string buffer and string builder, we must understand they are both similar concepts when they are compared with the string class. So string is immutable version, whereas string buffer and string builder, they are the mutable versions, right? So let me define this part, what is meant by mutability versus immutability. Consider you got this string str1, which is a new string having hello, and you got this one more guy known as string builder. You say builder assign new string builder, and you mention hello. Similarly, you say string buffer. Let's take this guy as a buffer. You say buffer assign new of string buffer, again hello. So I have taken up these three strings, let us say str, builder and buffer, and now what is next? I will be appending the data in these strings now. So you say str.concat. So in string you need to say the function as concat. So I'll say hi, and similarly let us concat it into the buffer and the builder. So I'll say builder dot append. So in the builder, the function which we use is append, and same goes with the buffer. So buffer and builder, they are quite similar now. Later when I'll do a CISO on str, and similarly the builder and the buffer part, let us say builder and then finally the buffer. So the buffer here, we run the code. You see one major difference over here is that you get hello. So nothing happens when you concat the data into the str, right? But in case of builder and buffer, the data is concatenated. This is why, because strings are immutable, whereas buffers and builders, they are mutable. This is also one of the very beautiful query, first of all. So guys, buffer and builder, they are the mutable sequences, whereas string, it is immutable. You cannot change it, even though you are going to perform an operation. So what is happening over here, whenever you concatenate the data, you will be getting a new string, right? So you need to store the data into a new string. So concatenation results the data coming out as a new string. The old string is not changed. So significant difference between buffer and builder now we'll be discussing. String buffer operations are thread safe. So it means that by default, when you are going to use buffer, it will be synchronized. You need not to worry on top of multiple or concurrent threading now. Whereas builder, it's not thread safe. String buffer is to be used when multiple threads, they are going to work on the same string, whereas builder is supposed to be in a single threaded environment. Other than that, builder is quite better as compared to buffer over the performance part, because there is no synchronization overhead. So you can just try to write out this snippet over here, which will be able to help you to come up with the timing difference, and you will be able to see that builder will outshine the buffer in terms of performance. All right, so let us understand the difference between heap and stack. So stack and heap, they are two memories which are very much famous when you talk about the Java runtime, right? So Java runtime, the RAM, we got these two major data structures, stack and heap. So first of all, let us see how the stack and heap will come into action, right? So let us take one example, guys. So I'll just remove this snippets. All right, so let us understand the stack and heap into action. When we are talking about the RAM allocation, so this RAM will be divided into two parts. The first part is the stack and the other part will be the heap. So this circle is representing the heap memory. So both of them are a part of RAM now, right? So both the data structure, they are part of RAM. We got stack and heap. So let us understand this point of stack and heap, how the data will be stored and where it will be stored. I'll just take up one basic example from the Eclipse now. Whenever you will be creating an object, so for example, finalize demo, I said fd-ref assign new finalize demo. This is known as object construction statement, right? So this is object construction statement. So here what we are doing, we are trying to create an object with the help of new operator. And to be very much more precise, I'll take one class like point, right? And we'll define some x and y as attributes within this class point, right? And I can have one function like show point, which can just display me the data of point. So I can say point is plus the value of x, let us say a hyphen plus y, right? So that's like a point now. So how I'll be creating the object of point now? Same way you created the finalized demo, you say point p1 reference assign new of point. So how this statement will be represented in the memory? So guys, for this statement to be represented in the memory, what will be going into the stack, what will be going into the heap? Let's have a close look onto that part now. P1 ref over here will reside into the stack like this, right? So this guy is P1 ref. It will be created on some memory location. So let us assume it's 4001. It will be a hexadecimal address, but I'm just assuming it to be one address over here as 4001. So this memory location, this container P1 ref is created out over here. What is next? The next part is an object which will be constructed in the heap, which will have two compartments. The first compartment is your attributes, that's like x and y, and the second compartment goes like the methods show point. So this is like the attributes, and the second compartment is for your methods. Now what is happening over here? So this object has no name now, right? So this is having no name. On the heap you don't have any name for this guy, but you can definitely have an address over the memory. Let's say this is 6001. So this object is constructed at 6001. So P1 ref will have the address of your object, and this guy P1 ref is doing nothing, but it is pointing to this guy 6001. So we say P1 ref as a reference variable because it is referring to the object available at 6001. It's not a kind of a pointer now, right? In order to prove this concept, we can just say sys out of P1 ref. When I will do a sys out of P1 ref, let's say P1 ref is plus the value of P1 ref. Now I'm gonna run the code. You will understand that P1 ref over here is showing me some address of an object of type point, right? Since we got in the package co.edureka, so it says that co.edureka.point at memory location. So this is the memory location 7852E922, which P1 ref is holding for your object. So now once we are good to go, what is available in stack, what is available in heap for this instruction, right? So guys, anything for which you use the new operator, that will be constructed in the heap. So heap is that memory location where we use the new operator, and new operator is used to create the things dynamically. When I use the word dynamically, it means at runtime. It means anything which is constructed dynamically at runtime in your program, it will reside in the heap, right? So that's what the new operator will help us to do. Now let us have some more differences between stack and heap. So guys, stack memory is used only by one thread of execution, whereas heap memory is used by all parts of the application. If you talk on the access level, objects stored in the heap are globally accessible, whereas stack memory cannot be accessed by the other threads. Memory is like LIFO, whereas the heap memory is basically the tree structure now, right? So the memory management is based on the generation associated to each object. So here what we try to store the data is in the form of key value pair. So each and every object will have a hash code now. So that acts as a key for your object. When you talk of the lifetime, so we got existence until the end of execution of the thread, whereas heap memory will live from the start till the end of the application execution, and your garbage collector can anytime free this memory space. If you talk of the usage now, when an object is created over the stack, so now please guys, in case of Java, every object is dynamically constructed, so there is nothing like objects being constructed in the stack, right? So we are just giving a general overview of heap and stack over here, not typically inline to your Java. These are the general differences now. In Java, your each and every object will be constructed dynamically in the heap space, not in the stack space. So in the stack space, you will be getting the references to the objects now, right? So guys, whenever an object is created, it is always stored in the heap space, and stack memory only contains the local reference variables which are pointing to the objects in the heap. So let us move towards the next basic question, that's like the difference between the array list and a vector. So these are the two data structures. These are the two collection APIs in the java.util package. So both of them are quite same. The very major difference is that array list is not synchronized, whereas vector is synchronized. So guys, when your data structure is not synchronized, so the performance will be a bit more better as compared to the other one. So that's why your array list will behave faster in terms of performance as compared to your vector. If an element is inserted into the array list, it increases the size by 50%, whereas vector, they don't do it so, but they just double the size of its array, right? And array list does not define the increment size, whereas in the vectors, you can define how much size the vector should increment when it has reached its limit. Other than that, array list can only use iterator for traversing, whereas in vector, right, except hash table, vector is the only other class which can use enumerations as well. So you can enumerate over the vector. With the help of enumerations, we can also, iterate within the vector. So that's like some of the differences which are highlighted over here. Similarly, the other collections, Hashmap and hash table. So this is again a relevant question which is asked in the interviews many a times as a basic question. So Hashmap and hash table, again, the first difference is the synchronization, right? And your hash tables, they are synchronized, whereas hash maps, they are not synchronized. Hashmap allows a null key and a null value, whereas hash table will throw a null pointer exception if you will try to add a null key or a null value. Other than that, since a hash map is not synchronized, it's gonna behave faster as compared to the table. And we can make the hash map as synchronized by calling the collection synchronized map API. So it's not like that we cannot mark the hash map as synchronized. We can come up with our own logics as well, right? So guys, hash map traverse can be done through iterator, whereas table can be enumerations as well as iterator. Hash map will inherit abstract map class, whereas hash table is totally working on the dictionary class. Now the next concept is the difference between equals and equal to operator. Now this is one, as a new Java developer, many times we'll do this big mistake by comparing the strings with the equal to operator. So unlike your other languages, here you need to use the equals method to compare the strings now, right? So guys, let us understand this concept first of all. I'll just try to demonstrate it by writing one example. So let us say you got one string str1 as new string. So just recently we had this discussion that this is an object construction instruction. So str1 is a reference variable, whereas the string object will be constructed in the heap. So str1 is having one address, right? So let me write down this thing. str1 is a reference variable. It is having the address of an object. Similarly, I'll create one more str2, right? So str2 is also a reference variable. It is having the address of some other object. The difference over here, which we need to understand, is that there are two different objects which are containing the same value hello, right? So objects are containing the same value hello, and str1 and str2, they are the two different references and having the different values. So that's why if you're gonna compare it using equal to operator, right? So it's gonna say str1. Let me just finish out the program, and in the else part I'll just say not of equal to. Right now you will observe that str1 is not equal to str2. The reason is very similar, because you are comparing references now. So double equal to, we are comparing references, right? So that's one important difference for us to understand. Now when you need to compare the objects, you don't use double equal to. Instead you use this method known as dot equals, right? So you say, let us compare the strings using equals method. So here I'll say equals and not equals. So we don't compare strings using the equal to operator. That's very risky. It's one big mistake. You compare the strings with the equals method. Equals method is not comparing the references, it is comparing the values within the objects, right? So that's what we are able to understand, comparison of references versus comparison of values. So you can take up this program, guys, over here. If you can see, right, just go ahead and try to run this execution. We got one more program over here. Let us predict the output for this program. So in the main method, you are calling the method 1 with the input as 11. So you pass this 11 over here. From here you are invoking the method 2 by passing 11 into 11, and in the method 2 you are passing method 3, which is division of 11, and then in the method 3 you are subtracting 11, and finally in the method 4 you are adding of 11. So guys, finally we'll be getting the result as 11 itself, right? Because 11 into 11, it's gonna be 121. Divide by 11, it's gonna be 11. Minus 11, it's gonna be 0. Plus 11, it's again gonna be 11. So try out this program, right, and see to it if you can get the same output or not. So these are some of the basic questions, right, highlighted by us, which are very important and crucial from the interview perspective. Next, we'll be jumping on to the object-oriented programming structure. Now, this is one key area which company or an interviewer is looking and expecting. As a developer, you should be quite good on these concepts, because the advanced concepts or any of the application development model, it relies heavily on object-oriented programming structure. So let us see what we can have in the object-oriented programming structure. So the very first question, as in question number 12, is the difference between abstract classes and interfaces. So let us see some of the differences. Again, guys, this is quite theoretical information, right? But I would like to take one very small demonstration on abstract class versus interface, because it is very important to have a very fair knowledge, and this concept is linked with your runtime polymorphism. So let us understand this concept. So I'm going to create one class shape, and we'll have this method known as a draw, right? So let's have a draw method, and you say so drawing a shape. Now this is something which even we teach in the traditional language like C, C++, I mean native languages. So this is the same concept carried forward. We got a shape class, and we got a draw method. So what you're gonna do, you're gonna create the object of shape s assign, or let us say shape s, and then say s assign new of shape, and then you can say s dot draw. So the output is very much simple. You get the method drawing a shape, but I want my shape to be either as circle, rectangle, or polygon, right? So what I will do, I will just come up with a class known as circle. So I'll say this guy's circle shall extend something known as shape, right? And in a similar way, I'll also try to come up with something known as rectangle. And lastly, I'll say a polygon. So shape has 3 children now, and each and every child will be redefining the draw method with the respective shapes, right? So here we are. Now this is very well understood that whenever you're gonna redefine the method, so the concept of overriding will come into action, right? So this is overriding, and now if you say circle C and C assign new of circle, and you say C dot draw, you will always get drawing a circle because overriding has come into action. What I want to do, I don't want to do this concept, right? It's a basic concept now that whenever you will create the object of child, always the definition of child will come into action as a concept of overriding. What I want to do, I want to say reference variable belongs to the parent and the object belongs to the child. Now this is known as polymorphic statement. So how it is a polymorphic statement now? The guy shape S is pointing to circle. So shape is now behaving as circle. Let us assume that. Now this instruction is equated. It's very well equated. The equation is true. Reason is that circle is also a shape. Circle is a child of shape. So technically their type is same now, right? So I'll say S dot draw. So I'm saying S dot draw. What you're gonna observe is you get drawing a circle now, which is very well true, because there are 2 definitions. One belongs to the shape, other belongs to the circle. And when you say S dot draw, you will be getting drawing a circle. So you will be giving the preferences to the children over here, and the parents definition, they again gonna get overridden. What I'll do now, I'll say S is now a new of rectangle, right? You say S dot draw, and then you say S is new of polygon, and then you say S dot draw. So every time you are able to achieve S dot draw, drawing the different shapes, right? So this is what we call as in runtime polymorphism. The same method draw over the same reference variable S, we are able to draw different shapes dynamically at runtime. So guys, this beautiful concept is known as runtime polymorphism, right? And what we need to understand from here is that the guy draw in the shape method is useless. Having this concept over here that S is a new shape, so having the object of shape and executing this guy S dot draw makes no sense. It's not a pretty good sense, right? Drawing a shape makes no sense. Shape has to be circle, rectangle, or the polygon. So what we need to understand from here is we need not to have the object for this class, and we need not to have the definition for this guy draw. So you can change the architecture of your program, and you can bring down one more class shape, mark this guy as abstract, and mark the method within your class also as abstract. So an abstract class is a class for which you cannot have objects now. You can't create the objects, right? So here you can see it's an error. Other than that, the method can also be marked as abstract, which means you need not to have definition. So guys, when a class is marked as abstract, you cannot create the objects, but runtime environment will create the object, right? So see, so I say shape is constructed. Very, very important difference which I'm going to highlight today. So when you say the constructor over here, right? So you are able to create the constructor. It means the objects can be constructed for the shape, but you cannot create it. Runtime environment will be able to create that. You cannot create. If you will try to create it, it's gonna give you an error, right? So the same problem statement is solved. Drawing a circle, drawing a rectangle, drawing a polygon, but before the construction of the child object, the parent object is constructed by the runtime environment. So we say this is object to object inheritance, right? So what is happening over here? Inheritance is happening over here from object to object. So the parent object is constructed by the runtime environment, and then the child object is created. So abstract class is a class. You cannot create the objects, but the runtime environment can do so, and it can have abstract methods which have no definition. So no definition for this guy. Who has to define this guy? The child has to mandatorily define the definition for the draw. So if the child is not defining the draw method, it's gonna throw an error. So let's try to see this. So you try to comment out this code, you can see now it is giving you an error. So if there is n number of abstract methods in the abstract class, you need to redefine them in the children. Now we can understand this part, that this shape has helped us to improve the concept of runtime polymorphism. But this is again, which is like a parent is writing some rules which are supposed to be defined by the children. Now there's a relationship known as parent and child relationship. So abstract class shape is, when extended by the circle, it's a parent-child relationship. For example, the parent is just making a rule that breakfast has to take place at 8 a.m. in the morning. Now the children, they need to define this rule, and they can come up with their own definitions. Okay, we'll come up with a breakfast at 8 a.m. but I'll have snacks, I'll have bread and butter or anything, right? So that's like a parent and a child relationship. And from basic shape class, we came to an abstract class shape with some, you can say there were some problems over here, that we didn't want the object to be coming up and we didn't want the draw method to take place, right? So we achieved a better way of coming up with runtime polymorphism through abstract classes. Now I'll come up with the best way. So I'll say one interface shape with the method as void draw. So guys, this is the best way to achieve runtime polymorphism now. So what I will do, I will not say extend shape, but I will say implement shape. Now this is the difference which we must observe over here. So rather than doing an extension, I am doing an implementation. And in the interfaces, by default, the methods are public abstract. So it is by default like public abstract void draw. And in the interfaces, if you will observe now, so this constructor is significantly an error. It means that neither you nor the runtime environment can create the objects of shape, right? So it's an error, right? So for the interfaces, neither you can create the objects nor runtime environment can create objects. It means this is not object to object inheritance. There is nothing like parent and child relationship over here. What is the problem over here? This is the kind of traffic police, or the police department is imposing the rules on us to wear a seat belt, and now we need to define that rule, right? So traffic police is imposing a rule to follow the traffic lights, and it is up to us that how we define that rule. So it's not a parent and a child relationship kind of a concept. It's not parent object and the child object concept, right? I hope you got the example and you are able to correlate the fundamental between the interfaces versus the abstract classes. Now, since this method is by default public, so in order to redefine, you need to always have a higher access or the same access, right? So this is how you have achieved one more refined way of runtime polymorphism. Right, guys? So what we have understood, let's come back and now summarize the whole concepts. So abstract class and interfaces, they are the two different concepts, but we can accomplish runtime polymorphism with both of them, one being the parent, other one being one implementation, right? So guys, an abstract class can provide complete default code or just the details that have to be overridden, whereas interface, it will not provide any code. So it's just the signature. There cannot be any definitions in the interfaces, whereas abstract classes, they can have the definition. So we can only extend a single abstract class, whereas a class can implement several interfaces. So this is not multiple inheritance, it is multiple implementation, right? Moving ahead now, abstract classes can have even regular methods, whereas interfaces they cannot have. Now the instance variables in the abstract class, they can exist, but an interface, it cannot have any instance variables. Its variables are by default static variables, right? In abstract classes, you can use public, private, protected, so on and so forth, whereas in interface, by default, the visibility is public or none, right? So it is by default public somehow. If you mention nothing, it is by default public now. So here we can have constructors, here you cannot have constructor. It means that you don't create the objects, but runtime environment will create. Here neither you can create nor the runtime environment can create. Now abstract classes are faster as compared to the interfaces. They are slow because it requires extra indirection to find the corresponding method in the actual class, right? So that's what we got, some of the theoretical differences after the practical implementations. So polymorphism, I hope, is now very well clear, right? So guys, polymorphism means more than one forms, where a mobile phone can serve the purpose of camera, remote, MP3 player, and alarm clock, so on and so forth, right? So polymorphism can be characterized into two parts. One is at the runtime, one is the compile time. So guys, runtime polymorphism is where you are coming up with this parent and a child relationship. Again, we saw this map example: shape, circle, polygon, and rectangle, right? So what happens in the runtime polymorphism, you create a parent class and then you create a child class. Child class must override the method of the parent class, and thereafter you do an upcasting by saying the reference variable of the parent can point to the object of child. And whenever you will execute the method, you will be able to see the method execution happens for your child. So what is the difference between overloading and overriding? So guys, overloading is concept linked with the compile time polymorphism, whereas overriding is linked with the runtime. So in the definition part, method overloading means that the same method name should have different inputs or the different arguments, right? Every time they must be different now. So in method overriding, the signature should exactly be same. So here return type will not make any difference, but here everything should be exactly same. If you talk of the behavior, method overloading is basically adding or extending the method's behavior, whereas overriding is changing the existing behavior of the method now, right? So here we are trying to add the functionality, here we are trying to change the functionality. So compile time polymorphism versus runtime polymorphism, different signature versus same signature. And when you are talking of the inheritance, it may or may not need inheritance in method overloading, whereas overriding is only linked with your inheritance. So this is one significant difference, guys, if you can see, right? So this we have already observed the overriding part, but in the overloading part, if you can see over here, the add method with the two inputs of type integer and two inputs of type double. So this is one significant example, right? So guys, this is like overloading and this is like overriding, right? So you can just, I think this is done wrongly. So overriding is this example, overloading is this example. All right. So if there is any method which is private or static, so can you just try to override such a method? So guys, the answer is no, you cannot do so. So private method will not be inherited, so it makes no sense to override it or to redefine it. Whereas static method, it belongs to the class, so you cannot override a static method, right? So it's basically what we call it as in a class to class overriding, which is known as hiding, right? So here the concept is known as hiding. So if there is a static method in the parent class, and if you want to create a method in the child class to override the static method, it should also be static, and that concept will be referred to as hiding now. So what is multiple inheritance and does Java support it? So guys, multiple inheritance is one class extending more than one classes. So this is not supported in Java. So if you can see, there is a diamond problem which comes into action, that if there is a class A, right, and B and C class, they are inheriting the A class, and there is a class D which is getting inherited from B and C. So two copies of A will be coming into the last class. So this kind of problem is not solved in the Java. It needs the virtual concepts to come into action, since there are no virtual keyword or any other pointer support available in Java. So we cannot solve this problem now, right? So Java multiple inheritance is not supported. So one more query now over here, right? What will be the output of this program? So if the parent is having this method foo, which is marked as static, and one method bar, which is a non-static method, and there is a parent-child relationship where we are hiding a method versus overriding a method, and you are executing these method calls, right? So guys, the output will be, so since if you can see over here, so this parent.foo and child.foo, then parent.bar and child.bar, right? So you'll be able to get all these four outcomes. I am foo in super, in child, then in child, and then in child, right? So just try to execute the code and get the behavior. Similarly, we got one more program. So guys, this is where we got multiple constructors, and you created the object for the A. So by default constructor will come into action, but this over the reference function call will execute the constructor over here, and this over here will execute the constructor over here. So you will get how are you, then hello, and then the hi, right? So this as a constructor execution will happen over here as a function call. So you'll get the output in the reverse order now. Right, so one more program, guys. What's going to be the output for the program? So it's basically one miscellaneous program where you got a block and a static block. So guys, a block is executed when you create the object of a class, whereas static block is executed when the class is loaded into the memory. So the idea is to define you guys the role for the static block and a normal block. So a block over here, if you can see, is executed when the object is constructed, and static block is executed when the class is loaded into the memory. So just try to run this program and come up with this output, guys. Alright guys, so now let's understand servlets, right? So this is where we're gonna pursue with the enterprise edition concepts of Java. So we have left out the core part of Java, and now we are moving into the advanced part of Java. So servlets is also one of the core concepts when we talk of the enterprise edition of Java. So let us understand what exactly is a servlet, right? So that's like, what is a servlet? So servlet is one Java program which is executed over the server. Now that's like one very basic definition to what exactly is a servlet. So what happens now, whenever you're writing an enterprise application, you need to have some code which is executed by the server. So if the client is sending a request via HTTP or the HTTPS, request will come to a server, and the server will execute your Java program, and it's gonna send back the response to the client. Now the client can specifically be browser, or it can be a mobile application, or any other kind of a client, guys, right? So Java servlet is a server-side technology which will extend the capability of web servers by providing support for dynamic response and data persistence. We got Java X.Servlet and Java X.Servlet.api HTTP package which provides the various APIs for writing the servlet program. Now, any servlet program should implement the servlet interface along with the lifecycle methods where you can manage your code snippets. As most web applications, they are accessed using the HTTP protocol. So we got a class known as HTTP servlet and we got a corresponding hierarchy for the same. So over the web, we use two of the major methods. One is the get, one is the post. So what is the difference between get and post? So guys, get and post, we got two major methods how we can send a request from a client to the server. Other than that, we also have various other methods like put, delete, trace, so on and so forth. So these are the two important methods. Get is when you need to have limited amount of data which can be sent, right? Because the data is sent as a part of URL now. So post is when you have a large data and you need to send it across the body. So it automatically comes up that the data is not visible as a part of URL and it is more secure in terms of post request, right? So security is more because the data is not exposed in the URL. Other than that, you cannot bookmark the post, but the gets can be bookmarked. We got idempotent versus non-idempotent. So guys, what is idempotent? When you send a request, you get a response. You again send a request, you again get a response, and you compare the two responses, whether they are equal or not, right? So idempotent. So this guy get is more efficient, right? And it is more used than the post, right? Where now it depends, right? So efficiency is like get is more efficient undoubtedly, but it depends upon a requirement where you need to use what. Okay, so let's say you want to do a sign in. So obviously we need to send the username and the password to the server, and you cannot send it across the URL. Even now you can send it, but you need to encrypt the data before you send it, right? So that's like the differences between get and post. Now, what is meant by the session management, right? So guys, session is one term which means the time interval between the client and the server. So we have techniques to manage the data within the session. So that's like the session management now. So what are the various methods? So number one, we got the user authentication, then the hidden form fields, cookies, URL rewriting, and we got HTTP session API also to manage the session. So session is a conversational state between the client and server, and it can consist of multiple requests and responses between both of them. Now HTTP is a stateless protocol. You cannot manage and maintain the state, so that's why we need to use some fundamentals through which we can come up with this, right? So guys, every session will have a session ID which will be passed between the client and the server during the request and response, and you can use various different techniques. So to name few, we have mentioned them, right? Now we also have two APIs known as servlet context versus servlet config. So what is the difference over here? So servlet context and config is where we need to extract the data which is stored somewhere as in part of your web.xml deployment descriptor. So we will consider that part now. So servlet config is a single object where servlet context is on a global level now, right? So it's like a local parameter associated with a particular servlet, whereas we got a global parameter. So both of them are the key value pairs, right, mentioned within the web.xml file. Whereas servlet config, so you mention the data within the servlet, whereas servlet context is mentioned out of the servlet tag. In the servlet program, you can use the APIs get servlet config and get servlet context, and thereafter on the basis of the key you can retrieve the data, right? So for example, shopping cart of a user is specific to a particular user, so you can use servlet config, whereas to get the MIME type of a file or any kind of a global level or a variable, you can use the servlet context. Now, what is a possible life cycle of a servlet? Now this is really important when you talk of servlets, guys, right? So servlets, they got 5 stages when you talk of the life cycle, right? The first of all, the servlet will be loaded, then it's gonna be instantiated, initialized, then a request will be sent to a servlet, and then finally the servlet will be destroyed. So we got init, service, and destroy as the three lifecycle callbacks involved when you write the servlet program. So we got three of the APIs now: init, service, and destroy. What is request dispatcher? If you want to share the data from one servlet to the other servlet evenly, right? So we got this guy known as request dispatcher, which can forward the request to the other resource. Now this other resource can be possibly a servlet or an HTML file or a JSP file, and we can do so using the two different methods. One is the forward method, other one is the include method. So what happens over here is, when you send out the request from the servlet 1 to servlet 2, when you use the forward method, response generated from the servlet 2 will be sent back to the client. In case of the include method, response from the servlet 2 as well as the servlet 1 will be appended and then sent back as a final response to the client. Now we got request dispatcher coming up with the forward and include in these two differences. So guys, one of the important concept associated with the servlet session management is cookies, right? So what exactly a cookie is? So cookies are the textual data which gets stored on the client machine, and this data is sent from the server. So data is stored in the local machine of the client, guys. Let us see this part, right? So if you can see over here, I'll show you this thing. So when you open down the settings of your browsers, right, and you try to say cookie, right? So if you can see over here, so you get these options of cookie coming up over here. Content setting, you can see cookies. So allow the local data to be set, which is evenly recommended. So guys, cookies are the textual data which gets stored on your machine, and you from the server can just use the method known as get cookies, right, to read out all the cookies, and you can create a cookie by using the API cookie itself. It's a hash map key value pair. Cookie C1 assign new cookie with the key and the value, right? And if you want to add the cookie to the client's machine, you just call the method add cookie over the response object. So the next part is the Java database connectivity. So guys, this deals with the database connections now, right? So Java database connectivity, we got the first thing as JDBC driver. So whenever you wanna create a connection, you must have a driver, right? So guys, driver is the layer which will help us to interact our JDBC APIs with the database. So there are four major types of drivers. We call them type 1, type 2, type 3, and type 4 driver. It goes like JDBC, ODBC bridge driver, native API driver, which is a partial Java driver. Then if you want to come up with a client server model, you got network protocol driver. And lastly, you got the pure kind of a driver, the thin driver, the fully Java driver, which we'll be using to interact directly with the database. So Java app, it's gonna use the JDBC API, and the JDBC driver manager will interact with the driver, and drivers will further interact with the drivers for the databases libraries, and hence this whole channel of communication will be established. So what are the various steps to connect to the database in Java? We use JDBC, and there are some sequential steps which you need to perform so that we can perform all the CRUD operations. So what are these now? So there are 5 sequential steps which you need to perform. So guys, any of the database whichever you are using, right, so you need to come up with the documentation over their website, right? What is their driver class name, what is the URL, so on and so forth. Anyways, let us have a look on to the snippet now. So the first one is registering the driver, which comes through the API known as class.forName. So here you manage to write the driver, type 4 driver, or any other driver which you are going to use. Then you need to create the connection, which is created with the help of an API known as driver manager. So you say driver manager dot get connection. We need to pass 3 things over here. The first thing is the URL where your database resides. So if it is on the local host, you mention the host name to be the local host, and you manage to write the port number and the database name. Then the username and the password for your database. Thereafter, you need to say create statement over the connection. Once you have created the statement, thereafter you will be able to execute any of your SQL query. But in the finally block, you must close your connections. Right, so this is important that you manage to close your connections regardless of whether exception is coming or not coming. So what are the different JDBC API components? So guys, we got various interfaces and classes coming into the Java JDBC package. So we got java.sql package, and many of the libraries, if you can see, the APIs are mentioned over here. So in the interface part, we got connection, statement, prepared statement, result set metadata, database metadata, and callable statement. So all these are the interfaces. So connection is used to have a connection, statement to execute the SQL statements, prepared statement is also used to execute the SQL statements, but prepared statement is different from the statement in terms of how you are going to substitute the data into the SQL statement. So here we use something known as wildcard characters as question mark, right? Result set is the retrieved data from the database, and the data about the retrieved data is known as result set metadata, and the data about the database is known as database metadata. Callable statements are used so that you can execute the stored procedures of your databases. And some of the few classes which are mentioned in the right hand side, it includes driver manager, which is used to get the connection. So blob and clob are the two APIs where you can manage the binary large objects and the character large objects. So binary large object means the audio files, the video files, right? Whereas clob means the textual files. Then the type will define what are the various types. SQL exception is exception in the JDBC. If there is any connectivity issue or any other syntactical issue or any different kind of SQL issues which gonna occur at runtime, so SQL exception is the class to get the error from. Now, what exactly a JDBC connection interface be, right? So guys, the connection interface is the one which will maintain a session with the database. So here we can use the transaction management logic, which means atomicity. So atomicity means that all and everything should happen at once. So let us understand. So connection is one important interface with the help of which we can manage the transaction. For the transactions, let us assume I want to transfer the amount from one account to the other account. So there needs to be two possible SQL statements which are supposed to be filed. One will be the updation in my account, that will be deduction of the payment. In the other account, again an updation query which will be the addition of the payment. So these two queries should be fired at once, and if any one query fails, the other query should be rolled back. So for the transaction management via the connection, you create the statement, and thereafter you can come up with the auto commit API where you can mark it as true, and then you can use the APIs like commit and rollback to manage your transactions. So close is a method where you are able to close the session with the database. Right guys, so there is one more possible difference between three of the APIs, that's like execute, execute query, and execute update. So guys, execute query, execute update, and execute, these are the three different APIs. All the three APIs are used to perform the SQL operations over the database, but query method is always focused to do a retrieve operation. If you can see now, select operation, right? So whereas your execute update method, it's gonna perform the DML and the DDL operations, insert, update, delete, create and alter of the table, right? Whereas execute method, it is able to perform any kind of operation now. So this is typically used to retrieve the data. Here the data can be modified, whereas execute method, any kind of SQL statement. Return type of these methods, they are different now. So result set will be returned from the execute query method. Here we will be getting some integer output, and here we will be getting some Boolean output. This method is used to execute only select queries, so non-select queries, and here both the select and non-select queries. Right, guys? So that's like the JDBC part, right? So how we got various APIs available in the Java database connectivity, but we need to come up and understand there are the 5 different steps. So you start from loading the driver, then creating a connection, writing the statements, executing the statements, and finally moving on to the closing of the statements. So the next part is the framework of frameworks. That's like the Spring framework. So if you know this, if you have a hold on your Spring framework, guys, so it's like you are done with almost everything now, right? So one of the most important framework in the enterprise edition of Java. Let us see what is Spring framework. So what exactly is Spring, guys? So Spring is an application framework which focuses on a concept known as inversion of control for the Java platform. So many of the great technologies, they are built looking on to the architectural model of the Spring framework. Even the Android, how the UI part is linked with the layout part, so that concept is again adopted from the Spring pattern, right? So it is one of the pattern which focuses on IOC, that's like inversion of control. So the framework's core features, they can be used by any Java app for building an enterprise edition application. One of the major advantage of writing a Spring framework app is it's lightweight. It is having an integrated framework architecture where we can use it to develop any kind of an enterprise app in Java, right? So it's less on a memory, it's high on performance, and it contains various frameworks available within it through which you can write a multi-purpose enterprise application. So guys, what and all are the modules available in the Spring framework now? So Spring framework has various modules. To start with, we got the very first layer as the core container. If you can see this core layer. So whole of your Spring framework is dependent on this core layer. So this core layer focuses on something known as inversion of control and dependency injection. So we got this as Spring context dependency injection. Then AOP is aspect oriented programming, which focuses on how we can fulfill cross-cutting concerns. Then the database module of the Spring framework includes DAO, JDBC, and ORM, as in the design patterns. So DAO, the data access object. So here we can write the DAO patterns to access the database. We got JDBC support. We also got the Hibernate or the ORM support, which is object relational mapping. The web module of the Spring framework can help us to write the web applications, where Spring MVC is one of the majorly used frameworks in the market now. So model view controller, where model represents the data container, view represents the UI or the presentation, and controller represents the business logic, as in servlets now, right? So Spring MVC is one of the very important concern when it comes to develop the web applications, and we got various web services coming out in this module itself. Let us move on to some annotations which are used in the Spring configuration. So guys, there are various annotations now which are used in the Spring framework now. @required, right? So it's like what is the input which is required. Auto wiring for your dependency injection. What happens pre-destroy, what happens post-construct, right? So before the object is finalized, just after the object is constructed, what is the resource, what is the qualifier. So these are some of the Spring annotations which are used for the configuration purpose. So what is bean in Spring and what can be the different scopes of the bean in the Spring, right? So guys, I'll take up one very a basic example over here to mention this concept, right? So let us take one example. So I got this Spring demo available with me with all the jar files available out here. We got this employee bean.xml file. So just give me a moment, right? So all right. So here you can see now we got this employee bean. So this is one XML configuration for the Spring framework. So we got co.edureka.employee as a class, right? And here what I am able to do is to define the property value tags for my bean, right? In the employee.java, I can say it's basically a bean or a pojo. So what is the bean class? Bean class is a class which will have the attributes along with the setter and the getters, right? So all the setter getter methods are also there. In my client class, what I am going to do, I'm just gonna use this Spring container, and thereafter I will just extract my employee object, right? So just let me do this part. All right. So I got the reference of the employee bean.xml, and in my class I got this emp bean1. So I'll just say emp bean1, and thereafter I'll do a CISO of emp, right? So let's try to run the code, and you can see that the data over here is coming up as in ID, name, and salary, right? I have just overridden this toString method out here. So along with this, I'm also supposed to do a super.toString, right? I'll do a \n and a super.toString. So now it will show me the data within the object as well as the reference variable m is pointing to the address. It is showing me the address as well to the object now. So the bean is extracted from the Spring container, right? So there are various scopes available now. For example, same emp bean1 in my client, if I try to get it again, right? So let us try to say get of bean again, right? As in emp1 and emp2. Let us say this is emp2 and this is emp1. Right, so I will closely observe one difference, one similarity, that every time when you request this guy get bean for the emp bean1, you are able to receive the reference to the same object. Scopes of the bean can be mentioned over here using attribute known as scope, and here now I am going to mention it as prototype. You can see we got this guy as a prototype. Now when I run my code again, you will find one significant difference, that here the reference is coming out to be different. It means now by default it was giving me the singleton as a design pattern, but when I change the scope to prototype, every time I am requesting the object of emp bean1 from the Spring container, it is now constructing a new object and returning it back to me. So guys, this is what we got as in what can be the scope of your bean in the Spring. So inversion of control container can have various scopes now. Singleton means only single object, which is by default. So prototype means you can have every time a new object. Request means one object per entire request. Session means one object per entire session, and global session means one object per entire global session on an application level. So how is a bean added to a Spring application? So guys, you use this tag known as bean, you mention the ID, and then you can have the properties as in key value pair, right? So what is the role of dispatcher servlet and context loader listener? So guys, dispatcher servlet is acting as a front controller in the Spring MVC. So many times I will call it as a receptionist now. So what happens, any request when it's gonna land up to your web application, so this guy dispatcher servlet will dispatch the request to the corresponding resource available on your web application. So it's gonna act as a receptionist in your program now. Whereas context loader listener, it's a listener which will give you the event callbacks when the context will be loaded. It's like startup and shutdown of the web application context in the Spring root. Now, what is the difference between constructor injection and setter injection? So before you come up with the constructor injection and the setter injection, you must understand what is dependency injection. So guys, let us understand this flow once again. I am having one class as employee, right? And there is one more class known as address. So employee can have the name, employee can have some salary, there will be definitely one employee ID, and employee can also have an address, right? So I'll just say an address to be as ADRS. So what we can do, we can create one constructor of an employee in this way, right? And here you can say EID goes like 101, name goes like, let's say, John, salary goes like 30,000, and address goes like some new address, right? Where address can have some address line, then you can have some city, you can have a state, and lastly we can also have some kind of a zip code. Just mentioning some parameters over here. Now what will happen, over the client part you will be writing employee assign new employee. So whenever you are creating the object of employee, this becomes the concept that the constructor of the employee will create the object of the address. We can see a significant dependency now. When you are creating the object of employee, within the constructor of employee, the object of address will be constructed. We say this concept as high dependency, or you can say we got a higher value of coupling. Now we need to reduce it, right? So you need to bring it to the lower level. So you need to take it as a low coupling. So what I will do, I will not use this technique. I will say, let us create one more constructor and pass the address as an input, right? And thereafter you can say address assign AD, or you can create a setter. You can say set address, and you can say address, and here you pass this guy. So guys, in these two approaches, rather than having a single employee object, you can now create an employee object. You can create address objects separately, right? You need not to be dependent upon the employee object, and later you can pass the address object. Or you can say employee E assign new employee and E dot set the address, and you can pass this guy A. So we want to reduce the dependency, or we want to come down with the coupling parameter. We created this logic out here. So setter injection and constructor injection are the two terminologies linked up in order to justify these two terms now, right? So let us open up our presentation once again and look on to constructor injection versus setter injection. So there is no partial injection, so setter injection can lead to partial injection. Here we need not to override the setter property, but here the constructor property, in case both the things are defined. So you can create new instance if any modification occurs. So you need not to create any instance if there is a property change. So better for too many properties, better for few properties. So guys, depends upon your choice, but constructor and setter injection, they are the two key concepts to bring down your dependency to the lower levels. Now, what is auto wiring in Spring? So many times when we are writing this dependency injection programs, you can perform these injection programs based on the names, right? For example, you can mention this auto wiring tag and you can say by name. So you need not to now write an explicit injection logic. It will be mapped automatically for you. So there are various modes through which you can have an auto wiring coming into action. So no is the default mode. It means you don't specify the auto wire. It means here nothing is enabled, so auto wiring is not enabled. So when you mention by name, it means you take the setter method and you map the data corresponding to the name. By type will use the type of the attribute, and constructor will inject on the basis of the constructor. So how can we handle any exceptions in Spring MVC framework, right guys? So there can be exceptions now when you are writing the program, right? So Spring MVC framework can help us to achieve robust programming concept through these possible ways. Number one, controller based. So you can define an exception handler method in your controller class itself. You can have a global exception handler where exception handling is a cross-cutting concern through AOP, right? And then you can have a handler exception resolver. So any Spring Bean which you have declared in the dispatcher servlets application context that can implement handler exception resolver, which can thereafter be used to intercept and process any exception which occurs in the MVC system and it is not handled by the controller part. So you can use the various different concepts out here. If you can see @exception handler annotation, so that you can specify that this view will be used to display some error. All right, so some important annotations again in the Spring framework, guys. We got @controller, @path variable, qualifier, configuration, scope, request mapping, response body, auto wired, service, and aspect, right? So all these annotations, they are quite important concepts and you must have a fair knowledge on all these, right? So for example, @auto wired, so either you can configure it in XML file or you can use annotations. So XML files, they come up with the inversion of control concept, whereas annotations, you need not to have XML files, you can use them directly. All right, guys. So lastly, in the Spring framework, we can also have Spring framework coming up with the database connectivity either through JDBC or through Hibernate or any other framework now, right? So Spring and Hibernate, they can work together. We have some ORM modules available within the Spring framework and we got an API known as Hibernate template. So if you want to come up with the Spring and JDBC, you got JDBC template API, right? So guys, Spring ORM module will help us to integrate Hibernate framework into a Spring application, and Spring ORM also provides the support so that you can use Spring declarative transaction management. You can use annotations and you can perform the actions now. So now we will be on our last concept, that's like the Hibernate, which is the backend framework based on object relationship mapping, right? So guys, let us see what and all we got in the Hibernate now. So the 44th question is, what is Hibernate? Hibernate is an ORM, which is object relationship mapping. It's a framework now where you just mention your Java object and you forget about your database tables. So guys, what we're gonna do, we're gonna write down some mapping files as in XML configuration files where you will be mapping that this attribute in my object in my class will be the column name in the respective relational table. So Hibernate provides a reference implementation of the JPA, Java Persistence API, right? And it makes a great choice as an ORM tool where we got the benefits of loose coupling. Now I hope you got the meaning of loose coupling, where dependency has been reduced to the maximal level. So Hibernate configures all the flexible and can be done from the XML configurations as well as through annotations programmatically, right? So it provides us both the ways now. So what can be the benefits with the Hibernate framework? So guys, Hibernate will eliminate all the boilerplate code, whereas in the traditional approach you need to mention and write various code snippets and you need to write the relationship mappings, the cache management. So everything is eliminated when you use Hibernate now. So this framework will provide us XML support as in through configuration files and annotational support through JPA, that's like Java Persistence APIs. Now Hibernate provides a very powerful language that's like HQL, which is very much inline to SQL, but you need not to learn it. It's more simpler than the SQL even. Now SQL itself is very simple language. You got more simpler language than the SQL, that's like HQL. So guys, it's an open source project from the Red Hat community and it is used worldwide and it's very famous, especially for any large enterprise application. Your Hibernate framework is one of the ideal choices now. Now any database vendor specific feature, Hibernate is suitable because we can also execute native SQL queries. So Hibernate is not just that we can use its native APIs and you can't do anything out of the box. You got to execute the SQL queries also with the Hibernate. One of the most significant features of the Hibernate is the cache management. So Hibernate provides 3 levels of cache through which your performance of the database operations, they're gonna get improved now. So what is the architecture of Hibernate, guys? So Hibernate of having an architecture in a very simpler fashion, guys. We got a database. On top of database, we got various modules coming in. For example, Java transaction APIs, we got Java database connectivity, and thereafter we got JNDI, that's like Java naming and directory interfaces. On top of it, we got the Hibernate APIs. So configuration API will read the XML configuration file and it will help us to create a session factory. Session factory will be used to create the session, and session is one API which maintains and creates a connection with the database. Using the transaction API, you can use the commit and rollback features, and query API will help you to create one query and retrieve the data. Criteria is one API which will help you to mention the criteria. For example, you got restrictions to manage, for example, greater than, less than, all equal to. So all these are criteria when you are trying to retrieve the data. In the Java application, you just write a Pojo class, you just write a bean, and you give this object to the Hibernate, and Hibernate's APIs, they're gonna manage everything for you. All right, we got the get method and the load method in order to perform the retrieve operation. So let's see the differences. Let's say we don't have a record available in the database, so load method will throw an exception, that's like object not found exception, whereas the get method will return a null, as in the object is not found. So guys, get method will always hit the database, whereas load method will not hit the database, right, in case it's not there, and you're gonna get a real object, not a proxy object, whereas load will return you a proxy object. So get should be used if you are not sure about the existence of instance now. So let's say that the record is existing or not, I don't know, so you use get. If you are sure about whatever you are going to extract from the database, it is existing, you can use the load method. So there are now significant differences between Hibernate and JDBC. Guys, this is one of the major query between, as in a part of interviews. So why Hibernate and why not JDBC? What are the differences? What are the advantages that you should be opting for Hibernate? Now, if you're writing a very small app, right, you need not to go on the Hibernate level. Hibernate level is required when you're writing an enterprise app, right, where you need to save the time and you don't want to do a rework, and there are various other differences. So let's have a look onto that now. So guys, first of all, you need to write a lot of code when it comes to JDBC, whereas Hibernate, you have very limited instructions to mention, right? Hibernate supports all the association, inheritance, collection mappings, where in case of JDBC API, you need to write all those logics. So one-to-one, one-to-many, many-to-many, all these mappings, they are available as a support in the Hibernate. Hibernate will also give you the transaction management implicitly, whereas in JDBC, again, you need to manage that part. Now, JDBC API, they will throw SQL exception, right? So it's a checked exception. So we need to write a lot of try-catch block code when you are using this JDBC, but Hibernate will internally manage this try-catch block for you. We got HQL, which is object-oriented programming, whereas JDBC, you need to write the native SQL queries. Hibernate will automatically give you the cache management for better performance in 3 levels of cache, whereas JDBC, you need to manage it yourself. So by default, Hibernate's performance is higher as compared to the JDBC part. So lastly, Hibernate will provide an option where we can create the database and the tables too, but for the JDBC, these existence should be there before you dump the data. Other than that, one of the very significant feature why Hibernate over JDBC is if you want to switch from one database to the other database, it's going to be very complicated with the JDBC. But in case of Hibernate, we got a configuration file. You just need to change the parameters in the configuration file and you will be able to shift from Oracle to MySQL or any other database to any other database of your choice. So guys, that will be all. Thank you very much. So any questions, any queries and your feedbacks, they are always welcome. Thank you very much, guys.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries and we will reply them at the earliest. Do look out for more videos in our playlist. Subscribe to Edureka channel to learn more. Happy learning!